Subscribe now and press the bell icon. Never miss an update.
Hello everyone and welcome to this lecture. In this lecture, I'm going to cover the course outline. If you guys remember, in the previous lecture, we covered the key ingredients to build any AI model. We learned that we need data, and I showed you guys a couple of sources to get that data. We also need a model, and finally we need the compute power to run the model and feed the data to my model as well. Okay, so let's go ahead and cover the various tasks that we're gonna cover over the 10 days. Okay, so in day number 1, we are going to develop an AI model to classify fashion elements using Google Teachable Machines. In day number 2, we are going to have a deep dive into AI technicalities, and we'll learn about artificial neural networks. We'll learn how to tweak the network parameters, hyperparameters, and number of epochs as well, and learning rates. And then in day number 3, we will learn how to build, train, test, and deploy an AI model to detect and classify facial masks. And the tool that we're going to use is known as Google Teachable Machines. In day number 4, we are going to learn how to visualize all the different state-of-the-art AI models. And we're going to learn how to use multiple tools such as TensorSpace.js. We'll learn about TensorFlow Playground and also Ryerson 3D CNN visualizations. In day number 5, we are going to develop a machine learning model to predict used car prices. And the tool that we're going to use in day 5 is known as Data Robot. And please note that all these different projects have been carefully selected for you guys to learn how to deal with images data, how to deal with text data, how to deal with tabular data, for example, to perform regression tasks, how to deal with tabular data to perform classification tasks. And also we'll learn many tools such as Google Teachable Machines. We'll learn about Data Robot. We'll also learn about Google Vertex AI and also AWS SageMaker Autopilot. So gonna be tons of fun. And this is, I would say, like one of the best courses I've worked on so far, and I put a lot of, I would say, effort in it and a lot of knowledge in it as well. I hope you guys will like it and you will enjoy it as well. So let's go back again to day number 5. So in day 5, we are going to use, as I mentioned, Data Robot. And please note that day 5 here is a regression type data set. So we'll learn how to solve regression type problems using Data Robot. And then in day number 6, we will develop an AI model to predict employees' attrition rate using Data Robot as well. And this is an example of a classification type tabular problems. In day number 7, we will develop an AI model to detect diabetic retinopathy disease using Data Robot. So this is more of a healthcare example, and we'll learn how to deal with images, and also we'll cover what we call it AI ML models explainability. So gonna be tons of fun. In day number 8, we will learn how to build, train, test, and deploy an AI model to predict sentiment from text data. So this again going to be quite new, and we are going to use Data Robot as well to do that trick for us. In day number 9, we will develop an AI model to predict credit card default using AWS SageMaker Autopilot. So here we'll learn how to use Amazon Web Services, and we're going to use SageMaker, which is super powerful tool that will enable us to build, train, test, and deploy AI models at scale. And we are going to do all of that without writing a single line of code. And that's, I would say, the unique feature about this course and about these projects as well. And then finally, in day number 10, we will develop an AI model to predict loan approval using Google Vertex AI. And Google Vertex AI is a super powerful, actually brand new tool by Google that can enable anyone to build, train, test, and deploy AI models at scale, again, without writing a single line of code as well. Okay, all right. So that's it. That's simply all I have for this lecture. I hope you guys enjoyed it. And now we're pretty much ready to go ahead and get started with day number 1. Please stay tuned. Best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. In this lecture, we are going to cover the 3 key components that we need to build AI models. Please note that this lecture, again, is quite easy. It's pretty straightforward. So let's go ahead and get started. If you guys remember, in the previous task, we have been able to cover AI superpowers. We learned about the definition of AI, or what do we mean by artificial intelligence. We also covered a couple of AI applications. We learned that the AI is applied in self-driving cars, in Amazon recommender systems, in Siri and Alexa as well, and Facebook automatic tagging system or facial recognition system as well. And finally, we went through a video. I hope you guys were able to you like that. And also, of course, the book. I recommend that you guys read that book as well. Okay. So what I'm going to do right now is I'm going to show you guys the main key recipe to build any AI or ML models. So essentially, to build any AI models, you need 3 things. The first one is you need data. So in order to train, let's say, an AI model, for example, to detect your face, what you need is you need data of your face, right? So essentially, when we train AI models, we need data, and we need a ton of data. And I'm going to also show you guys throughout our 10 days how to first use data that is already available online. And I'm also going to show you guys how to collect your own data set. We're going to learn how to open our webcam and actually collect our live training data. So going to be tons of fun. So that would be the first key ingredient to build any AI model. The second ingredient is, well, you need a model. You need essentially mathematical equations that can consume that data and learn the features in this data, and will be able to make proper decisions afterwards after the model is trained. And the third key ingredient is, well, compute. You need a computer, you need compute power, such as CPUs or GPUs, to take the model, consume that data, and essentially learn the features in that data. And essentially, these are the 3 main ingredients. Let me show you guys a kind of a deep dive into each of these areas. So let's go ahead and cover the data. Well, data can come from so many sources. It can come from images, audio, video, and text formats. One of the challenging areas for any company is how can we collect, structure, and analyze that data. So any company right now, in order for it to gain competitive advantage and gain customer insights, what they need is that they need to consume the massive amount of data about their customers, and essentially they are able to set their marketing strategy and maximize revenues and reduce cost as well. So for example, the data that we can use to train AI models could come in an image or video format. It could also come in a text format as well, such as, let's say, on let's say Facebook, for example, on Twitter. And we're actually going to have a project essentially to cover these different areas. So for example, we're going to have a project that deal with image data. We're also going to have another project that deal with text data. So we'll be able to essentially analyze Amazon reviews, and we'll be able to build an AI model to learn the sentiment of the customers. So going to be tons of fun. And then we can also consume data such as audio and sound, and also time series signals such as, for example, stock prices, or let's say temperature, for example, variations across weeks or months as well. Okay, so the next question is, okay, how can I get that data? So data is actually available in many sources. And if you guys are new to AI or data science or machine learning, there is an amazing website known as Kaggle. And I actually have it open here. And essentially Kaggle includes a ton of open source available data sets for you. So for example, once you open Kaggle here, you can search. What you guys see here is that we have almost 100,000 data sets. Just amazing. And it's actually like increasing every day. So you can, for example, let's say you wanted to train an AI model to, let's say, detect and classify, for example, disease. So I can say, well, I wanted to look for data related to disease, and what you guys see here, this is tons of data sets available. For example, you wanted to predict, let's say, heart failure or maybe COVID-19 classification, and if you click on see all, here are the different basically data sets available for you, which is super powerful. So if you, let's say, predict heart failure, what you guys see here is you should be able to go ahead and download the data set. So the data set's available. You can go ahead and look up the description of the data. So it's telling you that this is a cardiovascular disease data set. And also, and that's what's super powerful as well about Kaggle, is if you go under code, you would be able to see other people code as well. So how they handle that data, how they visualize that data, and all that code is essentially available for you here, and you can go ahead and essentially fork this notebook and go from there. And that's the first website that I wanted to show you guys. The second website is, I have it open as well, it's called UCI, Machine Learning Repository, and it's essentially for University of California. And if you guys scroll down here, you should be able to see tons of data available for you as well. So for example, if you scroll down, you should be able to see automobile data set. Let's say we have the breast cancer data set and so many available data set. For example, if you click on breast cancer, it can show you, first of all, you can go ahead and download the data, and it can show you as well how many instances, what's the size of the data, and so on, and also relevant paper if you wanted to go ahead and see how other researchers have been able to handle that data. Okay, all right. So that simply answers the first question, which is how can I get the data? And these are two of the key resources. Another as well example of how this data became available like crazy, which is a data set known as ImageNet dataset. This is essentially an open source repository of images that contains 21,000 classes. Essentially, it contains everything we have around us, okay? And it's right now, as we speak, it has 14 million images, and it's actually growing as well on a daily basis. So you guys can go ahead and look it up as well. It's called ImageNet, and I'm going to show you guys as well AI models that have been trained to classify all these different 21,000 categories, and we'll learn also how to visualize all these different neural networks. It's going to be tons of fun. Okay, the next question is the second ingredient is the model. So the human brain consists of billions of neurons that communicate with each other through electrical and chemical signals, and essentially enable us to feel, see, make decisions, and so on. And essentially, while I'm teaching right now this course, for example, my brain has hundreds or of billions of neurons, and all these neurons are communicating with each other, and it's allowing me first to see the slides right now, to talk, and to make decisions as well, right? And when I say that I need a model as a key ingredient to build AI, essentially, what we're trying to do is that we're trying to build what we call it an artificial neural network. And essentially an artificial neural network, think of it as more of a bunch of equations, okay, that try to mimic the human brain. So what we do is we grab that human brain and then we try to mimic that brain mathematically. And I know I don't want you to be intimidated. We're going to cover that in great details over the 10 days, I would say, challenge. But essentially, we are going to build nodes here and connect all these nodes together in a layered fashion. And we'll be able to build some sort of an artificial brain. So we can teach that artificial brain to detect objects, classify images, classify text, and so on. So that's the idea when I say I need a model. That's essentially the model that I'm talking about. Think of it as a bunch of math equations that try to mimic the human brain intelligence. Okay? The third area or ingredient to build any AI model is you need compute. So now we have the model, now we have these equations, we have the data, now we need to essentially feed that data to the model. And in order to do that, we need computer, right? We need compute power. And artificial neural networks essentially require computational power to learn from the data. And there's a great link here. It's by OpenAI. I actually have it open here. And it's a great article. I highly recommend that you guys read it. Essentially, it shows you how the compute power that is used for AI has been growing over the years. So basically, since 2012, the amount of compute used in the largest AI training runs have been increasing in an exponential fashion. And there has been around 3.4 months doubling time, which is pretty incredible. So basically, in 3.4 months from today, the amount of compute power available for us to train AI model actually doubles. And this is huge. This is like way more than Moore's law, which essentially states that there is a 2-year doubling period. Right now, we exceeded that by far. Basically, since 2012, that metric has grown by more than 300,000 times. So what you guys see here, and please again, don't get intimidated with all these names. We're gonna cover a lot of them actually throughout the days. So for example, these are different neural networks. These are different AI, essentially, models. And in 2012, for example, AlexNet, and we'll learn about AlexNet as well in Project 4, in Day 4. From AlexNet up until AlphaGo here, which is around 2018, 2019 timeframe, essentially there has been 300,000 increase in compute. Like 300,000 times increase in compute, which is pretty scary, to be honest. And that's essentially just what I wanted to cover right now. We're going to dig a little bit deeper into it as well throughout the days. And that will essentially cover the next topic that I wanted to show you guys, which is related to the compute power and how that massive growth in compute power over the years. And essentially a great article as well. I highly recommend that you guys read it here too. It's called, it's by Elon Musk, that essentially warns that AI could create an immortal dictator from which we can never escape. And think of it that now we are essentially every 3.4 months, we are doubling the compute power. Like the intelligence is increasing over time. Now we can solve problems that can even beat the best or the top humans. And essentially what Elon Musk as well states here, that the least scary future I can think of is one where we have at least democratized AI. So if we're gonna build like a dictator, basically like a super intelligence, it's actually better to democratize it, make it kind of, distribute that power across various humans, and instead of having just a very small company or a small group of people who have that like god-like digital super intelligence. And again, I highly recommend that you guys read this article. It's pretty interesting. Okay, so that's all I have. I hope you guys enjoyed this lecture. In the next lecture, I'm going to walk you guys through the course outline, and then we're going to get started with day number 1. Please stay tuned. Best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this new project on fashion items classification using AI and machine learning. So today we are going to start with task number 1, and we are going to cover what we call the project card and also a demo of the project that we are going to build today. Please note that in every single lecture, I'm going to add a bar here that can show how easy that lecture will look like. So this lecture today is going to be pretty straightforward. That's why it's quite easy. And then as we progress through the entire course and through the entire project as well, you will notice that essentially the level of difficulty starts to increase over time. But right now, let's go ahead and stick with the easy one, okay? All right, so let's go ahead and get started. So in every single project, I'm going to provide you guys with what we call the project card. And also, we are going to cover a demo to demonstrate to you what the project essentially at the end will look like. So for the project card, we are going to cover the goal of the project, what tools we are going to use. We're also going to cover the practical real-world application, essentially why are we doing this, why are we training an AI model, for example. And then we'll learn about the different types of data that we're going to use to train our model. We'll learn about the inputs and the outputs as well. So today, the goal of our project is to build, train, test, and deploy an artificial intelligence model or an AI model to predict fashion classes from images. Basically, we are going to train an AI model where I can deploy that model, meaning I can give the model an image, let's say an image of, let's say, a dress, and then the model will gonna tell me what that image contains. It's gonna tell me, well, based on this image, it looks like a dress to me. I can upload, for example, glasses or maybe an eyewear, and then the model will gonna tell me what that class looks like, essentially. And the tool that we're going to use today is known as Google Teachable Machines. And you guys will see that it's actually super easy and pretty straightforward to build really powerful AI applications without writing a single line of code. So the question is, what is the practical real-world application of today's project? So this project can be effectively used by fashion retailers to detect and forecast fashion trends and essentially launch targeted marketing ad campaigns as well. So what about the data? So the data that we are going to deal with is essentially a bunch of images. I'm going to have images from 10 different classes, and I'm going to train the AI model to distinguish between these 10 classes. That's all it is. So the output will be the fashion class or the label. And we're going to dig a little bit deeper into that over the next couple of tasks. Okay. All right. So the question is, what's the use or what is the practical application, for example, of this technology? So essentially, there has been a lot of products available right now on the market where they call it AI-powered lifestyle and fashion assistant. Essentially, you can upload an image, for example, and then the AI behind the scenes can essentially tell you, well, this is a short, and then it can extract the style of the short, for example, and the color of the short as well. And for example, if I upload an image like this one, and then again, you guys will get that this is a jacket, maybe perhaps a white jacket, for example, and this is a purse. And the question is, after the AI model detect the class, after, for example, it can tell that this is short, well, it can, for example, let's say recommend to users other different shorts, okay, with maybe a little bit like slightly different colors, for example, or maybe close styles to the one that you actually like. And that's the idea of having an AI-powered lifestyle and fashion assistant. So instead of hiring an actual human being to suggest fashion items to you, you can essentially leverage the power of AI to do that trick for you. Okay? All right. So let me show you guys a demo of the project that we are gonna build today. So what you guys see here is essentially Google Teachable Machines, and don't worry about it. We're gonna show you guys exactly how to build that project from scratch. But essentially here I have all these different classes. So I have bags, I have belts, I have bottom wear, I also have cuff links, we also have dress class, we have glasses or eyewear, we also have flip-flops, we have fragrance, we have jewelry, watches, and also we have socks, wallets, and scarves. And please note that just in today, and pretty much in every single project, I'm going to show you guys a sample of the project that will be kind of a small version of the project, and I'm going to give you guys a final project where you can take the project that I showed you to the next level. So for example, today I'm going to show you guys, walk you through how to build an AI model that can classify 10 classes only. And then you guys will take it to the next level to include additional classes in our final project. It's gonna be tons of fun. Okay. So the question is, okay, now I trained the brain, okay, now I wanted to test that brain. All what you need to do is to click on choose images from your files here, and then you can, let's say, select, for example, this image here, And then the AI model, after it has been trained, it can tell you, well, based on this image, this belongs to the eyewear category, which is, of course, with a confidence of 98%. You can also choose maybe another, for example, let's say this one here, double click on it, and then it can tell you that based on this image, I can tell that this is a flip-flop, for example. Let's try another one. For example, let's say this one here, double click on it. It can tell you that this is a bag with 95% confidence. And it also messes up, kind of tell you maybe it's a little bit of cufflinks or maybe fragrance, but because the majority or kind of the high confidence is in the bag, then this image will belong to the bag category. And please note that I'm going to show you guys exactly how to build this entire project, so don't worry about it. This is just a quick demo, and then we are going to, throughout the next 3 to 4 tasks, we will learn how to upload the images, how to train the model, and also how to deploy the model and then test the model as well at the end. Okay? Alright. So that's it. That's simply all I have for task number 1. I hope you guys enjoyed it. In task number 2, let's go ahead and cover AI applications in fashion. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 2. In this task, we will cover AI applications in fashion. Please note that this task is still categorized under the easy, I would say, category, so gonna be simple and pretty straightforward. Please note that in this task, we are going to have reading material. So I'm going to provide you guys with an article that you should read within, I would say, 10 minutes approximately. And then afterwards, I'm going to include a quiz for you guys, so you can go ahead, give it a shot, and assess your knowledge. Please note that we are going to follow the same structure in every single day. So tomorrow, again, we're going to do the same deal. In task 1, I'm going to provide you guys with the project demo and project card as well. And then in task 2, we're going to provide you guys with the actual real world practical application of whatever project that we are going to cover in every day. And also we are going to include a reading material and a quiz as well. And then over the next series of tasks, I'm going to show you guys how to build, train, test, and deploy the AI model at scale. Okay? All right. So if you guys remember in the previous task, what we have learned is we have been able to cover the project card and demo. So we learned that we're going to build, train, test, and deploy an AI model to predict fashion classes from images. We learned that we're going to use a tool known as Google Teachable Machines, and we learned about the inputs and outputs as well. And next, we went through a quick demo. I hope you guys enjoyed that one and found it pretty straightforward. Okay, so let's go ahead and cover AI in fashion. So the global fashion industry is valued at $3 trillion industry, and it accounts for around 2% of the world's GDP. And GDP, or the gross domestic product, is essentially a measure of the market value of all the goods and services that are produced in a given period of time. And the fashion industry right now, as we speak, is kind of undergoing a massive transformation by adopting artificial intelligence, machine learning, deep learning, and computer vision techniques and technologies. So in this project, we will assume that a fashion retailer has hired you to build a virtual assistant, or stylist we call it, that looks at customer Instagram and Facebook images and essentially classifies what fashion category they are wearing, meaning are they wearing bags, they're wearing glasses, flip-flops, dresses, and so on. The model can help the retailer detect and forecast fashion trends and launch targeted marketing ad campaigns as well. Alright, so what I wanted to show you guys is I wanted to show you 2 AI applications in the fashion industry. So the first application is known as virtual AI fashion models. So a company known as DataGrid has been able to develop a full body model automatic generation AI. And essentially they leverage a technique known as GANs, or generative adversarial networks. So let me show you guys what do I mean by that. So if you guys go back to here, this is the DataGrid website, and this is the application that I'm referring to. So if you guys go ahead and run this video, basically what's going on right now is there is an AI model that is able to generate all these different poses for all these different virtual models, essentially. So none of these models are actually real. So all of them are essentially generated by AI, or generated by what we call it GAN, or generative adversarial networks. And then what you guys see here is they can actually change poses. They can change as well, you know, like the fashion item they are wearing. It's actually super, super powerful, and it actually poses a huge risk to human fashion people or models, essentially, because it can take away their jobs. Okay, so let's go back here. So the AI can essentially automatically generate fashion images of non-existing models. And I've included the video. That was the video that we just saw right now. I highly recommend that you guys go ahead and check out the DataGrid website. There's a lot of useful information. And this is just one application of AI in fashion. The second application that I wanted to show you guys is what's known as Instagram virtual influencers or models. So instead of having real human being, you know, as a Instagram influencer, what's going on right now, there is a huge shift into having completely virtual digital Instagram influencer. So if you guys go back to here, this is one example of an Instagram model. It's known as like Shudogram. And essentially this is just a virtual fashion model. Essentially it's not real. And what you guys see here is following, like, it's amassing 218,000 followers, and there's a huge trend right now into moving from real fashion influencers and models into having digitalized AI-powered models as well. The next application that I wanted to show you guys is known as by Fabricant Digital Fashion House. So I have it open here as well. So this is the Fabricant Digital Fashion House. What you guys see here is essentially everything is digitized. What you guys see here is Digital Fashion House. All the videos that are being shown here, all the fashion items, they are generated digitally, not necessarily by AI, but the idea here is we're just moving from kind of the human element into digital virtual world, especially in fashion, as what you guys can see here. Okay, the next article that I wanted to show you guys is, well, this article has been published by Sinead Bovel. I hope I pronounced it right. Essentially states that I'm a model and I know that AI will eventually take my job. It's really interesting read, just show you guys kind of, you know, the power of artificial intelligence and how it could essentially pose a threat to a lot of jobs that are being done or conducted by humans. Okay, so that was the first application. The second application that I wanted to show you guys that is closely related to our project is known as Facebook AI Lifestyle Assistant. So AI Lifestyle Assistant can analyze photos and make product recommendations. There is an artificial neural network known as GrokNet, and essentially it's an AI-powered system that is designed for shopping. It simply works by recognizing product attributes from pictures such as fashion, home decor, and so on. And essentially what you could do is that you can try products virtually and listen to recommendations from friends and family. And I've included a link for you guys here to this article. It's called Powered by AI, Advancing Product Understanding and Building New Shopping Experience. So let me show you guys that video and let me play it for you just to get an idea of what's actually going on here.
We're building AI systems to not only make it easier to buy and sell things online, we're engineering something entirely new. Imagine this. You've moved into a new place and you realize you need a little more light. An AI lifestyle assistant can analyze your furniture and recommend the perfect mid-century lamp to complement your decor. You can then try it out virtually and even share photos with your friends to see what they think. Plus, when it's time to declutter, the AI assistant can help you sell things by categorizing and describing items in any language. Facebook AI is one step closer to making this happen.
All right, so as you guys can see here, this is actually really interesting application of AI. And again, the idea is to try to recognize elements in pictures, and then the AI model can essentially recommend to you products that you can try virtually, and it can also help you guys sell products as well online and categorize them to by classes or categories. Okay, so now it's time for our reading time and for our quiz as well. And today's topic is on AI applications in the fashion industry. So I've included a link here to an article by Vikram Singh Bisan. I hope I pronounced it right. And the article is a great article actually on how AI is changing fashion and the impact on the industry with use cases. So please go ahead, give it a shot. The article should take around 9 minutes, and then at the end afterwards, I'm going to provide you guys with a 5 minutes quiz approximately. So that's it. That's simply all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and perform data exploration. So please stay tuned. Best of luck on the quiz, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, we are going to perform data exploration. If you guys remember, in the previous task, we went through AI applications in fashion. We covered how the fashion industry right now is being transformed with the power of AI, machine learning, deep learning, and computer vision. And we also went through 2 AI applications in fashion in general. The first one was the virtual AI fashion models. The second one was the Facebook AI lifestyle assistant. We also covered the reading material, which is AI applications in the fashion industry. And I hope you guys were able to figure out the quiz and found it pretty straightforward. Okay. So in today's task, we are going to learn about data exploration. So we're just going to go ahead, check out our data, maybe explore it a little bit. And then in the following task, we will learn how to take all that data and then train our machine learning model or AI model using Google Teachable Machines. Please note that this task is still classified under the easy category. So let's go ahead and get started. Okay, so what we're going to do today is we are going to build an AI classifier model. Think of it as like a little brain, like a mini brain. And these are the type of images that we're going to use. So we are going to have 10 different classes, okay? So these are the 10 different classes essentially. So I have bags, belts, bottom wear, cufflinks, dress, eyewear, flip-flops, fragrance, jewelry, and watches as well. So what we're going to do is that we're going to essentially feed in all these input images to our AI classifier model to train it. And please note that what we're going to do is we're going to apply what we call it supervised machine learning technique. Meaning, for every image, let's say a fragrance, for example, I'm going to feed in the image, and I'm going to feed as well the actual label associated with it. And we're going to do that teaching in a supervised fashion. So for every image, I'm going to have the corresponding label associated with it. So please note that our data set contains 1,000 images in total. So for every class, again, since I have 10 classes, each class is going to contain 100 images. So 100 times 10, you will end up with 1,000 images. So this is essentially our fashion data sets. And please know that each of these images is actually quite small. They are 28 pixels by 28 pixels. So the width and the height of the image is 28 by 28. Okay? All right. So let's go ahead and dig a little bit deeper. So that's actually what the images look like. So these are the bags category. So these are the kind of images that we're going to use. Here on the right hand side here, we have all the belt category. Here we have our jewelry. And here I have all the flip-flops category. And essentially what we're going to do is that we're going to learn how to first sign up for our Google Teachable Machines, how to create a new project, and how to upload all these images to Google Teachable Machines. And then we'll also learn afterwards how to train the model. And once we train the model, we will learn how to test the model and assess its performance. And then finally, we will learn how to deploy that model and essentially test it. And we are going to test the model at the end using new images. So not these images that we use for training, but we're going to use another set of images that the model has never seen before during training. And we call those testing images or test images. Okay? All right. So that's it. That's all I have for task number 3. I hope you guys enjoyed it. In task number 4, let's go ahead and get started with the AI training and testing in GTM or Google Teachable Machines. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 4. In this task, we are going to learn how to train our AI model using Google Teachable Machines. Please note that this task is still categorized under the easy category, so it's going to be lots of fun and pretty straightforward as well. If you guys remember, in the previous task, in task number 3, we learned about data exploration. We covered that we are going to train an AI classifier model that is going to consume all the bunch of images, essentially, of various fashion items, and is going to classify those images to one of the 10 categories or classes. And we also learned that we're going to have 100 images per class. So in total, we're going to have 1,000 images. Okay, so we also went through the sample data as well. This is just, a bunch of images, and these are the type of images that we're going to use to train our AI model. Okay, so what I'm going to do right now is I'm going to show you guys from a very high level what is going on, and then we're going to head toward to Google Teachable Machines to actually build our model. So basically, when you guys open Google Teachable Machines, okay, what you guys see here is we are going to perform 3 key steps. The first step is we are going to upload the training data sets. Essentially, I'm going to provide you guys in the course package with all the images that we're going to use to train our model. And step 1, all what you need to do is to essentially upload the training data. That will be the first step taking place in here. The next step is, well, after you upload the data, you need to train the AI model. And that will be captured here in step 2, outlined as training. And then after the model is trained, we are going to head to the third here rectangle, outlining the testing phase of our trained AI model. So once the model is trained, that means now I have that mini brain, and that mini brain has been already trained, has learned all the features from the images in the training data. It's going to test it. So I'm going to assess the model performance. But, and this is a very important point, I'm going to test the model with new images. Basically, images that the model has never seen before here, has never seen before in the training phase. So essentially, once the model is trained, I'm going to upload a bunch of newer images and then I'm going to see if that model was able to correctly classify it or not. And I showed you guys a sample in the demo lecture in the first task when we uploaded an image of, let's say, a flip-flop, for example, and then the class was a flip-flop with 82% confidence. Okay? All right. So here we go. What you guys see here is, again, you upload an image and test the trained AI model, and then the AI model is going to tell you what the class will essentially look like. So let's go ahead and get started and head to Google Teachable Machines. So I want you guys to, so that's what I'm going to be doing here, is I'm going to go to Google Teachable Machines. So I want you guys to press enter, and then you open Google Teachable Machines, okay? And basically, this is a quick description. So we'll be able to train a computer to recognize your own images, sounds, and poses as well. So basically, within Google Teachable Machines, you can actually do wonders with it. You can use it to train AI models with images, and that will be our today's project. You can also use it to classify sounds as well. And you can also use it to classify or detect poses. So for example, what you guys see here is, this is a project where you can essentially classify if the image here containing just me, just a person, or a person and a dog. You can also detect poses of humans if they are opening their arms, or, you know, like their arms are down and so on. You can also detect, for example, here there is a marshmallow or not, for example, like a sorter, like a color sorter, for example. And again, there are tons of applications available here, and we are only going to focus today on just the image classification piece, okay? All right. So what I'm going to do is I wanted to show you guys this video here that can show you how to quickly build an AI model, and then we're going to dig right away and get started with our project.
People are training computers and creating machine learning models to explore all kinds of new ideas. New ways to interact. Yes. To understand the world. To play. And experiment. But machine learning is pretty intimidating to get into. So we've been wondering, what if it wasn't? With Teachable Machine, we set out to make it easier for anyone to create machine learning models without needing to write any machine learning code. When it first launched in 2017, it allowed everyone to get a feeling for what machine learning is all about. But now, Teachable Machine puts the power of machine learning in your hands, allowing you to save your models and use them in your own projects.
So let's say you want to build a model to recognize you versus your dog. You just open up the site, record samples of you, and samples of your dog. Click train, and you instantly have your own machine learning model, which you can use in your sites, apps, and more. You can upload your model to host it online, or download it to work entirely on device.
With Teachable Machine, you can create custom models for all sorts of things. Using images, audio, or even poses. Personalized machine learning models for the things that matter to you. And folks have already been trying it out, using Teachable Machine in their own experiments, solving problems in their communities, or even just at home. Start creating and see where your ideas take you at g.co/teachable machine.
All right, so let's go ahead and get started by building our fashion classifier AI model. So the first step is I want you guys to go ahead and click on Get Started. And then you should be able to see that here we have 3 different categories of projects. The first one is either you are leveraging or using image project. You can also use audio project or pose project. So today we are going to primarily focus on image project. So if you click on it, it will tell you that you're going to either use the standard image model or the embedded image model. So please go ahead and select on the standard one. So what you guys see here is the 3 different stages that I showed you guys earlier. The first stage is to, well, upload our images. The second stage will be to train the AI model. And then the third one is to test or assess the performance of our AI model. Okay? All right. So the first question is, well, where is the data? Well, if you guys have access to the course package, you guys should be able to see that here we have fashion training. So if you click on it, you should be able to see that here we have 10 different categories or classes. These are the bags, belts, bottom wear, cufflinks, and so on. And if you click on any of those, you should be able to see that I have 100 images that belongs to each of these categories. So if you go back, if you click, for example, flip-flops, you should be able to see that here are all the flip-flops that we have. Again, 100 images. So I have 100 images per class. So in total, I'm going to have 1,000 images. Okay, so let's go ahead and start uploading these images. The first one, the first class, and I'm going to go here in order, is, well, bags. So I'm going to go here and say bags, and you have one of 2 options, either to collect your own data set live using the webcam, and we are actually going to cover that in future projects, but today, just for the sake of simplicity, I'm going to show you guys how to upload the data. Just say upload, and here what you could do is to simply drag and drop the images. So we're just going to go ahead to bags. I'm going to say Control A, that will select all the images. And then I'm just going to drag and drop these images. And here we go. What you guys see here is I have been able to upload 100 images that belong to the bags category. Okay, all right. So let's go ahead and go back to our second one, which is belts. So I'm just going to go here, say, please show me the belts. I'm going to click on upload. And then I'm going to go back here, click on belts, and then Control A, and then drag and drop. Here we go. The next class, to add a new class, I'll need to go here and click on add class. And then after belts, I need to specify bottom wear. So I'm just going to say bottom wear. And then you click on upload. And same deal as well. You're going to say Control A, and then you'll drag and drop. Next, I wanted to go to the next class, which is cufflinks. So I'm gonna go here, say add class, and then I'm gonna call it cufflinks, and then I'm gonna click upload, and then same deal, I'm gonna say Control A, drag and drop. Here we go. And then afterwards, I'm going to go to dress category, Control A, come here, add a new class, and then I'm gonna call it dress, and then click upload, and then I'm going to drag and drop the dresses here. Afterwards, I'm gonna add an additional class as well, which is my eyewear. So I'm just gonna go here, say Control A, and then add an eyewear, and then click upload, and then drag and drop the eyewear. 100 images, looks great. And then the next class is going to be the flip-flops class. Again, Control A, and then I'm going to come here, call it flip-flops. I'm gonna click upload, and then drag and drop, and that will simply gonna upload the flip-flops for me. The next class is gonna be fragrance. So again, I'm gonna say Control A, I'm gonna add a new class, and then I'm gonna call it here fragrance. Upload images, and then drag and drop. I know it's kind of tedious, but again, it's very, very simple, which is amazing. And then I'm going to have the jewelry, and then you press Control A, and then you're gonna say here jewelry, and again I'm gonna say upload, and then drag and drop the jewelry. So that would be my next 100 images. And then finally, I'm going to have the watches. Again, Control A, you'll add a class, you're gonna call it watches, and then I'm gonna say upload, and then drag and drop, and here we go. So what you guys see here is I have been able to essentially upload all the different images that belongs to our 10 different classes. And now I'm pretty much ready to go ahead and train our model. So please note that there is a lot of stuff happening behind the scenes or under the hood. But all these topics we are going to cover tomorrow in day number 2. But just for today, I was just going to assume that, well, I don't know what's going on behind the scenes. I don't even know maybe what AI is or machine learning is. All I need to do is going to upload the data. Here I have a little brain. I don't care about what's actually going on here. I was just going to say train model. That's all it is. And now I'm going to essentially feed all these images, and then that little brain is going to learn all the features coming out from all these different 1,000 images. And what you guys notice is essentially it's taking some time for it to train. So please click on wait. And please note and make sure to do not close this tab here, because if you close it, you're going to lose all the images and the entire project essentially. So now the data is being prepared for training, and then once the training is complete, again, let it wait. Once the training is complete, then you will be able to go ahead and assess or test the performance of our trained model. So here we go. What you guys see here is essentially now the model is being trained, and I'm going to show you guys again tomorrow what's 50, what are these numbers. Essentially we're teaching the AI model over a series of iterations. It's like a little child teaching that kid, for example, how to walk. So now we're going to teach it like, one step at a time. So now 21 out of 50, 23 out of 50, and so on. And again, it's taking some time for it to train, but once the model is trained, then you will be able to essentially deploy the model and assess its performance as well, and actually use it in an app or in any application of your choice. So here we go. Now we are at 43, 44, 45. We are very close to 50. And here we go. So what you guys see here is that the model has been successfully trained, and what you guys see is I want you guys to shift from webcam to file, because essentially I'm not going to be uploading data right away to the trained model. I'm not going to be using the webcam. I'm just going to be dragging and dropping images to test the performance of our trained model. So what I'm going to do is I'm going to go back to our data. So if you guys go back here, you should be able to see that here I have my fashion training. I want you guys to please go ahead and click on fashion testing. So if you click on fashion testing, you should see here a couple of images that you can use for testing. So for example, I can drag and drop, let's say this one here, and then what you guys see is we're going to tell you that based on this image, well, it belongs to the flip-flop category. And please note that these images have never been seen by the model during training, which is again super powerful. Now you essentially have a model that is able to generalize and not memorize, meaning it just learned all the features, all the important characteristics of a flip-flop, and is able to make predictions on new images that the model has never seen before during training. Let's go ahead and give it another shot. Maybe grab that one, drag and drop again. Here we go. It's telling you that this is a fragrance with 100% confidence. Maybe drag and drop again. It's telling you that this is an eyewear with 72% confidence. And you can also maybe grab this one too. And it's telling you that this is a bottom wear with 96% confidence. Okay. All right. So that's it. That's simply all I have for today's task. And let me go ahead and recap what we have done so far. So today we learned how to essentially train and test an AI model using Google Teachable Machines. We uploaded the data, we trained the model, and then we test the trained model performance on new images that the model has never seen before during training. And that simply concludes task number 4. I hope you guys enjoyed it. In task number 5, let's go ahead and learn how to export and deploy our model in Google Teachable Machines. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, we will learn how to export and deploy our trained model in Google Teachable Machines. Please note that this task is, I would say, in the intermediate level when it comes to difficulty. So let's go ahead and get started. If you guys remember in the previous task, in task number 4, we learned how to train an AI model in Google Teachable Machines. We learned how to upload the data, train the model, and then test the trained model afterwards. We have been able to test it here with just a bunch of images and generate predictions. Okay, so let's head back to our Google Teachable Machines. Okay, so here we go. And after the model is trained, let me show you guys what we have done so far. What we have done so far is we have been able to first upload all the images. If you guys remember, we had 10 classes and we had 100 images per class. So in total, we have 1,000 images that have been used to train our model. And then we clicked on train model, and then the training took, I would say, maybe a couple of minutes. And then now it showed that model has been trained. And then afterwards, now to the fun part, now to the testing part. We have been able to drag and drop images and test the performance of the model. What we do in general is, once that model is trained, what we need to do is that we need to take that trained model and actually deploy it in the field. Meaning you can essentially create what we call it an endpoint. Meaning now I have an application that is running, and behind the scenes, it's actually using the trained model that has already learned all the features that's coming out from all these different classes. And then once I have that application, once I have that link, I can essentially call it from anywhere I want, from, let's say, my cell phone, from anywhere, send it an image, and then the application is going to generate back to me the label or the class associated with it. Okay, so the question is, how can I do that export and deployment? So if you click on export model here, what you guys see is actually Google Teachable Machines has made it really easy for you to export the model and create an endpoint out of it as well. So what you guys see here, it's telling you export your model, and it's telling you upload with a shareable link. So you tell them, okay, looks great. Please go ahead and click on upload my model. And right now it's showing that it's being uploaded. And then once the model is deployed and uploaded as well, here we go. All right, so now your cloud model is up to date, and essentially now I have a link. So if you click copy, that will copy the link here to your deployed model. You're gonna go ahead, click on new tab, and you just simply type Control-V, that will paste the link. You press enter, and here we go. So now I essentially have a model, and that model is already deployed right now, and you can easily access that model from anywhere you want. So what I'm going to do is I'm going to, again, change from webcam to file, and I'm going to test as well my trained model using our sample images, as similar to what we have done before during the training phase. So now I can simply drag and drop maybe this image here, and now it's gonna tell you, well, that this is a bag with 99% confidence. Now I can maybe upload that one. It's gonna tell me that's a belt with 100% confidence, maybe another belt with 100% confidence. And I can also upload maybe a short, for example, saying you that this is a bottom wear with 97% confidence. Okay, all right. So that's pretty simple, pretty straightforward way to export the model, deploy it, and actually obtain a link that you can access from anywhere. And you can essentially use that link, you know, as in any application you want, if you want to develop any application. And please know that we have done all of that without writing a single line of code, which is super powerful. Okay. Let's go back to our slides here. So what you guys see in task number 5, we have been able to export, save, and deploy the model. And if you guys remember, we clicked on export, and then we have been able to upload the model. We obtained the link. We have been able to test our model performance as well. And then we tested here with a bunch of images of bag, images of a fragrance, images of as well eyewear. And that's pretty much all I have for today's task, and that simply concludes our project. The one remaining question that I have here is, well, you probably guys are asking, what is actually going on under the hood? Like, what do you mean by epoch? So for example, if you expand and click on advanced here, you should be able to see that there are tons of parameters in there. What do you mean by epoch? What do you mean by a batch size? What is a learning rate? And then what do you mean by a confusion matrix? What is the accuracy? All these details we are going to cover tomorrow in day number 2. So we're going to actually dig a little bit deeper, understand how AI models train, how AI models learn, and we're going to learn about all these technicalities in a brand new project tomorrow. But before we conclude today's project, now it's time for our final project. And please note that the final project right now is going to be in the intermediate level, and we're going to cover the final project in the next task. So that's all I have for task number 5. I hope you guys enjoyed it, and see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, let's go ahead and cover our final project. If you guys remember, in the previous task, we have been able to export, save, and deploy our model using Google Teachable Machines. We have been able to also assess the performance of our trained model by testing it using images that the model has never seen before during training. And if you guys remember as well, in tomorrow's project, in day number 2, we are going to look under the hood and understand what do you mean by epoch, what do you mean by batch size, learning rate, confusion matrices, and tons of technicalities that we're going to use throughout the entire course. Okay, so now is the fun time. I want you guys to simply take our project to the next level. So please note that this lecture is in the intermediate level because you guys need to experiment essentially and kind of stretch beyond your limits. So here we go. So what I want you guys to do is, instead of having 10 classes, 10 fashion classes, I want you guys to add 3 new classes to our project. Namely, we want to add socks, we want to add wallets, and we want to add scarves as well. Alright, so if you guys check out the course package, you should be able to see a folder here entitled Final Project. So if you open it up, you will see essentially that we have new fashion training and new fashion testing. If you open new fashion training, you will see 3 additional classes or categories. As I mentioned, we have wallets, we have socks, and we have scarves. If you open socks, you should see that here we have 100 images that belongs to the socks category. And that's essentially what I want you guys to do. I want you to retrain the model by adding 100 new images per class. And then I want you guys to do pretty much the same thing. Upload the model and then deploy it, and then test the model using the provided testing datasets. Okay? Alright. So that's all I have. Please go ahead, give it a shot, pause the video, and then I'm gonna see you guys after the final project is complete. Alright, hope you guys were able to figure out the final project. Let's go ahead and build it together. So what I'm gonna do is I'm gonna go here and I'm gonna go back to my model here. And instead of just keeping these 10 classes, well, I'm just going to add additional classes. I'm going to add class 11. I'm going to call it socks. And then I'm going to say upload. And then I'm going to go back to the socks. I'm going to say Control A. That will select all. You drag and drop. And that we're going to simply upload our 100 samples or 100 images. I'm going to add an additional class. I'm going to call it wallets. So we're going to come here, I'm going to add additional class. I'm going to call that wallets. And then I'm going to say upload. I'm going to say Control A, drag and drop. And here we go. So now I have 100 images that belongs to the wallets category. And then finally I have the scarves. I'm just going to come here, say scarves. And I'm going to say upload. I'm going to come here, say Control A, drag everything, put it here. And here we go. So now I was able to essentially extend beyond the 10 classes that we included initially to have 13 classes in total. To train the model, all what you need to do is to click on train model, and now the model right now is gonna start to be trained. And again, it will gonna take a couple of minutes for it to train, but afterwards you should be able to assess the performance of your train model after the 50 epochs are complete. And again, all the details about epochs and all of that we're gonna be covered tomorrow. And what I'm gonna do is I'm gonna pause the video and then I'm gonna be back once the training is complete. Alright, and here we go. Now the model right now has been trained, and what I'm gonna do is I'm gonna shift from webcam to file. Actually, I'm gonna disable that, turn it back on again, and then select on file. Okay, and then what I'm gonna do is I'm going to simply right now, after the model is trained, I can go ahead and essentially test or assess the performance of our trained model by dragging and dropping additional images in here. And if you guys go back, you should be able to see that we have our if you go back here, we have new fashion testing. If you click on it, you have a bunch of images that you can drag and drop and see if that model is still performing well or not. So what I'm gonna do is I'm gonna go ahead and I'm going to grab one of these images, maybe like this image for example. I'm gonna drag and drop it, and here we go. What you guys see here is the model was able to correctly classify the image that belongs to the socks category, which is true, and the confidence was 93% confidence, which is pretty good. Maybe let's test another image, again another socks, and again 93% still, another socks with 100% actually. And let's go ahead and maybe try that one, drag and drop, here we go. It's telling me that's wallet with 100%. Maybe grab that one, it's telling me it's wallet as well with 100%. And maybe let's try one of that, which is a scarf, and here we go. Now we have been able to classify that image that belongs to the scarves category with 92% confidence. Okay. All right, the next step is, as always, as we have done before, if you wanted to export the model, you can just click on export, and then same deal, you can say your cloud model has been updated since last upload. You can say update my cloud model. So now the model will be updated with the new model and with the new 13 essentially classes that I have right now instead of the 10 classes. Now it's telling me that your cloud model is up to date. If I just click copy, we're going to copy that, come back here and then paste it, and then I'm going to press enter. Here we go. And then I'm going to shift from webcam to file, and now I can go ahead and actually test it again after the model is deployed. Maybe grab that image here, and here we go. Now it's going to tell me that this is a wallet with 100% confidence. Okay. All right, so that's it. That's simply all I have for today's task, and that simply concludes our project. Let's recap what we have done so far. In this task 6, we have been able to essentially add 3 additional classes. We train the model, we have been able to test the model here, and we have been also able to export and deploy the model, and even assess the performance with more than one image of scarves and wallets and socks as well. Alright, okay, so that's all I have. I hope you guys enjoyed this task, and I hope you guys enjoyed today's project. Please note that tomorrow we're gonna start with a brand new project. We're gonna cover tons of details and technicalities about AI, machine learning, and key performance indicators as well. Please stay tuned, have some rest, and I'll see you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 2. I hope you guys had a great rest yesterday and you enjoyed the content of day number 1. So today we are going to dig a little bit deeper into the technicalities of AI in general, and we'll learn about what we call the AI lingo, like the key terminologies. So if you guys plan to work in this field in the future, or if you're going through, let's say, an interview, understanding these concepts, how we actually train AI models, how we test and assess AI models, what do we mean by all the different key performance indicators such as accuracy, precision, recall, all these different lingo we are gonna learn and master today. Okay, so let's go ahead and get started with task number 1. So we're gonna start with an overview of what we're going to do today. And please note that today is again considered as an easy topic, just an easy lecture. Let me remind you what we have done in the previous project in day number 1. In day number 1, we have been able, if you guys recall, to grab all these different images that belong to all these different fashion classes. We had 10 classes and we had 100 image per class. And then we actually went beyond the 10 classes to include 13 classes. And that was during the final project, if you guys recall. And then what we did afterwards is that we fed all these images to train the model here. So we just click on model training. And then after the model is trained, we have been able to test the performance of the model and assess its performance essentially by just dragging and dropping images here to generate predictions. And if you guys remember as well, we tested it with multiple images too. So we had an image of a wallet, and then we have been able to generate a wallet here. We also had a scarf as well. We uploaded that, and then we have been able to get a scarf with a confidence or accuracy of around 57% approximately here. Okay, and the question was, and that was the topic that we actually closed yesterday, which is, what do we actually mean by epoch? So if you guys click on the advanced feature here, you will see that there are tons of terminologies. What do you mean by epoch? What do we actually mean by a batch size, for example? What about learning rate? What do these actually stuff mean? And when you click on the under the hood, you will be able to see that there are tons of definitions here. There is what we call it confusion matrix. What do you mean by accuracy per class? What are these graphs? What do you mean by all of that? And that's the main objective for today. And today we're going to learn about all of that. And we're going to actually dig a little bit deeper into this box here. And I wanted to show you guys, what do we actually mean by artificial intelligence in general? What do you mean by an artificial neural network? What actually happened when we just click on train model, okay? So that's essentially what we're going to cover in today's project. And at the end of the project as well, we can have a final project where I'm going to ask you guys to tweak multiple parameters and actually understand the effect of all these parameters on the model performance. And that's all I have for task number 1. I hope you guys enjoyed it. In task number 2, let's go ahead and cover the key terminologies of AI in general, and we'll learn about artificial neural network in a simplified fashion. And please note that the upcoming lecture will gonna be mid-level difficulty. So please stay tuned. Best of luck. Get excited. Grab your favorite cup of coffee, and let's go ahead and get started with task number 2. Hello everyone, and welcome to task number 2. In this task, we are going to look under the hood and understand what's actually going on when it comes to AI in general and when it comes to what we call it artificial neural network. Please note that today's task is, I would say, quite intermediate when it comes to difficulty levels, but I will do my best to make it as easy as possible. And please note that today's project, we're gonna kind of build the foundation for us throughout the entire 10-day challenge. Okay, so if you guys remember in the previous task, we learned about the project outcome, and that was the project that we have done yesterday, if you guys recall. And the main objective is we wanted to actually explore what is going on here when it comes to the model training, and also we wanted to understand what do we mean by all these different terminologies. What is epochs? What is batch size? What is learning rate? What do these graphs mean? And what do we mean by confusion matrix, for example? Okay, so let's go ahead and get started. So the human brain has over 100 billion neurons. And these neurons are simply an information processing models that communicate with each other through electrical and chemical signals. And when these neurons communicate with each other, they essentially help humans and empower them to see, to think, and generate ideas as well. So basically, right now, when I'm teaching, for example, this course, my brain has a bunch of neurons, again, hundreds of billions of neurons. I think maybe half of them are gone by now because of all the math and all the equations that I have been consuming throughout my life. But overall, in my brain, all these neurons are communicating with each other, talking to each other, and they are empowering me right now to think, to generate ideas, to talk, and to actually see the screen right now. And human brain actually learns by creating connections between these billions of neurons. And what we're trying to do here when it comes to AI or artificial neural networks is we wanted to mimic what is actually going on in our human brain, but we wanted to do that mathematically. We want to do that in just a bunch of equations in a computer program that mimic what is going on inside our human brain, which is super amazing and pretty inspiring. So what we see in here on the left-hand side, that's the example of a biological neuron. So this is what the biological neuron, or again, human neuron, looks like. Here we have what we call it nucleus, outlined here in green. And here we have a bunch of branches. And these branches, we call them dendrites. Long story short, these branches or dendrites collect information from neighboring neurons. So there is a neighbor here, there's another neighbor here. And this nucleus just consumes all that information from neighboring neurons and then process information inside the nucleus and then generate an output to what we call it an axon here. And that's the model of a biological neuron. And what we do is we actually connect hundreds of billions of these neurons together. They keep talking, collect signal, process information, and send the output to the axon. So when it comes to artificial neurons, what we wanted to do, we said, you know what? Let's go ahead and mimic what is going on in our brain. And maybe we can, come up with something artificial. And if we connect many of these, artificial neurons, we will be able to create an artificial brain to make decisions similar to humans. I know it sounds a little bit simplistic, but that's essentially the core of artificial intelligence and artificial neural networks as well. So what we have here, this is the model of an artificial neuron. Simply, I'm going to do some sort of operation here, mathematical operation. I'm going to consume a bunch of inputs. We call them X1, X2, X3, similar to the dendrites, similar to what's actually going on in our biological neuron. And then I'm going to do something in that neuron and then generate an output. And by getting thousands of these, so maybe hundreds of thousands of these neurons, I can essentially achieve pretty much similar intelligence or narrow intelligence similar to humans, which is super powerful. Okay, so let's dig a little bit deeper into our artificial neuron. And as a disclaimer, we're going to be a little bit of math, so please hang in there. I'm going to keep it as simple as possible. Let's assume that right now I have 3 inputs. And these inputs, we call them X1, X2, and X3. And what I'm going to do is I'm going to create a little brain, okay, like just one simple artificial neuron. And this simple brain had 3 connections, 3 weights. We call them weight 1, weight 2, weight 3. And basically the model of the neuron is as follows. The output, Y, will be equals to, I'm going to simply multiply all the inputs, which is X1 times weight 1. So X1 times weight 1 plus, so here there is summation, so I'm going to sum up the second input, which is X2 times W2 plus X3 times W3. And then I'm going to sum up what we call it a bias or B, okay? So I'll end up with X1 times W1 plus X2 times W2 plus X3 times W3 plus the B or the bias. And that would be the output here. And then I'm going to apply a function, okay, and I'm going to show you guys an example coming up in the next slide. We call this function an activation function to generate an output y. And simply what I have here is a model of a single artificial neuron. Please note that right now I have 4 adjustable parameters. What do you mean by adjustable parameters? Basically, these are the parameters that I can actually tweak or change when I'm training or teaching the artificial neural networks. So what I have here is this weight 1, weight 2, weight 3, and the bias. All these are adjustable parameters. Essentially, I can take them and essentially tweak them to map the input to the output. Let me show you a practical example. Okay, let's assume that I have a bunch of numbers right now. I have 3 inputs, and these are the values of the inputs. I have value 1, and then number 3, and then number 4. And let's assume that I have an artificial neural network, or maybe like a single artificial neuron, and this neuron has been trained already, okay? So all the weights and the biases, all of that is just fixed right now. So now I have weight 1 is equal 0.7, weight 2 equals 0.1, and weight 3 equals to 0.3. And the B, or the bias here, is set to 0. Let's go ahead and substitute in this equation. So if I multiply 1 times 0.7, so which is x1 times w1, so 1 times 0.7, plus 3 times 0.1, so 3 times 0.1, plus the third input, which is 4 times 0.3, okay? And then I'm going to sum up all these values. That will be 2.2. So the value that I'm getting here is actually 2.2. And then I'm going to apply an activation function f, okay? And let's assume that this activation function is, let's say, a unit step. Looks like that. Basically, if the input to the function is negative, the output will be 0. If the input to the function is positive, the output will be 1, will be constant threshold, will be just 1 at all times. So basically, based on the values here of the weights, and based on these set of inputs, if you substitute here, you will end up with, because 2.2 is positive, well, the output will be 1. That means y here will be 1. So the question is, you might be asking, like, what is actually going on? Like, what's the point of all of this? Basically, what I have right now is I was able to create or have a decision-making ability. Basically, I have a little brain. Think of this as this is the brain right now, and this brain has been tweaked, has been trained with these fixed weights. And by changing the inputs, so if I take these inputs and change them, I can essentially generate in the output here either 0 or 1. Think of it as, well, I can essentially make a decision. I can say, based on, let's say, an image, for example, of, let's say, cancer cells, I can tell if, based on these images, if the patient has cancer or not, 0 or 1. I can say, for example, if I should buy a stock or sell a stock. I can create a decision. I can make a decision. I can classify, for example, fashion classes. I can do many things just by tweaking and training these parameters. Okay, so that's from a very high level, the idea of just a simple, basic artificial neuron. Please note that this is, again, the idea is I want to mimic what is actually going on here in our biological neuron. Okay? All right. So instead of just grabbing one single neuron, what I'm going to do is, well, I'm going to go ahead and just go crazy. I'm going to go ahead and build a multi-layer artificial neural network. And that's the overall idea. Each of these blue circles here indicates one of these. Okay? So essentially, I'm going to go ahead and connect thousands of these neurons together. I'm going to build like a little artificial brain. And all what I'm looking for when it comes to training or teaching of these artificial neural networks is, well, I want to know what these values of weights are. That's all what I'm looking for. So essentially, the entire problem has been translated into one simple thing. All I'm looking for is I wanted to know what are the optimal values of weights that can map the input to the output. That's all what I'm trying to do. And that's the overall idea of artificial neural networks. Is I'm going to grab a bunch of artificial neurons, connect them together, and I'm trying to, when I teach it, when I'm training it to learn, for example, how to classify, let's say, fashion images, I'm trying to tweak the values of weights. That's all what I'm trying to do. I want to change these values of weights, and that's it. That's the overall objective. Okay? All right. So now it's time for our reading time and for the quiz as well. So I want you guys to essentially go ahead, check out this link here. And this is a great article by Nisha Talagala. And essentially, it states that Google built a trillion parameter AI model and 7 things that you should know. I really like the article because it essentially explains what is actually going on in here. So basically, what Google built is all these weights, all these connections, and all these weights that are connecting all these neurons are actually in the scale of a trillion parameter, like a massive brain with massive number of parameters. And basically what people are saying, like there's a lot of articles out there, it's like Google is kind of building, super intelligence that can kind of take over humanity in a way. And I'm expecting that this article should take 10 minutes approximately, and then we're going to be followed by a quiz afterwards. So that's all I have for task number 2. I hope you guys enjoyed it. In task number 3, we're going to go ahead and show you guys what's actually going on under the hood when we train our AI models. Please stay tuned, give it a shot, best of luck on the quiz, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, we are going to dig a little bit deeper and go under the hood and try to understand how do we train and test artificial neural networks. If you guys remember, in the previous task, we learned about the fundamentals of artificial neural networks. We learned about the difference between the biological neuron and the artificial neuron. We also went through an example where I showed you guys the math behind a single artificial neuron. And we found that it's just a basic, simple equation that governs the input with the weights to generate a specific output. And we also went through a practical example where we have been able to essentially generate a decision, which is either 0 or 1, based on the values of the inputs and based on the values of the weights. And we learned that when we train artificial neural networks, essentially all what we're looking for is we're looking for the optimal values of weights. So when I say I'm teaching AI or training AI, all what I'm looking for, think of it as a huge optimization problem where I'm trying to find the best values of weights that can solve my problem. That's all it is. And if you guys recall as well, this was on the neuron level. Now I have a multi-layer perceptor network. So now I have, instead of having one single neuron, now I have multiple neurons, connect them all together in a feed-forward fashion. And essentially all what I'm looking for is try to optimize this matrix here. And this matrix, just again, optimization problem, trying to find the best values of weights. Okay. And we also went through a quiz. I hope you guys were able to figure that out. And now what I want to do is I wanted to show you guys in details how do we actually train and test artificial neural networks or AI in general. And please note that this lecture is categorized under the medium level difficulty. So let's go ahead and get started. So what we do in general when we train any AI model is we take the pool of the data, and then we generally divide them into 80% for training and 20% for testing. And please note that numbers may vary. So for example, you might go with, let's say, 75% for training and 25% for testing. And what you do is you use a training data set, which is the majority of the data set. You use them to train the model. When I say train the model, that means you are doing weights update. Essentially, you are trying to optimize that matrix here, which is this matrix of weights, trying to find the best values of weights that can map the input to the output. And then, once the model is trained, what we do is we freeze all the weights, and then we test the trained model on a new data set, just brand new data that the model has never seen before during training. And we call that testing data set. And that would be 20%, sometimes it ranges between, let's say, 15% to 30%, for example. And this is essentially a very important concept. Is we want to make sure when we train any AI model that the models are able to generalize and not memorize. Meaning, for example, if I, let's say, train a detector, let's say, to classify fashion images, I wanted to make sure that if I take the same AI model and I actually put it in practice, if I put it in the field, on new data sets, basically that the model has never seen before during training, I want the model to still perform. I don't want the model to just learn all the details of the training data and that's it. It basically fails to generalize. We don't want that. We want the model to work with the training data and on the testing data as well, which is a brand new data that the model has never seen before during training. And a quick metaphor here is just to clarify. Basically, if let's assume that you are a student and you are, let's say, studying a new topic like AI, for example, and you plan to sit for an exam at the end. As a professor, for example, what we do is we give you guys assignments. So you give you assignments, you understand the concepts and so on. And then on the exam, we don't give you the exact same assignments. It doesn't make sense to give you the exact same questions with the exact same numbers. Because if I do that, that means, someone can go ahead without actually understanding the concept, without actually studying the material. They can just go ahead right there and just essentially memorize the information. But that's not what we're looking for. We want to make sure that the concepts have been understood by the students, and it's pretty much the same idea here when it comes to training of AI models. Okay, so let's go ahead and cover the training process. And please note that what we're going to do right now is a type of training known as supervised machine learning. Okay, so we are doing the training right now in a supervised fashion. Okay, so let's assume that I built my artificial neural network. And let's assume that the values of weights here, these are randomly generated. Basically, it's like a brain, but that brain did not learn anything at all. We don't know anything at all. And now I wanted to teach that brain to essentially classify images of dogs. So if I give it an image like this, which is an image of a dog, and I'm going to use a label, or what we call a desired output, and I'm going to call it dog. So essentially, I'm going to grab that brain, think of it as a little kid. He doesn't know anything yet. And I'm teaching that kid how to walk. So I'm showing the kid essentially the inputs and the output. I'm showing him the right way to do things. And that's the same deal here. I'm going to show the network an image of a dog and the desired label. Basically, I'm saying, okay, when you see that image, when you see that dog, that means it's a dog. That means the desired label or the target output is a dog. And because this brain right now is still didn't learn anything, okay, what's going to happen is the brain initially is going to tell me, well, the predicted output is a cat. So the Y estimate or Y hat is a cat or anything else. Because again, it didn't know what dog is initially because again, it's still brand new. So what we do in order to train artificial neural networks, we essentially calculate the error or the difference between the predictions, between what the model predicted, which is let's say a cat, and what we really want, and this is a dog, right? And we calculate the error signal. If the model predictions matches what we want, that's a great thing. That means the error is 0 and we don't need to do anything at all, no update. However, most of the time, especially in the beginning, we actually have an error value. So we take the error and then we go back and then we run some sort of an optimizer to try to optimize the values of the weights within my artificial neural networks. And that's the overall idea of AI model training in a supervised fashion. We have input, we have output, and then we calculate the error. We take the error, go back and update the weights in an iterative fashion. And similar to humans, we as humans, we don't learn in general in one shot. It actually takes us a very long time to learn. And we learn through trial and error. We learn through experience. And that's the same idea here. So when it comes to AI training, we train over a series of what we call it epochs. Epochs, these are multiple iterations of time where we go show the data, the inputs and output to the model, update the weights, and then we want to get better. And we do that over and over again. And that's essentially what I'm doing here. At the beginning, at epoch 1, we have a very large error. And then over time, the error goes down. And then one more time, error goes down. And we keep doing that over and over again until we reach a state where the error is reduced dramatically. And that's a great thing. I'm going to stop the training. And that's essentially how you train AI models in a nutshell. And please note that in the next lecture, I'm going to show you guys the details of what do you mean by an epoch and the actual definition. Especially, I'm going to link it back to Google Teachable Machines. Okay, so let me summarize. So what we have done so far is I'm going to show you guys the difference between the training process and the testing process. So in step number 1, we're going to do the training. We are going to use the training data. So now I have inputs, I have outputs. We generally call the inputs X and the output Y. The model initially doesn't know anything at all. It's just brand new. So the model will generate predictions, and these were going to be Y hat. I'm going to calculate the error, which is a difference between what the model predicted and what actually happened in real life. We'll take the error, go back, and update the weights. And we keep repeating that loop over and over again until the model is trained. And this is very important. Once the model is trained, once I have that, then I'm going to take all the network weights. I'm going to freeze all these weights. And then I'm going to go ahead and test the intelligence or test the network using a brand new data that the model has never seen before during training. And please know this is very important. Once we take the brain here, this brain has already been frozen, meaning all these weights here, all these connections have been optimized. They are good to go. They are frozen. Now I can go ahead and essentially test them or assess their performance. And please know that right now intelligence has been captured, meaning right now all these weights are captured. It's all good. Now I can take the testing data, feed it into the model, and then generate predictions. And that's the testing phase. And that's essentially the difference between the training process and the testing process. And that's it. That's all I have for task number 3. I hope you guys enjoyed it. In task number 4, let's go ahead, shift back to our Google Teachable Machines, and then understand the AI lingo behind it. We're going to learn about what's the difference between learning rate, epochs, and so on. And that's it. That's all I have. I hope you guys enjoyed this lecture, and see you in the next lecture. Hello everyone, and welcome to task number 4. In this task, we are going to cover key AI terminologies or lingo, and we're going to explore what is actually going on under the hood as well. If you guys remember, in the previous task, we learned about the difference between model training and testing. We covered the process of training an AI model, and we also covered the process of testing here. If you guys remember, after we freeze the weights and we test the performance of the model on a new data set that the model has never seen before during that phase, which is a training phase. Okay, so today's task is going to be in the intermediate level. So I'll try to make it as easy as possible. So let's go ahead and cover the first definition. So the first definition is known as epochs. And if you guys recall, if you click on under the hood, you will see that we have a parameter known as epoch, and it's by default set to 50. Basically, AI, similar to humans, learn through experience, learn through multiple iterations. We as humans, we don't learn in one shot. We learn over time, and that's why we call it practice makes perfect. So similar to humans, AI learns over time, and its intelligence kind of amplifies as we continuously feed the training data to it. So the question is, what is an epoch? An epoch means that AI has been fed with the entire data set just once. So let's say if we are training an AI model from scratch, most of the time, because we are exposing that data to the AI model for the first time, most of the time we start with a very large error initially. And then over time we get better. Over time we start to kind of learn from our past expertise, and then we get better over time. And that's why in general, over time at epoch 1, you will find that the mean squared error, for example, as a metric, tend to go down. And then in epoch 2, the errors tend to go down as well. Epoch 3 goes down as well. And over time, you will find that the mean squared error keep going down and down and down until we actually stop. And that means the model right now has been trained and is good to be deployed in the field and to actually be exposed to a new data set that it has never seen before during the training phase. Okay. So let's go ahead and cover the definition here by Google Teachable Machines. So one epoch means that each and every sample in the training dataset has been fed through the training model at least once. So for example, in our case, let's say in the fashion class, we had, in the original dataset, we had 10 classes and we had 100 images per class, meaning in total I had 1,000 images. So if I feed in the 1,000 images, the entire data set, and I update the weights of the AI model once, that's a good thing. That means now this is an epoch. So if you feed the entire data set once, that's an epoch. So for example, if I have, let's say, 50 epochs, that means the model will be exposed to the same data set 50 times. It's like, you know, like getting the AI model and feeding in the data. Please learn that data, learn that data, learn that data. And we're doing it like over and over again. And that's why it gets better over time. And we do it here. Let's say if we set the epoch to 50, that means we're going to repeat that 50 times. And most of the time, if we increase the number of epochs, you will find that you come up with better predictions over time. But at some point beyond, let's say, a certain number, of course, depending on the complexity of the data, depending on the architecture of the model, you might need not to go, you know, to train it for, let's say, 2,000 epochs. And that's why there's a lot of, I would say, human judgment that has to come into play to get an idea of what would be the best number. Google Teachable Machine set the default value to 50 here, okay? All right, so that covers the first definition. The second definition is known as the batch size. So when AI is trained, we generally don't feed the entire data set to the model in just one shot. And the reason behind it is we might have computation limitation. We might have memory limitation. And that's why, let's say if we have, for example, 1,000 images, we don't feed the entire 1,000 images at once. We break them down into groups or batches. And that's what we're doing here. So we generally break down the entire data into smaller batches, which are fed to the model individually. And essentially one epoch contains one or more batches. So if you zoom in here, a batch is a set of samples used in one iteration of training. So for example, if let's assume that I have, let's say, 80 images, for example, and if you choose the batch size to be equals to 16, that means I'm going to take the entire 80 images and I'm going to divide by the batch size, which is 16. I will end up with 5 batches, meaning I'm going to feed in the data to the model in batches, and then we're going to have 5 of those. Once all 5 batches have been fed through the model, exactly one epoch will be complete. Okay? All right. So that simply concludes the second definition. The third definition, which is one of the most important one, is known as the learning rate. And learning rate simply represents the size of the steps taken, which indicates how aggressive you would like to train the AI model. And think of it this way. Let's assume that you are a teacher and you have, let's say, a little, for example, kid, and you're teaching that kid, for example, how to walk. Well, you have 2 strategies. Either to teach that kid slowly, okay? When I say slowly, that means you are setting the learning rate to be very, very small. Or you can just go crazy. You can just set the learning rate to be very, very high and kind of push the boundaries for that kid to actually learn how to walk in a much, much faster way. And that's pretty much the same idea here. If I increase the learning rate, that means I become really aggressive, meaning I'm going to be training the AI model at a much faster rate. I'm going to be updating the weights a lot more aggressively. And if I set the learning rate to be very, very small, then it's like, I'm taking it easy. I'm going to take my time to train the AI model. And that's why if you set the learning rate to be very small value, then it will take much, much longer time for the AI model to converge. However, if you set the learning rate to be so high, you're gonna go crazy, right? So you're gonna be forcing the AI model to converge a lot quicker. And the problem is you might reach what we call it, you'll be essentially overshooting the point that you're looking for. So for example, what we call it global minimum point, I'm not going to be able to reach it. I'm going to be like shattering across that global minimum. And that's why adjusting the learning rate is an art on its own. And you need to come up with the optimal point, not too small, not too hot, not too large. And that's the overall idea in here, okay? So if the learning rate increases, the area covered in the search space will increase. So we might reach the goal, which is our global minimum, much, much faster. However, we can overshoot the target. So if you guys see here, this is essentially what we call it the error surface. And most of the time, what we're trying to do is that we're trying to find the point that minimizes the error. Like I need to get the minimum error. If you guys remember when we compare the predictions from the network to the ground truth, to the actual training data, and we calculate the error signal, all what we're looking for is that we're looking for the point where we minimize the error as much as we can. We want to find the minimum error. And that's the overall idea here as well. So if we grab the error surface, this is essentially the point that I'm looking for. That's what I want. And that's why if you increase the learning rate, that means you'll be moving here a lot faster. So you might achieve that point that you're looking for faster. But the only problem is that you will overshoot that target. However, if you set the learning rate to be very small, then training will take a much longer time for it to reach that point, but you are not going to be overshooting that target. Okay? All right. So that simply concludes our learning rate. And then the last definition that I wanted to cover for you guys is accuracy and loss. So if you actually click on under the hood, you guys will see that here on the right hand side, you will see graphs, and these graphs indicates the actual progress of our data, of our training over the number of epochs. So for example, here I have the accuracy. So initially, the accuracy wasn't too high, it was like 0.8, and then over time it starts to become better and better. Now it becomes like 0.9, and so on, until it reaches almost 100%. Same deal as well for the loss. When I say loss, think of it as more of an error. So the error starts very high initially, and then over time, you guys will see that the error tends to go down. And please note that here I have essentially two types of accuracies and two types of losses too. One for the training set and one for the testing set. And what you guys see here is on the accuracy on the training data tend to be way better compared to the testing data, which makes sense because in general, the testing data has never been seen by the model during training. And same deal as well for the loss. You guys will see that the loss or the error on the training data, which is my blue line here, tend to be less or smaller compared to the test loss or the error on the testing data set. Okay? All right. So that's it. That's simply all I have for task number 4. I hope you guys enjoyed it. In task number 5, let's go ahead and cover a very important definition, which is known as confusion matrix. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, let's go ahead and cover what we call it confusion matrix. Please note that this lecture is categorized under the mid-level difficulty. So I'm going to do my best to make it as easy as possible. If you guys remember in the previous task, we learned about key AI ML terminologies. We learned about the definition of an epoch. We learned about batch size. We learned about learning rate. And we also learned about the accuracy and loss curves as well. So if you guys went a little bit further and explored what's going on under the hood in Google Teachable Machines, you guys will be able to see something called confusion matrix. And it's from its name, it kind of sounds a little bit funny, but it actually makes complete sense. Basically, it's a matrix that can show you how the model is confused. And that's why we call it confusion matrix. Basically, what we do when we plot this matrix, we plot the ground truth. So we put what was actually true in real life, which means this is the actual true data coming from the training or the testing data. And then we plot versus, on the matrix, we plot as well the model predictions. So basically, we plot what the model think the right thing is versus what is actually happening in real life, what was actually true. So we can get an idea of how messed up my model is or how accurate my model is. So let me show you guys how we plot the confusion matrix. And in order to demo that, I'm going to assume that I have an AI model that I have trained to classify cancer patients. So basically, all I have right now is I have one of two scenarios. Either the patient has cancer or not. So if the patient has cancer, that means he has been classified as positive. That means he has cancer. And if it's negative, that means the patient does not have cancer. And just for the sake of simplicity, I'm going to assume again that these are the only two scenarios that I have. So what we do to plot the confusion matrix is as follows. What we do is we plot on the horizontal here, we plot the predictions. These are what the model think it is, okay? On the columns here, we plot the true class, meaning we put what was actually true in real life. And this is again is coming from my labeled data set. So let's go ahead and pick a couple of scenarios. If the model predicted positive, if the model predicted that the patient has cancer, and in real life, that matches what is actually going on in reality, which is that means that patient in real life had cancer, we call these true positives. And that's a good thing. That means the model predictions matched what actually happened in real life. Okay, that's the first scenario. So what we do is we put here the overall number of samples that have been correctly classified as true positives. And that's why we list them here, and we put them here as well, highlighted in green, because essentially these are the samples that have been correctly classified, and that's a good thing. The second scenario is, well, if the model predicted negative, meaning if the model said that the patient does not have cancer, and in real life the patient did not have cancer as well, we call these true negatives, and we put the overall number in here. Okay, so basically what we do again, just to summarize, in the diagonal elements here, that's when we got the classification right. When we got the classification right, we put them here in the diagonal. Now to the troubles, now to the issues, okay? So now, if the model predicted positive, however, in real life, the actual true class was actually negative, we call these false positives. Let's pick a scenario again. Here, the patient in real life, that's again the true class, was healthy. He didn't have any cancer at all. However, the model predicted that the patient has cancer. Basically, we call these false positives because it was the model predicted positive, but it was actually false. It wasn't actually true. It wasn't actually correct. We scared off our patient, and that's of course a terrible thing. Okay, the second point is, well, if the model predicted negative, however, in real life the true class was actually positive, we call these false negatives. And these, again, that's another level of problems, another level of issues. Let's pick an example. Basically, in this scenario here, we assume that the model predicted negative, meaning the patient in real life, the true class was positive. Meaning in real life, the patient in reality has cancer. He was sick, he had cancer. However, the model said, you know what, he's fine, it's negative, he doesn't have any cancer, no disease, and that's why we call these false negatives. And we actually highlight those in red here. Why? Because this is a massive issue. Why? Because we actually haven't detected a disease in a patient, and in this specific scenario, the patient, condition might get worse over time, and of course that's terrible. We missed the detection essentially. But what we have done here is we detected that that's positive, so we said the patient has cancer. However, in real life, he was healthy. Still a problem, but we call this type 1 error, and we call this false negatives type 2 error. Okay? Alright. So let's go ahead and summarize the terminologies for confusion matrix. So a confusion matrix is used to describe the performance of a classifier model. And we put the true positives, or TP. These are cases when the classifier predicted true, meaning the classifier said the patient has a disease, and the correct class was actually true. That means in real life the patient has disease. We have true negatives, or TN, and that's when the cases when the model predicted false, when the model said, well, the patient does not have a disease, and the correct class was false, meaning the patient did not have a disease as well in real life. So these are what we call it true negatives. And these are the good stuff, and we put these stuff in the diagonal element. Now to the troubles. The false positives, or type 1 error, that's when the classifier predicted true, but the correct class was actually false, meaning the patient did not have a disease. And then we have false negatives, or FN, or what we call it type 2 error. That's when the classifier predicted false, meaning the patient do not have a disease, but they actually do have the disease in real life. And that's why we call it false negatives. The next KPI, or key performance indicator, that we can get or extract out of our confusion matrix is what we call the accuracy, or classification accuracy. Basically what we do here is we say, okay, how many times was my classifier right? Well, we sum up the stuff that the classifier got it right, which is the true positives plus true negatives, and then we divide by the overall number of samples. And that will kind of give us the accuracy, how accurate was my model. Okay? Alright. And then the second KPI, or key performance indicator, is known as misclassification rate, or error rate. And that's essentially what is the percentage of the predictions where the model messes up, where the model just doesn't get it right. So what we do here is we sum up the false positives plus the false negatives, and then we divide by the overall number of samples. So classification accuracy is used to get to give me an indication of how many times I got it right, and misclassification rate, or error rate, tells me how many times I messed up, basically. Okay? Alright. So let's go ahead and explore our confusion matrix for our fashion classification project, if you guys recall. Basically what I have here is essentially these are all the different classes. I have bags, belts, bottom wear, cufflinks, and so on. Here I have the same deal, bags, belt, bottom wear, and so on. Whenever the model class matches the prediction, and please note that what I have here is it varies depending on the tool. So what I have here with Google Teachable Machines is that they put the predictions here in the columns, and they put the true class in here in the rows, which is essentially opposite of what I've described here, but it's okay. Like it depends on the tool. It depends on for demonstration purposes. Okay, so what I have here is whenever the class matches a prediction, that's a good thing. So we put the overall number of samples in here. That means right now the model has got 13 samples of the bag correct. Here they got 15 samples of the belt correct. The bottom wear 13 samples, and so on. Anything that is off that diagonal element, so for example here I have 2 samples, these have been misclassified. Here I have 2 samples misclassified, 2 samples misclassified, and so on. And when I take a look at the table, I should be able to see the accuracy per class. So I can see that the bag, for example, I got 0.87. For the belt, we got them all 100%. For the bottom wear, we got 87. Cufflinks, 93, and so on. Okay, all right. So that's simply all I have for task number 5. I hope you guys enjoyed it. In task number 6, now it's a fun time. We're gonna go ahead and cover the final project part A. And then in task number 7, I'm gonna provide you with a brand new data set. and I'm going to ask you guys to go ahead, train an AI model within Google Teachable Machines from scratch, and of course explore all our key performance indicators, plot the confusion matrix, loss, and also visualize as well the accuracy and the misclassification rate or the error rate as well. So that's all I have. I hope you guys enjoyed this task and see you in the next task. Hello everyone and welcome to task number 6. In this task, we are going to cover our final project part A. So let's go ahead and get started. Please note that this project, I would say, is in the intermediate level difficulty. So it's not that hard, gonna be tons of fun. Let's go ahead and get started. If you guys remember in the previous task, we have been able to understand the confusion matrix. We learned about the true positives, true negatives, false positives, false negatives. We also learned about type 1 error, type 2 error. We also learned about 2 key performance indicators or KPIs, such as classification accuracy and error rate or misclassification rate. We also have been able to visualize our confusion matrix. And now, what I want you guys to do is, using the new model that contains our 13 different classes, I want you guys to experiment with changing different number of epochs and maybe try different batch size and maybe learning rate. I want you guys every time to retrain the model and plot the confusion matrix, loss curve, and accuracy per class. And then I want you guys to tell me which model actually provide the best performance of all. And I want you guys also to kind of, as a stretch assignment, to increase the learning rate like really high and tell me what do you notice and why, like explain your answer, like why are we getting these kind of results when we set the learning rate to be too high. So that's all I have. Please go ahead, give it a shot, try all these different, I would say, iterations or combinations, and pause the video, and then I'm gonna see you guys after the project is complete. Alright, hope you guys were able to figure out the final project. Let's go ahead and show you guys here the different iterations. So basically what I got right now is I'm gonna have here all the different, I'm gonna upload all the images, so we have done that already. And please know that right now we have all the 13 different classes. And if you guys remember, if you go under advanced, you can go ahead and change here the values, right? So the default is I have 50 epochs, I have batch size of 16, and then I have a learning rate of 0.001. These are the default values. And if you go ahead and you click on train model, these are the kind of results you're gonna get. So I took snapshots of it. So it looks like the model actually did pretty okay, pretty well over the entire samples. There are a couple of misclassified samples. There's like 2, there's 4, 5, there is 6 here, there is 7, 8, 9, 10, 11, around 11 samples that have been misclassified approximately. And you guys will see that the accuracy curve looks pretty good, and here the loss looks like the model is a little bit overfitting the training data, meaning the model is doing really well on the training data, however it's doing quite poorly on the testing data set. Okay, the second iteration that I tried here, and again, please guys, just feel free to train the model whatever you want, really. So what I'm going to do here is I'm going to set the number of epochs to 100. So here, I'm just going to tweak the number of epochs only. So what we have done here is we left the default values, which is 50. Now I'm going to set it to 100. So I can go back here, and if you guys want to change it, of course you can come here, change it to 100, and then say train model. And that, of course, is going to take some time for it to train, because right now we actually have 100 iterations. So we're going to feed in the training data 100 times and update the weights 100 times. And here we go, the model right now is being trained, and just to fast forward, basically these are the results, what you guys should expect. And what you guys see here is that we tweaked the number of epochs to 100, and it looks like the performance of the model did not actually improve that much. It looks like it stabilized pretty much around, let's say, epoch 40, for example, and it's pretty much stable afterwards. So you guys will see that the performance here did not improve that much. We still have, I would say, around 11 samples that have been misclassified in total, and that should simply explain the first tweaking or first iteration. And here we go. The model right now is being trained. Now this is epoch 1 over 100, 2 over 100, and so on. And what I'm going to do is I'm going to go ahead, pause the video, and then I'm going to be back once the model is trained. Alright, so now the model has been trained, and now we finished the 100 epochs. If you guys click on under the hood, you should be able to see all the different results in here. So for example, what you guys see here, actually the more that we let the model train for, actually it looks like the performance actually dropped a little bit. It's like the loss or the error over the testing data set tends to increase, in fact. And if you go ahead and click on confusion matrix, this is simply the confusion matrix here. And what you guys see is, again, it looks like if you sum up all the number of samples that have been misclassified, let me move that a little bit away. And if you count them, basically you'll find that here I have one sample, 1, 2, 3, 4, 5, right? And then I have 6 and 7. And then here I have 8, I have 9, 10, 11, and 12, 13. So it looks like I actually have more samples that have been misclassified compared to the default parameters. So the conclusion out of this is, yes, increasing the number of epochs might improve the performance of the model, but it's not a necessity. It's not like guaranteed. You might not need to go to 100 epochs, and maybe 50 epochs might be good enough. And again, a lot of tweaking and a lot of personal judgment as well. Okay. The third parameter that I tried here is decided to change or tweak the learning rate. So for example, I tweaked the learning rate. Instead of setting it to 0.001, here I set it to 0.01. And I'm not going to retrain the model. I'm just going to show you guys what I got here from a result standpoint. What you guys see here is the model actually started out pretty good, and then afterwards at the end it just went like crazy. And the idea here is that because we increase the learning rate, if you guys remember, that actually could allow us or help us to achieve the global minimum much faster, at a much faster rate, but we might actually overshoot the target, and that's what is happening here. After we actually achieved maybe a sweet spot and we achieved the decent accuracy, because the learning rate is high, basically you are overshooting the good point. You are already there, but because you are aggressively changing the values of the weights and the parameters, that's why you will see that the model performance deteriorated afterwards. And again, if you count here the number of samples, you will see that here we misclassified 6 samples. Here there is 8, and then 9, and then 12, and then in 4 it's 16, and then 18, 19, 20, 21 samples that have been misclassified, a lot worse compared to the previous values. Okay, what if you change, let's say, the batch size? What you found here, if you change the batch size to 64, and please note that in every single iteration here, I'm only changing one parameter only, okay? So I'm keeping everything else the same as default. So the learning rate, I didn't change it. Epochs, I didn't change it. I only changed the batch size to be 64. And here we go. What you guys see here is I have 2 and 1, 3, 4, 5, 6, and then I have 7, 8, 9, only 9 samples that have been misclassified, and that's actually pretty good. It's very comparable to the default values, or even better, I believe, by 1 sample or 2 compared to the default values. And of course, you guys can go ahead and change the batch size maybe to a little bit more. Here I just set it to 64. And then what I did here is I decided, you know what, let's go crazy. Let's go and change the learning rate maybe to 0.5, like really, really large value. And what you guys see here, something interesting happened, and that simply answers the last question here. Experiment with increasing the learning rate and setting it to an extremely high value. Basically what you guys get here is the model performance is actually really terrible. Actually, we did not even train the model. Why? Because right now you are essentially being extremely aggressive and you can't get anywhere. You can't achieve the global minimum point. You're just aggressively changing the weights like really hard, setting the learning rate to be very, very high. And that's why you're getting really terrible values, and you didn't even get a single point right, basically. Except for the scarves class, except for the last class here. But otherwise, you got accuracy of 0 along the way. Okay, what if I maybe change, let's say, the batch size and maybe change it to a very large value, to let's say 512. You will find that the model performance actually doing still pretty okay, pretty good. And if you count the number of samples that have been misclassified, here I have 1, 2, 3, 4, 5, 6, 7, and then I have 8, 9, 10, 11. It's a little bit worse compared to the default values, or compared to this here, where we had only 9 samples that have been misclassified. But overall, it did not have a dramatic change on the performance, similar to the learning rate. And the final value here, I set the epochs to be 500, like really large value. And what you guys see here, it did not actually improve the performance of the model. It actually increased the loss in a way here. And if you count the number of samples that have been misclassified, here I have 3, 4, 5, 6, 7, and then I have 8, and then I have 9, 10. So now I have, again, it's pretty much comparable, which means that I don't actually really need to go to a large number of epochs like this one here. But again, it's a lot of trial and error and a lot of experience that comes into play. Okay, all right. So that's all I have for the final project part A and task number 6. I hope you guys enjoyed it. In task number 7, I have another final project for you guys, and that should simply gonna conclude our day number 2 challenge. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. In this task, we are going to cover the final project part B. If you guys remember, in the previous task, in task number 6, we had been able to cover the final project part A, and we learned how to tweak the model hyperparameters, how, for example, tweaking the learning rate should dramatically improve or deteriorate the model performance, and I hope you guys were able to experiment with as many parameters as possible. Now, before we conclude today's activity, I want you guys to essentially experiment with a new data set and apply all the learnings that you guys have acquired today and yesterday as well to a brand new data set. So let's go ahead and get started. So using the sign language data set, I want you guys to select any 5 numbers or letters and train a Google Teachable Machine model to perform classification. You guys can choose any number of images you want, but just as a rule of thumb here, or maybe a guidance point, choose 100 images per class. And then afterwards, I want you guys to assess trained model performance by exploring the confusion matrix, accuracy, and loss. And then I want you guys to test the trained model using new images that the model has never seen before during training. And then finally, I want you guys to export the model and deploy it in the field as well. So the question is, what is the data? So if you guys go to the course package, you will see under day 2, you will see that here we have the final project sign language dataset. If you open it, you will find that here, another folder, open it. And basically what I got here is every single number, so numbers from 0 up until 9, and all the different letters from A up until Z. And if you open, let's say, letter A, for example, what you guys see here is I have, these are the sign language that represents the letter A. So what you guys see here is, it's actually pretty interesting to me, to be honest, to see, like, you know, this is letter A. And if you check out, let's say, letter N, for example, this is letter N. And let's say, grab, let's say, number 2, for example, that's what number 2 look like in the sign language. And then if you go back and maybe grab maybe another one, let's say letter V, so that's V, okay? And this is essentially it. So I provided you guys with the data set for every single letter that we have and every single number as well. But I don't want you guys to go ahead and train the whole thing because it will take you a very long time. I just want you guys to experiment only with, just select 5 of those, maybe like 2 numbers and 3 letters, or maybe 1 number, 4 letters, and so on, and then choose 100 images each and just go ahead and train the model. So that's it. Please go ahead, give it a shot, pause the video, and I'll see you guys after the final project is complete. Alright, hope you guys were able to figure out the final project. So let's go ahead and build it together. So what I'm gonna do is I'm gonna go here, I'm gonna say create a new project. So I'm gonna say new project, and then I'm going to say create a new image project, and then go ahead and upload the data set. So what I'm going to do is, let's say I'm going to pick, for example, the V letter. So that would be the V letter. And I'm just going to go back here to the images that belong to the V letter. And I'm going to go ahead and grab only 100 images. So I'm just going to grab 100 images. So Shift and click on the mouse, or Control A, that will select the whole images. And you can just drag them and drop them basically. But before we do that, I just want to click upload first, and then you can essentially drag and drop. And what you guys see here is that 100 images have been uploaded of the V class. Same deal, I'm just going to go back and I'm going to grab maybe, let's say, letter A, for example. And then same deal, I'm just going to go grab 100 of those. So I'm going to grab 100, and then go here. And then that will be letter A. And then I'm going to say upload, and then I'm going to drag and drop. Here we go, now I have 100 images that belong to the A letter. Let's go ahead and grab maybe a number. So I'm going to grab, let's say, number 3, for example. Or maybe, let's say grab number 5, for instance. So that's number 5. So I'm going to grab 1 up until 100. And then I'm going to go here, add a class, and then I'm going to call that number 5. Click upload, drag and drop, and that will be number 5 uploaded. Next, I'm going to grab another letter, maybe letter W, for example. Or maybe I can grab, let's say, letter R. So that's R. So I'm going to go here, select R, and then click upload, and then grab 1 till 100. Drag and drop. Here we go. So now I got the letter R. And then finally, I was just going to grab maybe Y, for example. So now I have, this is the Y here. Okay. And then I'm going to go ahead, say add class, and then say Y, and then click upload, and then drag and drop 100 images of the Y class. So I'm going to say 1 up until 100, and then drag and drop. And that's it. So now I have been able to select one number and 4 different characters. I can just go ahead and say train model, and now the model will be essentially trained. And I'm gonna essentially stick with the default parameters or default values. So epochs will be 50, and the batch size, I believe, was 16. And it will take some time for it to train, but once the model is trained, what I'm gonna do is I'm gonna go ahead and essentially use any other image beyond the number 100. For example, I can grab, let's say, image number 268, for example. This image the model has never seen before during training. And let's see if that model actually worked or not. And right now the model is being trained, which looks pretty good. And if you click on advanced, you guys will see that we set the number of epochs to be 50. The batch size was set at 16, and the learning rate is set at 0.001, and these are all the default values or default parameters. We're almost there. Alright, and here we go. What you guys see here is the model has been trained. If you check out what's actually going on under the hood, you will see that the model actually did really well. Like, it's almost like at 100% accuracy. If you check out the confusion matrix, every single sample have been correctly classified, and the accuracy is almost 100 over all of them, which is pretty great. And of course, why? Because again, these images are very distinct. You guys see even the colors as well, and the lighting as well are very different. So it's the model was able to easily being trained on all these different classes and classify them all. So what I'm going to do is maybe I'm going to grab a new image. Let's say this image, for example. Okay, this image has never been seen by the model during the training phase. So if I drag and drop, what you guys see here, it has been classified as the Y character or Y letter, and that's essentially belongs to the Y letter here as well. And maybe let's try, for example, the letter A. So I'm going to go up, go to the A directory, grab brand new image, which is, let's say, this one here, drag and drop, and here we go. It has been classified as A with 100% confidence. Okay, all right. The last piece is if I would like to export the model, I can just simply click on export model. And if you guys remember, I can say upload my model. It will take some time for it to run, but once it's uploaded, then it can show here in green, indicating that the model has been uploaded, and now I can essentially use or copy that link. So if you say Control V, you will essentially paste the link in here, And now we should be able to go ahead and actually test the model right now in the field, in practice. You can again grab any image, for example 2 to 4 here, and then you can end up with a prediction right away. And of course you can take that model and deploy it in any application. And that's simply all I have for the project, for the final project part B. And I included a summary for you guys here, and as well the source of the data set, which is available on Kaggle. And that's it. That's all I have for task number 7, and that simply concludes our today's activity. I hope you guys enjoyed today's activity and found it interesting, exciting, and fun. Please take some rest, have a good sleep, and I'll see you guys tomorrow with a brand new challenge and a brand new project. See you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 3. Today we will learn how to collect our own live training data, and we are going to learn how to build, train, test, and deploy an AI ML model to detect facial masks. So in the age of the coronavirus pandemic and COVID-19, wearing a mask could dramatically save lives, and it can limit the spread of the virus. So what we're going to do today is we are going to use Google Teachable Machines to essentially collect our own training data. And I'm going to show you guys how to collect your own live training data. And we're going to build an AI model to essentially detect if a facial mask has been worn properly or not. And we're going to also learn about various classification models, key performance indicators. So we'll learn about different metrics such as precision, recall, and we'll also learn how to deploy the model. So it's going to be tons of fun. Let's go ahead and get started. So in task number 1, we are going to cover the project card and demo. And this is essentially the theme that we have been following along throughout the entire course. Is for task 1, I'm going to show you guys essentially what we are going to build. So I'm going to show you a demo of the project. And please note that today's activity is quite easy. So it's very easy on the scale here. And let's go ahead and get started. So the goal first is to build, train, test, and deploy an artificial intelligence model to detect face masks. And the tool we're going to be Google Teachable Machines. From a practical real-world application, this project can be effectively used in indoor spaces to automatically detect if people are wearing masks or not. And what we're going to do as well is we're going to also learn, kind of train AI models to essentially tell me if even if someone is wearing a mask, are they wearing that mask properly or not? So we have to make sure that the mask, for example, is covering their nose and covering their mouth. So we'll also be able to teach the AI how to do that as well. So when it comes to the input data we're going to be facial images. We're going to also learn how to record our live data using our webcam. And the output is going to be the mask detection status. So essentially, you're going to tell me if that mask is worn properly or not. So let me show you guys a quick demo of what we're going to build today. So what you guys see here is I'm going to head back to our Google Teachable Machines. Here we go. And hi everyone. So right now I have my webcam open, and essentially what I'm going to do here is I have 4 different classes. So let me zoom out. So what you guys see here is I have the first class, which is no mask detected. That's when the mask is not worn at all. The second class is going to be when there is no mask detected, basically, but essentially the mask, I'm wearing the mask, but it's not covering my nose or the mouth. The third class is going to be the mask is worn as well, but it's only covering the mouth and it's not covering my nose, so nose not covered. And then the final one is if the mask is worn properly and everything looks good, then the mask will be detected. And that will be the only case where essentially the AI model is going to flag us, going to tell us, well, that's true, that's correct. You can easily access, for example, the facility. Otherwise, all of that means there's an issue and you need to take an action to fix it. Okay, so what you guys see here is right now the AI model is essentially function. What you guys see here is right now it's detecting that on my face, because I have the camera on, I'm not wearing any mask. And that's why the class here is no mask detected at all. And it's the confidence here is 100%. If I go ahead and put on the mask, and I'm gonna wear it essentially fully here, and what you guys see is now the mask has been detected, and of course because I'm wearing that mask properly, right now it's shown that the mask has been detected with 100% confidence and looks good. Okay, now to the troubles. What if I maybe, let's say, covered only, let's say, my nose, for example. I'm sorry, covered only my mouth. So what you guys see here is, if I do that, this is the class here. So it's showing that essentially no mask has been detected, the nose hasn't been covered, and if I do that, what you guys see is now I have been able to detect that right now, yes, I'm wearing a mask, but the mask is not covering my mouth and it's not covering my nose as well. So these are essentially the 4 different classes. Here we go, back again. If I take it off completely, I'm gonna go back again to no mask detected. Okay, so gonna be tons of fun. I would say it's pretty interesting, and it's not challenging at all to show you guys how to collect our own training data. And that's pretty much all I have for that demo. I hope you guys enjoyed it. In task number 2, let's go ahead and cover the business case. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 2. In this task, let's go ahead and cover the business case. Please note that this lecture is quite easy, so I would say it's going to be pretty straightforward. I'm going to show you guys the business case. Why are we here? Why are we doing that? And then we are going to also go through a reading material and a quiz as well. If you guys remember, in the previous task, we learned how we are going to build our project. We also learned about the tools. We also learned about the goal as well. And we covered as well a practical application, a real-world application, and we also learned about the data, including what type of inputs we're going to use and what type of outputs as well we are going to generate. And I showed you guys as well a demo. I hope you guys enjoyed that one and you get really excited to build that model together. Okay, so what I'm going to do right now is I'm going to cover the business case. So as I mentioned earlier, is in the age of COVID-19 pandemic, wearing a mask in public is crucial to limit the spread of the virus and ensure public safety as well. So artificial intelligence, machine learning, and deep learning can essentially automate the entire process of detecting masks in public by looking at camera images and trying to extract proper features from those images. And these techniques can essentially be used to ensure compliance with public health guidelines and also limit the spread of the virus as well. And here is an article, like really cool article. It's called by a company called Real Networks. And Real Networks just released its first hardware product. Essentially, it's a machine that you can install in essentially any store, for example, and it can check for proper face mask usage or coverage as well. So let me show you guys. I'm gonna go back to the article. So this is the article here, and the article basically talks about the, what would we call it, mask check, essentially machine that you can install, and it can essentially tell you if that mask is worn properly or not, and essentially gonna tell you if you are ready to go kind of access the facility or not. If you don't have a mask on, or if that mask is not properly worn, essentially the machine will gonna flag you, gonna say you're not wearing it properly, and then that means an issue essentially, and you will not be able to access the facility. And if you guys actually click, and there is a link here, if you guys click on the new mask check, so I have it open here, essentially you can go ahead and buy this machine for around $1,000 approximately, and you can also ship it as well to either US or Canada as well. Okay, and what we're going to do today is, as I mentioned, we're actually going to build a very simple, I would say, prototype of the AI model that is running behind the scenes. Okay, so we're going to collect our own training data, and we're going to go ahead and train our AI model in a very, very simple way without, again, writing a single line of code, which is going to be super powerful and fun as well. Okay, so this simply concludes our business case. If we go ahead and cover our reading material and quiz, So today our topic is going to be AI applications for facial recognition. And I picked today a really cool article. So I actually have the article here, and I'm expecting this article to take around, I would say, 10 minutes for it to read. It's mentioning here that it's take 14 minutes, but I'm assuming you guys were going to read a little bit faster and maybe like skim through it. I'm not expecting you guys to like study the whole thing. And essentially the article talks about facial recognition, how it works. It's going to talk as well about the different applications of facial recognition technology. And going to talk about various companies and what type of neural networks as well and type of accuracy that you guys get. It's really intuitive and really interesting read. And it's going to talk as well about the deep learning technologies behind the facial recognition technology. And there is also a really cool video here. I highly recommend that you guys watch that one as well. And it's going to talk afterwards about the applications of facial recognition. So it's going to talk about security, for example. It's going to talk about, if you guys scroll down, about how to identify and track criminals. Talk about health, for example, in healthcare. It's going to talk about banking and retail. Really interesting article, really cool. Please go ahead, give it a shot. And afterwards, I'm going to include a 5-minute quiz for you guys. So after you go ahead and read the article, you can go ahead and check the quiz. And that's it. That's simply all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and perform data collection using Google Teachable Machines. I hope you guys enjoyed this task and see you in the next task. Hello everyone and welcome to task number 3. In this task, we are going to jump right ahead into Google Teachable Machines, and we are going to start the data collection process. If you guys remember, in the previous task, we covered the business case. We learned that we are going to build a face detection model powered by AI and ML, and we are going to learn how to collect our own live data, how to train our model, how to test our model, and how to deploy our model as well, and make inference on the deployed model as well. And we also went through reading material and quiz. I hope you guys were able to figure that out. Okay, please note that this task is still considered quite easy. It's actually pretty fun, no coding at all. So let's go ahead and get started. So basically what I'm going to do is I'm going to collect our own live data. If you guys remember from previous projects, is whenever we train a model using Google Teachable Machines, we have to first start with the data collection stage. So we collect the data or we upload the data, if you guys remember. So in previous projects, we had the fashion class images, if you guys recall, and these images have been collected already. So all what you need to do is to simply click upload, and then you can upload the images. What we're going to do today instead is we're going to learn how to collect our own data set. So we're going to turn on our camera and we'll be able to use the webcam to collect our own training data. And please note that I highly recommend that you guys make sure that you have very good lighting and you have solid background as well when you train that model, just to make sure that you are ensuring, kind of maximizing or the chances to get really good performance when you train the model. So let's go ahead and head to Google Teachable Machines. So what I'm going to do is I'm going to go back. This is Google Teachable Machines here. And please know that this project is already built. What I'm going to do is I'm going to build a new one from scratch. So I'm going to click here on Teachable Machines, and please click on New Project, and this new tab will open, and you have 3 options. You can either build an image project, you can also build an audio project, and you can also build a pose project as well. So what I'm going to do today is I'm going to build an image project. So if you click on image project, it's going to tell you either you need standard image model or an embedded image model. Basically, embedded image models are primarily used kind of optimal for microcontrollers, and they are primarily used for grayscale images and the pixels, kind of smaller images that are 96 pixels by 96 pixels. However, what we're going to do today is we're going to use the standard image model. And that's best for most use cases, and we can essentially train a model with images that are 224 by 224 pixels, and they are of course color scaled images as well. So please go ahead and click on it, and here we go. Now you will be able to see that essentially you have two options: either to upload the data, which is what we have done before, or you can click on the webcam, and using the webcam you can collect your own live training data set. And that's essentially what we're going to do today. Okay, so what I'm going to do is I'm going to collect class 1, and class 1 I'm going to call it no mask detected. So we're going to say no mask detected. Okay, and I'm going to right click, and you can add an emoji, for example, and you can essentially add, let's say there are so many options in here, but for example you can select, let's say, that X value here, mentioning that, well, this is no mask detected, you are not allowed to enter the facility. Please note that this is optional. You can just say no mask detected and you're good to go. The next point is, well, I'm going to turn on my webcam, and please note that I've connected an external webcam. It's called Logitech webcam. You don't have to do that. You can just leverage the same webcam that you have on your laptop. So please go ahead and click on webcam, and here we go. And what I'm going to do is I'm going to shift back to HD Pro webcam. So this is the external camera that I have. And what I'm going to do is I can essentially go here under settings, and I can set the FPS, or how many frames per second. You can just leave it at 24 for now. You can either do hold to record, which is essentially you have to press at all times to record, or you can essentially set a delay of, let's say, 3 seconds, and maybe collect for, let's say, duration of 17 seconds, for example. I can maybe reduce that to, let's say, 15. So I'm going to essentially, for 15 seconds, collect images, and I'm going to have a delay of 3 seconds from the moment that I hit start until we actually start recording. So I'm going to save settings, and I'm going to go ahead and get started. So I'm going to click record. And please note, this is the 3 seconds, and now I'm collecting real world data sets right now, live data. And please note that I'm moving, I'm just changing my face location just to make sure that the model is able to generalize the data. So I'm trying to change again my location. Here we go. So what you guys see here is I have been able to collect 330 sample images, and these are all the different images that I'm going to use to train our AI model. Pretty cool, pretty neat. Okay, the second class is gonna be, well, that's when I have the full mask. So I'm gonna say mask detected, and that will be the only case. If you right click and click emoji, you should be able to see that now I have the green indicating now I'm good to go, and now there is a mask that has been detected properly. If you click on webcam, and before you record anything, of course I need to shift it to our camera here, and I'm gonna have a mask, and hit record. Here we go. And of course I'm changing the location as well, like where I'm moving everywhere, to make sure that the model is able to generalize and learn all these different features. Okay, and here we go. So what you guys see here is I have been able to only select 2 classes only, either mask detected and mask not detected. And what I'm going to do next is I need to go ahead and train our AI model. Please note that in the final project, I'm going to ask you guys to kind of stretch your limits a little bit and kind of improve that project a little bit by adding these different variations. If you have a mask, but it's, for example, not worn properly, meaning it's not covering your nose and then not covering your mouth. And that's pretty much all I have for today's task, which is the data collection task. And in the next task, in task number 4, we will learn how to train our AI model. So we're going to cover the model training. So that's all I have. I hope you guys enjoyed this lecture, and see you in the next lecture. Hello everyone, and welcome to task number 4. In this task, we are going to train our model in Google Teachable Machines. If you guys remember, in the previous task, we learned how to collect our own live data sets. And it was actually pretty simple, pretty straightforward process. All what you need to do is to click upload or webcam, essentially, if you wanted to either upload your own data or collect live data. And because we're collecting live data, we clicked on webcam. We essentially collected around 350 images approximately per class. And we essentially had only 2 classes, either no mask detected or there has been mask detected. And now we're pretty much ready to go ahead and actually train our model. So I'm going to head back, and then I'm going to go to Google Teachable Machines, and here we go. And essentially what you guys do or could do is that you can just simply click on train model and call it a day. Or if you click under advanced, and if you guys remember, we covered all these different terminologies before. Here we have the number of epochs, and 50 is the default value. You can obviously change it, maybe let's say to 80, for example. When it comes to the batch size, this is essentially how many images we are feeding in per batch. And I can either leave it at 16 or maybe change it, let's say, to 32, for example. And also here we have the learning rate, which is how aggressive you would like to update the neural network parameters. And this is the default learning rate. And if you guys remember, learning rate is quite sensitive parameter. So if you actually change the learning rate and increase it quite aggressively, if you guys recall, we have played with it before in previous projects, yesterday actually. And if you change it to, let's say, 0.5 or kind of something really high, you will end up with the model not being trained at all, because essentially you are aggressively moving the weights like back and forth, and that's why you are essentially missing the global minimum point that you're looking for. Okay, so you can either leave all the parameters as default values, or you can just maybe tweak it, maybe try 80 and 32, and you can just go ahead and click on train model, and that simply is going to kick off my training. And it's gonna take some time for it to train. And please note that it might take, I would say, around 2 minutes approximately to finish the overall epochs. And what you guys see here is telling me that this page is unresponsive. Just say click wait, and it's gonna take some time for it to kickstart our training. And here we go. Now the training has started, and now we are 1/80, 2, 4, 5, and it's looking pretty good. And of course, if you click under the hood, you should be able to see the progress essentially of the training. It looks like, as you guys see here, the model already captured pretty much all the variations, I would say, or all the features in both images quite quickly, and you actually don't need to wait for 80 epochs to train our model. And that's pretty much all I have for today's task. In the next task, we are going to learn how to essentially deploy and evaluate our trained model. So that's all I have. I hope you guys enjoyed this lecture, and see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, let's go ahead and deploy and evaluate our trained model. Please note that this task is quite easy. It's pretty straightforward, so it's classified under the easy category. And if you guys remember, in the previous task, we learned how to essentially tweak all the different parameters here, such as number of epochs, the batch size, and learning rate. And we have been able to essentially click on train model, and the model has been essentially trained. And if you head back to our Google Teachable Machines, here we go. What you guys notice here is essentially the model right now is still being trained, in fact, and it's going to take some time for it to train until we reach 80 epochs. And we are going to essentially come here, and first of all, I'm going to go ahead before I actually test the model. I'm going to close that. I'm going to shift it to the webcam. And here we go. Now the model right now is telling me that I'm at 100% no mask detected, of course, because I'm not wearing a mask. And you can, of course, put a mask on, and the mask has been detected with almost 100%. Even if I move within the image here, or with, like, the camera, the model is still able to detect that I'm wearing a mask with 100%. What if I did this, for example? What you guys see here is now the model is kind of confused. Am I wearing a mask or I'm not? And that's essentially what we're going to learn how to tweak or train in the final project, where I'm going to ask you guys to add additional classes in between. But that's simply how you train your model. What I'm going to do next is I'm going to essentially click, first of all, I'm going to assess what's actually going on under the hood. So if you click on under the hood, you should be able to see here the progress of the accuracy over number of epochs. Here I have the progress of the loss as well over the number of epochs too. And if you click on calculate confusion matrix, what you guys see here is I have been able to correctly classify essentially 50 samples and 49 samples, and we have been able to essentially not make any errors because the model is really accurate. And of course it makes sense because right now we collected a lot of images and the class is actually pretty straightforward. Like even the model can just capture the color, for example, of the mask, not even the features in general. Just by detecting there is a red color, then it can tell, well, that belongs to the mask detected class. And if you click on calculate accuracy per class, what you guys see here is I had 50 testing images that belongs to the no mask detection category and 49 images for the mask has been detected category, and of course the accuracy here is set at 100%. Okay, all right. So in order to export and deploy the model, what you guys need to do is you guys need to click on export model. And if you guys remember, we have done that before in the previous projects. What you guys need to do is to click on upload model, and that's gonna upload the model for us. And then once the model is uploaded, once it's available, right now it's telling you uploading your model. It should show green here, your cloud model is up to date. And if you click on copy, now it's telling you that the link here has been copied. You can go ahead and deploy or assess the model live. Essentially, you can provide that link to anyone and you can go ahead and essentially test your deployed endpoint. So if you click on, if you add a new tab, and then you copy your link here and you press enter, what you guys see is you have been able to have your deployed model here. You can change it to like webcam, and here we go. This is essentially again the model, the live model. It's collecting real life data right now and you are essentially assessing its performance live. So what you guys notice right now is no mask has been detected, and of course if you put the mask on, it will tell you that the mask has been detected. Okay. And what you could do as well is you can essentially test the model performance using maybe a plain mask, for example. So let me show you what do I mean by that. So what I have right now, for example, is I have another mask. It's kind of like another cool mask per se. So what you guys see here is if I wear that one here, what you guys notice is the model is still able to detect that there has been a mask detected. Of course, the accuracy is not as high, or the confidence is not as high as the red mask, which has been used for training. But again, the model is still able to detect that the mask has been detected, which is pretty cool. And that's simply all I have for today's lecture. I hope you guys enjoyed this one. And again, here what you guys see is the model evaluation and deployment. Of course, you can check out the confusion matrix. You can check out the actual performance here of the model using images that the model has never seen before during training. And of course, you need to click on export and upload your model, and then you can test the deployed model as well. And of course, you can view the confusion matrix and also view the accuracy per class, and the model did really, really well. You actually don't need to wait for 80 epochs to train the model. And that's it. That's all I have for task number 5. I hope you guys enjoyed it. In task number 6, let's go ahead and cover the classifier models KPIs, or key performance indicators. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, let's go ahead and cover the classifier models KPIs, or key performance indicators. As a quick disclaimer, this lecture is on the intermediate level difficulty, so gonna be a little bit of technicalities, a little bit of math as well. If you guys remember, in the previous task, we learned how to deploy and evaluate our trained AI model. We have been able to essentially, after we upload the data, we have been able to train our model, and then we have been able to assess its performance. We also visualize the confusion matrix and also the accuracy per class. We have been able to upload the model and then test the deployed model afterward as well. Okay? Alright. So the next point is, what do you mean by confusion matrix? We have already covered the confusion matrix before, if you guys remember. But let me review it a little bit more as well today. And I wanted to show you guys additional KPIs or key performance indicators that we focus on to assess the performance of classifier models. So if you guys recall, a confusion matrix, it is just a way to visualize how our classifier is doing. So if you guys recall, let's assume that we have a classifier that is able to detect, let's say, cancer cases, for example. And what we do is we put the model predictions here on the rows, and we put the true class here in the columns. When I say true class, think of it as the ground truth. This is the absolute truth. That's what actually happened in real life. However, the predictions here, that's what the model is guessing. That's the predictions coming out from the model. And essentially what we do is we say, well, if the model predicted positive, if the model says that this patient has cancer, and in real life that patient has cancer as well, which means it's positive as well, we call those true positives. If the model predicted negative, so if the model said, well, that patient is cancer-free, doesn't have any disease, and in real life that true class was actually negative as well, we call these true negatives. And these are what we call it the good stuff. That's when the model predictions matched what actually happened in real life. Now to the troubles. If the model predicted positive, so if the model says that that patient has cancer, however, in real life, in reality, that patient didn't have any disease. He was actually fine. He was actually negative. We call these false positives. And then the final stage is when the model predicted negative. So when the model said that this patient does not have cancer, however, in real life, the patient was actually sick. He actually in real life had cancer. He was actually positive. We call these false negatives, or what we call a type 2 error. So when it comes to KPIs or key performance indicators, what we do is, first of all, we calculate the classification accuracy. Simply, it's a percentage that can tell me how many times was the model actually good, how many times would the model have been able to correctly classify the samples. And what we do is that we sum up the true positives plus the true negatives, and then we divide by the overall number of samples. So we say true positives plus true negatives divided by true positives plus true negatives plus false positives plus false negatives. And then what we do as well is we calculate what we call it the misclassification rate or error rate, and that's simply how many times did my model mess up. So we sum up the false positives here plus false negatives, which is here, and then we divide by the overall number of samples. And that's essentially a percentage that can tell me how many times would the model, made wrong classifications or messed up our classification. Next, what we do is we calculate another KPI known as precision. And essentially, we calculate the precision, and there is another metric as well, which is known as recall. We add these two metrics because accuracy in general is quite misleading, and that's why we need to add additional KPIs or key performance indicators to get an objective assessment of our classifier model. So when it comes to precision, simply precision equals to the true positives divided by the total true predictions. Simply, it's true positives divided by true positives plus false positive. And the way I kind of, say it here is we divide true positives divided by the rows, divided by true positives plus false positive. And simply, that's how we define precision. When model predicted true class, when the model said positive, how often was that model right? How often was it right, essentially? So when the model said that prediction was positive, the question is, how often was it right? Meaning is, maybe it might be 50% or maybe 60% or 80%. And that's an indication of how precise my model is. And if you guys are a little bit confused, don't worry. I have a practical example coming up to show you guys that in great details. The next definition is known as recall. And simply the recall is the true positives, which is again true positive as well, but it's divided by the columns. It's divided by the actual true. It's divided by the true positives plus false negatives. And the definition of recall is when the class was actually true. how often did the classifier got it right? I know it might sound a little bit confusing. It was also confusing to me as well at first. So let me show you guys a practical example. Let's assume that I have 100 patients in total. And out of these patients, I have 91 of those who are healthy and 9 patients who are in fact have cancer. And so basically what I have here in that blue box, that's the reality. That's what actually happened in real life, okay? And this is simply the model predictions. This is the classifier performance. So what I have here is the true positives were 1, meaning out of these 9 patients, the model was able to only get 1 patient right. So I had 100 of those patients, 91 of those were healthy, they didn't have any cancer, 9 of them had cancer, and based on what I'm saying here is the model has been able to only get 1 cancer patient right. And the true negatives were 90, false positives were 1, and false negatives were 8. So basically, if I go ahead and calculate only the accuracy as a KPI or key performance indicator, I'm going to say classification accuracy equals to true positives plus true negatives divided by the overall number of samples. So I'm going to sum up 1 plus 90, and then I'm going to divide by the overall number of samples, which is 100. I will end up with 91%. If someone is a little bit new to machine learning or AI in general, they're going to say, well, that model might be actually pretty cool, pretty good. It's, it's 91% accurate. However, if you actually dig a little bit deeper under the hood, you guys will see that this model is actually worthless. It's actually useless in a way. And the reason behind that is we have an unbalanced data set. The number of patients who are healthy, a number of patients who are actually have cancer is unbalanced. And if I have an unbalanced data set, if you only rely on accuracy, then you will get misleading results. And that's why we go, I would say, a step further, and we have to calculate 2 additional KPIs or key performance indicators, and these are precision and recall. So if you substitute within the definition of precision, we divide the true positives, which is 1, divided by the total true predictions, which is divided by true positives plus false positives. So 1 divided by 2, that will give you 50%. And that means that the model is essentially 50% precise. And another way of looking at it is, well, the model right now, based on what I'm watching right now, has only said twice that the case is positive. So the model said the predictions, okay, there were only 2 cases out of the 100 cases where the model said that this patient has cancer. One of them was right, this is the true positive, and one of them was actually false. That was a false positive, it wasn't actually correct. So, and that's why the model precision here is 50%. It was 50% precise. 50% it said true, which was a hit here, and 50% was false. And if you wanted to calculate the recall, essentially recall is out of these 9 positive cases, out of these 9 patients who actually have cancer, how many of those have been detected by the model? Well, the model only detected 1 patient only. It was true positive, only 1. So the recall is 1 divided by true positives plus false negatives, so 1 over 9. That will give you 11%. And of course, that model is really terrible. Again, out of these 9 patients, the model was only able to detect 1 of those 9 cancer patients. And that's it. That's all I have for task number 6. I hope you guys enjoyed it. In task number 7, let's go ahead and cover the difference between precision and recall. We call it deep dive. I'm going to show you guys really cool examples and practical applications. And that's all I have. I hope you guys enjoyed this task, and see you in the next task. Hello everyone, and welcome to task number 7. In this task, we will learn about the difference between precision and recall. If you guys remember, in the previous task, we briefly covered the difference between precision and recall. We went through a practical example. And today, I just wanted to kind of go a little bit further and dig a little bit deeper and show you guys real-world practical examples as well. So let's go ahead and get started. And please note that this lecture is categorized under the medium difficulty level. So let's go ahead and first cover the precision deep dive. If you guys remember, in the previous lecture, we covered that we have 100 patients. 91 of those patients are healthy, they don't have any disease, and 9 of those actually had cancer in real life, in reality. And what I got here, these are the various numbers that the model has actually performed. Basically, the model has been able to detect 1 cancer case. They missed 8 cancer cases. They messed up here with 1 false positive was equals to 1, and then the true negative was equal to 90. So if I wanted to do kind of some sort of a precision deep dive, I'm going to say precision equals to true positives divided by the total true predictions. So precision is equals to true positives divided by true positives plus false positives. So essentially, if you guys remember, it's true positives divided by the rows, divided by whatever positive predictions have been generated by the model. So if I wanted to substitute, it's simply 1 divided by 1 plus 1. We'll get 50%. And precision is simply a measure of correct positives. And in this example, the model predicted 2 patients were positive classes, meaning 2 patients that the model thought that they have cancer. However, one of them was right, and that was this one, and one of them was a mess up, and that was that one, the false positive. And precision is an important metric when false positives are important, meaning how many times a model says a pedestrian, for example, was detected and there was nothing there. And of course, examples include drug testing as well. Okay, what about recall? Again, I'm going to keep the exact same numbers as is, and let's do a deep dive on recall. Recall is equals to true positives divided by the actual true. So recall is true positives divided by true positives plus false negatives. So recall is 1 divided by 1 plus 8, you will end up with 11%. And simply recall is called the true positive rate or sensitivity. And essentially in this example, I had 9 cancer patients and the model was able to only detect 1 of those cancer patients right. And it's essentially an important metric when we care about false negatives. An example of that is fraud detection and perhaps self-driving cars as well. Okay, so let's dig a little bit deeper and cover 2 practical examples. The first one is bank fraud detection. Let's assume that you work as a data scientist at a bank and you have been assigned to, let's say, develop a fraud detection algorithm, and that algorithm could be able to detect fraudulent transactions. Simply, it's a binary classification problem, and we're trying to teach an AI model to detect if that patient, if the transaction is fraudulent or not. So as a data scientist, the question is, which KPI would you optimize? Would you care about precision or would you care about recall? And I want you guys to plot kind of the 2x2 confusion matrix and list out various scenarios. So here is the solution, and let me walk you guys through the solution. Basically, if I draw the confusion matrix, I'll get something like that. The model could predict positive, meaning the model would say, well, this transaction is fraudulent, and in real life, the transaction was actually fraudulent too. So there was fraud, and model predicted fraud. So we put the number of samples here, and that's the good stuff. Here, the model will predict negative. So the model will say, well, based on these features, this transaction is not fraudulent. And the true class, which is in real life, well, the transaction was not fraudulent as well. So there was no fraud, and the model predicted no fraud as well. So we are good. So here we're good, and here we're good as well. Now to the troublemakers. If the model predicted positive, so if the model said that this transaction is fraudulent, however, in real life, that was a normal transaction, and actually that happens to me a lot. Let's say whenever I travel anywhere and maybe use my credit card somewhere else, the bank sometimes block the transaction for me. And it pisses me off. Like as a customer, I feel I'm pissed off. But again, the bank is still okay, meaning the bank was kind of extra sensitive, but the bank did not lose any money. So basically the cost of this here is there was no fraud at all, and the model just predicted fraud, just the model stopped the transaction. Maybe the customer has to call maybe the bank, or just to relieve that transaction, or kind of, resume it again, or activate the credit card. So you might end up maybe with a pissed off customer, but the bank is still okay. And now to the troublemakers, now to this here. If the prediction was negative, meaning the model said that this transaction is not fraudulent, however, in real life, the transaction was fraudulent as well. So meaning that the actual transaction, there was fraud, like the bank already lost money and the AI model just missed it, just didn't say anything at all. And that's a huge problem, because in this example, the bank actually lost money. So in this case, which is this case here, the bank cares about recall. And basically the bank want to make sure that every single fraudulent transaction will be detected. Even if the bank messes up a little bit and maybe makes some mistakes here, it's okay. The customer will be a little bit pissed off, but as long as I'm ensuring that no transaction that has been fraudulent that I missed, basically, which meaning the recall is maximized as possible, the bank would be still okay. And that's the first example. The second example that I wanted to show you guys is called the spam email detection. And right now we assume that you work as a data scientist at Google, for example, and you have been working on a project to detect spam and ham emails. Basically, spam emails, these are emails that's trying to sell you something or maybe steal your password, for example. And ham emails, these are the good emails. They actually have content in them and are being sent by real people. The algorithm should be able to automatically detect or block spam emails. The first question is, which KPI would you optimize in this case? Do you want to optimize precision or recall? And I want you guys to plot a 2x2 confusion matrix just to list out all the various scenarios. And here we go. The good stuff are pretty straightforward. There was a spam email and the model predicted spam as well. Okay, so that's good stuff. The model predicted spam, the actual email was in fact a spam, and the algorithm blocked the email. So we are all happy, it's all good. Here the prediction was negative, meaning the model predicted that this email is ham, meaning it's a good email. And in real life, the true class was actually a good email. So there was no spam email and the model predicted no spam as well. So basically it went to the inbox. And here we're good as well. Now to the troubles. If the model predicted positive, meaning if the model said that this email based on these features is positive, meaning it is spam, however, in real life it wasn't spam, that's a problem. Meaning in real life that was actually a good email, meaning it's an email maybe that has an important message. Maybe that's an email, for example, that has, let's say, your dream job, for example. And the algorithm, because it messes up, it just blocked it. And that might cause massive issues. Just imagine, your dream job, you're getting your, I would say, your dream job offer. And then, let's say Gmail or Google just decided to block that email and send it to the spam folder, for example. You would be extremely pissed off. You're not going to use email or Gmail again anymore, right? So that's why we care about precision in this specific example. And the last example here is when the model predicted negative. So when the model said that this email is fine, however, in real life it was a spam, that means it was positive. Well, that means the email will go to your inbox, and I would say it's not a big deal. You just got a spam email. As long as you just ignore it, we're fine, we're good. And it's fine if you get maybe 1 or 2 spam emails in your inbox. However, we want to make sure that the good emails are not being sent to the spam folder. Okay, we want to make sure that every email that is legitimate has successfully arrived to your inbox. And in this case, we care about precision, and it's okay if we mess up a recall a little bit. Okay, all right. So that's it. That's all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go ahead and cover our final project. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, and they're going to be our final task. We are going to cover the final project, and I hope you guys will figure that out. And please note that today's lecture is categorized under the medium level difficulty. So if you guys remember, in the previous task, we had a deep dive into precision and recall. We learned about the difference between both of them, and we went through 2 examples. The first example where we cared about recall, that was a bank example. And example 2 where we cared about precision, and that was the ham spam email example. Okay, so right now, let me walk you through the final project. So in some scenarios, customers don't properly wear facial masks. And of course, this is critical. The trained AI ML models are able to detect those cases. So if you guys remember, in today's project, we have been able to detect have 2 classes. The first class is the person is not wearing mask at all. The second class is when the person is wearing a facial mask, and that facial mask is proper, it's covering their face, it's all look good, covering their nose and covering their mouth as well. However, there are some scenarios where people or customers might be wearing a mask, but they are not wearing it properly. Meaning the mask could be on, but the nose, for example, is not covered. Another scenario is when the mask is on, but let's say the nose and mouth are not covered, for example. And what we're going to do is I want you guys to go ahead, collect additional data. I want you guys to collect at least 300 images per class. I want you guys to tweak the model hyperparameters and maybe enhance some of the performance. Analyze the confusion matrix. So the confusion matrix right now, we're going to have 4 rows and 4 columns. And I want you guys to upload the model and also deploy it. And the stretch goal, and that will be, I would say, kind of a take-home exercise, is to try to improve the generalization ability of the model by maybe including different masks with different colors, different lighting conditions, and so on. So that's all I have. Please go ahead, give it a shot, pause the video, and then I'm going to see you guys after the final project is complete. Alright, I hope you guys were able to figure out the project. So what I got here is simply the solution. I simply added 2 additional classes, which is no mask detected, but nose and mouth are not covered. And then I had additional class, which is no mask detected as well, but nose not covered only. And I went there, I retrained the model, and then I was able to test it. So let me show you guys how to build that model together. So what I've got here is actually going to close that, and I'm going to go back here, and I'm going to add an additional class. Actually, let me stop the okay, it's called file. Okay, so now I'm going to add 2 additional classes to my model. The next class is going to be no mask detected, and in this example I was just going to say, let's say nose, for example, not covered. Okay, and I can also add, if I wanted to, an emoji here just to show that this one as well is not accepted. Okay, alright, and I can go ahead and start to collect our data set. So I'm just gonna say open the webcam, switch to our webcam here. I'm gonna put on the mask. So here's my mask. Okay, and I'm going to basically do that. So I'm gonna say right now the mask is not detected, but the nose is not covered. Okay, so I only covered my mouth and the nose is not covered. So can I do that? Okay, and make sure the settings here are the same. Duration 15 seconds, the delay 3 seconds, and FPS is the same, is set at 24. And here we go. Alright, so here we go. So now we have been able to collect around 300 images approximately. Looks great. The next one is I'm gonna say no mask detected as well. So I'm gonna say no mask detected, and then I'm gonna say nose and mouth not covered. Okay, alright, and then I'm gonna add an emoji as well. So I'm going to say emoji here, and then I'm going to add the X as well. Okay, and then I'm going to open the webcam, and now I'm going to do that. Make sure that I have the right camera. And again, I'm wearing the mask, but right now the nose and the mouth, both of them are not covered, okay, which is way worse, I would say. And let's go ahead and start recording. Alright, so here we go. So now I have been able to essentially retrain, recollect additional data, which is additional 2 classes. I can go ahead and train the model afterwards. And this process might take a little bit more time because not right now I have a lot more images, of course. And please note that this is the only case where the customer is allowed to access the store, because that's the only case where the customer was able to wear the mask properly. And right now we are essentially training the model, so it's going to take some time for it to train. Again, I'm leaving it to 80 epochs, which is not the default values. If you guys recall, the 50 epochs was the default values. Now I set it to 80. I also changed the batch size to be 32, and the learning rate right now is set at 0.001, and this is the default values for the learning rate. What you could do as well is, if you essentially, once the training starts, you can essentially look under the hood and you can get an insight of how the progress of the training is taking place. Here we go. What you guys see here, the error starts very large in the beginning, and then the model actually converged pretty quickly. You actually don't need to wait for, let's say, 80 epochs, but here we go. Just give it a shot. And you can also take a look at the confusion matrix and also the accuracy per class as well. Here we go. Now the model is being trained. What I'm going to do is I'm going to simply pause the video, and then I'm going to be back once the 80 epochs are complete. Alright, so here we go. Now the model has been trained, and what you guys see here is right now I have the no mask detected, of course, because I'm not wearing mask at all. Let's test the different 4 classes. So right now I have the mask has been detected, and with almost 100% confidence. Now if I do that, what you guys see here is no mask detected and nose is not covered. And if I do that, now I'll be able to see that now the 3rd class, which is no mask detected, because right now I'm not covering my mouth nor my nose as well. Okay, and of course if you do that again, you should be able to see that the model is actually quite good. And if you can do that, now I'm covering my face completely. Now the mask has been detected, and that's the only case where the customer is allowed in the store. Alright, okay, what you could do as well is you can go ahead and export the model, and same deal, you can say upload the model. You can go ahead, copy the link, and then you can go ahead and once the model right now is up to date, so what you could do is that you can essentially copy the link and then paste it here and just press enter, and now you have essentially a model that has been deployed and is pretty much ready to go. I'm gonna go ahead and change the camera again, and no mask is detected, and you can of course change it to mask has been detected, and of course you can do that as well. And then you can do that, you can see, kind of test all the different 4 classes. Okay, alright, so let me go back. So what you guys see here is in the final project we have been able to essentially retrain the model with additional 2 classes, and we have been able to also kind of tweak the model hyperparameters as well to kind of enhance model performance. You actually did not need to do that. 80 epochs was just too much. And as a stretch goal or stretch assignment, what I'm asking you guys to do is maybe try different types of masks, maybe try to change the lighting conditions, for example, and see how robust your model is. Okay? Alright, so that's simply all I have for this project, and that simply concludes our today's activity and today's project. I hope you guys enjoyed today's activity, and tomorrow we're gonna come back with a brand new project. Please stay tuned, best of luck, and I will see you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 4. Today we are going to have a brand new project for you, and we are going to learn how to visualize various AI models. So let's go ahead and get started with task number 1, which is our project card and demo as well. Please note that this lecture is quite easy, okay? So gonna be straightforward, and then we're gonna get a little bit advanced as well as we progress through our today's activity. Okay, so let's go ahead and cover the goal. So the goal is to understand deep neural networks and visualize their layers and various architectures as well. So what I'm going to do today is I'm going to show you guys various tools. An example of those tools is what we call it TensorSpace.js. So I'm going to show you guys various AI models and how these AI models can actually extract features from images. And it's going to be super fun and super, I would say, intuitive. And we're going to go as well beyond the TensorSpace.js, and I'm going to cover as well 2 additional tools. So I'm going to cover what we call it Google TensorFlow Playground tool, which is another data visualization tool as well. And we are going to also cover the Ryerson 3D and 2D as well convolutional neural network visualizations, or CNN visualizations. So from a practical application point of view, this project could be effectively used to help you guys understand how AI, ML, and DL models work, how we can actually build these AI models in a layered fashion, and how we can extract features from images. So it's going to be tons of fun. And as well, we're going to reinforce the knowledge that we gained in the previous 3 days, where we learned how to detect and classify facial masks, and also classify fashion images, if you guys recall. So when it comes to the data, so we're going to learn essentially how to classify various numbers. So for example, here we're going to write the number 3, for example. So that will be, I would say, the input that we're going to use to test and visualize our network. And when it comes to the outputs, it's going to be a class, which is essentially one of numbers that range between 0 and 9. So what you guys can see here, this is TensorSpace.js, and what you guys see here is we have a bunch of AI models, and we can open any of those and try to visualize it. So for example, if I open, let's say, LeNet network, and please don't worry about like what does LeNet mean, because we're going to cover that today. So what you guys see here is we are able to, if we write any number here, for example, let's say number 5, for example, what you guys see here is we're able to see what the actual layers of these convolutional neural network. So for example, we can see all the different convolutions, the dimensions as well of the different layers. And if you click on it, you can essentially open all these different layers and understand what is actually going on, what are these features, what do we mean by all these features, what is the dense here fully connected artificial neural network, and how we came up with a specific number or prediction, which is number 5, for example. So please don't worry about it. Again, we're going to cover that in great details, but that's one of the tools that we're going to learn today. The second tool is known as TensorFlow Playground, and it's primarily used to visualize feed-forward artificial neural networks. So we'll learn how to change different layers, how to change the size of various layers, and how to essentially train the AI model here to be able to classify different inputs, such as a spiral, such as different linearly separable data, and so on. We'll also learn how to change these different parameters, such as learning rate, activation functions, regularization, and so on. The third tool that I'm going to show you guys today is what we call it Ryerson 3D data visualization. And what you guys see here is an example of an artificial neural network that we can essentially write, let's say, number 3, for example, and we'll be able to visualize in 3D what is actually going on, what do we mean by these features, how we can extract features using these kernels or feature detectors. And that's essentially what we are going to learn today. And that's it. That's all I have for task number 1. I hope you guys enjoyed it. In task number 2, we will learn about Artificial Neural Networks 101. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 2. In this task, we are going to cover the fundamentals of artificial neural networks. And please note that we covered already some of the basics in the previous couple of days, but today we're going to dig a little bit deeper because we need to understand how artificial neural networks work, because we wanted to visualize it afterwards with all the tools that I discussed in the previous task. And please note is today's lecture is, I would say, in the intermediate level, because we're going to be some math and some as well, a little bit of advanced topics as well. If you guys remember, in the previous task, we have been able to cover the project card and demo as well. We learned that we are going to understand deep neural networks and how to visualize the various layers and architectures. And we also went through a couple of demos showing TensorSpace.js. We also showed you guys the TensorFlow Playground and the Ryerson 3D visualization as well. Alright, so let's get started with just a quick introduction. And I'm going to start with an article that has been published by CNBC, and I have it open here. And essentially it discusses that Elon Musk is warning everybody about the dangers of AI, and that what's going on right now is that we're creating an immortal dictator, essentially, that we will never be able to escape from as humanity in general. And I highly recommend that you guys go ahead and read it. It's super powerful and super interesting to read. And what I'm going to do right now is I wanted to show you guys kind of a reminder of how to build just a basic single artificial neuron model. If you guys recall, is we, in order to build just a single neuron, we assume that we have a bunch of inputs, input 1, 2, and 3. We had also a bunch of weights as well. And we have a bias signal too. And what we do to build that basic artificial neuron model is we substitute in this equation. We say, okay, y equals 2 f, which is our activation function f, and then we multiply the inputs by the weights, and then the input by the weights, input by the weights. So essentially we multiply 1 times 0.7, 3 times 0.1, and 4 times 0.3. We end up with 2.2, and then we apply a function or an activation function f, and that activation function is essentially here in this example is a unit step function that could generate either 0 or 1, depending if the input here was negative or positive. And basically what we learned out of this example is we can actually come up or make a decision. So the output could be 0 or 1, meaning, well, based on the features, based on the input, I can say if that patient has cancer or not. Or if, let's say, if it's a self-driving car, I can say if there is, let's say, a car in front of me or not, and so on. And what I wanted to show you guys next is, if you guys remember, instead of having a single neuron, what we did is that we built a multi-layer artificial neural network. And that's why I wanted to cover the fundamentals right now, because I wanted to show you guys how to actually visualize it using Google TensorFlow Playground. So what you guys see here is we have multiple of these single neurons, and then we organize them in a layered fashion. So we have a bunch of inputs, here we have a bunch of hidden layers, and then we connect them together. And essentially the process of AI training is the kind of the attempt to try to find the matrix of weights. All what I'm looking for when I'm training AI models is, think of it as it's a massive optimization type problem. We are trying to find what are the optimal values of weights, which is this matrix here, just a bunch of numbers that can map the inputs to the outputs. That's all it is. Okay? Alright. So the next point that I wanted to show you guys is there are different types of artificial neural networks. And please note that in this course, I will primarily going to focus on the first two types, and we're going to ignore this type for now. So the three types are as follows. First one is what we call it feed-forward artificial neural networks. The second one is what we call it convolutional neural networks, or CNN for short. And the third one is recurrent neural networks. And as I mentioned, we're going to focus primarily on visualizations, and when we build also our models, we're primarily going to focus on these two types of models, the feed-forward and the convolutional neural networks. So please note that I'm going to cover CNNs or convolutional neural networks today, and we're going to cover it in great details. But just from a very high level, feed-forward artificial neural networks, it's essentially we are grabbing all these different neurons, connecting them in a multi-layered fashion, And we call it feed forward because the direction of the data just flows from the input to the output in one direction. And we can essentially use these type of networks to do classification type problems, or to solve classification type problems, and to solve regression type problems as well. And please note that this type of neural networks, these are similar to this one here, which is what we covered already. And I'm going to show you guys how to visualize it in TensorFlow Playground today. Okay, the second type of networks is known as convolutional neural networks, and these type of networks work really well with image data. And that's where we are going to use tensor space.js and also Ryerson 3D visualization to visualize all the different layers in here, all the different convolutions, pooling, and all of that. Don't worry about it. We're going to cover it in great details today. And the last type of networks is known as recurrent neural networks, and they are essentially used to cover what we call it temporal or time information. So essentially, instead of the data being flowing from the left-hand side to the right-hand side in one direction, we have what we call it a memory element. We kind of provide a feedback loop from the output back again to the input, and that will help us to predict, let's say, stock prices, to translate text, and so on. Okay, all right. So a little bit about deep learning history. So please note that all these different type of networks are off-the-shelf networks, and they are readily available. And actually today I'm going to show you guys how to visualize these two types of networks. The first one is what we call LeNet network, and the second one is known as ResNets, or residual neural networks. So let me show you kind of a quick history. So we started first with the LeNet. That was in 1998, and this is essentially a 7-layer convolutional neural networks. It has been developed by a researcher, his name is Yann LeCun, and essentially it has been working really well to classify handwriting numbers, just a bunch of numbers. And I'm going to show you guys today how can we actually build a LeNet network. And then in 2012 we have been able to kind of offer massive improvement over LeNet, and we came up with AlexNet, which is in 2012. And the error has been reduced from 26% to 15.3%, and that's a huge improvement. And then afterwards there has been ZFNet, that was in 2013, and the error was around 14.8%. And then it came by GoogleNet and InceptionNet, that was in 2014, and now the error has been reduced to 6.67%. And then we have the VGG network in 2014, and then followed by ResNets, which is 2015. And ResNets are super powerful, state-of-the-art convolutional neural networks. It has many layers, over 152 layers, and the error achieved is at 3.57%, which is amazing, which is essentially superior compared to humans. And please note that again, the two ones here highlighted in red, these are the ones that I'll be focusing on when we visualize our networks today. Here there is a great article, a great resource for you guys if you guys wanted to read a little bit more about different architectures. And now it's time for our reading time and quiz as well. So I included an article for you guys here that the expectation is gonna take around 12 minutes for you guys to complete, to read. So here is the article. So the article is by Raini Karim, and essentially it illustrates all the different architectures of convolutional neural networks. And please note that I'm going to be covering all the CNNs and how they actually work and all of that, but this is essentially kind of a summary of all the different models and their actual accuracy as well. Don't worry about it, I'm going to cover them, the actual architectures in great details. I just want you guys to scan through it, understand what are the type of networks, what's the performance are, but when it comes to the actual architecture and actually what's going on under the scene or behind the layers, we're going to cover them in great details in the following lectures. Okay, so please go ahead, give it a shot, try to read this article and as well finish the quiz. And that should simply conclude task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and start with visualizing feed-forward artificial neural networks in GTP or Google TensorFlow Playground. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, let's go ahead and visualize our feed-forward artificial neural networks in Google TensorFlow Playground. Please note that this task is categorized under the medium difficulty. So if you guys remember, in the previous task, we have been able to kind of review our AI basics. We learned about the single artificial neuron. We built multiple of these neurons together to build our feed-forward artificial neural network. And we also learned about the various architectures of the networks, including feed-forward, convolutions, and recurrent neural networks as well. We went through a brief deep learning history, and we went through a quiz. I hope you guys were able to figure that out. Okay. So what I wanted to show you guys right now is I wanted to show you the first tool that we're going to cover today, which is our TensorFlow Playground. So I want you guys to please go ahead to playground.tensorflow.org, and I actually have it open here. And let me do that. And here I have my TensorFlow Playground. And basically what I wanted to do first is I wanted to essentially build here a feed-forward artificial neural network. So please know that this tool, you can actually play with it the way you want. You are never going to be able to break it. You can essentially specify kind of input. What input do you want here? And the idea here is that we're performing classification type problem. So we have two classes. These are the orange class and the blue class. And all we're trying to do is that we're trying to essentially differentiate between these two classes. That's all it is. And what we're going to do first is I'm going to start with this data set, which is our circular data set here. And I'm going to, what I could do here is I can essentially have multiple hidden layers. So I can go ahead, add a hidden layer, for example. And I can also change the number of neurons per layer. I can also delete a layer if I wanted to by clicking on negative minus here, and that will remove a layer for me. I can also come here, remove a layer, and so on. And what I could do as well is I can reduce the number of neurons. So let's say I'm going to stick with 6 neurons only. And what you could do here as well is that you can go ahead and change the learning rate. And if you guys remember, we covered the learning rate before, which is essentially a hyperparameter that will allow us to essentially change how aggressively we would like to update the network weights. You can also change the different function, the activation function here. So we have multiple options. And I actually have a couple of slides as well available for you guys that covers various activation functions. So what I wanted to do first is I'm going to keep it as is right now, is I'm going to use a linear activation function first. And then I'm going to go ahead and train our model. And if you guys remember, when we train any AI model, what we do is we just essentially feed in the training data to the model, and then we try to update the values of weights. So all these values of weights here, I'm trying to adjust, or I'm trying to optimize, essentially. So if you click run, what you guys see here is quite interesting. What you guys see here is that the actual model performance is actually not improving at all. Like the training loss is around 0.49 and the test loss is around 0.5, meaning that the model is actually not able to classify these two classes. And what you guys see here is I wasn't able to draw a boundary between these two different classes. And the reason is well, first of all, our neural network here is pretty simple. Okay, it's only have 6 neurons, only one hidden layer. And the second reason is the activation functions that I'm using here are linear. And that's why it's kind of, you are getting a very difficult problem and you have a very small brain. So the brain is not able to capture all the nonlinearity and the complexity as well that we have in our input. And that's why what I've included for you guys here is I wanted to include just a quick summary of various activation functions that we have. So I'm just going to go through them pretty quickly. So the first type of activation function that we can use is what we call it sigmoid activation function. And that's what the sigmoid activation function looks like. Essentially, it takes a number and sets it between 0 and 1. Think of it as more of it's kind of saturating, essentially, the inputs to either 0 to 1. And it can convert large negative numbers to 0 and large positive numbers to 1. And that's essentially what the output will look like. And of course, right now, when you introduce a sigmoid activation function, you are introducing nonlinearity in my network. The second type of activation function as well is known as ReLU, or rectified linear units. And that's what the ReLU looks like. essentially if the input is negative, the output will be 0. And if the input is positive, the output will be essentially as is, will pass along similar to the input. So if x is greater than 0, then the output will be x, will be the same as the input. And what's powerful as well about ReLU or rectified linear unit is that essentially avoids what we call the vanishing gradient problem. Don't worry about it too much. But the overall idea is we can use ReLU activation functions in the hidden layers and they work really, really well. Okay. The third type of activation function is known as hyperbolic tangent activation function. And that's what the activation function looks like. It looks pretty much the same as the first one, which is a sigmoid, but it ranges here between -1 and 1 instead of 0 to 1. And in practice, the hyperbolic tangent activation function is actually preferred over sigmoid activation function. All right, so that's kind of a quick summary of the various activation functions that I have. I just wanted to show it to you guys because right now I wanted to go ahead and change the activation functions here in our TensorFlow playground, and maybe that might improve our performance. So for example, what I'm going to do is I'm going to change the activation function. Instead of linear, I'm going to go to sigmoid. And now you guys know what sigmoid look like. I'm going to keep the number of layers as is, and let's see if that helps us to fix a problem or not. So I'm going to let it run here, and what you guys see is, well, the actual network has been able to do the classification for us, so it actually was able to work, even though the loss is still at 0.02, but now the model was actually able to capture the nonlinearity that we have in our function, which is pretty cool. What I could do as well is I can change the sigmoid function here and maybe change it to hyperbolic tangent. And if I run it, what you guys see here is it's trying, it's still trying. Here we go. Now the network was able to actually do the classification and draw that boundary between these two different classes. And what you guys see here, the test loss stands at 0.013 and the training loss is at 0.005. Okay. So the key, I would say, takeaway out of this one is, well, the first one is the activation function actually makes a big difference. So if you change the activation function, let's say from linear, for example, and try to solve the problem, you will not be able to solve the problem. But if you change the activation function, maybe to a little bit of introduce nonlinearity in there, maybe it's sigmoid, you will be able to actually draw that boundary and will be able to solve the problem as well. Another key point that you could do is, well, I can maybe keep it as linear, for example, and maybe change the number of layers, maybe change the number of neurons, add one hidden layer and maybe add a couple of neurons as well, maybe add another layer, for example, a couple of neurons as well, and let's see if that works or not. And if I run it right now, again, I'm still keeping it in a linear format. And again, what you guys see is no matter how many layers I'm trying to add in there, no matter how complex the network is, activation functions do make a big difference. What you could do as well is that you can go ahead and maybe play with the learning rate. Maybe I'm going to change the learning rate, kind of increase it a little bit, maybe to 0.1. And again, no matter what I do, I wasn't able to do the classification here. I'm going to go back to the original learning rate of 0.01 and then go back, of course, to, let's say, hyperbolic tangent. And if I run it, what you guys see here is the network was, of course, was able to do the classification, because right now I have a lot more powerful network. Think of it as a lot more powerful brain, essentially, to do the classification for me. Okay? All right. So that's it. That's simply all I have for today's task. I hope you guys enjoyed it. In the next task, we're going to go ahead and cover our final project part A. So I'm going to give you guys an assignment, essentially, and I'm going to learn how to use TensorFlow Playground to visualize our network. Please stay tuned. Best of luck. I hope you guys enjoyed this lecture, and see you in the next one. Hello everyone, and welcome to task number 4. In this task, we are going to cover our first part of our final project. And please note that this lecture is categorized under the intermediate level difficulty. So if you guys remember, in the previous lecture, we have been able to visualize our feed-forward artificial neural networks in Google TensorFlow Playground. We have been able to change our activation functions, playing with the linear, sigmoid, and hyperbolic tangent. And we also have been able to change the architecture as well of the network by adding more neurons, more hidden layers, and we also covered the differences between various activation functions such as sigmoid, ReLU, or rectified linear units, and also the hyperbolic tangent function as well. Okay, so now is the time for our final project, which is our fun time. So what I want you guys to do is I want you to choose 80%, 20% split between the training and testing data. And then I want you guys to select a high level of noise of around 30% approximately. And then I want you guys to set the batch size to be 20. I want you to choose the spiral data set as an input and to modify the network architecture and tune the network hyperparameters, the learning rate, for example, the regularization, and so on. And then finally, I want you guys to assess network performance and comment on your results as well. Please note that I haven't covered or haven't showed you guys how to change the batch size, for example, in Google TensorFlow Playground. I haven't showed you guys how to change the split, let's say, and how to change the noise level. And that's the overall idea. I want you guys to go ahead, experiment with the tool, play with it, try the spiral dataset, and that's the, I would say, the most challenging dataset of all. So what you guys see here, this is essentially the spiral dataset, and I want you guys to go ahead, play with all these numbers here, play with all these parameters such as a noise, a batch size, and I want you guys to see if you are able to solve that problem or not. And maybe you need to change the network architecture, maybe change the number of hidden neurons or hidden layers, maybe change the learning rate, maybe try basically maybe do external research to try to find how you can or you'll be able to perform the classification here on a very, very hard or very challenging data set such as a spiral data set. So that's it. That's all I have. Please go ahead, give it a shot, pause the video, and then I'm going to see you guys after the final project is complete. Alright, hope you guys were able to figure out the final project. So here we go. So what I'm going to do first is I'm going to start small, okay? First of all, I'm going to follow the footsteps. First, I wanted to change the split here. If you guys see the ratio of the training to the testing data, I'm just going to go with 80%, 20%, similar to what the final project actually question asked me to do. The second one is the noise. So what you guys see here is by changing the noise levels, you can either have a simple or easy task or simple problem. By changing the noise, by increasing the noise level here, so what you guys see here is now the actual two classes are coming on top of each other, making it much, much harder. So I'm just going to set the noise to, let's say, 30. And then when it comes to the batch size, I'm just going to set it to 20 for now. I'm going to say regenerate, okay, and that will regenerate the data for me. And of course, I'm going to select the spiral, and that will be the main data set that I'll be working with. And what I'm going to do for now, I'm just going to stick maybe with, let's say, 8 neurons for the first hidden layer, 8 neurons for the next hidden layer, and then 8 neurons for the last hidden layer, and then I'm going to feed that to the output. When it comes to the hyperparameters, I was just going to stick with the basics. I was just going to keep the learning rate as is, which is 0.01. The activation function here, I'm going to stay away from linear because I wanted to introduce non-linearity in my layers here. And we actually discovered that just using linear activation function didn't work really well, even with a very simple problem, which was the circular problem here, if you guys recall. Just going to stick with, let's say, the hyperbolic tangent. I'm not going to apply any regularization, and then of course I'm going to keep the problem to classification type problem, and let's see if that works or not. So if you guys click on play here, what you guys see here, I have the overall number of epochs, which is, if you guys remember, we covered that before. That's essentially every time we feed in the entire training data to the model and update the neural network weights just once. And what you guys see here is the network is actually really trying really hard to do the classification, but no matter what you do, the training loss seems to stagnate, kind of, saturate at 0.4, and the testing loss is much higher, it's around 0.513. And again, it's still trying. It looks like it's gonna go somewhere, hopefully. And it looks like the problem is much, much harder compared to the actual neural network architecture right now that we have at hand. That said, again, the network is trying really hard. Basically, what we're trying to do is that we're trying to draw a boundary between the blue spiral here, between the blue class and the orange class. I'm trying to kind of create a sleeve here around the blue and kind of separate it from the orange class. And what you guys see here is, well, the network's actually doing a little bit pretty well, actually. It's going to 0.331, so it looks like increasing the number of epochs, it's actually helping the network to achieve what we're looking for. Here we go. Now the loss actually reduced to 0.3, which is pretty amazing. Now the boundary has been started to create here around these different layers, so it looks like we are actually onto something. And of course, what you guys see here when you hover on top of these various weights is the values of weights are actually changing over time. And of course that makes sense, because these values of weights, that's the idea of AI training. All the idea of AI training is that we wanted to essentially find the optimal values of weights that can map the input to the output, essentially. Here we go, the loss stands at 0.244, and the network is really trying, but looks like it's messing it up here. It's not like continuous across these layers, but again, it's really trying. And here, of course, this is messed up area 2, and that's these two areas, of course, are contributing to our error here that we're seeing of 0.213. That said, again, the network is still trying, and we are standing at around 2,000 epochs so far. And I'm gonna let it run maybe until 3,000 epochs, and let's see what's gonna happen. Again, the training loss stands at 0.194, 0.195. That's pretty amazing. And please note that you can, of course, go ahead and change the learning rate, maybe increase it a little bit, or maybe add or introduce regularization. And I haven't covered regularization in great details. The overall idea is that we wanted to kind of improve the generalization ability of the network. And what you guys see is the network is actually doing pretty okay. Now the losses stands at 0.16, but the key point here is we needed actually around 2,600 epochs. Like, we needed a lot of compute power and a lot of time as well to run it. And here we go. Now the training loss stands at 0.09. Pretty cool. Now I was able to actually draw the boundary between the two classes. Looks pretty amazing, actually, 0.089. And I'm just going to stop until at around 3,000 epochs. And here we go. So here we go. Now we have been able to actually train our network. We haven't actually, we didn't have to play, for example, with all these different features in here. But all we have been able to do is that we have been able to let it run for additional number of epochs to be able to draw that boundary. And it looks pretty good as well. What I'm going to do next, and that's what I wanted to show you guys afterwards, is we can actually implement a little bit of a trick for us that can allow us to achieve even better results than this with a much less number of epochs. Let me show you. Alright, so what I could do instead, which is a little bit of a trick that I can do here, is instead of feeding in the inputs as x1 and x2, what I could do is I can also do what we call it feature engineering. Meaning, if I maybe insert, instead of inserting these data points here as x and x1 and x2, I can also feed in x2 square and x1 square as well. Think of it as you took the input, you squared it, and then you used it as an input to our AI model. And let's see how many epochs do we need to achieve the exact same results, or even better, with the exact same network. Everything is exactly the same. The only change that we have made is in the input here, and of course in the connections between the input layer and the first hidden layer as well. So if you click run right now, what you guys see is the network right now is trying. It's really trying, and now we have fed in the input as is, raw, and we have been also able to feed in our x1 squared and x2 squared. And what you guys see here is quite interesting. We are actually achieving a much better results. We are like at pretty amazing 0.04, 0.05, only in around 400 epochs only, which is again pretty incredible. If you guys remember in the previous trial, when we feed in only the inputs as is without feeding in the x1 square and x2 square, we have been able to achieve pretty much the same results as well, but it took us around 3,000 epochs to do that. Now, by just doing a little bit of a trick, we are able to achieve even better results. Like, the boundary here is very smooth, and we have been able to do that in only 400 epochs only. Okay, alright, so that's it. That's simply all I have for this project. I hope you guys enjoyed it. And what you guys see here is I've included the summary of the first trial and the second trial as well when we added the different additional features. And that's it. That's all I have for task number 4. I hope you guys enjoyed it. In task number 5, let's go ahead and I wanted to show you guys how to visualize a different architecture of artificial neural networks, and that would be a convolutional neural networks. So first, I want to show you guys how do they work, what do you mean by CNNs first, and then we're going to go ahead and visualize them in 2 different brand new tools for you. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, we will cover the fundamentals of convolutional neural networks. Please note that this lecture is quite advanced, and I will try to, do my best to make it as easy as possible. If you guys remember, in the previous task, we have been able to cover our final project. We have been able to build our artificial neural network using Google TensorFlow Playground, and it was quite fun. I hope you guys were able to figure that out. Okay, so before I cover convolutional neural networks, I just wanted to cover the fundamentals of an image, essentially, in a digital format. So convolutional neural networks work really well with image data. So the question is, what is an image? So essentially an image, what we see here, let's say the image of the Mona Lisa, for example. Essentially, if you break it down, you will notice that it contains a bunch of pixels, and each of these pixels has a number, and that number could range anywhere between 0 and 255. Essentially, the number 0 indicates that this is a black cell, and if the number 1 indicates that this is a white, essentially, cell or pixel. And that's essentially what you guys see here. So for example, if I have a bunch of pixels that has number 0s in it, that means this color is dark, is black. And if you have these cells that has number 255, that indicates that these cells are essentially white, and anything in between, that means it's a grayscale. So for example, number 155, that means it's a grayscale. And what we see here, this is simply the binary representation of the exact same image. So these numbers here are in decimals, and these are the numbers we are familiar with as humans, I would say. But the language of the computer is essentially a bunch of zeros and ones, and that's what we call a binary. So the number 0, for example, here is represented in 8 bits of bunch of zeros, and the same deal as well, the number 255 in decimal represents 1111, essentially 8 ones in a binary format. Okay, all right, so let's go ahead, grab that image, okay, and let's go ahead and see how we can build a convolutional neural network. So essentially, a convolutional neural network contains, from its base, it has a feed-forward dense artificial neural network. So basically what we have here is the exact same network that I covered in the previous tasks. And let's assume that we'll be working with a data set, and this data set essentially contains a bunch of images from chest data. So it contains an X-ray images of the chest, and we are trying to classify these images to either one of these classes, either healthy, or someone has, let's say, COVID-19, or viral pneumonia, or what we call it bacterial pneumonia, okay? And the point is if we wanted to use a dense, fully connected artificial neural network only, and we feed it in here an image like this one, for example, you would notice that the performance actually turned out to be quite poor. And that's why what we need to do is that we need to apply kind of a pre-processing stage somewhere in here before we feed in the values to a dense, fully connected artificial neural network. And these stages are as follows. First of all, we apply what we call it convolutions. Essentially, we use what we call it kernels or feature detector to try to extract features from the image. Again, I'm not going to cover the math behind the kernels or the feature detectors, but the overall idea, essentially, we try to extract the important, critical features in the image. And we generate that first. And then what we wanted to do is we apply what we call it pooling. And pooling simply tries to compress these features, reduce the size of them. So for example, here, if I have, let's say, 20 by 20 pixels, Here I will end up with 10 by 10 pixels, okay? And then afterwards, what we do is we apply what we call it flattening. So we take all these different pixels, we flatten them up, we make them in one array, essentially, and then we feed them to a dense, fully connected artificial neural network. And that's what we call it convolutional neural network in a nutshell. From a very high level, that's what we do. We, again, extract features from the image, we reduce their size, we flatten them up, and then we feed in or pass them to a feed-forward artificial neural network. One key point as well is we sometimes add what we call it a ReLU or rectified linear unit somewhere here. And the idea that we wanted to introduce non-linearity in my network, and that's actually like dramatically improve the performance. Okay, so I know that might sound a little bit confusing at first to you guys. So let's go ahead and dig a little bit deeper into, let's say, the first process, which is our feature detector. So essentially what I have here, when I say I wanted to apply the kernel or feature detectors, if I have, let's say, number, for example, 5, what we do is we essentially scan a given image and apply a filter to it to try to apply kind of a certain effect out of it. Think of it as you wanted to obtain, let's say, blurring or sharpening of a given image. And what the kernel does in machine learning, it tries to perform what we call it feature extraction. Kind of, again, extract the most important features out of the image, and that's essentially what we see here. So for example, number 5 here, when we apply a kernel or a feature detector on it, we end up with a bunch of what we call it feature maps. And these feature maps, think of it as more of different variations of the original image, okay? And then we are going to use those in the next stage to kind of compress them and reduce their size in the next step. So let me show you guys an example of a live convolution. So what we see here is I have an image, okay? And as I mentioned, an image is just a bunch of numbers, zeros and ones, essentially. And what I have here is I have a feature detector. So what we do is we essentially place the feature detector on top of the image, okay? And what we do is we simply multiply all the values of the pixels. So we multiply 1 times 0 plus 0 times 1 plus 0 times 1 plus 0 times 1 and so on. We keep doing that, and then we sum up all these values. So we end up with, let's say here, number 1, for example. And then what we do is that we take that feature detector here, and then we scan it to the right a little bit. And then again, we apply the convolution process again. We multiply these pixels by these pixels and so on, and then we sum them up, we end up with a number here, 1. And we keep repeating that process over and over again until we end up with a feature map. And I have a really cool website here available for you guys. Let me show it to you. Alright, so here is a really cool example by Victor Powell. So what you guys see here, this is essentially an image, okay? And on the right hand side, and on the left hand side, that's the digital representation of the image. So what we see here is every pixel on the right hand side, okay, is represented by a number digitally and stored in the computer. And you guys see is these numbers could range anywhere between 0 and 255. And as I mentioned, if you grab, let's say, a white cell, for example, here, you will notice that these numbers are quite high. Let me zoom in a little bit. So for example, if I hover on top of the white cells, you will notice that the numbers are 254, 256, and so on, indicating that this is a white cell, essentially. And if you go to a little bit of a darker cell here, you will notice numbers are 24, 25, indicating that this cell is a dark cell. Anywhere in between, these are grayscale. So here I have 157. Here I have, for example, 161, and so on, indicating any number between 0 and 255. Okay, what I have here is what we call it a kernel. And what you guys see is I can essentially select various kernels. For example, I can select a kernel. When I say a kernel, think of it as a matrix. This is a kernel, a matrix, that is simply 3 by 3 matrix. And to apply convolution process, as I mentioned, we take that kernel and then we place it on top of the image, okay? And we do the multiplication, essentially. It's really cool. So what I have here, for example, is I multiply the values of the pixels, which is, let's say, 75, 200, 249, 96, 143, 223, and so on. We multiply the values of the pixels by the values of the kernel, which is 0.0625, 0.125, 0.0625, and so on. We multiply the values of the kernel by the pixel values, we sum them up, and then we come up with one number, and that's 167, and then I place that number on the right. And that's essentially how you apply a kernel on top of the image, and you end up with a single number. And what you guys see here is, well, you have been able to take the original image and essentially apply blurring to it. You have been able to blur the values. Well, I can go ahead and maybe change it to, let's say, sharpening, for example. And what you guys see is the values of the kernel changes. However, the values of the pixels here are the same. So when you apply the kernel on top of the images here, you will end up with a sharpened image on the right hand side. Again, exact same process, but different numbers. Okay, all right. So this is simply convolutions in a nutshell. The second process that we do after we apply the convolutions, as I mentioned, is we apply what we call a pooling or downsampling. And the overall idea is we wanted to essentially reduce the size of our feature map. And the intent is to improve the computational efficiency while preserving our features. So what we see here, for example, is, let's say I have a feature map that looks like that. And what I do is I apply what we call it max pooling as an example. So essentially we take every 4 pixels here and we obtain the maximum value out of these pixels. So here, for example, I have 1, 1, 3, 6. I will pick the number 6 and I put it here. And then shift to the right, for example. And then I have here a bunch of numbers again. I obtain the maximum value, which is 8. And then I put it here. And so on. I'll get number 9. And then here I get the maximum value, which is 4. And this is simply what we call it the max pooling process. And please note that the max pooling process here, what we have done is we have been able to select only the important features, only the important prominent numbers, like number 6, 8, 9, and 4, and we essentially ignored anything else otherwise. And then after we do that, we apply what we call it a flattening process. So we take all these different values here and then we flatten them up, and then we take them and then we feed them to the dense, fully connected artificial neural network. Okay? All right. So that's it. That's simply all I have for task number 5. I hope you guys enjoyed it. In task number 6, let's go ahead and show you guys the convolutional neural network visualization. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, we will learn how to visualize our convolutional neural networks that we introduced in the previous task. Please note that this task as well is quite on the advanced end, so I'll do my best to make it as easy as possible. Okay, so if you guys remember, in the previous task, we learned about convolutional neural networks. We learned what is an image, first of all. We learned about the feature detectors or feature maps, and then how to do pooling afterwards, and how to flatten all the different pixels, and then we feed it into a feed-forward dense artificial neural networks. We dig a little bit deeper into the feature detectors, and also we have been able to cover the pooling process, or what we call it downsampling process as well. Okay, alright, so what I wanted to show you guys right now is I wanted to show you the second tool that we are going to cover today, which is by Ryerson 2D and 3D visualization. So here is a link to the tool, and I actually have it open here. It's pretty simple, I would say, pretty straightforward. But the overall idea is it tries to essentially open up the convolutional neural network and trying to show you what is actually going on behind the scenes, what's actually going on inside it. And what you see here on the left hand side is we can essentially write a number, we can draw a number, and then we can see how the convolutional neural network is able to recognize that number and essentially classify it here. So what I have here is the input, and what I have here at the end is the output. And what we have here in between is we have the first convolution layer. If you guys remember, we apply kernels, and these are the first convolution layers, or the kernels, and we extract multiple features from the original image. And then what we do next is we do what we call a downsampling. So essentially we reduce the size of our feature map. What you guys see here is the size has been reduced, and this layer, or I would say this network, contains multiple convolution layers. So as I showed you guys previously in the previous example, we only had one convolution layer followed by one downsampling. But right now, this network is quite deep, That's where the term deep learning or deep neural networks comes into play. Now we have another convolution layer followed by another downsampling layer. And then what we do afterwards is we take all these different pixels and then we flatten them up. That's what you guys see here, essentially a 1D array. And then we have a dense, fully connected artificial neural network here. And then finally we have the output layer, and essentially contains numbers that range between 0 and 9. Okay, what you guys do as well is that you can go ahead and show different convolutions. So you can show a layer and you can hide it. You can also do downsampling, so you can show the downsampling layer and hide it as well. And again, you can also, of course, show the second convolution layer and the second downsampling layer. Here I have the fully connected layer, the first one, the second one, and then I have the output layer, which is this layer here, and of course the input layer, which is the first layer here. Okay. All right, so let's go ahead and see one of those layers in action. So for example, what if I say, let's say I have a bunch of numbers here between 0 and 9. So if I, for example, write, let's say number 3, for example, what you guys see here is, first of all, when it comes to the guess of the network was actually able to guess it right. Right now, the actual class was number 3, meaning that the network was able to, first of all, extract features out of the image that I draw myself. And because this network right now is pre-trained, it has seen many of these samples, many of these examples before. And that's what I have here. The first layer is the convolution layer 1, and that's the feature extraction stage. So extracted features out of my image. And then what happened afterwards is you compress those features. So you apply downsampling or pulling, and that's what we're doing here. So we reduce the size of the features. And then afterwards, we have another convolution layer afterwards, followed by another downsampling layer here, which is a pulling layer. And then we take all these different pixels, we flatten them up, and then we have a dense, fully connected artificial neural network. And then finally, we have the class, which is number 3. And what you guys see here is the first guess was number 3, and here, the first guess is number 3 here. My apologies. And then the second guess was number 6. Okay? All right. So that's simply all I have for this tool, the data visualization tool by Ryerson. And now it's time for a quick mini challenge. I want you guys to use that 2D convolutional neural network data visualization link that I provided with you guys. I want you guys to experiment with at least 3 numbers and assess the performance of the trained model. Was the actual model able to get the class right? Maybe try number 4, for example, or maybe number 9, some of these, let's say, complex numbers. And then the second step that I want you guys to do is, instead of using 2D convolutional neural network visualization, actually Ryerson, they provided as well another, what we call a 3D convolutional neural network visualization. I want you guys as well, I provided a link for you guys here, so you can go ahead, give it a shot. And I want you guys to essentially visualize at least 3 different numbers as well and assess the performance too. Okay, so please go ahead, pause the video, give it a shot, and I'll see you guys after the challenge. Alright, hope you guys were able to figure out the challenge. It's pretty straightforward. What I have here is, well, I can go ahead and change these numbers. Maybe write number 7, for example. And what you guys see here is the first guess was 7, meaning that the network was able to correctly classify the image. I can also try, let's say, number 8. So here is number 8. What you guys see here is the first guess was actually 3, meaning that the network is confused between number 8 and number 3. Okay? And what you guys notice is the network was actually quite close, meaning the second guess was number 8. So let's go ahead and maybe try it one more time. So this is again, maybe see if it's able to detect it. Here we go. Now the first guess was number 8, meaning that maybe we need to provide the neural network, maybe, or retrain it with more or additional images for the number 8, because it messes up with number 3, for example. I can also try, let's say, number, for example, 4. So this is number 4. Here we go. And the first guess is 4, and the second guess is 1. That was right. And maybe try the last number, which is, let's say, number 1, for example. So that's number 1. Here we go. The first guess is 1. Looks great. And that's it. That's simply all I have for the first part of the mini challenge. If you open the second part, which is our 3D visualization, here we go. here I have the 3D visualizations. What you guys see here is pretty much the same, but you can actually rotate these different neural networks, and you are able to visualize all the different layers in 3D, which is a lot more cool, I would say. And of course, I can go ahead and give it a shot again. So for example, I can write, let's say, number 3, for example. Here we go. And the first guess is number 3, and you are able to visualize all the different layers in 3D. So again, you have the first layer, which is our convolution layer. We extract new features, and then we're feeding all these different features to a downsampling or a pooling layer. And what you guys see here, the size is reduced. However, the features are still maintained. And then we have another convolution, followed by another downsampling. And then we take all these different pixels, we flatten them up, we feed them to a dense, fully connected artificial neural network here. And then finally, we end up with the predicted class in the output layer and indicating this number 3, which is of course matches the input that we got in here. Okay, all right, so that's it. That's simply all I have for this task. I hope you guys enjoyed it. In the next task, let's go ahead and show you guys a couple of the off-the-shelf convolutional neural network, and we're gonna cover a network known as LeNet convolutional neural network, and then I'm gonna show you guys how to visualize these different networks using different tools such as TensorSpace.js. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. In this task, I wanted to show you guys a type of convolutional neural network known as LeNet, okay? And please note that LeNet convolutional neural network is actually quite old. It actually appeared around 1998 timeframe. And I'm going to show you guys the architecture from a very high level, and then in the next lecture I'm going to show you guys how to visualize the LeNet convolutional neural network as well, and we'll learn how to essentially use LeNet to classify various numbers that ranges between anywhere between 0 and 9. Please note that this as well task is quite advanced. So if you guys remember, in the previous task, we have been able to use the Ryerson 2D and 3D data visualization tool, and we have been able to visualize a basic convolutional neural network, if you guys remember. I hope you guys were able as well to figure out the mini challenge too. Okay, so when it comes to LeNet, so LeNet is a convolutional neural network that has been presented by Yann LeCun. And Yann LeCun is one of the top kind of prominent researchers in the field of deep learning. And this is the paper here for the image, essentially. And I actually have the paper open for you guys. It's pretty interesting, but of course it's quite advanced. But essentially in this paper, it's around 1998 timeframe. And if you guys scroll down, it essentially explains the different, the architecture of the LeNet convolutional neural network. And here is the actual network that I'm referring to. And simply, again, from a very high level, what happened is you take the input image, and then you first apply convolution process. So you try to extract features from the input image. So essentially what I have here is I have a 6 convolutions, and each of these has the dimensions of 28 pixels by 28 pixels. If you guys remember, when we apply the first layer, which is a convolution layer first, we try to extract prominent important features from the image. And that's what we're doing here. We essentially have 6 different variations of the original image. And then what we do afterwards is we apply downsampling, or what we call it here, subsampling or pooling, kind of reduce the size of the feature maps. And that's what we're doing here. So essentially we take these different feature maps and then we reduce their size. So we do subsampling, and now I have still 6 layers here, 6 layers, and each of them is 14 by 14 pixels instead of 28 by 28, because now I reduce their size. And I'm not going to stop there. I'm going to add additional convolution layers. So now I have another convolution layer. And what I have here is I have right now 16 different feature maps, and each of them is size 10 by 10. And then I'm going to reduce their size again. So now I'm reducing their size. I'm doing another subsampling or downsampling. And what you guys see here is the size was 10 by 10. Now the size became 5 by 5. And then afterwards, we take all these different pixels, we flatten them up. If you guys remember, we have a fully connected artificial neural network here. So now I have 120 layers, followed by 84 layers here, or I would say 84 neurons per se. And then finally I have 10 outputs, and of course the number 10 makes sense because I have 10 different numbers that I'm trying to classify. These numbers range between 0 and 9, right? Okay, so this is essentially the architecture of the Linnet convolutional neural network in a nutshell. Pretty simple, pretty straightforward. Another key point that I wanted to show you guys is whenever you see the word C, that means, so C for example here, C1, that means you are doing convolution first. And then here I have another C, that means you're doing another convolution. When you see the letter S, that means you're doing subsampling. That means you're doing tooling. You are reducing the size, and that's what we're doing here. So there is a subsampling layer, there is another subsampling layer here too to reduce the size of the feature maps. And then finally I have the F layer, and that means it's a dense, fully connected artificial neural network, and that's what I got here. And that's where I have 84 neurons in the output layer, or before the output layer, I would say. And that's it. That's simply all I have for this task. It's pretty straightforward. What I'm going to do in the next task is I'm going to show you guys how to visualize our Linnet convolutional neural network using tensorspace.js. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, let's go ahead and perform 3D visualizations using tensorspace.js. Please know that this lecture is intermediate level difficulty. And if you guys remember, in the previous task, in task number 7, we have been able to cover the Linnet convolutional neural network. And we learned that Linnet essentially has a feature detection layer, convolution layer first, followed by a downsampling, and then another convolution, followed by another downsampling, and then we have our dense, fully connected artificial neural network, and then finally we have the output containing 10 different outputs for our different numbers, essentially 0 to 9. Okay, so what I wanted to show you guys right now is I wanted to show you the tensorspace.js. So I'm going to head to tensorspace.js here. So I have it open here. Alright, so if you guys go to tensorspace.org, what you guys see here is we have multiple convolutional neural networks that you're able to visualize, which is super powerful. So as I mentioned, we are going to visualize today our Linnet convolutional neural networks, and then there are a couple of other examples as well, such as ResNet and AlexNet as well. Don't worry about those, we're going to cover them in the next couple of lectures. So if you click on Linnet, what you guys see here is, well, here I have my Linnet convolutional neural network, which is super cool. So if you guys go back to our slides here, what you guys see is the first layer was a convolution layer, the feature extraction layer, consisting of 6 feature maps. If you guys recall, I have 6 feature maps. So if you guys go back here, what you guys see is that's essentially what I see here. I have the first 6 feature maps, these ones here, and each one of them is, if you guys hover on top of it, is 28 by 28 pixels, and that's what I got here. I have 6 feature maps, each of them is 28 by 28. If you guys recall, the next step is we have a downsampling or subsampling layer. Now we are reducing the size of our feature maps, and that's what I'm doing here. So if you click on it, that's going to expand the layer for us, and here we go. What you guys see is I still have 6 as well here, convolutions, if you guys see, or I would say feature maps here, but now we have been able to reduce them, reduce their size. So the original size was 28 by 28, however if you go here, what you guys see, now I have 14 by 14, the blue ones here, okay? Alright, and then what I have next, if you guys recall, I have another convolution, and then I will end up with 16 different feature maps, and each one of them is 10 by 10. So if you go back, and if you try to expand the next layer here, here we go, I have 16, so I have 1, 2, 3, 4 by 1, 2, 3, 4. So 4 by 4, that means 16, and that's the second, essentially, convolution. Afterwards, I have another downsampling, and if you guys see here, I still have the same, essentially, size, so I still have 16 different convolutions here, right, or I would say feature maps, but their size is much smaller. What you guys see is essentially I took these features here and then I was able to reduce their size in the next layer. And that's what I've got here. I took these 16, reduced their size, and that's what I ended up here. Still 16, but now they are 5 by 5 instead of 10 by 10 pixels. And then afterwards, if you guys see here, if I try to expand that, now I took all these different pixels, if you guys remember, essentially flattened them up, and that's what I ended up here. So I flattened them up, and then I was able to connect them to a dense, fully connected artificial neural network, and that's what I've got here. So you took all that, you connect them to another layer here. This is the 84 neurons, and then I have the output, and what you guys see is if you write, let's say, number 5, you will see that the output here, number 5, has been able to fire, or essentially has the highest probability per se. And you can actually go ahead and test the network right now with different numbers. For example, I can write, let's say, number 3, and what you guys see here, that's essentially what's going on behind the scenes. You extract different features initially with the convolution layer first. You reduce their size, you perform downsampling. You do another convolutions afterwards, another downsampling, you flatten it up, you add another dense, fully connected artificial neural network, and then you end up at the end with the output. And of course, you can go ahead and clear it up. Maybe you can write number 6, for example, here. You can say, let's say, number 6. And what you guys see is number 6 here has been able to fire, and that's essentially what the network can see behind the scenes. Super interesting, super cool. And if you guys go back, you will be able to see I've included a couple of slides here for you guys. So in task 8, as I mentioned, we're going to go ahead and visualize our LeNet convolutional neural network using TensorSpace.js. Here we go. Here we have our CNN LeNet that I just showed you guys. And that simply concludes task number 8. I hope you guys enjoyed it. In task number 9, let me show you guys another convolutional neural network, which is one of the state-of-the-art convolutional neural networks available right now, which is known as ResNets, or residual neural networks. And then we're going to learn how to visualize them, and then we're going to have our final project, and that's it. That's simply all I have for today's task. I hope you guys enjoyed it, and see you in the next task. Hello everyone, and welcome to task number 9. In this task, I'm going to show you guys super powerful type of convolutional neural networks is known as ResNets, or residual neural networks. Please note that ResNets are super powerful, and it actually won the ImageNet challenge back in 2015 and is able to achieve incredible performance compared to human performance on classifying images, which is super powerful. If you guys remember, in the previous task, we have been able to visualize our LeNet convolutional neural network in TensorSpace.js. What I wanted to show you guys today is I wanted to show you ResNets, what they are, and please note it's quite complex, and that's why I'm going to show you guys kind of the architecture from a very high level, and then I'm going to show you as well the visualization behind the scenes in TensorSpace.js, and that should simply is going to conclude our today's activity. And of course, we're going to have a final project in task number 10, where you guys are going to take a brand new network and you will be able to visualize it as well in TensorSpace.js. Okay, so the question is, what is ResNets and why they are called ResNets, or residual neural networks? So ResNet is a powerful convolutional neural network that won the ImageNet challenge back in 2015. And if you guys remember, ImageNet is an open source repository of images. It contains like 14 plus million images, and it contains over 21,000 categories. And ResNet was actually able to achieve pretty powerful performance, like around 3.57% error, which is pretty incredible. And the main key point behind ResNet is right now we are essentially able to stack many layers, maybe around 152 layers approximately within the ResNet, and we're able to do that and also overcome a problem known as the vanishing gradient problem. Basically, before ResNets, whenever we stack additional layers on top of our just the basic, let's say, LeNet or AlexNet, when we stack additional layers, what happens is that a problem known as vanishing gradient problem tend to occur. Basically, we use the gradient to try to go back to the network and update its weights. And one of the challenges, when you stack all these different layers on top of each other, the gradient becomes very, very small, and essentially the network performance becomes super poor, extremely poor, and you're not able to train the network anymore if you have a very deep convolutional neural network. And the key, I would say, takeaway that I want you guys to get out of ResNets, because again, it's a complex, essentially, topic, but the overall idea is we use what we call it skip connection. Basically, we feed in the input here, let's say, to this layer, and we also do skip connection. We feed in the exact same input, we skip the convolution layer here, and then we pass it along to the next layer. And by doing that, we are able to overcome the vanishing gradient issues, and we're able to stack hundreds of layers on top of each other. So I have a couple of resources available for you guys here if you wanted to dig a little bit deeper. So for example, this is the first resource. Basically, it states the understanding and coding of ResNets in Keras. And again, this course, we're not going to be doing any coding in it at all. I just want to show you guys, for example, a couple of performance, let's say, of various networks. So if you guys remember, here I have, let's say, a couple of networks, such as AlexNet, for example, and it only has 8 layers. We also have VGG, another network, has around 19 layers. And what you guys see here is ResNet has 152 layers. We're actually able to stack many layers on top of each other, and we're able to achieve massive improvement. Like the error was again around 3.57% on ImageNet dataset, which is super powerful. And there is also a couple of description here. So ResNets, short for residual neural network, is a classic neural network that is primarily used as backbone for many computer vision tasks. And the model has won the 2015 ImageNet challenge. And the main breakthrough within ResNet is you are able to train extremely deep neural networks with over 150 plus layers. And before ResNets, we weren't able to actually do that. And that's why the limitations here that we had, because of the vanishing gradient problem that I described earlier. Okay, and you guys can go ahead, of course, and read a little bit more about the skip connection. The overall idea is we feed in the input to the convolution layer, and we skip this layer here, and then we feed it into the next layer. And I'm going to show you guys, when we cover the visualization as well, how we do that skip connection. And if you guys wanted to kind of open and explore the structure of the network, here is the structure of the network. What you guys see, again, we have many layers, 152 layers. And please note, guys, that this is super powerful. This is essentially like you are building like a brain, like a mini human brain that is able to classify images, able to recognize objects, which is super powerful. And this is simply the skip connection that I'm talking about. So you have a bunch of convolution layers, and then here you are skipping you are feeding in the input, and you're feeding in as is to here, to this layer. And then you're feeding and skipping it again, and skipping it again. And by doing that, you are overcoming the vanishing gradient problem when you train your convolutional neural network. Okay, all right. So what I wanted to show you guys next is, let's go ahead and head to tensorspace.js. And I wanted to show you guys the residual neural network. So if you guys see here, we have LeNet. Here we have the ResNet 50. So if you click on it, what you guys see is right now it's around 98 megabytes approximately, and we are right now loading the ResNet 50 pre-trained model. And what we're going to be able to do is, I wanted to show you guys all the different layers, and I wanted to also show you guys the feature of the skip connection. I wanted to show it to you visually, and that should simply going to conclude our today's task. And in the next task, we are going to have a final project where I'm going to ask you guys to explore a brand new network. And here we go. What you guys see here is basically I have my residual neural network, or ResNet. And what you guys see is ResNet here has many layers. Of course, it's a lot more complex compared to LeNet, which only had 5 layers before. And if you open, let's say if you zoom in a little bit and you open, for example, one of the layers here, let's say the first layer, what you guys see is I have a ton of feature extraction layers, right? I have tons of convolutions, what you guys see here. And then if you guys hover on top of this red here layer, you guys will notice that there is a skip connection. That's essentially the skip connection that I'm talking about. You are skipping the input here from this layer, these 2 layers, and you're skipping them. And that's what helps us or empower us to train a very deep convolutional neural network, and without having the vanishing gradient issue or vanishing gradient problem. And of course, if you try to expand all these different layers a little bit, here we go. You can essentially expand upon this layer. This is another convolution layer, another convolution layer. Pretty amazing. This is essentially, again, like, you know, like a brain that is able to do human level tasks, which is pretty incredible. And this is simply the skip connection that I'm referring to. And here we go. If you open, let's say, another layer, another convolution layer, and here again another skip connection. That's what we got here. And what you guys see is all these different layers. Again, it's a massive brain essentially, and when you get closer to the end, that's where you have your output. And in the output, essentially, I have the dense fully connected artificial neural network at the end. So if you guys see here, essentially these are the output layers. So if you try to expand upon it, again, I have the skip connection, I have the last layer, and then I have a dense fully connected at the end here. Again, pretty intuitive, pretty amazing. Again, it's a lot more complicated, of course, compared to AlexNet, but these are essentially the different feature extraction layers and convolution layers within our residual neural network, or ResNet. Okay. Alright, so that's simply all I have for today's task. I hope you guys enjoyed it. And basically in the next task, in task number 10, I'm going to cover our final project. So I'm going to introduce you guys to a brand new convolutional neural network. I'm going to ask you guys to explore this type of convolutional neural network and also visualize it in TensorSpace.js. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 10. In this task, we are going to cover our final project, part B, and that should simply conclude our today's activity. And if you guys remember, in the previous task, we covered another type of convolutional neural network known as ResNets, or residual neural network. We learned that ResNets have over 150 layers, around 152 layers in fact, and we learned about the skip connection as well, and we were able to visualize the ResNet in TensorSpace.js. And now it's fun time, okay? And I'm going to ask you guys to first research a different type of networks, which is known as AlexNet, and I want you guys to explore the network architecture as well. And the next step is I want you guys to visualize AlexNet in TensorFlow.js and kind of make sure that the network that you guys researched or looked for matches the TensorFlow.js implementation. So please go ahead, pause the video, give it a shot, and I'll see you guys after the final project is complete. Alright, so I hope you guys were able to figure out the final project. So first of all, when it comes to AlexNet performance, if you guys go back to our previous article here, what you guys see is essentially I have multiple networks, and AlexNet here is listed as one of them. The AlexNet network has 8 layers, and the performance is 16.4% error, as compared to ResNet, which is residual neural network, that essentially has 152 layers, so it's a lot more complex compared to AlexNet, and of course the performance is much better compared to AlexNet as well. Okay, so the second point that I wanted to show guys is if I go back to our slides here, this is simply the architecture of our AlexNet. So what you guys see is essentially I have the input image, and essentially the input image is RGB image. Essentially it's red, green, and blue. So essentially it's a colored image. So what you guys see here, these are the dimensions of the input image, and this 3 means I have a 3-dimensional input. It's not like grayscale, it's actually colored input image. And then we have a convolution layer first, followed by a pooling, and then another convolution, and then another pooling, and then another convolution, another convolution, another convolution. So I have here 5 convolution layers, followed by another pooling, and then I have dense, fully connected artificial neural network here, and then I have the classes here in the output. So what I'm going to do is I'm going to head back to our TensorSpace.js, and what you guys see is we have been able to already explore AlexNet architecture. We also explored the ResNet architecture as well. Let's go ahead and visualize AlexNet, and let's see if actually that matches our diagram that I just showed you guys right now. Alright, so here we go. So now I have AlexNet has been loaded. It actually took a couple of minutes for it to load. And here we go. If you guys click on, let's say that's an image of a dog right there. So if you go ahead and click on it, well, you guys see that now we have essentially 3 different layers. As I mentioned, because right now we're feeding in colored images. So essentially I have the red, green, and blue. Okay, and then the first one is I'm going to have the first convolution layer first. And then it looks like I have a downsampling layer afterwards, another convolution, followed by again another layer downsampling, and then another convolution, another convolution, another convolution, one more downsampling. Pretty amazing, to be honest. And then if you zoom in a little bit, you should be able to kind of explore all these different features, kind of like going inside the brain, you know, like going inside essentially all these different feature detectors and see what they actually see when they detect a dog, for example. If you zoom out a little bit and maybe explore the additional layers in here, you should be able to see now I have a dense, fully connected artificial neural network and the output, and then another dense, fully connected, and then I should be able to have the final layer as well, which is the output layer. And that's it. That's pretty much how you visualize AlexNet. Pretty amazing, pretty incredible. And that simply concludes our project for today. I hope you guys enjoyed this project. In this project, we actually learned a lot. We learned how to visualize various state-of-the-art convolutional neural networks. And we also have been able to visualize as well just basic, plain, feed-forward artificial neural networks. We have done that in many tools. So we have used Google TensorFlow Playground, we use TensorSpace.js, and we also have been able to visualize it using Ryerson 2D and 3D visualization as well. So that's it. I hope you guys enjoyed this task, and please have some rest, and I'll see you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 5. Today, we are going to learn a brand new tool known as Data Robot. And we are going to use Data Robot to predict car prices using various features, such as horsepower, number of cylinder, engine size, the make, and the weight as well of the vehicle. So let's go ahead and get started with task number 1. So in task 1, we will cover the project card and the demo as well. And please note that this task, I would say, is quite easy, so gonna be pretty straightforward. And as we move forward throughout the entire day, all the topics and the tasks will become a little bit more advanced. Okay. So here is the project card. So the goal is to build, train, test, and deploy a machine learning model so we will be able to predict used car prices based on their features. So for example, I'm going to use a couple of car features such as the make of the vehicle, the model, the type, the origin, the drivetrain, engine size, number of cylinders. And the objective here is to try to predict the MSRP, which is essentially the price of the vehicle. And the tool that we're going to use today is known as Data Robot, and you guys will really like it because it's super powerful and it will make our life extremely easy. We'll be able to build, train, test, and deploy a machine learning model without writing a single line of code. In fact, instead of just training one model, we are going to train many models, and we are going to pick the best one to deploy it. And in this project, from a practical real-world application point of view, the project can be effectively used by car dealerships to predict used car prices and essentially understand what are the key factors that can be used to kind of contribute to the actual prediction. So we can know, for example, let's say the horsepower of the vehicle has a direct correlation with the actual price of the car. Here are the inputs, I mentioned them already, and the output, of course, is the MSRP. And if you guys wanted to check out the actual data source, you guys can go ahead and click on this link. The data is available on Kaggle website. Okay, so let me show you guys a demo. So here is a demo of our application within Data Robot. And essentially what you guys need to do is to come here, insert all the features. So for example, let's say I have a car dealership, and I wanted to come up with kind of a prediction of the used car price given various features. So for example, I'm going to go and say, well, I have a car that maybe has 210 horsepower. Maybe the number of cylinders, maybe I have 10 is a lot. So maybe let's say I have a car that has, let's say, 6 cylinders, for example. Okay. And then I'm going to say the MPG of the city, or the mileage per gallon for the city, is, let's say, 19. For the highways, let's say 26, for example. And the make, let's assume, for example, it's, let's say, a Mazda, for example. So I'm just going to go here, say a Mazda. And the car is, let's say, let's stick with hybrid, for example, drivetrain all. This is the length and the wheelbase as well. And all what you guys need to do is to essentially click here, and that is going to go and tell you the actual prediction of the actual car price. So basically the car price is $25,000. So based on these features and based on the actual training data that the model learned in the past, it can be able to predict for you the actual car price. Let's assume, for example, that I have another vehicle, and this vehicle maybe has, let's say, for example, 410, let's say, horsepower, for example, like really high. And let's keep all the features as is. And if I go here and click refresh again, you guys will see that the price actually starts to increase quite a bit, meaning that the horsepower variable here has, of course, a direct correlation with the actual price of the used car, which of course makes complete sense. What if I, let's say, maybe go back and shift it, let's say, to 210, for example, again, and you run it again, so the price will go down, of course. And I can go ahead and maybe change, let's say, the make from Mazda, let's say, to BMW, for example. If you run it again, you guys will see that just the brand on its own just increase the actual car price by, let's say, $2,000 or $2,000, which of course makes sense. And of course, if you increase the number of cylinders to maybe, let's say, 10, for example, and you run it, you should be able to see, of course, that the car price starts to increase again. And that's pretty much all I have for today's demo. Let's go back to our slides. So go back here. And in the next task, in task number 2, we will learn about success stories. And I'm going to show you guys as well a reading material. We're going to be able to go through a quiz. So that's all I have for task number 1. I hope you guys enjoyed it, and see you in task number 2. Hello everyone, and welcome to task number 2. In this task, we will cover a couple of success stories. If you guys remember, in the previous task, we covered the project card, and we also went through a quick project demo. I hope you guys enjoyed that demo. Okay, so regarding success stories, in this project, we will learn how to perform price prediction. And price predictions of products and services is generally a critical task for any company to try to maximize revenues and reduce costs as well. And fairboom.com is an innovative tool that leverages machine learning to predict flight prices. And the tool has been developed by a company called Altexsoft, and I really like the case studies that they actually shared on their website. So if you guys click on this link here, you should be able to see a ton of examples and case studies. I actually have it open here. So there are tons of case studies available that try to apply AI and machine learning to perform tons of tasks. One of them, of course, is price predictions. So for example, here you should be able to see building machine learning based recommender system for real estate marketplace. You will see as well other applications on trying to personalize all the user experience in OTA as well. If you scroll down, you should be able to see a couple of other applications as well on the market segmentation and freight booking as well. And the actual case study that I'm interested in is here. The link is available here, which is on fair price predictions. So if you guys click on it, you guys should be able to see this case study here on fair price predictions. Actually, I have it open here. Okay, so you guys will see that essentially Fairboom is a project that has been primarily used to try to kind of predict the price of different flights. And there are a lot of information available here regarding all the business challenges and all the different value delivered as well. Basically, by leveraging AI and machine learning, the company has been able to uncover the hidden patterns within millions and millions of data sets. And they have been able to predict the future price movements with high confidence, and of course to try to seamlessly integrate the price predictor with the website, and also to perform kind of an optimized experience as well to the customers. And here is the product UI. So essentially you can say, okay, where do you want to fly from, where do you want to fly to, and the time, and they can essentially show you the actual predictions of all the prices in the future. So basically you can kind of come up with an informed decision of when is the best time to book your flight to maximize essentially to minimize the fare ticket price. Okay, so the fare forecast feature has been developed to help users make better purchasing decisions, and the tool can guide customers to select the best time to purchase their flight. And the tool essentially, of course, is built on a self-learning machine learning algorithm that can predict the future price movements by taking into consideration historical data, all the deals, demands, and seasonal effects as well. Okay, so now it's time for our reading time and quiz as well. And here is a link to an article. It's entitled Price Forecasting: Applying Machine Learning Approaches to Electricity, Flight, Hotels, Real Estate, and Stock Pricing. So I have actually the article over here, and basically the reading time is approximated to be around 19 minutes, but I'm not expecting you guys to read the entire article per se, or might kind of, like skim through it, because we only have dedicated around 1 hour, might take a little bit longer, but for the entire case study. So I'm expecting you guys to skim through the article and of course answer the quiz afterwards. So the actual article itself might take around, let me see here. So the actual article can take around, I allocated 10 minutes for it, and the quiz should take around 5 minutes. So that's all I have for task number 2. Best of luck on the quiz. And in task number 3, we will learn how to perform data exploration. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, we will learn how to perform data exploration. So if you guys remember, in the previous task, we went through our reading time, which is our article here, and we went as well through a quiz. I hope you guys were able to figure that out. Okay, so let's go ahead and cover the inputs and outputs for our model at hand. So the objective here is to develop a machine learning model, and the inputs to the machine learning model is as follows. We have the make of the vehicle, the model, the type, the origin, the drivetrain, the engine size, number of cylinders. We also have the horsepower, the mileage per gallon for the city and for the highway, and also we have the weight, the length, and wheelbase as well. And the main objective is to try to predict the vehicle price, or the MSRP price. That's all it is. So please note that this task is primarily what we call it a regression type problem, meaning what we're trying to predict here, since it's a continuous output, like let's say the price of a vehicle, or maybe a stock price in the future, or maybe employee salary, for example. Since we are trying to predict a continuous variable, then this problem is categorized under what we call it regression type problems. And please note, in task number 9 and 10, we are going to learn about the technicalities of the algorithm. What's actually happening behind the scenes? What do we mean by actual regression to start with? So hang in there, and we're going to cover that in great details in the later tasks. Okay, so here is an overview of the data. So the data we have our make, and this essentially could be all the different makes for vehicles. So we have Acura, we have Audi, we have like BMWs, we have Chevy, and so many other various makes as well. Here we also have the model of the vehicle. So you can see that, for example, you have, let's say, a convertible 2D, or 2 doors, I mean. Here we have, let's say, the different models, let's say Acura MDX, or let's say the Audi A4, for example. And here we have the type. It's either sedan, sports, or SUV. We also have the origin, which is the country for each of these vehicles. So for example, Acura came from Asia. Audi is, of course, since it's a German brand, so it came from Europe. We also have the various drivetrain, like if it's either all-wheel drive or front or rear wheel drive. Here we have our MSRP, and this is essentially our output from the model. So what we're going to do is that we're going to take all these different features in here, okay, and feed them as an input to the model. And the MSRP here, that will be the actual output from the model. And please note the MSRP stands for the manufacturer's suggested retail price. And this, think of it as more of the price, essentially, that we're trying to predict based on all these features. We also have the engine size. We have the number of cylinders. We also have the horsepower. And you guys will notice as well that horsepower plays a critical role in determining the price of the vehicle. We also have the mileage per gallon for both the city and the highway. We also have the weight of the vehicle, the wheelbase, and the length as well. Okay? Alright. That's pretty much all I have for task number 3. I hope you guys enjoyed it. In task number 4, let's go ahead, jump right away into our data robot and learn how to upload the data and how to explore the data as well. So that's all I have. I hope you guys enjoyed this lecture and see you in the next one. Hello everyone and welcome to task number 4. In this task, let's go ahead and learn about data robot. So please note, in the next couple of tasks, we are going to shift to data robot, and I'm going to divide the different tasks as follows. In the first one, in task 4, we will learn how to just upload the data. And then in task number 5, we will learn how to perform data exploration. And then in task number 6, we will learn how to actually train our model. So let's go ahead and get started with task 4, which is data upload. Please note that this task is quite easy as well. It's pretty straightforward, and I'm going to show you guys how to upload the data and how to sign up as well for data robot. If you guys remember, in the previous task, in task 3, we learned about the various inputs and outputs for my model. We learned that we're going to have the make, the model, the type, and the MPG as well. And we are going to train a machine learning model to try to predict for us the vehicle price. And we also explored the data as well, if you guys recall. Okay, so right now, I want you guys to please go ahead and head towards datarobot.com. And I want you guys to click on free trial. Please note that here I took snapshots just to show you guys how to sign up for Data Robot. So the first question is, what is Data Robot? So Data Robot is the leading end-to-end enterprise AI platform. And the objective is to try to automate the process of building, training, and deploying AI models at scale. Okay? So you guys will see that it's actually super powerful and really, really easy to really build, train, and deploy machine learning models without writing a single line of code. And another key point as well that I would like to elaborate on is this interface might be a little bit different. Okay, so of course they update and refresh the website a couple of times as well, but essentially the key steps should be the same. So we're going to click on free trial, and then you need to enter all your information like your first name, last name, and so on, and you should be able to get a free trial associated with it. So after you do that, you say get started, and then you should be able to receive a confirmation email that are going to be sent to your email with a 14-day trial period. So you activate the trial period, and then you should be able to kind of tell Data Robot about yourself, like what is your role, what is your industry, and why do you want it, essentially. Why do you want it to use? Do you want to use it for training machine learning models, or for ML operations, or for data preparation? And after you do that, then you need to specify as well the kind of customization. So you set it to dark theme, and then you here select the actual application. So you, of course, you're going to use it to create AI models. You can, of course, use Data Robot to prepare the data, to explore insights, and to deploy and monitor. Just please go ahead and click on Create AI Models. And then once you do that, then you should be able to come up to this page. And this is essentially the page that I have in here. Okay, so all what you need to do, which is again super, super powerful, is you need to go ahead and click on ML development. And there are several options as well within Data Robot. So for example, you can use it to perform data preparation. So you can visually prepare data sets and kind of make them ready to train machine learning models. You can also perform machine learning development. So you can use AutoML, you can use visual AI and more kind of to build machine learning models in minutes. And you can also use it to perform machine learning operations or MLOps, to deploy, monitor, and manage machine learning models in production. So what we're interested in right now is this one here. So if you click on it, and you should be able to see create new project. So please go ahead and click on create new project. And what you guys see here is very simple. All what you need to do is to simply drag and drop your data in here. So in the course package I've included under day 5, you should be able to see used car price. And this is simply the Excel sheet that has all the information you need. So what I'm going to do is I'm just going to simply drag and drop. So I'm just going to say, please grab the used car price and just drop it here. That's all what you need to do. And what you guys see here is on the right hand side, you should be able to see that the data is being uploaded. And right now it's reading the raw data as well. And then you should be able to perform afterwards kind of preliminary exploratory data analysis. And what I really like about Data Robot, it's really intuitive and very simple. All what you need to do, just take the data, just drag and drop the data, and you should be able to see here that the data is being read, and it's actually really fast compared to many other services. Like I compare the service, for example, to AWS SageMaker, and you guys will see that this one is extremely fast, like way faster and a lot more efficient. And also I compared as well with other machine learning tools such as Microsoft Azure ML. And what you guys see here is the following. So now the data has been updated, which is pretty great. So if you guys scroll down, you should be able to see all the different columns here that I have in my data. So here you should be able to see the make, the type, the origin, the drivetrain, essentially all the different columns that I have in my Excel sheet. The second point that I wanted to show you guys is here, it shows data quality assessment. So if you click on view information, you guys will see that the Data Robot has indicated that there has been outliers in 7 of the features. And because this, I would say, warning here is pretty simple, pretty straightforward, I'm just going to go ahead and just dismiss it. Okay, so don't worry about it. And this is simply all I have for this task. In the next task, I'm going to show you guys how to explore the data, actually how to click on these different features here, and how to also set our target column as well. So before I conclude, let me go back to our slide. So this slide 4 again. So here are the different steps. All I need to do is to simply grab the used vehicle prices.csv, drag and drop. And after the data is being uploaded, you just need to simply ignore the data quality assessment information here that appeared, and the warning messages, because it's pretty straightforward, just outliers. We're just going to ignore it for now. And that's simply all I have for task number 4. I hope you guys enjoyed it. In task number 5, we will learn how to perform data analysis. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, we will learn how to perform exploratory data analysis. If you guys remember, in the previous task, we learned how to simply just upload the data to Data Robot. All what we have done is we dragged and dropped our used vehicle price.csv file to here, and simply ignored our warning sign here showing outliers. And now we're pretty much ready to go ahead and perform exploratory data analysis. And please note that right now we're still in day number 5 and we are still in task 5. And please note that this is quite easy as well. Okay, so what I'm going to do is I'm going to head back to our Data Robot to show you guys. So first of all, what you need to do is if you scroll down, you should be able to see all the different features. For example, if you click on make, you will see all the different makes of the vehicles. So you should be able to see that there is a lot of Toyota, for example. These are the number of rows here. So I have 28 rows that belongs to the Toyota brand. We have the Chevy as well. We have 27 rows. And if you guys see, there are Jaguar, Kia, Lexus, and so on. And of course, if you are a car fan or car enthusiast, you should be able to really like this data set and found it pretty intuitive. And if you scroll down, you should be able to see the type as well. So here I have the sedan, SUV, sports, trucks, and so on. And please note that if you try to do the exact same data visualization, but just using, let's say, Anaconda, for example, and Python, it will take you a lot of time to use and leverage a lot of the data visualization tools or libraries such as Matplotlib and Seaborn. Here it just automate the entire process for you and make it really easy without writing any code, which is super powerful. You can also click on origin, so you see these are the different origins. So you should be able to see that Asia, we have around 160 rows or 158 rows approximately. That belongs to the Asia. There is US and there is Europe as well. If you check out drivetrain, we have the front, rear, and all. We also have here the MSRP. And please note the MSRP, which is the manufacturer's suggested retail price. This is simply our target column. That's what we're trying to predict. So what you guys notice here is a lot of the vehicles range between, I would say, $20,000 and maybe $30,000 approximately. And you guys will notice that here, as the price goes up, as you hit let's say $50,000 and beyond, of course the frequency of occurrence reduced, because this is not very common that people will go and let's say spend $70,000 or $80,000 on a car, for example. And what you guys need to do here is, because the MSRP is my target column, I'm just going to go here and say use as target. So if you click on it, now you should be able to see that now target has been shifted to green, indicating that now the target has been selected. When I say target, simply I'm referring it to the output, okay? And if you scroll down, you should be able to see as well the engine size. Here I have all the different engine sizes, starting from 2 liter up until, let's say, 8 liters approximately. We also have here the number of cylinders. We have 4, 6, 8, 10, and 12. And we also have the horsepower. Here is the horsepower of all the different vehicles that I have in my data set. We also have the MPG for the city, with the mileage per gallon for the city, and the mileage per gallon as well for the highway. And finally, we have the wheelbase, the weight, and so on. Okay? All right. So what we have done so far is we have been able to perform basic exploratory data analysis. What we've also done is we have been able to select the target column. So once you select the target column, what you guys notice is this start button here has been activated, meaning right now we are pretty much ready to do the training. So that's all it is. Really simple, pretty straightforward. But before we start the training, I wanted to show you guys one more thing. If you guys see here, I want you to click on the show advanced options. And what you guys notice is I wanted to essentially take my training data set and I wanted to divide it as follows. I want you guys to click on train validation holdout, and I wanted to show you guys the difference between the training data, the validation data, and the testing data, or what we call it the holdout data set. So let me shift back to the slides to show you guys what do I mean by that. So please note that all what we're doing here is we select the target, we have done that, and you guys will see that here are all the different visualizations that I showed you. The origin of the vehicle, here we have also the number of cylinders as well, the engine size, and here is the fun part. So in general, what we do is that we divide our data into 3 portions, into training data, validation data, and testing data. And we use most of the data sets to train the model. So what we do is that let's say I'm going to divide the data into 60% for training, 20% for validation, and then 20% for testing, or what we call it holdout data set. And we generally use the training data set to essentially train the model. So I'm just going to go ahead, train my AI and machine learning model with the majority of the data set, which is the training data set. And what we do is we use the validation data set to essentially assess the performance of the model throughout the training. All what I'm trying to do is I wanted to make sure that the model is able to generalize and not memorize. Meaning, I wanted to make sure that the models are not overfitting the training data. And in order to do that, as the model is being trained, I'm going to use the validation data set and essentially feed it into the model to make sure that the model is able to still generalize. And the key point here that I wanted to illustrate is that the training data and the validation data, both of them are being used by the model during training, meaning that they have already leaked within the model. Once the model is trained, and that's the very important part, we wanted to perform an independent assessment of the trained model. And that's why we use what we call it holdout dataset, or the testing dataset. And this is primarily used to perform the final assessment on our trained model. So after the model is trained, we take the testing data or the holdout data, and then we feed it in to the trained model to assess its performance. Okay? Alright, so what I wanted to do is to go back to show you guys here is I'm going to go ahead and select train validation holdout. And I'm going to, again, you guys are free to select here. You can change the actual percentage. So this is the validation percentage, and this is the holdout percentage. So in general, we may be divided to 60% for training, 20% for validation, and 20% for holdout. And you should be able to see here the color code. Most of the data has been fed to training. The validation is 20%, and the holdout is 20% as well. Okay? Alright, and that's pretty much all I have for this lecture. I hope you guys enjoyed it. In the next task, we will learn how to perform data training or model training. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, we are going to train our AI and machine learning model. Please note that this task is quite, I would say, in the intermediate levels, because we're going to dig a little bit deeper into our model training, and we'll go a little bit far away from just basic stuff such as data exploration and selection of the target as well. If you guys remember, in the previous task, we learned how to perform data exploration. We explored our data set, and we also learned how to divide our data or split our data into training, validation, and holdout as well. Okay, so what I'm going to do next is I'm going to head back to our data robot, and I'm going to, first of all, show you guys how to train our model. So to train the model, it's actually super simple. All what you need to do is to just go ahead to the start and just click on start. And that is gonna simply start our training of our model. And what you guys see here on the right hand side, you should be able to see how to set the target features. And these are the different, I would say, stages or steps that Data Robot go through. So they create the holdout partitions and the validation or cross-validation data sets as well partitions. Think of it as more of a splitting the data, and then they characterize the target variable, and then they load data and prepare the data as well, and then they analyze the features, and then they generate models blueprint. So what you guys see here on the right hand side, you should be able to see tons of models are being trained for you. And what you guys notice is here I have the different, what we call it, Keras, residual neural networks. And these are type of neural networks essentially that are being used to perform regression tasks. And they are built in different tools as well. So here, for example, they are using Keras and TensorFlow. And these are the Google platform or framework for training machine learning models. And what you guys notice as well is if you go to models, you should be able to see all the different models here are being trained. And that's super powerful because essentially right now you can go ahead and instead of training one single model, Data Robot is training many models for you, and it's going to show you as well which one is the best, so you can select that and use it for deployment. So if you go back and click on the data again, and if you go and click on feature associations, you should be able to see all the different associations between various features. For example, there is an association between the make and the origin of the vehicle. There is also association between the number of cylinders and the engine size, which kind of makes sense because as the number of cylinders increases, the engine size tends to increase as well. And this number here indicates that there is a positive association between them, meaning as the number of cylinders increase, the engine size tends to increase as well. There is also an association between the mileage per gallon in the city and the mileage per gallon in the highway. And there is also association between engine size and horsepower, which of course makes sense. As the engine size increases, the horsepower as well of the vehicle tend to increase as well. And of course, you can hover on top of it. You should be able to see here all the different associations between, let's say, engine size, for example, and the horsepower. So here I have the horsepower. And here I have the engine size. So here, if you click on it, you should be able to see the actual number. So this is horsepower, this is engine size. You should be able to see the actual mutual information, which is 0.478. And the importance as well is set at 0.41. Okay. Another point that you guys can do is if you click on the feature association again, and if you go down to say view feature association pairs, what you guys notice is if you go ahead and select, let's say I wanted to visualize the horsepower versus the MSRP. What you guys see here is there is an actual correct, MSRP. So what you guys notice here is that there's an actual kind of correlation or relationship between the horsepower and between the MSRP. So as the horsepower tend to increase, you will notice that the MSRP or the actual price of the used car tend to increase as well. If you also go back and let's say change it here to cylinders and you change that to MPG for the city, what you guys notice here is if you have a vehicle that let's say have 4 cylinders only, you should be able to have a high MPG for the city. You can actually drive it. There's a lot of mileage that you can get out of it per gallon. However, as the number of cylinders tend to increase, let's say if you go to 10 cylinders or maybe 12 cylinders, for example, you will notice that the MPG or the number of mileage per gallon tend to reduce quite a bit and tend to go to almost 10 or maybe less as well. Okay? All right. So that's all I have for this lecture. I hope you guys enjoyed it. In task number 7, we will learn how to perform model assessment. So let me go back to the slides and show you guys where we at so far. So I'm going to go back here and I'm going to... So these are all the steps that we went through in task 6. We will learn how to train our model. We also went through the actual, explored the actual progress bar here on the right hand side. We also explore the feature associations. We also plot the different features with each other as well. And that's all I have in task 7. Let's go ahead and perform model assessment. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. We are very close to deploying our model and actually generate predictions or making inference out of our model. So please hang in there and let's keep going. So in task number 7, we will learn how to perform model assessment. And please note that this lecture is, I would say, in the intermediate level difficulty wise. And if you guys remember, in task number 6, we have been able to train our model. We learned that the data robot goes through multiple steps to train our model. It actually trained multiple models. And we also have been able to learn and explore our feature associations between all these different features, such as cylinders and MPG of the city, and also horsepower and MSRP as well. Okay. So let's go back to our data robot and show you guys what we're going to do next. So what you guys see here is the data robot has been able to train multiple models for us. So here we have the rule fit regressor. We also have, if you guys scroll down, you should be able to see we have the extreme gradient boosted trees, or what we call it XGBoost algorithm. And if you scroll down, you should be able to see that we have elastic net regressor, and we also have the Keras residual neural networks. And what you guys notice as well, which is really super powerful and I really like about Data Robot, is all these different models are actually trained in different tools and in different languages as well. So for example, here random forest regressor, for example, is trained using, that's a Python model, for example. If you go here to the Keras residual neural network, you will notice that this one leverages Keras and TensorFlow. And Keras and TensorFlow, these are the frameworks that is being used by Google to build, train, and deploy artificial neural networks and AI models at scale. And if you go up as well, you should be able to see that we have here Light GBM model. And if you scroll up as well, you should be able to see that this is a Data Robot model here. Okay. And what you guys notice is you should be able to see here, these are what we call it the model leaderboard. And these are all the different models. And what's powerful as well about Data Robot is just going to tell you, well, this is the best model, and that's model that has been recommended for deployment. So if you click on it, first of all, you should be able to see that this model has an ID, and the model ID here is 21. And this is the performance of the model. So now we are standing around 79% approximately. And the first step is I wanted to show you guys what we call it the model blueprint. And when we train any AI or machine learning models, as developers, we actually hate what we call black box models. We don't want to deploy a model that we don't understand. We don't know what's going on behind the scenes. We wanted to know what's actually going on behind the scenes. We want to know if that model is accurate or not, or powerful or not. And by understanding what's going on behind the scenes, I can actually go ahead and tune the model hyperparameters as well. So the first step that I wanted to show you guys before I cover the blueprint of the model, if you go to the metric here, and if you select, here are different metrics for regression type problems. And if you guys select what we call the R squared metric, this metric here is essentially as an indication of how the variation in the output has been explained by the variation in the input. And the R squared, or what we call the coefficient of determination, as a number close or becomes closer to 1, that's a good thing. So for example, 0.86, that's a good value here, right there, right? That means around 86% of the variation in the output has been explained by the variation in the input. And what you guys notice here is if you zoom in a little bit, you should be able to see that this is simply all the different steps that data robot go through. So here I have the data, and then they split it here to categorical variables and numerical variables. They do one-hot encoding. You don't really need to know all the details of what's actually going on. But if you wanted to, let's say, learn about what's actually going on, the one-hot encoding, for example, and if you want to learn how data robot does it, you can go ahead and click on the documentation. You can actually go as well to, let's say, the algorithm, which is rule fit regressor. And if you click on it, you should be able to see the actual documentation of the algorithm that has been developed by Data Robot, what parameters are there, and so on. And please note that this is kind of beyond the scope of this course. The objective here is to show you guys practical, real-world applications without digging a little bit of details into the theory or the math behind the algorithms as well. Okay. The next step is I want you to show you guys is if you click on understand, you should be able to see all the what we call it feature impact or feature importance. So what you guys notice here is the horsepower is the most important feature of all. And this is again a very important piece of information because by using or leveraging this, you can know which features have a direct impact on the output, meaning the horsepower has a direct impact on the MSRP price, followed by the origin of the vehicle, followed by the weight, the type, the make, the wheelbase length, and so on, which is really important. Again, as developers, I wanted to understand what's actually going on or happening behind the scenes for me. Which feature is the most important one that actually affects the output? If you go and click on feature effects, what you guys see here is if you remove the partial dependence here and just click on predicted actual and disable that, what you guys see here is using the horsepower information, which is plotted here on the x-axis. Here I have the target, which is my MSRP. What you guys notice here is, of course, as the horsepower tend to increase here, for example, going beyond, let's say, 100 horsepower to, let's say, 340 horsepower. What you guys see here is the MSRP or the price of the vehicle tend to increase. So that means there is direct correlation between the independent variable, which is our horsepower, and the dependent variable, which is our output, or the target variable, which is our MSRP. And what you guys notice here is the prediction versus actual. Actually, the model is doing pretty well. This is what the model predicted in blue versus the actual values in orange. Okay, and if you guys wanted to go ahead and click on evaluate, and if you go ahead and click on residuals, and please know that there are tons of elements and features here that you guys can explore, and functionalities that you guys can explore. I just want to focus on key ones that we're going to use for this project. So what you guys see here is here I have the actual values. This is the actual prices, and here I have the predicted prices. And if you have a perfect model, you should be able to see a nice perfect line here standing at 45 degrees. And this is essentially what I'm seeing here, meaning that the model is actually doing a pretty good job, and the actual values for the used car prices is actually matching the predicted values here, which is super powerful. Okay, all right. So that's simply all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go back here. In task number 8, we will learn how to deploy our machine learning model and actually make predictions. Let's recap what we have done so far. In task number 7, again, we checked out our leaderboard. We have been able to select R squared here, which is our metric that we wanted to use to assess regression type models. We also here explored our blueprint of our model. We also explored the horsepower, that is the most important feature. And we also explored as well the feature effects, showing the predicted value versus actual values. And we also showed here the nice 45-degree line indicating that the model is actually doing a pretty good job. And that's all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go ahead and deploy our machine learning model. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, we will learn how to perform model deployment and to also make inference on our deployed model. Please note that this lecture is categorized again as, I would say, medium difficulty level. And if you guys remember, in the previous task, we learned how to perform model assessment. We explored the leaderboard for all the different models. We also explored the model blueprint, and we checked out from an AI ML model's explainability, and we learned about the feature impact, and we found that the horsepower is the most important feature of all. And then we have been able to plot our predicted value versus our actual value, and then we have been able to also check out the residual curve, just showing the actual predictions versus the actual values, my apologies, versus the predictions. And we found that we came up with a nice 45 degrees line indicating that the predictions matches our actual values. Okay, so what I'm going to do next is I'm going to head back to Data Robot, and then I'm going to show you guys the model deployment piece. So here I am back at Data Robot here, and what you guys see is this is our leaderboard, and these are all the different models that have been trained. And what you guys notice is this is the best model according to Data Robot, and what you guys see, it's shown here that it has been recommended for deployment. So what you guys could do is I want you guys to click on Deploy Auto Model, and you guys will see that now the model is being deployed, showing you deploying. And then I want you guys to click on Auto Model right now. And once you do that, you should be able to see that now we can essentially create an application based on our deployed model. Alright, so after the model is deployed, what I need to do right now is I need to create an application that leverages the deployed model behind the scene. And in order to do that, I want you guys to go ahead and click on Applications, and then click on Application Gallery. And please note that within Data Robot, they are planning to essentially update or kind of replace the Application Gallery that we have in here with what we call the AI App Builder, okay? So I would say the process will be pretty much the same. Maybe the interface might be a little bit different, and the idea is the same. We're just going to create an application that leverages the endpoint or the trained model that we deployed already, and then we can go ahead and just make inference on it. So what you guys see here is I want you guys to click on Predictor, so you can say Launch Predictor, and I want you guys to come here, select Model from Deployment, and to go ahead and select our model here, which is the recommended model for MSRP on used car prices.csv. And then I want you guys to click on Launch, and that will simply is going to launch our application here. And in order to open it, it might take some time for it to run or to be deployed. But once it's deployed, then you should be able to see that Open here is activated. And once you click on it, you should be able to see a window. And here we go. Here we should be able to see the application has been deployed. So if you go ahead and click on Open, it should open our application here in a new tab. So if you go ahead and click on Create a Record, you can give that record a name. Let's call it Test 1, for example. You can also give it a quick description. And you can go here and you need to specify, again, the horsepower, cylinders, MPG per city, engine size, and so on. So what if, just for the sake of, I would say, simplicity, I can just go ahead and say use average values. And what you guys see here is the horsepower is 210, cylinders is 6, the MPG for the highway and city, 19 and 26. And if you say get predictions, the model right now will essentially run. Again, I trained the model already, and now I'm making inference based on that trained model. And that's what I'm getting here. The price is $37,000 based on these features. And if you can go ahead and, let's say, change the horsepower maybe to, let's say, 350, for example, and you refresh it, you should be able to see the price tend to increase, of course, which makes sense, because again, as I mentioned, horsepower is one of the most important features that can influence the actual price of the vehicle. Okay, all right. So here we go. Congratulations. What you guys have been able to do is that you have been able to create a super powerful application in Data Robot without writing a single line of code. We trained multiple models, and then we selected the best one, and we have been able to take the best one and deploy it as well and make inference afterward on it too. So here I have, after I deploy the model, here I created application, and then I selected again the predictor option. And then you select model from deployment. You select the MSRP, essentially model that we trained or we deployed. And then you click on open to open the application. You come here, you create a record, you give it a name, and then you specify all the different features in here. And then you should be able to generate predictions afterwards. Okay, all right. So that's all I have for task number 8. I hope you guys enjoyed it. In task number 9, we're gonna go ahead and study some of the technicalities behind the scenes. So we'll learn about simple linear regression, we'll learn about multiple linear regression, and we'll also learn how to optimize the model parameters. So that's all I have. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 9. In this task, we will learn about some of the technicalities behind machine learning regression in general. If you guys recall, in the previous task, we have been able to deploy our model and create an application that leverage our deployed model. And we also have been able to test our model just to see if it actually works or not. And we found that it actually make pretty good sense, given that if we change the horsepower values, the MSRP price will tend to change as well. Okay, so what I'm going to do right now is I wanted to show you guys the difference between simple linear regression and multiple linear regression. Please note that this lecture is quite optional. It's kind of, like a deep dive into what's happening behind the scenes. And essentially the application has already ended right now, and we have been able to create the application. And in the next task, we're going to go through our 2 super important final projects. I hope you guys will find them pretty interesting. Okay. So what I'm going to do right now is I have our trained machine learning model, and essentially I wanted to select, let's say if I give it engine size, I should be able to come up with the vehicle MSRP price. And basically that's again my objective, is to train a machine learning model, to give it an input or multiple inputs, and to generate specific output. And in this example was the vehicle price. So here on the x-axis I have the engine size, on the y-axis I have the MSRP price. And essentially what we do is we go ahead in the field and then we collect the training data. So this is simply the training data sets. And in our example, this training data has been collected by car dealerships. And all what I'm trying to do is I'm trying to come up with the perfect straight line that can fit all these data points. Basically, when I say I'm looking for a machine learning model, I'm trying to come up with the slope and the y-intercept for that straight line. Because once I have it, then I will be able to come up, after the model is trained, come up with the specific number of, let's say, cylinders, let's say 8 cylinders, go to that model, and then generate predictions. And then, okay, the price is $40,000 if I have, let's say, engine size that has 8 cylinders, for example. Alright, so let's go ahead and cover what we call it simple linear regression. So in simple linear regression, our goal is to try to obtain a model. And when I say a model, all what I'm trying to do is I'm trying to come up with a relationship between 2 variables. The first variable, we call it the independent variable, and the second variable, we call it dependent variable. So all what I'm trying to do right now is I'm trying to come up with a relationship between the engine size and, let's say, the vehicle MSRP. And here, all what I'm trying to do is I'm trying to come up with a relationship between these 2 variables only, and we're only assuming that the vehicle MSRP is only dependent on the engine size, just one parameter only, or one independent variable only. So what you guys see here is this is simply the equation of the straight line, y equals 2b plus m times x, where m, if you guys recall from any statistics course, m is the slope of the line and b is the y-intercept. And simply x is what we call it the independent variable, and in this example here that's the engine size, and y is our dependent variable, and in this example here is the vehicle MSRP. Basically all what I'm trying to do is I'm trying to find what are the values for b and m. I'm trying to find that straight line here that can best fit our data, because once I have that straight line equation, then I can go in the future, substitute with x value here, and then should be able to generate y value corresponds to the independent value, which is the engine size that I put in here. So for example, if you guys recall before, if I have, let's say, 8 cylinders, I should be able to come up with the MSRP price of $40,000, for example. Alright, so next, let's go ahead and cover what we call it multiple linear regression. So what you guys see here is, when it comes to multiple linear regression, it simply examines the relationship between more than two variables. So if you guys remember, the simple linear regression will only examine the relationship between two variables only. Now we can take it a step further and study more than one variable. For example, here I have multiple independent variables such as engine size, I have the MPG for the city, I have the horsepower, for example. So now I have x1, x2, x3, up until xn, for example. All these are independent variables. And what I'm trying to do is I'm trying to find what are the coefficients, what's B node, what's B1, what's B2, that can best fit all the training data to be able to generate our dependent variable, which is our vehicle MSRP in our example. Okay, all right. The next point that I wanted to show you guys is, well, now I was able to come up with the equation either for the simple linear regression or for the multiple linear regression. The next question is, how can I obtain model parameters? How can I basically fit that straight line to our training data? And in order to do that, what we do is that we use an algorithm known as least sum of squares. And I'm not going to dig a little bit deeper into the algorithm. I'm just going to show you guys from a very high level how we actually do it. So let's assume that I have our training data. So this is our training data. And here I have the engine size on the x-axis, and here I have the price, which is the MSRP for the vehicle on the y-axis. So what we do is we say, okay, well, maybe the equation of our straight line is, let's say, looks like that, for example, had that specific slope and has that specific y-intercept. So what we do is we go ahead and then we calculate the residuals. And when I say residuals, this is simply the vertical offset between our model, which could be wrong, and our training data. And what you guys see here is that distance is simply the difference between the actual values and the estimated values. So we call this estimated, or yi hat, because this is the predictions. And yi, this is the actual value. This is the actual data that we got from the training, or from the field, or we use for the training, of course. And we calculate the distance, which is the error between the two. So the distance is simply y hat minus y. Again, the estimated minus the actual value. And once I do that, I'm going to calculate more than one residual. I'm just going to calculate the error, or the residual, for this point, and then for this point as well, this point too, and so on. And once I do that, I take all these errors and then I'm going to square them up. When I square them up, essentially I'm just removing the sign. To get rid of the sign, we square it up and then we sum up all these errors. And all we're trying to do is that we try to minimize that value. And that's what we call it least sum of squares. We square up the errors, we sum them up, and then we obtain the least. We kind of run an optimizer to minimize that value. And that's essentially all what we try to do in here to try to come up with the optimal or best line here that can fit our training data. Okay? Alright, and if you guys wanted to learn a little bit more about simple linear regression and multiple linear regression, these are two great resources for you guys. You can check out, they are readily available and they are free as well. You can click on any of these PDFs and you can go to either page 123 in the first book or page 61 in the second book. Okay? Alright, and now it's time for a quick mini challenge. What I want you guys to do is I want you to essentially match the equations. So you're gonna have two equations, y equals to 4 times x. You're gonna have another equation, y equals to 20 minus 5x. And I want you guys to match the equation with the actual graph. So either this equation goes with here or this equation goes with here. And I also guys want you to explain why. So please go ahead, pause the video, give it a shot, and I'll see you guys after the challenge. Alright, hope you guys were able to figure out the challenge. Simply, all what you need to do is that you need to compare the slope of the line and the y-intercept, or kind of calculate it first. So for example here, y is equals to mx plus b. So this is essentially our m, that's the slope, and there is no b, there is no y-intercept, because b equals to 0. That means that the slope of the line is positive, which is 4, and because there is no y-intercept, well, this equation has to match this graph. Because this straight line here actually goes through the origin, meaning we don't have any y-intercept at all, and of course the slope of the line is positive, meaning as x increases, the y increases as well. If you check out the second equation, which is y equals to 20 minus 5x, what you guys notice here is this equation matches this one. Why? First of all, there is an actual value for b. So b is equals to 20. And that's what I have here. There is an actual y-intercept. And the slope is minus 5. And what you guys see here, which makes sense. Why? Because, well, it's because the relationship here is inversely proportional. Meaning, as x increases, y tends to go down. So based on the slope of the line, I can tell that this equation matches this graph. Okay. Alright, so that's all I have for task number 9. I hope you guys enjoyed it. Let's go ahead in task number 10 and cover our final project part A. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 10. In this task, we will go through final project part A. And please note that this task is classified as kind of medium difficulty level. So let's go ahead and get started. If you guys remember, in the previous task, in task number 9, we learned about the technicalities of simple linear regression and multiple linear regression as well. And we also went through a quick mini challenge. I hope you guys were able to figure that out. Okay, so here's the final project, part A. So using Data Robot, I want you guys to select the best model that has been recommended for deployment. And I want you guys to explore how to tune the model hyperparameters. I want you guys to set the upper and lower bounds of the model hyperparameters, such as the learning rate. And I want you finally to train the model and assess its performance compared to other models on the model leaderboard. So I haven't covered how to tune the model hyperparameters, but that's the overall point. I want you guys to do external research, kind of stretch your limits a little bit. And the overall idea, again, is to grab that model here and to try to optimize the model hyperparameters and see maybe if you change the learning rate, for example, will you be able to improve its performance or not? Okay, that's all it is. So please go ahead, give it a shot, pause the video, and best of luck, and I will see you guys after the challenge. Alright, hope you guys were able to figure out the final project. I would say it was pretty straightforward, and again, this is just part A of the project. In the next task, we'll cover part B of the project, which is going to be a little bit more, I would say, advanced. Okay, so if you grab that model here, if you just click on it, and if you go to evaluate, you guys will see here on the right here, you should be able to see advanced tuning. So if you click on advanced tuning, what you guys see here is essentially all the different model parameters. Okay, so these are all the different hyperparameters that you can go ahead and change and kind of tweak. So basically the learning rate right now, for example, is set at 0.1. So if you click on it, what you guys see here is you can go ahead and choose, let's say, a range. So for example, you can select a range between 1 and 4, for example. Here, let's say I want to search between 0.1 and let's say 1. So if you say 0.1-1, you can say update parameter. Here we go. And I'm just going to stick with just the learning rate right now. I'm just going to keep everything as is. And if you just go ahead and say begin tuning, that is going to go ahead and kick off a new training here with the updated hyperparameter range. So essentially the model, data robot, we're just gonna go ahead and train models, and it's gonna go and select various learning rates between that range, between 0.1 and 1. And if you go back to the model leaderboard, you guys should be able to see that this is the best model that has been recommended for deployment. However, what you guys can see as well, if you scroll down, you should be able to see this is the new model that you guys have started to work with. And what you guys see here, it's telling you that the training has been complete, and it's telling you that this model ID is M29, okay? And it has been tuned from M21. So you guys see here, this was model 21. We have been able to tweak it or tune it. And these are the different learning rates that has been used, which is 0.1, 0.2, essentially up until 1. And what you guys notice here is if you change the metric and set it again to R squared, which is our coefficient of determination, you guys will see here as well, the actual performance, it actually increased. So it becomes 0.91 as compared to 0.86. That's good news. That means by just tweaking the hyperparameter, we have been able to essentially improve the model performance. So you can grab that model, deploy it, and you can also use it to generate predictions as well afterwards. Okay? All right. So simply, that's all I have for this project. That was pretty straightforward. We have been able to again select the best model and then tune or tweak its hyperparameters, changing the learning rate, and we have been able to assess its performance as well compared to other models on the leaderboard. So, and here are all the steps that we went through. I hope you guys were able to figure that out. And that's all I have for task number 10. I hope you guys enjoyed it. In task number 11, we will cover final project part B. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 11. In this task, we will cover final project part B. So let's go ahead and get started. So in this final project, part B, I want you guys to use the attached insurance premium prediction dataset. So in the course package, I've included another dataset entitled final project insurance data, .csv. And what I want you guys to do is I want you to use that data. I want you to upload that data to Data Robot. And I want you guys to perform exploratory data analysis. I want you to train multiple models in Data Robot. I want you to assess train model performance and also deploy the best model and perform inference. Okay? And let me show you guys the actual data. So if I open the file in Excel, and here is the data. So let me walk you through it. So it will be pretty straightforward for you guys. So essentially what I have here is I have the age of different patients or customers per se. Here I have the sex. Here I have the BMI or body mass index of various customers. Here I have the number of children that they have. Here I have also their smoker status. Are they smokers or not? I also here have their region. Where do they live, essentially in the US? And here I have the charges, and this is essentially the actual premium that they have to pay from an insurance standpoint. And basically what I want you guys to do is, this is again a regression type problem. So we are trying to predict a continuous variable, which is the charges variable here. And here we have a bunch of features. These are the bunch of features. So what I want you guys to do is I want you to please go ahead, use Data Robot, upload that data, go ahead, perform exploratory data analysis, train multiple models, pick the best model, deploy it, and make inference as well. So best of luck. I hope you guys will be able to do the final project and test it as well and assess its performance. So go ahead, please go ahead, pause the video, and I will see you guys after the challenge. Alright, hope you guys were able to figure out the final project. So what I'm going to do right now is the following. I'm going to go back to Data Robot. And again, if you guys remember, everything was pretty straightforward, I would say. If you click on Data Robot here, that will bring you back to the home page. And all what you guys need to do is to simply go ahead, drag and drop our data. So right now, we're going to go ahead and create new project. I'm going to grab our final project insurance data, just drag and drop, pretty straightforward. And what you guys see here is, again, Data Robot is going to upload the data. It's going to do quick reading of that raw data. and it's going to also perform exploratory data analysis as well. So right now it's taking some time for it to be read here, and afterwards we will be able to learn how to train multiple regressor models or regressors, and we'll be able to, after the model, all these models are trained, we're going to pick the best one and we're going to use it for deployment. So what I really like, as I mentioned, about Data Robot, it's actually pretty straightforward. It's actually really fast as well. So here we go. Here are all the different features. So let's go ahead and explore all these features. So for example, I have the age. So this is the distribution of the data. So here, for example, I have the 30 years old, 35 years old. Here I have 40 years old. Looks like the data is pretty consistent, I would say. There is no like normal distribution or anything. And if you scroll down, you should be able to see the sex distribution. So again, the number of male and female is pretty much equal, pretty much the same. If you check out the body mass index, you will see that the BMI here follows a nice bell curve here. If you check out the children, these are, so a lot of people actually in the study did not have any children. And then when you have one kid, there's like 300 rows, for example. And here, if you hover on top of it, these are the people who had only between 2 and 3, I would say. I have 20 people, 20 rows, and then next one, or the next bin, is the 157 rows. And if you guys scroll down, you should be able to see the smoker. So these are the number of people who are smokers and who are not. So this is smoker, this is not. And it looks like a lot of people actually do not smoke in this study, which is great. If you go to the region, these are the regions. So I have the southeast, northeast, southwest, and northeast. And if you check out the charges, these are the different charges that I have. So essentially what I have here is a lot of people are actually not paying a lot, so less than $10,000, for example. And then the premium tend to increase here once the premiums or the charges tend to increase, let's say to 40,000 or 50,000, for example. The, of course, number of rows or number of occurrences tend to increase because these are kind of massive, I would say, insurance charges. Okay. So if you guys remember, the next step to train our model, of course, we need to select our target. And the charges here is our target. So just going to go to the charges and then I use it as target. And once it has been highlighted here, you should be able to see the start here button has been activated. So if you go ahead and click on start, that is going to go ahead and kick start our training process. And as always, what you guys see here is Data Robot is going to upload the data, it's going to partition the data into training, testing, and validation. It's going to analyze the features and also generate the blueprints as well. So again, it's taking some time for it to run, but once that is complete, then I'm going to go ahead to the leaderboard under models, and I should be able to go and see all the different models and their performance as well. So what I'm going to do is I'm going to pause the video, and then I'm going to be back once all these models are trained. Alright, so now I'm back, and what you guys see here is a lot of the models have been already trained, and if you go under Models tab, you should be able to see all the different models here. As always, Data Robot just going to train multiple models, such as Random Forest Regressor, for example, XGBoost algorithm. We have XGBoost algorithm here. We have also the neural network within Keras and TensorFlow. We also have here, if you scroll down, you should be able to see the light gradient boosted trees. And we also have the elastic net regressor as well. And here we go again, the models are still being trained. And if you guys go to under metric and choose the R squared metric, you should be able to see that the it's still in progress, but the extreme gradient boosted right now trees is actually on the top of the leaderboard, stands at 0.85. And what you guys notice as well is none of the models have been selected for deployment. If you guys recall, in the previous model or the previous data set, we saw here that the best model has been shown here as recommended for deployment, and going to be indicated here in a green tab. But again, none of them has been evaluated yet fully. So let's go ahead. I'm going to go ahead and pause the video, and then going to be back once all these models are trained. Alright, so now I'm back, and what you guys see here is we have been able to train multiple models on the leaderboard. And what you guys see is the best model that has been recommended for deployment is the Extreme Gradient Boosted Trees, or XGBoost algorithm. So of course, if you wanted to deploy the best model, you just go ahead and click on it, and you can go and say deploy auto model. That will deploy the model for us. And of course, if you wanted to explore what's actually going on behind the scenes, if you zoom in a little bit, you should be able to see this is the data, and then we perform tree-based algorithm pre-processing version 1. And this is essentially a proprietary algorithm by DataRobot. And here, essentially, they use the extreme gradient boosted trees or XGBoost algorithm. And you can go ahead and check out the documentation. And XGBoost is actually one of the cutting edge algorithms, and it has won several Kaggle competitions recently. Super powerful and works really, really well for regression and classification type problems as well. And if you go ahead and click on understand to see which feature is the most important one, here you'll be able to see that the DataRobot is computing the feature impact. So I should be able to go and see which one is the most important feature out of all of them. So it's taking a little bit of time because it's still training a couple of models in the background. Here we go. So for example, here you should be able to see the smoker, being, a smoker or not, has a massive impact on the actual charges for insurance. The age, of course, plays a key role, and then we have the BMI and number of children afterwards. Alright, so next, click on Auto Model, okay, and now we have been able to deploy our model, okay, and the next step is I wanted to create an application based on it. So if you go ahead and click on Applications, and then if you click on Application Gallery, you select the predictor and launch the predictor, and then under Select from deployment, and then go ahead here and you should be able to see our final project insurance data.csv. So select that and then click on launch, and that should simply is going to launch our application. And again, it's still it's not activated yet, it's still kind of being prepared for deployment. But once it's ready, you should be able to go ahead and click on open. So here we go. So now application has been deployed. If you click on open, that should open a new tab where you can go ahead and create a record. I can call it test 1. And if I say, just to make it easy for me, use average values, for example, here I can select either smoker or not. Here I can select the age. I select the body mass index, and maybe someone has, let's say, 2 children. And if you say get predictions, you should be able to calculate, this is the actual insurance premium that this new customer with all these different features have to pay, which is super powerful. If you maybe change the age, let's say to 50, for example, and run it again, you should be able to see, wow, the insurance right now increased quite a bit, which makes sense because, as people age, they tend to have more health problems. Of course, not a must, but again, it's kind of, a general trend, I would say. What if you change, for example, the body mass index, let's say maybe to 40, for example, and run it again? What you guys see is, well, there has been a slight change, slight increase, which makes sense because if you guys remember when we checked out the feature importance, we found that the being smoker or not actually plays a key role. We also have the age as well play the key role as well, but the BMI and number of children didn't actually make that much of a difference. If you change the smoker and maybe change it to yes and click run it again, here we go. What you guys see here is just by changing the smoker status from just no to yes, the number just went like crazy. Went from like $11,000 to $41,000, just indicating how just changing the smoker status from yes to no makes a huge difference in here. Okay, all right. So that's it. That's all I have for this project, and that simply concludes our task 11, and that simply concludes our day number 5. I hope you guys enjoyed it. Please go ahead, take some rest, and I'll see you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 6. Today we will learn how to build a machine learning classifier model using DataRobot. So in today's task, we will cover the project card and also the demo of our project. And please note that this lecture is categorized on the easy level, I would say. It's pretty straightforward, just an overview of what we're going to achieve today. Okay, so let's go ahead and get started. So the goal for this project is to build, train, test, and deploy an AI/ML model to predict which employees are more likely to quit based on their features. So we're gonna consume different features about employees, such as their education, their job involvement. Are they satisfied with their job or not? Are they satisfied with their relationships, for example, with their manager or not? How do they, let's say, evaluate their work-life balance and how they're actually doing in the job, such as performance rating. So we're going to use all that data and train a machine learning model to essentially tell me or generate prediction or classification whether that employee will stay or will leave. That's all it is. And the tool that we're going to use is, of course, Data Robot. And here is the practical real-world application. So this project can be effectively used in human resources department to predict employee attrition and understand key factors that can contribute to it. Regarding the data, here are the inputs: job involvement, education, satisfaction, work-life balance, performance rating, and the output is employee attrition, which could be either employee stayed or left. And if you guys want to check out the data, here is the source of the data. It's available on Kaggle. Okay. So let's go ahead and cover the project demo. So let's go back to our Data Robot here. And what you guys see is simply our application. And that's what we're going to build today. So at the end of today, we will be able to create an application that looks like this one. You can essentially go here and select what we're going to be the job role, for example. So let's say research director. Do you work overtime or not? So maybe yes, I work overtime. The monthly income, maybe 5,000. Maybe I will set it to, let's say, 6,000, for example. How long have you been, with the manager? So years with current manager, maybe 3. Age is 36. How long do you have been working? So total working years, let's say, set it to 15, for example. And then you can add additional features as well. Your marital status, divorced or single or married. The job satisfaction. There's also department, maybe research and development or sales. You can also select the job involvement, which is essentially a number that indicates how involved are you in the job. So maybe let's say to 5, for example. Work-life balance and years since last promotion. You can also add the education field. Are you in the life sciences or medical field and so on. And you can also select the number of companies that you work for. And also relationships satisfaction, maybe I'll set it to 5. And distance from home, maybe I'll set it to, let's say, 9, for example. And all what you need to do is to say, go ahead and refresh for me and tell me if that employee is more likely to stay or to leave. And what you guys see here, this is categorized as on the low category, meaning that this employee is most likely to stay. So 0, that means you're going to be staying. 1, that means you're going to be leaving the company, essentially. Okay. All right, so that's essentially what we're going to build in today's project. And that's all I have for task number 1. I hope you guys enjoyed it. In task number 2, let's go ahead and cover the business case and couple of success stories. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 2. In this task, we are going to cover the business case and success stories as well. And please note that this lecture or this task is classified as easy. It's pretty straightforward, and we're going to go as well through a quick quiz at the end of the task. If you guys remember, in the previous task, we covered the project card, and also we went through a demo. And let's go ahead and get started with task number 2. So hiring and retaining employees is an extremely expensive process and requires a lot of skills, a lot of time and capital as well. And average companies lose between 1% to 2.5% of their total revenue on the time it takes just to bring a new hire just up to speed. And also, companies spend between 15% to 20% of the employee's salary to recruit a new candidate. And what we have here, these are 7 ways AI is reinventing human resources. So if you guys check out this link, I actually have it open in here. So these are the 7 ways that AI has been revolutionizing human resources in general, reinventing human resources. So what you guys see here, and I've included them as well, all these different points on the slides, is AI could be used to essentially scan through candidate resumes and extract insightful information. It can also be used to understand and analyze employees' referrals. It can also be used to extract key insights about the data and about candidates in general, and also about the current employees who are currently working at the company. It can also be used to develop what we call it AI-backed chatbots, just to keep the employees engaged in the conversation. It can also be used to boost learning and development programs, and also can be used to leverage transactional workforce data, and finally can be used to power and empower workforce analytics, just to understand, are my employees happy or not, what made them engaged. If I wanted to, let's say, develop a customized learning path for each of the employees. And these are all the different areas where AI could be used to revolutionize human resources. So what you guys see here, this is simply the summary. So AI, as I mentioned, could be used to extract information from candidate resumes using AI. We can use AI to assess the employee referrals. Can be used to gain key insights. It can also be used to improve engagement using AI-powered chatbots. We can also leverage AI and machine learning to create a customized learning journey for employees, and also could be used to predict employees' retention, their potential, and their fatigue, and finally, enhanced workplace analytics. Okay. So now it's time for our reading material and for the quiz as well. And I expect this reading exercise should take around 10 minutes approximately. And then the quiz should take around 5 minutes. And the title is Employee Attrition, How AI is Transforming Human Resources Practices. And here is the link to the article. And I actually have the article open here. And here is the article. So I highly recommend that you guys go ahead and read it. And I think so I actually have it open in here. So if you guys check it out, you should be able to see all the different details in here, you know, like how can we leverage AI in human resources in general. Like you can use it for hiring, predictive analytics. We can track employees' behavior, for example, using sentiment analysis. We can also use it for training and reskilling as well of employees, and performance evaluation as well. So I want you guys to please go ahead, give it a shot. Best of luck, and please go ahead, give the quiz a shot as well. And that's it. That's all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and jump into our data robot and upload our data and start to perform data exploration as well. So that's all I have. I hope you guys enjoyed this task, and see you in the next task. Hello everyone, and welcome to task number 3. In this task, let's go ahead and perform data exploration. If you guys remember, in the previous task, we learned about our business case and success stories as well. We learned how to apply AI and machine learning in human resources. And we also went through an article and a quiz. I hope you guys were able to figure that out. Okay, so in task number 3, it's pretty straightforward. I was just going to provide you guys with an overview of our data. And please note, of course, that this is again a pretty easy and straightforward lecture as well. Okay. So here are the different inputs and outputs to our AI and ML model. So these are the list of inputs. So we are going to consume the job involvement, how involved our employees are within a given company. Their education level. We're also going to include the job satisfaction, their performance rating, their relationship satisfaction, their work-life balance as well. We're going to consume all that data as input. And then we're going to predict the output. And the output is just going to be either 0 or 1, indicating the employee attrition rate, which is would that employee stay in the company or is going to leave the company. And please note that these type of problems are known as classification type problems, as opposed to our previous project, which was regression type problems. And if you guys recall, in the in yesterday's case study, we were trying to predict a continuous variable, continuous value, which was the price of vehicles, if you guys recall. But right now, we are actually performing a classification task. So the output could either be 0 or 1. Could be either the employee stayed or left. It's, you know, it might be, let's say, sunny tomorrow or maybe rainy tomorrow. These are all the different categories or classes. And these are what we call it classification type problems. Okay, So here is an overview of our data. So let me zoom in a little bit. So if you guys open the Excel sheet, these are the actual features that you get. Here I have the different age, I have the employee attrition, and this is simply our target variable. So that's the actual variable that we're trying to predict. Here I have the business travel, I have the daily rate, the department, the distance from home, their education level, what field they are in, the employee count, employee number as well. How satisfied are they with their environment, their gender, their hourly rate, their job satisfaction, are they single or married? We also have the monthly income, monthly rate, and of course, are they over 18 or not? And pretty much in the entire, I would say, study, all the data set, all of them are over 18. We also have the number of companies they worked for, and do they work overtime or not? And also we have the percentage salary hike, and finally have the performance rating. And please know that this data is actually a real world data set, and you'll find it's actually quite rich, and it has a lot of information, a lot of content associated with it. And if you check out the attrition column here, and that's our target column that we're trying to predict, what you guys notice is simply the output is again 0 or 1 or yes or no. And here what you guys see is the people who actually stayed in the company are actually quite a lot, and these are the actual people who actually left, which is kind of a fraction of the overall number of people who stayed within the company. And this is essentially our target variable, or the variable that we're trying to predict in this project. Alright, okay, so that's all I have for task number 3. I hope you guys enjoyed it. Task number 4, let's go ahead and start to upload our data. Please stay tuned, best of luck, and I will see you guys in the next task. Hello everyone, and welcome to task number 4. In this task, let's go ahead and get started with our data robot demo. And let's go ahead and start with the data upload piece. If you guys remember, in the previous task, in task number 3, we learned how to perform data exploration. We checked out all the inputs, all the outputs, and we also checked out the Excel sheet that summarized the actual data sets. We saw that we have many inputs, and we only have one output, and that was the employee attrition value. And this is simply a binary value that could be either 0 or 1, yes or no, and so on. Okay, so in task number 4, we are going to upload our data to Data Robot, and this is pretty much, I would say, will be pretty much the same as task number 4 in the in yesterday's project. And please note that, again, this task is quite an easy one, pretty straightforward, so let's go ahead and get started. So please note that all these different slides are optional because we went through all the sign up for Data Robot before. So if you guys have Data Robot already and you signed up already, please go ahead and skip all these different slides, but I was just going to scan through them really quickly, just in case if someone decided to skip day 5 and just jump right away to day number 6. So basically here, again, Data Robot can be used to automate the process of building, training, and deploying AI models at scale. You guys, in order for you to access Data Robot, you need to click on that link here, and you need to sign up with your name and the job title and so on. And then you need to, you can essentially activate your 14-day trial period, and then you can tell Data Robot a little bit about yourself, you know, what you do, what's your industry, and so on. And you can also say that you wanted to create AI models. And then once you're done with the sign-up process, you should be able to come up with this homepage. And this is essentially what I got here. Here we go. This is the homepage. I can actually go ahead and close these. And what you guys need to do first to create a new project, as we have done before, you need to click on Create New Project. And all what you need to do is to, in the course package, I've included here our employee data sets. All what you need to do is just drag and drop the employee data to Data Robot, and that's it. That's pretty much how you upload the data to Data Robot, which is pretty straightforward and very simple process. So what you guys see on the right hand side, you should be able to see the process here. So here we're uploading the data, and then we're reading all the raw data, and then we're going to afterwards perform exploratory data analysis afterwards. And if you guys recall as well, is after we upload the data, then we can go ahead, visualize all our features, and then next what we could do afterwards is we can select the target column And once the target is selected, then we can essentially go ahead and train our machine learning model. So here we go. What you guys see here is, here we have all the different data sets, like the age, the attrition, business travel, and so on. And we're going to explore all these features in the next task. But for now, what you guys see here is, when it comes to the data quality assessment, if you click on view information, you will see that here we have a couple of outliers. So outliers have been detected in one feature. So since this is a pretty, I would say, straightforward, very simple warning, so I'm just gonna go ahead and ignore it for now. And so I'm just gonna say dismiss for now and say close information. And that's it. That's pretty much all I have for today's task. I hope you guys enjoyed it. Let's go back to our slides here. So, and walk you guys through task 4. So after you sign up, all I need to do is to upload the data here, and then you are going to use employee of course underscore data.csv. You drag and drop, and then all the different processes here that data robot go through. And then you need to ignore the data quality assessment here, all the warning. And that's it. That's all I have for task number 4. I hope you guys enjoyed it. In task number 5, we will learn how to perform data analysis. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, we are going to continue our data robot demo, and we're gonna perform data analysis. So if you guys remember, in the previous task, we have been able to upload the data to data robot, just perform basic raw data analysis here. And we also have been able to ignore our outliers, which is our warning sign that we got, because it was pretty simple, just a very basic, just one feature that included an outlier. So we're just gonna go ahead and dismiss that warning. And right now, what I wanted to do is I wanted to select the target, and I also wanted to explore all our features. So what I'm going to do is I'm going to go ahead to our back to our data robot here, and here we go. So what you guys see here, if you scroll down, you should be able to see all these different features. So for example, here I have the age, for example. So if you click on it, you should be able to see the actual distribution. Looks like a nice bell curve distribution here. So a lot of people in our study, they range between 30 and maybe 40 years old. And then, you know, like as you go like a little bit younger, for example, 20 years old or maybe older, around 60 years old, the number or the frequency of occurrence tend to go down. And if you scroll down, you should be able to see the employee attrition rate. Basically, again, this is the actual target column that we're trying to predict. It's either 0 or 1. So if you guys wanted to select it as target, you can say use as target, and that will be essentially our output column that we're trying to predict. Here we also have our business travel. Here we have the travel rarely, people who don't travel and maybe travel frequently. If you go scroll down to the daily rate, you should be able to see the daily rate here, and check out the department. You should be able to see there is R&D department, there is sales, and there is human resources as well. Here we have distance from home, so a lot of people actually lived very close to home, and then as distance increases, the number of people tend to generally decrease as well. Check out education. This is the different education levels, and again, all these different categories indicate if someone has, let's say, a high school, for example, or maybe a bachelor's degree, or a master's and a PhD as well. If you check out the education field, here we have life sciences, medical, marketing, technical, and so on. We have a lot of features. Actually, we're not going to explore all of them. Maybe let's explore, for example, hourly rate. This is the hourly rate here. Let's go ahead, job involvement. These are the people who are actually just a number that indicates how involved these people are in their jobs. Here we have the job level. We have the job role. For example, sales executive, manufacturing, healthcare, management, and so on. Let's check out the monthly incomes. These are the different monthly income. A lot of people, they make between, I would say, $2,000, $3,000 up until $6,000, for example. And then as you go to these like very high numbers, you know, 16,000 and 18,000 and so on, the number of people tend to go down. If you check out the marital status, here these are the people who are married, people are single, and people who are divorced. If you scroll down, you should be able to see the relationship satisfaction here. And if you check out, again, lots of features. These are the work-life balance. Again, classes or categories indicates if people have a good work-life balance or low or bad work-life balance. Here we also have the years with current manager. These are the different years with current manager, and these are the frequency of occurrence. And also we have the years since last promotion as well. Okay, all right. So this is simply how you perform data exploration. And once you select the target column here as the attrition, what you guys see here is a data robot just automatically detected that this is a classification type problem, and it also showed you the, if you zoom in a little bit, it will also show you the actual distribution of the data. So these are the people who decided to stay, and these are the people who left the company. And if you guys remember from the previous project, what I want you guys to do is I want you to go under show advanced options, and I want you to select the train validation holdout data sets, and I want you guys to set it maybe to 20 for the validation data, and then 20 for the holdout or the testing data, and then the remaining, which is 60%, will be used for training. So 60% for training, 20% for cross validation, and the final 20% will be used as a holdout data set. And I covered this before in the previous lecture or previous task, I would say. And what you guys see here is this is the exact same slide, if you guys recall, just to differentiate between the training set or training data, validation data, and holdout data set. And that's why I listed this slide here as optional, because I covered it in the previous project. Okay, so let's recap what we have done so far. In this task, we have been able to select our target column, which is employee attrition value. And what you guys see is the start button here has been activated, basically indicating that now we are pretty much ready to start the training. Here we have the distribution for the age, the attrition, the distance from home, job satisfaction, marital status. Here we also have the split or the divide between the training, validation, and testing. And that's it. That's all I have for task number 5. I hope you guys enjoyed it. In task number 6, let's go ahead and actually train our machine learning model in Data Robot. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, let's go ahead and train our machine learning model in Data Robot. If you guys remember, in the previous task, we have been able to explore our data set and perform data analysis as well. We selected our target, which was our attrition column, and we also explored all our different features in here. I hope you guys were able to figure that out and follow along with me. And if you guys recall as well, we have been able to split our data into 60% for training, 20% for validation, and then 20% for holdout or testing data set. Okay. So what I'm going to do right now is I'm just going to go ahead and actually train our model. So let's go back to our data robot here. And basically, as always, in order to train the model, all what you need to do is to just go ahead and select start. So by selecting start, what's going to happen is data robot here, we're just going to go through all these different stages or steps. Just going to create our holdout partition and cross-validation partition as well. And then it's going to load our data set, prepare the data, analyze the features, and generate as well models blueprints. And if you guys recall as well, if you check out under models, you should be able to see the leaderboard. Again, right now it's still kind of splitting the data, and it's gonna kickstart a series of model training experiments essentially. And you should be able to see the results and performance of every single model here on our, what we call it, leaderboard. Okay, so here we go. Now we're at stage 6 and then stage 7 afterwards. And what I'm gonna do next is I wanted to show you guys the feature association. So if you guys go back to the data, okay, again, it's taking some time for it to run. Here we go. So you guys see on the right hand side, you should be able to see all the various models. So I have Keras, for example, residual neural network model. I have the XGBoost or extreme gradient boosted trees. And if you guys remember as well, they are being developed in different languages. So for example, here, this is a Python model. This is a Data Robot model, and we also have Keras and TensorFlow, which is Google's framework to build, train, test, and deploy AI and ML models at scale. Okay, So if you guys go ahead and click on the feature association, you should be able to see here all the different features and their relationship together as well. So what you guys see is there is a strong association between the department and job role. Also, there is an association between job level and monthly income. And actually that makes complete sense, because as the job level tend to increase, that means people tend to have more work experience. That of course will be reflected on their monthly income. We also have a correlation between the years at a company and years in current role. We also have year at a company and years with current manager. And we also have percentage salary hike and performance rating, which of course makes sense. As employees perform well, they tend to have higher percentage salary hike as well. Okay? Alright. The next step that I wanted to show you guys is if you go ahead and click on View Feature Association Pairs, you can go ahead and select any, you can essentially plot any feature versus a different or other feature. So for example, I can go ahead and select, let's say, the monthly income, for example, and I can select the job role, for example, here. What you guys see is, let's say, the research, the lab technician, for example. This is in general, the box plot showing all the different monthly income. So for example, here you'd see the median stands around, let's say, $3,000, for example. However, if you check out, let's say, sales executive, they tend to make a lot more money, for example. And if you check out the healthcare representative, they tend to have higher salaries as compared to lab technician. And within the other, you should be able to see that, there's a lot of, I would say, features that are captured under the other, and I would say different job roles under the other, and they can range or can go up until, let's say, $18,000 and even $20,000 as well per month. Okay? Alright. So that's it. That's all I have for this task. I hope you guys enjoyed it. Let's go ahead and recap. So in this task, what we have been able to do is we have been able to train our model, or actually multiple models. We checked out the progress here on the right hand side for the training. We checked out the feature association as well between for all the entire data set. And we also explored the feature association pairs, kind of plotting the monthly income versus job role. And that's it. That's all I have for task number 6. I hope you guys enjoyed it. In task number 7, let's go ahead and cover classification models analysis and KPIs, or key performance indicators. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. In this task, we are going to cover classification models, KPIs, or key performance indicators. Please note that this lecture is quite, I would say, intermediate level when it comes to difficulty, and we're gonna dig a little bit deeper into a lot of technicalities as well. So keep it up, and let's go ahead and get started. If you guys remember, in the previous task, we learned how to train our model. So we click start, we checked out all the different associations as well between features, and we also visualized the, what we call it, feature association pairs, showing the monthly income versus the job role as well. Okay. So what I wanted to show you guys right now is I wanted to show you what we call it the confusion matrix. And please note that we covered confusion matrix briefly in the previous case studies. But right now, I wanted to dig a little bit deeper into additional KPIs, or key performance indicators. And we are going to cover what we call it precision, recall, and we're going to also learn about the ROC, or receiver operating characteristic curve. So if you guys remember, a confusion matrix is simply a visual representation of our classifier model performance. What we do is that we put the predictions here on the rows, and we put the true class here in the columns. Sometimes, just FYI, we might reverse them. So the true class might be here and the predictions might be in the columns. But let's stick with this structure for now. And let's assume that I wanted to, let's say, train a classifier model, and this classifier job is to try to detect cancer in patients. So for example, if the model predicted that the patient has cancer, so this is positive, okay, and in reality, in the ground truth, which is in real life, the actual patient actually had cancer, well, that means the model predictions match the reality. That's a good thing. And that's why we call it true positives. So we put the total number of samples that have been classified as positive here, okay? And then what we do is we say, well, if the model predicted negative, if the model said, well, according to this data, this patient does not have cancer, and in real life the true class was actually negative, meaning that the patient in real life was actually healthy, didn't have any disease at all, or cancer specifically, well, we call that true negatives. And we put the total number of the true negatives in here. So basically what we have right now is, in the diagonal elements, we put the number of samples that the model was able to get it right, okay? All right, now let's go ahead and cover the mess up. Now if the model predicted positive, meaning if the model said this patient has cancer, however, in real life, the true class was actually negative, the patient was fine, he was healthy, but we simply scared him off. We said, well, you have cancer, and in real life, he didn't have anything at all. So that's what we call it false positives. And we list that in general in orange color. And then what we do afterwards is, if the model predicted negative and the true class was positive, we call that false negative. Example is, well, if the patient in real life has cancer, okay, but the model said, well, he's fine, the AI model said he's okay, he doesn't have any cancer or any of that, and that's why we call it false negatives, meaning we missed a detection. And in general, we call these false positives, we call them type 1 error, and we call the false negatives types 2 error. And here in this example, which is the cancer detection case, what we have here, we call this type 2 error because, and we list them as well in red, because, well, the patient actually had a disease, but we missed it. We did not say anything at all. And that's a problem. That means, the patient, unfortunately, like the situation might get worse, and, like let's say the hospital, for example, or the doctor might get sued. There's tons of other issues associated with it. Okay. All right. So here are the various KPIs, or classification models, key performance indicators. We have the true positives. These are the cases when the classifier predicted true, meaning they have a disease, and the correct class was actually true, meaning the patient has a disease. True negatives are cases when model predicted false, meaning no disease, and the correct class was actually false as well, meaning the patient do not have a disease. Now to the troubles. False positives, or type 1 error, that's when the classifier predicted true, but the correct class was actually false, meaning the patient did not have a disease, and the classifier said, well, he has one. And that's why we call it false positives. And false negatives, or FN, or what we call a type 2 error, that's when the classifier predicted false, patient do not have a disease, but they actually did have the disease in real life. Okay, and then what we do afterwards is we calculate what we call the classification accuracy, and simply we go here, we take the diagonal elements, so the number of samples that have been correctly classified, so true positives plus true negatives, and we divide that by the overall number of samples. We divide them by overall, by everything, basically. And then we have what we call the misclassification rate, or the error rate, which is how many samples, percentage-wise, have been misclassified. Meaning, we go back, we take the number of samples here, and plus the number of samples here, and we divide by the overall number of samples. Okay? So false positives plus false negatives divided by the overall number of samples. Okay. So the next definition that I wanted to show you guys is the difference between precision and recall. So precision is simply as follows. Let's go back again. Here we have all the different matrix. And please note that precision versus recall might be a little bit confusing, and that's why I have a practical example available for you guys after in the next slide. But essentially, precision is the following. It's the true positive divided by true positives plus false positive. So simply we get true positives, and then we divide that by true positives plus false positive. And simply we say the following. Precision is when the model predicted true class, how often was it right? Meaning, here the model predicted positive. I just wanted to know when the model predicted positive, when the model said that this patient has cancer, how precise it was. How many times did it get it right, which is the true positive, divided by the true positives plus false positives. Okay, and I'm going to show you guys an example coming up. The second definition is recall, and that's simply the true positive divided by true positives plus false negatives. And simply recall is when the class was actually true, how often did the classifier get it right? Meaning, let's say if I have, for example, 10 cancer patients, how many of these cancer patients I was able to classify correctly or get them basically, or detect them. So I know it might sound a little bit confusing at first. Let's go ahead and show you guys an example. Okay, let's assume that these are the facts. I have 100 patients in total. 91 of those patients are healthy. They don't have any issues. 9 of those patients have cancer. And I wanted to simply calculate the accuracy, precision, and recall. So what I have here, these are the actual model performance. So the model, the true positives were 1, true negatives were 90, false positives were 1, and false negatives were 8. And simply, if I go ahead and I assume, okay, you know what, I'm going to just rely on accuracy. I'm going to say the accuracy is quite misleading, in fact. Let me show you. So if I only decided to only focus on accuracy, I'm going to say the following. The accuracy is, well, 1 plus 90, so true positives, plus true negatives. And then I'm going to divide by the overall number of samples, right? Which is true positives plus false positives plus true negatives plus false negatives. So if I do that, well, 91 divided by 100, that means I have 91% accuracy. If someone from the outside, or maybe getting started with machine learning, well, they're going to say, well, that's amazing. The model is accurate with 90%. However, this model is actually pretty useless. Why? Because accuracy is generally misleading, especially when we have an unbalanced data set, meaning when the number of patients who are healthy, a number of patients who have cancer are off, like, this is like 10x, right? The amount. If you only rely on accuracy, you will get generally misleading results. And that's why we need to go beyond accuracy and calculate additional metrics such as precision and recall. So precision is, well, true positives divided by the row, right? Divided by true positives plus false positive. So simply we're going to say 1 divided by 1 plus 1, which is 2, we'll get 50%. Meaning, when the model predicted positive, when the model said, well, the prediction is plus, meaning the patient has cancer, essentially. Well, it got only one right, only one of those patients have been detected, and the other one was off, right? And that's why the model was 50% precise. And that's why precision is 50%. When it comes to recall, recall is equals to true positive divided by the actual true, meaning true positive divided by true positives plus false negative. And basically is 1 divided by 9, and that means 11%. Meaning, again, when I say recall, all I wanted to know is, out of these 9 patients who actually have cancer, how many of those I was able to correctly detect? So I was only able to get only 1 and actually missed 8 of them. And that's why the recall is 11%, which is really terrible. Okay? Alright. So the next definition that I wanted to show you guys is what we call it ROC, or Receiver Operating Characteristic Curve. And simply ROC curve is a metric that is used to assess the ability of the model to distinguish between binary classes or 0 and 1 classes. And essentially what we do is on the x-axis we put the false positive rate, and on the y-axis we put the true positive rate. Simply, all what I'm trying to do is I'm trying to say, okay, when the model makes predictions, how often does that model is kind of skewed towards the true positives? Meaning, how often is that model is able to actually make correct predictions versus making false predictions? So if I have a model that actually have a perfect 45-degree line here, meaning that this basically model is kind of useless in a way, meaning it's kind of random predictions, because it messes up, it generates false positives in the same rate as the true positives. And that's why what we do is that we wanted to draw here what we call the ROC curve, or Receiver Operating Characteristic Curve. And the ROC curve in general tend to be something like that, like these are the different curves here. Okay, and essentially the more that this curve is skewed towards the top left corner, the better. That means the model is actually making better predictions and is actually skewed towards generating true positives as compared to making false positives. Alright, so let's go ahead and take a look at a practical example. Let's assume that I have 3 models right now. This is the first model, which is highlighted in red, And this is simply a random predictor, meaning it's kind of useless, because since it's at 45-degree angle, that means the false positive rate is pretty much the same as the true positive rate, and the model is just generating random predictions. There is no the model predictions are not skewed towards generating true positives as compared to false positives. And the what you guys see here is generally predictor 1, which is that green one here, is generally better than predictor 2, which is that blue one. Why? Because the area under the curve is actually larger in predictor 1 as compared to predictor 2, meaning that the model is able to make more positive true predictions compared to messing up, comparing to make false positives. And again, what we aim for is we wanted to have the rock AUC, or the area under the curve, we wanted to set it to 1. So if the area is basically, if we cover the entire area here, if I have a predictor that may be pretty much perfect, like making a lot of true positives as compared to false positives, that's a great thing. That means I have a perfect classifier. This model here, meaning that this is just 0.5, the area under the curve, and of course, because the area under the curve for predictor 1 is greater than predictor 2, meaning that predictor 1 is more accurate, or is better compared to predictor 2. Okay? Alright. So that's it. That's all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go ahead and assess our model. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, let's go ahead and assess our model performance. Please note that this lecture is, I would say, quite difficult, but I will do my best to make it as straightforward as possible. And if you guys remember, in the previous task, we learned about the different classification models, KPIs. We learned about confusion matrix. We learned about precision, recall. We also covered the difference as well between the AUC, or area under the curve, and the ROC, or the receiver operating characteristic curve as well. So right now, what I wanted to do is I wanted to dig a little bit deeper into the models that have been trained and start to assess their performance. So here we go. Now we're back to data robots. So if you guys go back to models, you guys will see here, these are all the different models that we have available that have been trained. And if you guys go up here under metrics and maybe change it to, let's say, I want to see, for example, AUC, for example, which is the area under the curve. If you guys remember, what we wanted to do is we wanted to maximize AUC. So if we have a classifier that with AUC that's close to 1, the better. That means the model is able to make better correct predictions as compared to making false predictions. So what we have here, that was actually the best model. It's elastic net classifier, and I'm not going to dig deeper into the actual ins and outs of the algorithm. You guys can check out the documentation if you want, but this is essentially the model here. The model ID is 23, and the metric here, the AUC, is set at 0.89. The next one is actually standing at 0.8864 and then 0.8850. And if you keep going down until you reach the worst one, which was the random forest classifier, which was programmed here in Python language. Okay, so if you guys click on it here, you should be able to see the model blueprint. If you guys remember, we have done that before in yesterday, actually, in day 5. And here we take the data, and then we do regularized linear model pre-processing. And if you guys click on it, you will see that the pre-processing piece, that's actually a proprietary algorithm by Data Robots, so there is not a lot of documentation associated with it. However, if you click on the elastic net classifier, you should be able to see the documentation. So if you just click on it here, you should be able to see the documentation for the algorithm, what hyperparameters do we have, and so on. But again, that's beyond the scope of this course at the moment. Alright, and then next, I want you guys to please go ahead and click on Understand. And you should be able to see all these different feature importance. So what you guys see here is over time actually plays a key role in affecting the employee attrition. And we also have the environment satisfaction. Of course, makes sense as, you know, employees becomes more satisfied with their job, with their performance as well. In general, they tend to stay. They don't want to leave. We also have the number of years since last promotion that also affect the output. And then we have the business travel, number of companies that have been worked for, and job satisfaction. So these are the most important key features that essentially contribute or make or affect the output, which is the classified output. Okay? Alright. The next point that I wanted to show you guys, if you go ahead and click on feature effects, you should be able to see that is right now DataRobot is computing feature effects, and you should be able to see all the different features in order, and you should be able to see as well kind of plot the predictions versus the actual values, just to get an idea of like how accurate your model is from a very high level. And then I'm going to dig a little bit deeper and actually plot the confusion matrix, and as well come up with a precision, recall, and F1 score values as well. Alright, so let's go ahead and explore a couple of these features. So for example, let's say job satisfaction, for instance. And what you guys can do here is these are the actual different categories for job satisfaction, starting from 1, 2, 3, and 4. And these are the actual values. So if you show the predictions versus actual, you will see that the model is actually doing an okay job, essentially, to try to make predictions that match the actual values or the reality, basically. If you check out, let's say, distance from home, you guys will see that the model, again, it's a little bit skewed here, of course, a little bit, and here as well. But again, the trend tend to be okay, I would say. And please note that this data is real-world data set, and it has a lot of, it's not linearly separable. And that's why the performance of the model is, even the best model out of all of them, is not that great. I'm going to show you guys that in the next couple of slides as well. Okay. So what I want you to do next is I want you guys to click on predictions explanation. And I really like this feature here in DataRobot. Basically what it's telling you, can essentially tell you, okay, the model made these predictions because of all these reasons. And this is a key, I would say, important feature when you train any AI or machine learning models, is that we wanted to understand what features that the model actually consider before it make any predictions. And that's what we call it AI ML models explainability. We want to make sure that the model is looking at the same important features that we humans are actually looking at. And that's what we see here. For example, the sample ID 915, for example, has been predicted as almost 1, and these are the explanations. It's telling you that, well, the business travel, well, that certain employee was traveling frequently, his work-life balance was ranked at 1, and his environment satisfaction was ranked at 1, and that's why he probably left, basically, the company. If you check out, let's say, for example, a sample like this one here, okay, this guy here, the prediction was almost 0, and why? Because the business travel was non-travel, he didn't travel at all. Distance from home was 1, and his age is 56, so maybe he was very close to retirement, for example, and he didn't want to, leave the company. He lives very close to home, he doesn't travel, and he's probably satisfied with his job, and he's age 56, he's very close to retirement maybe, and that's why, he didn't want to leave. And stuff like that. That's why you can gain a lot of insight and information here by leveraging AI ML models explainability or prediction explanations, which is really, really powerful. Okay, next I want you guys to click on evaluate, and please note that there are a ton of functions and visualizations here that you guys can do. I'm just going to stick with the most simple one for now, okay? And you guys can please feel free to explore additional options in here, okay? So what you guys see is when you click on evaluate, you should be able to see the bins based on predicted value, and here we have the average target value, and you'll see that the actual model predictions pretty much matches the actual value, which is pretty good. Okay, all right, now to the fun part, and I would say maybe a little bit challenging part. I want you guys to click on ROC, or receiver operating characteristic curve, and here we go. What you guys notice here is we have first our confusion matrix. If you guys remember, just by looking at the confusion matrix, you can tell how many samples have been correctly classified, how many samples have been misclassified, and so on. So here I have the true negatives, here I have the true positives, here I have the false positives, and here I have false negatives. So these are the samples, number of samples that have been correctly classified, and these are the number of samples that have been misclassified. I can also take a look at additional metrics here. So for example, here I have the true positive rate set at 0.58, and I also have the false predicted value, or the precision, which stands at 0.45. What you guys can do as well is that you can go ahead and start to change. If you basically move or shift that threshold value, you guys will see that you can actually play with the F1 score, the true positive, and the precision as well. And I know that this piece might sound a little bit confusing at first, and that's why I included a couple of slides for you guys here. So let me walk you through it first. Okay. All right. All right. So what I'm going to do is I'm going to show you guys two extreme examples. The first example is if I set the threshold too high, and the next example here, if I set the threshold too low or so little. Okay. So the first question is, what do you mean by threshold? Basically what I have here is I have essentially a classifier, and this classifier is generating prediction. Okay. This predicted value could be anywhere between 0 and 1. Might be 0.1, 0.5, 0.6, 0.7, and so on. And what I need to do is I need to say, you know what? I'm going to set the threshold of, let's say, 0.9, for example. And I'm going to say any value that comes above 0.9, I'm going to classify it as 1. Any value that goes below 0.9, I'm going to classify it as 0. Meaning, above 0.9, that means class 1, that means employee left the company. 0, anything below 0.9, that would be classified as 0, and that means the employee stayed in the company. So if I go and set the threshold too high, that means that the model will become super selective, meaning that the recall, which is the true positive rate, will be set to 0. Because I need to be super selective, so I'm not going to be able to essentially detect all the employees who actually left the company, who are classified as one class. And that's why the true positive rate will be set to 0, or very close to 0. But what's going to happen as well is you're not going to be making many mistakes as well, because you became super selective. So your false positive rate will also reduce dramatically as well. So what you guys see here is if I set the threshold too high, what you guys notice is, well, on that curve, on the rock curve here, what you guys see is this data point will be in effect, meaning that the false positive rate will be very, very small, almost 0, and the true positive rate or the sensitivity will be very close to 0 as well. Okay, what if I went the other way around? What if I say, you know what, I'm just going to set the threshold too little, meaning I'm just going to say, okay, the threshold is, let's say, 0.2. Any value above 0.2, that will be classified as 1. Any value below 0.2, that will be classified as 0. So if you set the threshold too little, you are not going to be selective anymore. And that means that most data points will be classified as 1. Basically, I'm going to say, you know what? Everybody left the company. That's every data sample that I have will be classified as 1. And the employee attrition will be essentially everything will be 1. And that means that the recall or the true positive rate will be equals to 1. That means, why? Because you have detected every single employee who have left, because you said everybody is 1, right? However, your false positive rate will also increase dramatically because, well, you mess up too much. You have been making so many mistakes. And this is essentially how you go and you tweak the threshold value. And let me go back to data robots. I know it might sound, again, a little bit confusing for you guys, but this is essentially it. What you guys could do is you can go ahead and shift here the threshold value. So you can change it between very small number and very large number. So if I set the threshold here, so this is the threshold value here. If I set the threshold too high, what you guys see is the false positive rate tends to fall, become almost 0, and the true positive rate will tend to be 0 as well. If you change the threshold value and you shift it maybe to a very small value here, you will notice that the false positive rate starts to increase and the true positive rate or the sensitivity tend to increase as well. So the point is that you need to find a sweet spot, like kind of the best spot for that threshold to be able to maximize, again, any of these metrics. Are you looking to maximize the recall, or do you want to maximize the sensitivity, for example, or the true positive rate, or the precision, or you wanted to maximize F1 score? By changing these values, you can change the actual values in the confusion matrix, and you should be able as well here to change the all the metrics such as precision, recall, and so on. And what you can do as well is you can go ahead here and select between confusion matrix within number of samples and also percentages, so you can get an idea of how many samples in general or in total you have been able to correctly classify. And you can go ahead, of course, by changing these values as well. You should be able to see these numbers change dramatically. Okay, all right, okay, so that's it. That's simply all I have for this lecture. I know that was quite a tough one, but that's all I have for this task. In the next task, task 9, we are going to cover our final project, so please go ahead, stay tuned, we're almost there, and I'll see you guys in the next task. Hello everyone, and welcome to task number 9. Now we are pretty much ready for the final project, which is, I would say, pretty simple, straightforward project. So let's go ahead and get started. If you guys remember, in the previous task, we learned about how to assess our trained models. We saw that the best model was the elastic net classified model. We also we discovered the model blueprint. We checked out the feature importance. And we also studied the explanations as well, or prediction explanations out of our model. And we also went through to study the threshold effect on our various KPIs. And that's pretty much all what we have done in task number 8. So right now, I want you guys to first, using Data Robot, I want you guys to deploy the best model. And then I want you guys to create an application based on the deployed model. And then finally, I want you guys to try at least 3 different values and test the deployed model as well. I want you guys to use the average values to generate predictions as just a good starting point. We have done that in the regression task before, yesterday. And I want you guys to experiment that right now with classification type problems. So please go ahead, best of luck, pause the video, and I will see you guys after the final project is complete. Alright, hope you guys were able to figure that out. So let's go ahead and show you guys how we can do this. So if you guys remember, you just go back to our models leaderboard, and this model has been recommended for deployment. All what you need to do is to say deploy auto model, and then right now it's telling you it's being deployed, and then you click on auto model. Here we go. And what you guys can do afterwards is, so right now the model has been deployed. If you check out the applications, and if you check the application gallery, you can go ahead and click on predictor, and you select model from deployment, and you need to go to the recommended model for attrition on employee data.csv, and you just say launch, and that should simply is going to launch our application. And what you can see here, it's still being deployed, but once it's ready, then you can go ahead and click on open, and that's just simply going to open our application in a separate tab. And you should be able to receive a notification here once the model is deployed and once the application is generated as well. Again, it's taking some time for it to run. Here we go. So now it's telling you application deployed, and if you click on open, now you should be able to see our application. If you say create a record, you say test 1, or you can call it anything you want. And just for the sake of simplicity, you can just say use average values. And here we go. What you guys see here is I have the job role, I have an overtime, I have their monthly income, the age, their marital status, for example, job involvement, distance from home, and so on. And all what you need to do is to simply say, well, get predictions. And here we go. What you guys see here is this prediction is 0.63%, meaning it's slow. That means this employee is most likely to stay. And also you can check out the prediction explanation. It's telling you that this guy works in human resources, the department is human resources, the work-life balance stands at 3, job involvement is 3, and he is divorced, and basically that's why he stayed in the company. And of course you can go ahead and maybe play with the values here. For example, you can change the business travel maybe to travel frequently, and maybe you can also change, let's say, the relationship satisfaction, maybe reduce it, for example. Maybe work-life balance, also reduce it as well. Maybe you can change, for example, the age, maybe change it to 50. For example, years with current manager, make it 1. And maybe change the overtime, make it he works overtime. And let's refresh it. And what you guys see here is that the explanation tends to increase quite a bit. So now the prediction becomes high. Okay, that means that this employee is more likely to leave. And these are the reasoning behind it. Well, he works overtime. He's actually not really happy. Their work-life balance is almost 1. He travels like crazy. Most likely this employee is quite stressed, and his relationship satisfaction is not that great as well, and that's why he's most likely to leave the company. Okay? Alright, so that's it. That's all I have for this project. So let me go back and show you guys here. So these are the different steps. Again, you click on Deploy Auto Model, and then click on Auto Model, create an application, select a predictor, create a record, give it a name, and then pick numbers, and then generate predictions. And that's it. That's all I have for this project. I hope you guys enjoyed it. You guys are doing great, doing amazing. This simply concludes our day number 6. And tomorrow we're gonna start with a brand new project. Please have a great rest and have a great night. And I'll see you guys tomorrow.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 7. I hope you guys had a very good rest last night, and let's go ahead and get started. So today we are going to apply the power of machine learning, artificial intelligence, and deep learning as well into healthcare. And we are going to detect a disease known as diabetic retinopathy, and we're going to learn how to leverage data robot to do that trick for us to build, train, test, and deploy really super powerful machine learning algorithm, and also we'll learn how to deploy that model and make predictions as well. Okay, so as always, we're gonna start with task number 1 with the project card and demo. And please note that this lecture is quite easy, some sort of like introductory lecture. So let's go ahead and get started. So first of all, the goal is to build, train, test, and deploy an image classifier AI model to detect and classify a disease known as diabetic retinopathy. And basically, diabetic retinopathy is a disease that affects the eye, and it's primarily it's the main source of blindness in many countries. And what we're going to do is we are going to leverage data robot, and we have actually used data robot as well in the past to perform classification tasks, to perform regression tasks as well, but we primarily leverage tabular data set. Today we are going to shift gears and actually apply data robot to perform image classification instead. So this project, from a practical point of view, can be effectively used to detect diabetic retinopathy and prevent also blindness among people who are living in rural areas. And these people might have issues trying to access, for example, experienced doctors, and it can be used essentially to automate the medical screening process and kind of reduce the reliance on experienced doctor that might be limited in this area. So the input is going to be images, and the output is going to be class and severity as well of that disease. And what you guys see here on the right hand side, this is an image of a diabetic retinopathy image. And what you guys see is essentially there is some damage here in the blood vessels in the retina within the eye. And it's primarily caused due to level 1 and 2 diabetes. And because if diabetes is left for a prolonged period of time without any treatment, that's basically what happened here. And of course it can cause blindness, which is extremely severe, of course. Okay, so let me show you guys the actual demo. So what we're going to do right now is we are going to take a look at the train model, and we're going to grab 5 images, and these are sample test images, and we're going to essentially feed the images to the train model and see how that model is going to generate predictions. Okay, so what I'm going to do is I'm going to shift right now to our trained model here. So here I have the trained model for the diabetic retinopathy. And if you guys check out the code, the course package, you should be able to see that here I have the train and test. And if you click on test, you should be able to see that here I have 5 test images. And in order to use data robot to essentially test a trained model, first of all, you guys need to make sure that you zip the folder containing all the images. So here I have the zipped folder here entitled test. All what you need to do is just drag and drop. So I'm just going to drag and drop here to generate predictions. Okay, and basically what's going to happen is right now we are uploading the file, and then it's going to process the file, and once that is done, then it's going to go ahead and actually download the prediction file. So here we go. Step number 2 is we're going to prepare file for processing, and it's taking some time in step 2, and then after step 3 is complete, I should be able to have access to an Excel sheet where the predictions for all the different classes is appearing. So here I have step 3. Right now we're processing the file, and here we go. What you guys see here is compute and download predictions has been activated. If you just click on it, so now we are computing, and essentially right now we are initializing the prediction job. All what we're doing is that we're taking the trained network or the trained model. We're going to feed in all the 5 images to generate 5 predictions. And what you guys see, it might take some time for it to run, but essentially you should be able to see it. Here we go. So it has scored 1, 2, 3, 4, 5 rows. And if you open the Excel file that has been downloaded, here we go. And basically what I got here is essentially the all the different classes. So basically, and I'm going to dig a little bit deeper, of course, when we start to train our model. So these are the different severity of diabetic retinopathy. And essentially the first data set, the first image has been classified as severe case. The second one has been classified as moderate, and then severe, severe, and severe afterwards. Okay? Alright. So that's it. That's pretty much all I have for today's task, for the project card and the demo task as well. In tomorrow, what we're going to do is that we're going to go ahead and explore our data. So we'll learn about business case, and also we'll learn about success stories. So that's all I have for task number 1. I hope you guys enjoyed it, and see you in task number 2. Hello everyone, and welcome to task number 2. In this task, we will learn about the business case for today's project, and we'll also cover a couple of success stories. If you guys remember, in the previous task, we covered the project card, we learned about the goal, the tools, the practical real-world application. We also learned about the data and what kind of images we're going to use as well. And we also went through a project demo, and we learned that we are going to grab the images, feed it into the trained network or trained model, and we'll be able to generate predictions afterwards. Okay. So please note, in task number 2, from a difficulty standpoint, it's pretty easy, I would say, pretty straightforward. So let's go ahead. So diabetic retinopathy, as I mentioned, is a disease that results from complications of type 1 and 2 diabetes. And actually, in my family, it hits me directly. We have a history of diabetes on my dad's side, actually. And I know it's really hard to deal with. And the disease can develop if blood sugar levels are generally left uncontrolled for a prolonged period of time. So the disease is caused by the damage of the blood vessels in the retina, which is located in the back of the patient's eyes. And simply, retina is the light-sensitive tissue in the eye. And diabetic retinopathy is the leading cause of blindness in the developed world, and it actually estimates that 347 million people have the disease worldwide. So with the power of AI and deep learning, doctors are able to essentially detect and predict blindness before it occurs. And there is a hospital called Aravind Eye Hospital in India, and there has been a lot of research going on, and Google as well is involved in that research to try to essentially automate the process of detecting and classifying diabetic retinopathy, essentially without relying on an expert doctor. Just so when you do that, you can essentially deploy these systems in rural areas where medical screening and experienced doctors are generally limited. So I highly recommend that you guys go ahead and check out this article here. It's by Kyle Wiggers, so I actually have it open. So essentially, the article states that Google works with Aravind Eye Hospital to deploy AI that can detect eye disease. And I'm not going to read through it. I just want to show you guys from a very high level what's going on. So essentially, Alphabet and Google, they are essentially have been working on developing an artificial intelligence system to diagnose and essentially detect diabetic retinopathy. And It's the fastest growing cause of blindness among the affecting essentially more than 415 million diabetic patients worldwide. And the overall idea is to try to essentially leverage the power of AI to automate the process of detecting and classifying as well the disease. And what you guys see here is essentially the article states that they have been able to train the model with thousands and thousands of images, and they are able to actually kind of achieve human level performance, actually even exceed the baseline performance with over 97.5% accuracy, which is super powerful. So I highly recommend that you guys go ahead and read the article. It's pretty enlightening. And what I'm going to do in the next slide here is I'm going to show you guys these are the different images or classes that we're going to try to classify in our project. So here we have no diabetic retinopathy. That means this is a healthy, essentially, patient. Here we have the mild case. This is a sample from a moderate case. We have severe case. And finally, we have what we call it proliferative diabetic retinopathy. And this is some sort of like severe case, extremely severe case, I would say. So essentially what we're going to do is that we're going to have many images that belong to each of these classes, and then we're going to leverage data robot to essentially classify all these different images. And now it's time for our reading time and for our quiz as well. And the article that I have for you guys today is entitled How Artificial Intelligence is Helping to Prevent Blindness. And the article is by Sandeep Ravindran. I hope I'm pronouncing it right. And it essentially talks about how AI could be used to prevent blindness, and what technologies are being used, what are the trials that are there. I found it really interesting and enlightening as well. So, and I expect this process should take around 10 minutes approximately to read it, and then followed by a quiz that will take around 5 minutes afterwards. Okay? Alright. So that's all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and perform data exploration. Please stay tuned. Best of luck. I will see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, we are going to perform data exploration. Please note that we are still in the easy, I would say, scale here, so it's pretty straightforward lecture. So let's go ahead and get started. If you guys recall, in the previous task, we have been able to cover the business case and success stories. We learned about diabetic retinopathy and how essentially Google has been working with Aravind Eye Hospital in India to try to deploy AI model to detect eye disease. And we learned that we're going to essentially classify between 5 classes. We have the no diabetic retinopathy or healthy case, and here we have the 4 different severity of diabetic retinopathy. And we also went through a quiz. I hope you guys were able to figure that out. Okay, so let's go ahead and explore the inputs and outputs. So in this project, we are going to leverage data robot to build an AI ML model. And instead of leveraging tabular data similar to day 6 and day 5, where we have been able to use tabular data to perform classification task and regression task, today we are going to feed in bunch of images essentially. So we're going to feed in a bunch of input images, and the objective is to try to tell me one of these classes, either no DR, mild, severe, moderate, or proliferate DR. Okay? Alright. And if you guys, we're going to show you, of course, once I go to Data Robot, this is essentially what we're going to be viewing within Data Robot. And this is simply the distribution of all the different classes. So it looks like I have an unbalanced data set. So here I have around more than 500 images that belong to the healthy case or no DR case. And then I have around 200 images belonging to the severe one, around 150 belongs to mild, around 350 to moderate, and the proliferate is around 300 approximately, give or take. Okay? Alright. So that's it. That's simply all I have for task number 3. That was pretty straightforward. In task number 4, let's go ahead and upload our data. So please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 4. In this task, we are going to jump right ahead to Data Robot, and we'll learn how to upload our data and just perform basic exploratory data analysis. Please note that this task, again, it's quite straightforward, pretty easy one, just drag and drop and basic exploration. And we have done that before in the previous couple of days when we leveraged Data Robot to perform regression tasks and classification tasks on tabular data sets. Okay, so if you guys remember in the previous task, in task number 3, we learned about our input images, we learned about the output. We had 5 different classes that we're trying to teach our AI model to classify them, essentially. And we also found that we have the distribution of all the images that we have in the data set is not even, and we have most of the samples belong to the no DR class or the healthy class. Okay, all right. So what I have here is I've included a couple of slides. If you guys remember, we have done that before, just in case if someone decided to just jump right ahead to day 7. I just included these slides here as optional. So Data Robot is simply the leading end-to-end enterprise AI platform that help people, anyone essentially, to build, train, test, and deploy AI models at scale. You can go to this link to access Data Robot, and then you have a free trial. You enter your information, and then you start your 14-day trial. You tell them about yourself, about your industry, and you set the theme as well. I really like the dark theme here. And then you specify that you wanted to create AI models, and then you are pretty much ready right now to go ahead to upload the data, and it's simple drag and drop. And that's what I'm going to do right now is I'm going to head back to Data Robot here, and I'm going to go to the homepage. Here is the homepage, and what I'm going to do is I'm going to say create new project. So that will create a new project here, and all what you need to do is to drag and drop basically images to here, and Data Robot, which is going to essentially analyze the data. It's going to also make the data ready for training as well. So in the course package in day 7, what you guys see here is I have the training data and testing data sets. So the training data, of course, is primarily used for model training. And then once the model is trained, I'm going to assess its performance with testing data sets, which is images that the model has never seen before during training. And what you guys see here is here I have the training. So if you click on it, you should be able to see all these different classes. And within each of these folders, I've included all the different images that belong to each of these classes. So if you go back and if you check out here the train, basically this train here is a zipped version of the train folder here. And when we deal with images, Data Robot accepts a zipped version of our data sets. So I'm going to use the train zipped folder here. I'm just going to grab it and drag and drop to our Data Robot. And basically that's what's going to happen. It's going to upload the data, it's going to read the raw data afterwards. That will take, that's actually pretty quick. And then it's going to perform exploratory data analysis afterwards. And please note, because this data is around 100 megabytes, it might take some time for it to be uploaded. But what I'm going to do is I'm going to go ahead, pause the video, and then I'm going to be back once the data is uploaded. Alright, so here we go. Now the data has been uploaded, and then now we're pretty much ready to perform exploratory data analysis on the data. So if you guys scroll down, the data is actually pretty straightforward. Here, if you click on class, you should be able to see the distribution of all our samples or our classes. So as I mentioned, most of the data, like maybe, actually let's hover on top of it, around 520 images belong to the no diabetic retinopathy case, meaning this is a healthy eye basically. Here we have the moderate case, around 338. We have the proliferate, which is kind of, beyond severe. We have the severe case, and then we have the mild case afterwards. And the next point that I wanted to show you guys, if you go ahead and click on image, you should be able to see here a sample of all the images that we have in our data. which is again super powerful. You don't need to leverage any of the advanced Python visualization tools such as like Seaborn libraries or Matplotlib libraries or any of that. You can just visualize it here in DataRobot, which is pretty powerful. Okay, all right. So let's go back to our slides. So what we have done is simply we have signed up for DataRobot. We dragged and dropped our file. We uploaded the data. We explored the data, and then I wanted to show you guys the data quality assessment as well. In general, we don't have any issues with the data quality, so it was all good. So we didn't have to ignore them or dismiss them, for example, similar to previous projects. Just keep it as is. And then we checked out the different distribution, I would say, of the data and the count of all the images per class. And that's it. That's all I have for task number 4. I hope you guys enjoyed it. In task number 5, we're going to be pretty much ready to go ahead and train our model. And please know that the upcoming lecture is quite in the intermediate level difficulty. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, let's go ahead and train our machine learning model. If you guys remember, in the previous task, we have been able to upload the data and sign up, of course, to DataRobot. And essentially, we have been able to check out as well the distribution and count of all the different images per class. And today, we are going to go ahead, select our target, and then train our model. So what I'm just going to do, we're just going to go back to our DataRobot here. And the first step is I need to select the target. So if you guys remember, all what we have is a bunch of images. These are the input to the model. And here I have the class. So I'm just going to say class use as target, and that the target here has been selected. And if you guys remember, the data quality assessment was actually pretty good. There is no excess zeros, no missing images, no outliers. It's all pretty good. And that's it, really. So now I'm pretty much ready to go ahead and train our model. And before I do that, if you guys see here on the left hand side, I have the distribution of our classes. So here I have the no DR is most common class. It has over 500 images. And then the rest of the class is kind of more of like a normal distribution kind of distribution. So what I'm going to do is please go ahead, click on start, and that is going to kick off the training for various models. And of course, I'm assuming you guys are familiar with this right now. On the right hand side, I have the setting target feature, creating the cross-validation and hold out partitions, and then going to characterize the target variable, load the data set and prepare it, and then save target and partitioning information, analyze features, and then generate the model's blueprint as well. So if you guys go ahead and click on images, what you guys see here is these are the sample of images. So these are 30 images that belong to various classes, okay? And if you check out class as well, you should be able to see all the different distribution. We have done that before. And what I'm going to do is I'm going to head to models, and once essentially the all these processes are over with, you should be able to see the leaderboard here showing all the different models and their performance as well. And what I'm going to do is I'm going to pause the video, and then I'm going to be back once the models are trained. Alright, so I would say it took around 5 minutes for all these models to train. And please note that there are still a couple of models as well that are being trained as well in queue here. But overall, we have our regularized logistic regression model that has been the model that has been recommended for deployment. And if you guys go ahead and check the metric here, maybe change it to, let's say, accuracy, for example, you should be able to see that this one is, I would say, one of the best ones, standing at 0.70. If you check out the AUC or area under the curve, this one is, I would say these two are quite comparable to each other, but this one has been recommended for deployment and also prepared for deployment as well. And if you guys scroll down here, you should be able to see the Keras Slim Residual Neural Network Classified Model. And if I, let's say, decided to, for example, grab these images and, let's say, train a machine learning model or a deep neural network model, let's say using Python and in an Anaconda environment, for example, what I'm going to do is I'm going to generally use a deep neural network to do the classification, because they are super powerful and they work really, really well with images as well. So for example, I can use, let's say, ResNet or residual neural network to do that trick for us. Or here, for example, the data robot here had selected a pre-trained mobile net v3, which is, think of it as more of a prune network, like kind of a crash version of a deep neural network that could be run effectively on a mobile device. So they're basically like computationally efficient, essentially. So what you guys see is, you should be able to see here, this is the blueprint. You take the data and then you check out the images variables, and then you don't do any image augmentation. And we essentially do image augmentation to try to improve the generalization ability of the model. And then you feed it into a pre-trained network. There is some sort of like transfer learning in here. And then there is standardization, and then Keras Slim residual neural network classifier, and then you afterwards use it to generate predictions afterwards. If you guys go back to the data and if you check on images, what you guys see here is, you should be able to see right now the 5 classes, and it can show you as well the number of samples or images per class. So for example, if you check out the NoDR class, if you open it, you should be able to see that are 520 rows or 520 images. And what you guys see here is all these different blood vessels here, they look pretty intact, meaning there is no leak or no damage to the blood vessels. Again, I'm not an eye doctor per se, but I tried to read as much as I can to understand, like, how can I differentiate between all these different images. But this is essentially how you can tell that there is no diabetic retinopathy, because all these different blood vessels here are pretty intact. So there's no leak, for example, anywhere. And these are the features that the AI model should be actually looking at when we train. Okay? If you go ahead and check maybe, let's say, one of the cases, let's say the severe case, for example, what you guys see here as well, for example, here, looks like there is a leak here in these blood vessels, or there's like a damage in the blood vessels. There's some damage here as well. If you scroll down, you should be able to see that there is some damage here too. All of that, of course, can cause blindness. And that's where the deep neural network and AI in general can come in here, intervene, and try to solve these issues. Okay, so the next topic that I wanted to cover is, I wanted to go back to our model. So I'm just going to go to models again. And then if you click on the model that has been recommended for deployment, you should be able to see, if you click on describe and then you click on model info, here is the info of the model. So it can tell you essentially the model file size is 0.2 megabytes. Can also show you the prediction time. So it takes around 19 seconds for it to score 1,000 rows. So that can be effectively kind of a metric that is important, especially if you plan to run this model in real-time applications. And what you could do as well is, you can go ahead and explore the confusion matrix as well. So for example, if you go ahead and click on metrics, so if you say evaluate, and if I click on confusion matrix, you should be able to see the confusion matrix here. If you guys remember, these are the actual values here in the rows. Here are the predicted values. And what you can see here is, essentially, you can see that these are the number of samples that have been correctly classified, and these are the number of samples that have been essentially misclassified. Okay? Alright. So please know that there are tons of options here, and there is a tuning option. There is also an understand and describe as well. There is so many options. We're going to dig a little bit deeper into those in the next couple of tasks. And that's it. That's all I have for today's task. Let's go back to our slide here. So what I've got is, let's recap. Basically, in today, we have been able to train our model, start the training. We have been able to explore all these different 5 classes. We also checked out our leaderboard. We checked out the model blueprint. And then we have been able to explore the model that has been recommended for deployment. We also checked out the model info, such as prediction time, for example. And also we checked out the confusion matrix as well. And that's it. In the next task, in task 6, we are going to learn how to deploy our model, which is the best model. And then we're gonna learn how to make inference on our deployed model. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 6. In this task, let's go ahead and deploy our model. if you guys remember, in the previous task, we have been able to train our models, to actually train multiple models, and then we have been able to explore the best one, which has been recommended for deployment by Data Robot. Okay, so what I'm gonna do is right now, I'm just gonna head back to our Data Robot here. And what I wanted to do next is I wanted to deploy the model. So if you guys remember, I can simply click here on the regularized logistic regression, and then you click on deploy auto model. So here right now we're deploying the model, and then you click on auto model. Okay, here we go. Now the model has been deployed. And what I'm going to do right now is I'm not going to create an application that leverage the endpoint. Instead, I'm just going to click on predictions. So I'm just going to click on predictions here. And if you guys remember, we have done that before when I showed you guys the demo in the first lecture today. So all I wanted to do is I wanted to simply drag and drop our testing images in here and see how we can generate predictions. So what I'm just going to do is I'm going to grab the test images. If you guys remember, that was a test. So I'm just going to drag and drop here, and it will take some time for it to execute or for it to run. And now we are essentially uploading the data, preparing the file for processing, and then finally we are going to generate predictions afterwards. And then once we are done, we are gonna essentially have access to a CSV file or an Excel sheet where we can see all the different predictions coming out from every model. Okay, so what I'm gonna do is I'm gonna go ahead and pause the video, and then I'm gonna be back once the predictions are generated. Alright, so here we go. So now we have been able to, if you guys see here, compute and download predictions have been activated. So if you click on it, that simply is gonna compute or generate our predictions. And what you guys see here is showing initializing prediction job. It might take a couple of minutes for it to run. So what I'm just going to do is I'm going to pause the video, and then I'm going to be back once the predictions are generated. Alright, so here we go. So what you guys see here is we have our test.zip, and you should be able to see a CSV file that has been available for download. And here we go. What you guys see here is the first image has been classified as severe, and these are all the different probabilities that has been generated for each of the classes. Because the class severe predictions was 0.64, that was the maximum compared to the proliferate, and compared to the mild case, that's why it has been classified as severe. Same deal as well here for moderate. What you guys see here is the moderate one here has the highest prediction, which is 0.44. That's why it has been classified as moderate. And then same deal as well, severe, severe, and severe. Okay? Alright. So what I'm going to do is I'm going to go back to our slides here. And that's simply all the different steps. So let me recap what we have done so far. So what we have done is we took the best model that has been recommended for deployment. And then we here clicked on predictions. And then afterwards, we have been able to drag and drop our test.zip file here to generate predictions. You click on compute and download predictions, and then you check out the Excel sheet. And that's it. That's all I have for task number 6. I hope you guys enjoyed it. In task number 7, let's go ahead and shift gears a little bit and cover explainable AI and GradCam visualizations. And please note, just as a disclaimer, that the upcoming lecture is actually one of the hardest one. And I'm going to try to make it as easy as possible. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. In this task, we will learn about explainable AI and GradCam visualizations. As a quick disclaimer, this lecture is quite advanced, and I actually put it as kind of, one of the hardest lectures. But I'm just going to do my best to make it as simple as possible. So let's go ahead and get started. If you guys remember, in task number 6, we have been able to deploy our trained model, and we have been able to test as well and assess the performance of our trained model using a bunch of images that the model has never seen before. And we ended up with an Excel sheet that include all the different predictions. So we had the prediction was severe, moderate, then severe, severe, severe. Okay, all right. So what I'm going to do right now is I wanted to show you guys what we call it AI ML models explainability. So as an AI developer, what you essentially are looking for is, yes, you want to go ahead and train a model, but what you wanted to do as well is you wanted to make sure that that model is actually looking at the right stuff in the image to make given predictions. What I mean is we wanted to avoid treating AI models as black box. We actually want to open the brains behind it and try to look at the various layers and see if the AI model is actually looking at the right areas within the image or not, similar to humans. By doing that, then we can have more trust in our model, and of course you can deploy it in the field with a lot more level of confidence per se. Okay. So what I'm going to do right now is I wanted to remind you guys with how convolutional neural networks work. If you guys remember, we covered that before. Essentially what we have here is I'm going to take a look at data sets known as the food classification data set. Essentially I have a bunch of images for food elements, and I'm trying to classify it to either dessert, fried food, seafood, and or vegetables and fruits. So for example, here I have an image of fried food, and then the model, the AI model, should predict that this is a fried food, okay? And if you guys remember, first we have our dense, fully connected artificial neural network. And what we do is we take the image, if you guys recall, and then we extract the important features from this image using our kernels or convolution layer. So we use all these different feature detectors to extract important information from our image. Afterwards, we perform what we call it pooling. So we try to perform pooling or downsampling. So essentially we reduce the size of all these feature maps to reduce size here. And then we take all these pixels, we flatten them up, and then we feed them to a dense, fully connected artificial neural network as we see in here. Okay? Alright. And if you guys remember, that was the Ryerson website. If you guys recall, that was the link here. That was the convolutional neural network in action. Essentially, we feed in here an image of, let's say, number 3, and then we have our first convolution layer, followed by a downsampling layer, which is this layer here. And what you guys see, the size has been reduced compared to this one. And then afterwards, we have another convolution layer, which is this layer here, followed by another downsampling. And then we take all these pixels, we flatten them up, we flatten it up here, and then we add a dense, fully connected artificial neural network to generate specific prediction at the end. Okay? Alright. So what I wanted to do right now is, well, now I know how convolutional neural networks work. Now I wanted to perform, again, explainable AI, or understand what is actually going on under the hood, what is actually going on behind the scenes. Basically what I'm trying to do is I'm going to use a technique known as gradient weighted class activation mapping, or GradCAM. And this technique helps visualize the regions of the input that contributed towards making predictions by the model. Basically, if you have an image like this, in order for the AI model to make predictions, well, maybe it's looking at this area, for example, in the image. Maybe it's looking at the color or maybe texture of this area. And that's why it triggered it to tell that this image belongs to the fried food category. So what we do here is we essentially superimpose the input image and we put on top of it a heat map. And based on this heat map, I can essentially check out or kind of look at the areas or regions within the image that have contributed to making this specific prediction, which is in this case was our fried food predictions. And that's what we call it, the activation maps, essentially. So the technique does so by using the class-specific gradient information flowing into the final convolution layer of the CNN to help localize the important regions within the image that resulted in predicting that particular class. I know it might sound a little bit confusing at first, so let's go ahead and show you guys that in details, okay? So what you guys can see here, this is essentially GradCAM in action, okay? All right. So what I'm going to do is in the next slide here, okay, I'm going to go through the steps and then I'm going to go back and forth to show you guys what's actually going on this diagram. All right. So the first step is to visualize the activation maps. What we do is we take the image and then we feed that image through a model to make predictions. So if you guys go back here, we have our CNN. a convolutional neural network. And please note that this CNN right now is trained. It's trained, weights are frozen, everything looks great. And now I'm gonna take the image, which is my fried food image, and then I'm gonna pass it through the network. And the network will essentially gonna generate predictions. So if you guys go back, this is the first step. Okay, so we pass the image through the model to make predictions. Next, we use argmax to find the index corresponding to the maximum value in the prediction, which gives the predicted class. So basically what we have here is, once we feed the image to the network, what happened is you essentially have 4 different classes here in the output, either dessert, fried food, seafood, or vegetable and fruit. And think of it as, essentially in the output, we have 4 different probabilities. It could be any number that range between 0 and 1. And essentially what we do is that we use the argmax to be able to tell me, well, here, because the image here was fried food, and because the convolutional neural network was actually properly trained, what you guys can see here is perhaps maybe like the predictions was, let's say, 0.05, maybe 0.1, maybe 0.1, and the fried food here category was maybe like, let's say, 0.7, meaning that this output here has the highest value. That was the highest probability, indicating that's most likely this image belonged to the fried food class or category. Okay, all right, so that was the second step. What we do next is we calculate the gradient that is used to arrive at that value with respect to feature map activations, AK, of the convolution layer. So basically, after we take that prediction here, which is Y predictions, we take that output and then we obtain the derivative. We obtain the gradient of that output with respect to the activation maps, which is A here. And the overall idea is that we're trying to find where are the areas in the image that actually have contributed to make the fried food prediction, essentially. And that's essentially the derivative part here. So we take after we perform the argmax, we take the output, which is Y, we obtain the derivative of that output with respect to the activation maps A. And then what we do is we obtain, or we apply, what we call global average pooling. So we average that over the entire features here. And then we obtain a value is called alpha. All right? Okay. Since we want to enhance the filter values that resulted in generating that specific prediction, what we do is we multiply the filter values obtained using TensorFlow.gradient tape. And essentially TensorFlow.gradient tape is used to obtain the gradient. Okay, so we multiply the gradient times the filter values in the last convolution layer. And essentially that will help us enhance the filter values that help us generate this specific prediction, which was fried food in this example. So if you guys go back, after we calculate the alpha, which is here the derivative of the output with respect to the feature maps, what we do afterwards, we multiply the alpha, which is the gradient values, times the A. And once we do that, we take these values, which is alpha times A, and then we apply, first of all, we sum them up. We obtain the linear combination of it, and then we apply ReLU, or rectified linear unit activation function, on it. And once we do that, then we'll be able to generate a heat map. And in this heat map, just by taking a look at the colors, you should be able to see what regions in the image, in this image here, has contributed to making this prediction, which was fried food predictions. I know it sounds a little bit confusing. I understand it's quite hard. And if you guys wanted to dig a little bit deeper into this technique, please check out a couple of my other courses. I have the Modern Artificial Intelligence course with 6 practical case studies. And one of the case studies just dig a little bit deeper into the actual coding and what's actually going on behind the scenes as well, in much greater details. But of course, here in this course, as promised, I'm trying to make every single project with 0 coding. Okay, so just think of it at just a very high level, very high overview of what's actually going on behind the scenes. Okay, all right. So after we enhance the filter values, what we do, then we perform weighted combination of activation maps and follow it by a ReLU to obtain the heat map. So essentially we multiply the alpha times A, we sum them up, we obtain the ReLU, and that essentially is going to generate our heat map. And then finally what we do is that we superimpose the feature heat map on top of the original image to see the activation location on the image. So essentially we superimpose this heat map on top of the image to show me the actual image. On top of it, we have the heat map, and you can of course tell which areas or which regions have contributed to generating this specific prediction. Okay, and if you guys wanted to read a little bit more about this technique, I've included a paper for you guys here. You guys can go ahead and check it out. All right, so let's go back to our data robot. So basically, what I want you guys to do is once you grab the model, if you click on understand, you should be able to click on activation maps, and you should be able to see this really powerful, intuitive visualizations. Basically, this is essentially the explainable AI in a nutshell. You can actually see which regions in the image has actually helped triggering or making that specific predictions. So for example, in this image here, the network was actually looking at this region here to generate that specific prediction, meaning that, well, that's actually a good thing, because that means the actual network was actually looking at the veins here, or at the blood vessels. And as we know from the diabetic retinopathy introduction lecture, we know that the actual diabetic retinopathy actually relies primarily on the leakage that occurs within the blood vessels. And because the actual network is looking at the blood vessel, that's a good thing. That means the model is actually looking at the right areas within the image to generate that specific prediction. Same deal here as well. The network was actually looking at this region as well to come up with these predictions. The network here looked at this region, so it looks like this might be a mild case. Also here we have the network was looking at this region too, and again this looks like a mild case as well, or a moderate case, where there is a little bit of damage within our the blood vessels here. And I wanted to show you guys how does that work in Data Robot, but please note that it has been giving me some troubles here, and I actually wanted to report that to the Data Robot team. Essentially, you guys should be able to run it on your machine. So basically, you guys see the activation maps here are being shown. However, it just breaks down afterwards, just tell you something went wrong. But hopefully they will be able to fix it at some point. But essentially, if you click on understand, and then if you click on activation maps, you should be able to see all the different activation maps here. And what I've done, I've actually taken a snapshot here so you guys can be able to see it, because it goes right away, goes blank right away. Perhaps it has something to do with maybe the size of the images, for example. Let me refresh it again for you guys. Again, right now the activation maps are being generated here, which is super powerful, but unfortunately it just shows there is an error that appears right away. And again, that's all I have for this lecture. I hope you guys enjoyed it. Let's recap what we've done so far. In this lecture, we learned about explainable AI and GradCam visualizations. We learned about convolutional neural networks. We learned how they actually work behind the scenes. And we also covered explainable AI, what it is, and also we covered the GradCam visualization technique. And finally, we went through the different steps of GradCam visualization strategy. And then here, I showed you guys how to do that in Data Robot. Okay? All right, so that's all I have. Congratulations, you guys have made it. In the next task, in the final task, we're gonna go ahead and cover our final project. So please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, let's go ahead and cover our final project. If you guys remember, in the previous task, we learned about AI ML models explainability. We learned also about GradCam visualizations as well. So we learned how convolutional neural networks work. We learned about how to visualize convolutional neural networks in action as well. We also covered explainable AI and also GradCam visualization here. And finally, we went through the different steps of GradCam visualizations. And finally, I showed you guys how to visualize the various activation maps in Data Robot. Okay, so let's go ahead and show you guys the final project. So in this project, we will assume that you work as a consultant and you have been hired by a hospital in downtown Toronto to automate the process of detecting and classifying chest disease. The team has collected X-ray chest data and essentially approach you to detect and classify the disease in less than 1 minute. And basically we have right now 4 different classes. We have 133 images that belong to these 4 classes. We have healthy case, we have COVID-19, bacterial pneumonia, and viral pneumonia as well. And what I want you guys to do is essentially train an AI ML model to essentially grab all these different images. So here I have, for example, normal case or healthy case, viral pneumonia, bacterial pneumonia, COVID-19. Just grab all that data, feed it in, train an AI ML model to generate all these different predictions and classifications. So here are the goals. I want you guys to use the COVID-19 chest X-ray data to train an AI model that can detect and classify images. Test the model by exploring confusion matrices and model accuracy. Deploy the model and assess its performance with brand new images that the model has never seen before during training. And then finally, I want you guys to visualize the convolutional neural network activation maps. So what I want you guys to do right now is, if you guys go to the course package, so in the course package under day 7, you should be able to see the final project dataset. If you just open it, if you click on lung disease AI, you should be able to see the training data and the testing data as well. And here are as well zipped versions of the training and testing data, because of course you guys will need them when you upload the data to Data Robot. So that's all I have. This is just an overview of the final project. Please go ahead, give it a shot. Best of luck. Pause the video, and I will see you guys after the final project is complete. Alright, so let's go ahead and train our model. So if you guys go to the home page for Data Robot, and then you click on Create New Project, and then all what you need to do is to simply go to the course package, grab the lung disease training data here, just drag and drop that, and that's it. Let Data Robot do the magic for you. So here we're uploading the data, then we're going to read the raw data, and then perform exploratory data analysis afterwards. So what I'm going to do is I'm going to go ahead, pause the video, and then I'm going to be back once the data is uploaded. Alright, so now the data has been uploaded, and what you guys can see here, if you scroll down, you should be able to see the class. So if you click on class, you should be able to see that we have equal distribution of all the different classes. So I have 133 images that belongs to the bacterial pneumonia, 133 images belong to the healthy class, viral pneumonia, and COVID-19 as well. And if you click on images, you should be able to see all the different images here belongs to all the various classes. And essentially what you guys need to do next is the next step is to select the class to be the target. And once you do that, you should be able to click on start, and that will kick off the training job. And what you guys see here on the right hand side, you will be creating the cross-validation and holdout partitions, and then you're gonna characterize the target variable, load the data set, save the target, analyze features, and generate blueprints as well. So what I'm gonna do is I'm gonna pause the video, and then I'm gonna be back once the model is trained. Alright, so what you guys can see here is the training process took around, I would say, 5 minutes for it to train, and it's actually still work in progress as well. It's still in process. So if you guys hover on top of the models, you should be able to see all the different trained models that have been trained here with Data Robot. For example, here I have the Keras Slim Residual Neural Network, for example, and it's again implemented in as a Keras model. We also, if you go up, you should be able to see there is another Keras Slim Residual Neural Network as well. And if you simply click on it, this one has been recommended for deployment and also prepared for deployment as well. So what you guys see here is we consume the data, we don't do any image augmentation. And essentially image augmentation is a strategy or a technique to try to improve the generalization ability of the model. Basically taking the image, maybe rotating it 90 degrees to the right, 90 degrees to the left, changing the brightness, for example. And the idea is to try to expose the model to multiple variations of the original image to make it generalize and not memorize. And basically we're not doing any image augmentation. And then we use a pre-trained MobileNet v3 model, and then they do normalization, and then they feed that to the Keras Slim Residual Neural Network classifier training, and then afterwards we generate the predictions afterwards. Okay, so the next step is, well, I can go ahead and say evaluate, for example, and then you should be able to, if you check out the predictions versus the actual value, it looks like it's pretty good fit. If you click on confusion matrix, you should be able to see the confusion matrix, and it looks like the models actually did pretty well, given that we only have a very small number of samples. We only have 133 images per class, which is not that high. And again, the model has been doing pretty well overall. And in order to deploy the model, what you guys need to do is you need to grab that model, as you guys recall. Actually, before deploying it, if you guys remember, you can change the metric here. For example, if I check the AUC, you almost reach almost 98.98 for the area under the curve, which is very close to 1, indicating that we have a really good classifier model here. To deploy the model, you just say, well, this has been recommended for deployment. You just say deploy auto model, and now we are deploying it. And then if you click on auto model, you should be able to see that the model here has been deployed. And then what you could do next is, if you click on predictions, you can simply drag and drop the testing data. So if you guys go back, you should be able to see that here we have the lung disease testing data. You can just drag and drop that here. And basically within that zip folder, there are a couple of images. So you can essentially see the predictions out of these images. So here it's taking some time for it to be uploaded, and then it's going to be fed to the trained artificial neural network model. So now they are preparing the file for processing, and then finally they are going to generate predictions afterwards. Alright, so here we go. Now we have our compute and download prediction tab here has been activated. If you just click on it, and you should be able to see that now the prediction job is being initialized, and it will take again a couple of seconds for it to run and for the predictions to be generated. And then afterwards we should be able to download a CSV file that includes all the different predictions within our model. And here we go. What you guys see here is I have 12 rows, essentially 12 images. So if you go ahead and click on the Excel sheet, you should be able to see an Excel sheet including, here we go. So what you guys see here is the first image. So these are the different predictions coming out from the image. Okay, so the first one here was bacterial pneumonia, and what you guys see here is the actual data was actually bacterial pneumonia here. So from the naming convention, you can tell that the true class, what the true class was. And you should be able to see, if you compare the predictions, that the class bacterial pneumonia here has the highest probability at 0.79. If you check out, let's say COVID-19, for example, COVID-19 here, that was the highest one of 0.99, and that matches COVID-19, COVID-19 as well. And then we have the viral pneumonia versus viral pneumonia, that's pretty good. And again, the prediction here was 0.96 for the class of viral pneumonia. Bacterial pneumonia next matches bacterial pneumonia. Here we have, this one actually has been, this one is healthy as well, looks pretty good. Then bacterial, healthy looks great. Viral, 2 virals, and then healthy, and then COVID. And it looks like the model actually did a pretty good job overall, which is pretty amazing, pretty great. And that's it. That's simply all I have for this project. I hope you guys were able to figure out the project. And I've included here a couple of snapshots of all the different stages or the steps that we have done. The last point that I wanted to show you guys is, if you click on understand and then activation maps, you should be able to see the areas where the model was actually looking at, and that will help you explain what the model was actually thinking instead of just treating it as a black box. And the final point is, please note that when you guys run the activation maps, you might find that the data robot just gets stuck somehow. It just says, like, like there's an error that occurred essentially, and that's why I try to take snapshot here and just save it, just in case if you guys wanted to just see what's actually going on here behind the scenes. Alright, okay, so that's all I have for task number 8. I hope you guys enjoyed it. Congratulations, and that's all I have for today's project. Please stay tuned. Best of luck. Take some rest, and I will see you guys tomorrow. Hello everyone, and welcome to day number 8. I'm super excited because today we are going to start with a brand new project, and we are going to learn how to deal with text data. So in this project, we are going to build what we call it a sentiment analysis model to get an insight of what customers are talking about. Are our customers, for example, happy or not? We can get sentiment from text data, which is a super powerful tool that can empower any company to gain insights about their customers, kind of understand, are they happy or not? Why are they happy? Why they are maybe like they dislike the product or service? And we are going to leverage Data Robot as well to do that trick for us today. Okay, so as always, in task number 1, we will start with the project card and the demo as well. And please note that this lecture is categorized under the easy category, so it's pretty straightforward. Let's go ahead and get started. Alright, so here we go. So the goal of today's project is to build, train, test, and deploy an AI model to predict sentiment from real Amazon Echo customer reviews. So the picture that I have here is for the an older version of the Amazon Echo, and it's essentially a product that is offered by Amazon, and it's powered by Alexa. And think of an Alexa as assuming most of you guys are aware of it, but just in case if you aren't, basically Alexa is a virtual assistant that is powered by AI. So you can essentially call Alexa and tell her, okay, like, Alexa, please turn on the light, for example. Alexa, please book an appointment for me, and so on. And what we're going to do today is we are going to leverage Data Robot, and that will be the tool that we're going to use to build, train, test, and deploy our project. So the question is, what's the point of all of this? Like, what is the practical, real-world application? So AI and ML based sentiment analysis is essentially crucial for any company, because any company right now has a social media presence. They have Facebook pages, they have Instagram, they have Twitter, and as a company, what you wanted to do is that you wanted to automatically predict whether their customers are happy or not. I want to, every, let's say, week or every month, to go out there, kind of harness all the data that I have about my company on every single social media platform. And I wanted to automatically tell, are my customers happy or not? What are they actually talking about? And if they are not happy, why is that? And that's essentially what we're going to learn in today's project. And we are not going to do that manually. In fact, we are going to leverage artificial intelligence and machine learning to essentially do that process automatically for us. So this process could be done automatically without having humans manually review thousands of customer reviews. So the question is, what does the data look like? Well, the inputs is going to be Amazon reviews. So these are going to be real customers giving or writing real reviews on the Amazon Echo product. And the output, it's going to be either 0 or 1. So I just want to say, okay, like, are my customers happy or not? And in addition to that, we are going to also visualize a lot of the text data, and we're going to gain a lot of the insights about if my customers are happy, what are the common words they are talking about? What are they happy about about my product or service? And if they are not happy, okay, why aren't they happy? Like, what's the main keywords that they are talking about? So it's going to be tons of fun. We're going to learn a lot. So let's go ahead and show you guys a demo of what we are going to achieve today. So today we are going to build an application, okay? And if you guys remember, we have been able to build applications as well in the past. We have been able to leverage Data Robot to build a regression type, or to solve regression type problems, to solve classification type problems. And these were on tabular data. We have also been able to use Data Robot as well to classify images, if you guys recall, and that was yesterday. Today, we are going to learn how to deal with text data, okay? And when it comes to the application, I'm going to have two main inputs that I need to provide. The first input is going to be my verified reviews. Essentially, assume that you're a customer and you want to write a review to the Amazon Echo product. And what you need to do as well, or you need to provide a variation. Basically, when you buy Amazon Echo product, there are going to be tons of variations here. For example, it could be, let's say, walnut finish, for example, or maybe, let's say, it's an oak finish. They have different finishes here. So what I'm going to do is I'm going to say, okay, from a verified review standpoint, I might say maybe I'm a happy customer. So I'm going to say, I love Amazon Echo. The product is super cool. Something like that. And I'm going to choose a variation to be, let's say, you guys can pick anyone. Let's say walnut finish, for example. And if you click refresh, what you guys see here is the model has been able to grab the sentiment from the review here and is able to tell me, well, this is a positive review that is 98% high, meaning the output was 1, meaning that the customer is happy. And again, we have been able to do that automatically, which is super cool, super powerful. Alright, so let's go ahead and try a negative kind of review. Let's assume that I have a customer and this customer is not happy, is not satisfied. So I'm going to go here and write, let's say, I hate Amazon Echo. The sound quality is, let's say, terrible, for example, something like that. And if I change, let's say, the variation, for example, change it to, let's say, whatever, like charcoal fabric, for example, and if you run it, what you guys see here is now the classification has been classified as low. And please know that here I have my threshold, meaning anything beyond that, that means it's high, means it's positive. That means the customer is happy. Anything below that, especially if it's in the tail end here, meaning that the prediction is low, meaning think of it as the output is 0, indicating that now I'm not happy with the product. And that's essentially how you perform sentiment analysis, and that's what we are going to build today. Okay, alright, so what I'm going to do is I'm going to head back again to our slides here, and this is essentially the demo that we're going to build today, the app that we're going to build. And that's all I have for task number 1. I hope you guys enjoyed it. Task number 2, let's go ahead and cover our business case. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 2. In this task, let's go ahead and cover our business case. If you guys remember, in the previous task, we covered the project card and we also covered the demo, and we learned that we are going to build an AI ML powered sentiment analysis tool that can essentially consume text data, and it can tell me if that sentiment is positive or not. Are my customers happy or not? Okay? Alright, so in today's task 2, we are going to cover the business case, and if you guys see here, again, this lecture is categorized under the easy category. Alright, so let's go ahead and cover the applications of natural language processing techniques. And in this project, what we're going to do is that we're going to build an NLP model, or a natural language processing model, that can essentially predict customer sentiment from real Amazon Echo customer reviews. And as I mentioned in the previous task, is that AI ML based sentiment analysis is crucial for companies to automatically predict whether their customers are happy or not. And there are so many applications of sentiment analysis and AI ML NLP techniques per se. And let's go ahead and cover some of those. First one is social media monitoring to understand what makes customers angry or happy. Also, NLP techniques could be used for customer service. So you can essentially use customer service techniques with personalized messages to customers. You can also perform what we call it brand monitoring. So you want to monitor the brand over multiple channels or outlets, such as Facebook, Instagram, Google Maps, and so on. You can also do market research and perform analysis as well on the company's competition. So instead of consuming your own data, you can also kind of analyze the competition too. So you can consume as well and perform brand monitoring on the competitors as well by doing market research and analysis, again with the power of AI and machine learning. And then finally, you can analyze employees' voice on Glassdoor, for example. If you guys are not familiar with Glassdoor, essentially it's a website where former employees or current employees can essentially talk about the company, can say if they're happy at the company or not, and essentially any company can go ahead, scan the data or harness the data from Glassdoor, and then they can perform sentiment analysis to understand what makes employees happy, why they are not happy, and so on. So Monkey Learn is a great tool that could be used by essentially any company to perform sentiment analysis on text data, essentially from customers. And you can also understand the intent from the customers as well. So here is a link to Monkey Learn. So if you guys, I have the link open here. So you can essentially leverage Monkey Learn to train custom machine learning models to get the topic, sentiment, intent, keywords, and more. And there's a really cool video here, so I'm just gonna play it to you guys.
Language, text. It's how the entire world communicates, making our thoughts visible and our voices heard. But in business, when the messages flood in or the support tickets pile up, we can't extract the information we need or properly engage with our customers. And that's why there's Monkey Learn. Monkey Learn makes it possible for companies to analyze and organize text at massive scale through trainable artificial intelligence. By classifying information by topic, customer intent, and even their sentiment. All of this is actionable data that you can extract via companies, people, keywords, and more. Monkey Learn already integrates with the apps you use every day. And for developers, you have access to simple APIs and SDKs, so you have the power to use machine learning on all your unstructured data. From marketing and sales to customer service, Monkey Learn's text analysis can automate entire workflows. Whether you need to categorize support tickets, organize all your replies for mass email campaigns, or process huge quantities of valuable customer feedback, Monkey Learn now makes it all possible. AI that's designed for scale and simplicity. Monkey Learn.
Alright, I hope you guys enjoyed this video, and actually I'm not going to be covering Monkey Learn in this course, but essentially I might consider it in the future because the tool looks really powerful actually. Alright, so here is a summary again of the business case. We have covered that, and now it's time for our reading time and the quiz as well. And the article for today is actually from Monkey Learn as well, and the article is entitled AI-Enabled Sentiment Analysis in Business. Here is a link to the article, so let me actually open it up for you. And the article essentially explains how sentiment analysis works with AI. It covers a lot of applications such as social media monitoring, for example, customer service. If you want to grab, for example, are the customers happy or not. You can also perform brand monitoring on various social media outlets. You can also do market research and analyze the competition. You can also grab the voice of the employee on Glassdoor, for example. And I think this article should take around 10 minutes for you guys to read. And of course, as always, I've included a quiz afterwards. The quiz should take around 5 minutes approximately to complete. And that's it. That's all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and perform data exploration. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, we are going to perform data exploration. If you guys remember, in the previous task, we have been able to learn or understand the business case, and we also went through a really cool video by Monkey Learn, and we also went through an article and reading material as well, and we went through a quiz. I hope you guys were able to figure that out. Okay, so today's task, it's going to be easy as well, and let's go ahead and explore the data that we'll be working with. So the data is actually pretty straightforward and simple. We are going to have Amazon reviews, and the Amazon reviews could be a positive one or a negative one. For example, if the customer wrote, "I love my Echo," I want to train a sentiment analysis model, which is again powered by AI, ML, or an NLP model or natural language processing based model. And the model here should be able to predict for me the sentiment. Is it positive or is it negative? So for example, if the customer says, I love my Echo, then the model should predict for me that the label is positive or 1. If, for example, the customer states that, well, sad joke, worthless, well, the AI model here, the trained one, should be able to predict for me that the label here is negative or the class will be 0. Please note that this data is a classification type data set. If you guys remember, we covered the classification type problems. Actually, we used Data Robot before to perform the classification for us on tabular data, but we haven't worked with text data yet. And that's why the main intent of today's project is to learn how to deal with text data. So you guys will be able to have lots of, I would say, skill set under your belt. So now you know how to deal with tabular data for classification, tabular data for regression. We also learn how to deal with images data, and now we learn how to deal with text data. And these are super powerful techniques that you can leverage essentially in any application. Okay, so that's what the data here looks like. So what I have here is I have the rating, okay? And the rating could be any number between 1 and 5. Think of it as more of the stars. How many stars you give, for example, let's say, to this course, for instance. And the next column here, I have the date. So this is the date of the review. That's when the customer actually gave the review. Here I have the variation. And essentially this is, as I mentioned, in Amazon Echo product, there are so many colors and variations. There is walnut finish, there is like charcoal fabric, there is like, you know, like a black dot, white dot, and so on. And the next column is called verified reviews, and that's the actual reviews that the customer left. So this is real text coming from real customers. Someone said, I love my Echo. Someone said, I loved it. Someone said, perfect for kids, listening to music. And the last column here is called the feedback column. And essentially the feedback column here states that it's essentially a binary output, either 0 or 1. And simply, if the rating here is either 4 or 5, the feedback will be 1. So what you guys see here is rating was 5, that means the feedback was 1. Okay, rating here was 4, still positive, you know, that means someone gave the product 4 stars. Then the feedback here will be 1 as well. And if anything less than that, then the feedback will be categorized as 0, meaning that the customer is not happy with the product. Okay, all right. So if you guys recall, whenever I train a model using Data Robot, I need to essentially specify, first upload the data, if you guys remember, and then the second step is to specify the target. What is my target? And essentially here in this project, the target is going to be my feedback column. That's what I'm trying to predict, essentially. Okay, all right. And this is an example of one of the really positive reviews, I would say. Someone was really happy with the product and they said, incredible piece of technology. I love this right center in my living room. Someone, you know, wrote like a huge paragraph per se, and they're really happy. It looks like they have a very positive review. And of course, what I want is I want my AI model or trained AI model to consume that text data and essentially tell me that the feedback here was positive. It was 1, essentially. Okay, all right. So that's all I have for task number 3. I hope you guys enjoyed it. In task number 4, let's go ahead and upload our data. I'm gonna head right away to Data Robot, and I assume most of you guys are familiar with it right now, but let's go ahead and show you guys quickly how to sign up for it, just in case if you guys decided to go to day 8 right away and skip all the previous days. So that's all I have. I hope you guys enjoyed this lecture, and see you guys in the next lecture. Hello everyone, and welcome to task number 4. In this task, let's go ahead and get started with Data Robot. So if you guys remember, in the previous task, we explored our data, we performed data exploration, and we learned that we are going to build a sentiment analysis model to just perform essentially or classify customer reviews. Can tell me either positive or negative, pretty straightforward. And we also explored the data set here. We know that we're gonna deal with text data, and the outcome or the output will be either 0 or 1, indicating the feedback or the class. And here, that was an example of text data from a positive or happy customer, essentially. So the AI model should be able to classify this one as 1, meaning that the customer was happy. Okay, so what I'm going to do right now is I'm going to go ahead and shift to Data Robot. But before I do that, I just wanted to show you guys or walk you through how to sign up. And if you guys remember, we have done that before yesterday and the day before yesterday and so on. Again, just in case if someone hasn't basically decided to go ahead and maybe skip every single day and jump to day number 8 right away. This is how you essentially sign for the tool. Okay, so first of all, what is Data Robot? It's essentially a leading end-to-end enterprise AI platform that automates the process of building, training, and deploying AI models at scale. And you guys can get a free trial if you click on this link here. And you need to insert all your information, pretty simple. And then you should be able to receive a confirmation email to start your 14 days trial. And then you need to tell Data Robot about yourself essentially here, and you can change as well or customize the theme. And then next you can specify that you need to create AI models, and of course you can use as well Data Robot to prepare the data, to gain insights about the data, or to perform exploratory data analysis. And finally you can also deploy and monitor endpoints in production as well. And then finally you will end up with this homepage where we are going to get started and essentially train our sentiment analysis model. So let me go ahead and shift to Data Robot, and then we can go ahead and get started. Alright, so now we have Data Robot open, and I've already signed up for the Data Robot as well. And essentially what you need to do is that you need to come here and click on Create New Project. So once you click on Create New Project, it's really simple essentially to upload the data. First of all, before I upload the data, if you guys scroll down here, you should be able to see there's tons and tons of case studies and use cases available for you. So if you wanted, for example, to, let's say, predict early payment of loans, you can also use Data Robot to perform hospital readmission, for example, prediction. You can also do plant disease detection, and that's some sort of visual AI or dealing with images. And you can essentially click here on explore results and or import the data sets and essentially repeat what the demo here is showing you. Okay, so all what you need to do is if you go to the course package under day number 8, you guys will see that here I have Amazon reviews. All what you need to do is to drag and drop that here, and that's about it. That's essentially how you upload the data. We have done that so many times in the past. And what you guys see here on the right hand side, you will be able to upload the data, and then Data Robot will essentially gonna read the raw data, and then it's gonna perform EDA or exploratory data analysis afterwards. And then once that is complete, then we can go ahead and select the target and as well perform EDA or exploratory data analysis, kind of visualize all the data set. And please note right now, because we are dealing with text data, which is a brand new data that we have never used before in this course, we have different type of data visualizations. It's going to be super interesting and super exciting. And here we go. Now the data has been uploaded already, and what you guys see here is if you check out the data quality assessment, if you click on it, you guys will see that we don't have any issues. The data is clean, it's nice, there's no outliers, there are no excess zeros, there is no missing values, everything looks perfect. And essentially what I could do right now is I'm pretty much ready to start the training, but what we're going to do is we're going to do that in the next task. So let me shift back to our slides. So in the next task, what we're going to do here is we are going to, let me maximize that. And essentially what we're going to do in the next lecture, we are going to perform data analysis, and that will be in task number 5. And let's recap what we have done so far in this task. It's pretty simple. We signed up for Data Robot, and then we simply dragged and dropped our data. And then afterwards, we make sure that there are no issues with the data here. And then afterwards here in task number 5, we are going to go ahead and essentially perform data analysis. So that's all I have. I hope you guys enjoyed this lecture, and see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, let's go ahead and perform data analysis. If you guys remember, in the previous task, we learned how to upload the data. It was pretty straightforward, pretty simple. And then we have been also able to just make sure that we don't have any data quality issues. Okay, So in task number 5, let's go ahead and analyze the data. So the first step is I'm going to head back to Data Robot, and if you guys remember, all what we have done is we have been able to drag and drop our text file in here. And what I'm going to do right now is if you guys scroll down, you should be able to see all the different columns. So here I can see the rating, the date, variation, verified reviews, and feedback. So first of all, if you guys click on rating, what you guys see here, this is simply the count plot for the rating, meaning, well, this is simply how many stars did our customer give to Amazon Echo product. So for example, here I have 1 star, 2 star, up until 5 stars. And what you guys see here is, well, a lot of customers are actually happy about the product. And myself included, I actually really like Amazon Echo product. It's one of my favorites, and Alexa is super powerful as well. So what you guys see here is if you hover on top of it, you should be able to see that I have around 2,200 rows that belong to the 5-star category. Here we have around 455 rows belong to the 4-star category. And then the 1-star, 2-star, and 3-star, we have very small numbers. We have like 161. Here I have 96 rows, and here I have 152 rows as well. Okay. If you guys go back and maybe click on date, what you guys see here, we have the date distribution. So a lot of reviews actually came by around on the 30th of July 2018. Some of them came on the 29th of July 2018, and so on. If you go back and check out the variation, these are the different variations essentially of our Amazon Echo product. So what you guys see here is I have the black dot here is I have around, let's see, I believe around 516 rows, followed by the charcoal fabric, and then we have the next one is configuration, it looks like, and then black plus, black show, and so on. Okay, all right. And then if you click on verified reviews, this is essentially what you get here. And basically what you guys see, these are the actual reviews from different customers. For example, you see some people said love it, for example, and then love it again. And then there is a great product. And these are all the different reviews that I've got. And then next one is my feedback. And if you guys remember, our task is a simple classification task. All I have is the output could be either 0 or 1, if my customers are happy or not. 1 means happy or the feedback was positive. 0 means not happy or the feedback is negative. And what you guys see here is I have essentially an unbalanced data set where most of the customers are actually happy about the product. And here we have around 2,800 approximately rows belong to the positive category. And here I have around 257 rows belong to the unsatisfied or unhappy customers. Okay. So what I'm going to do next is I wanted to select the target. And if you guys remember, what I'm going to do is I'm going to use the feedback here as my target. So what you guys do is you can click on use as target. And if you guys go up here, you should be able to see the feedback appeared to the distribution essentially of my target column. Here I have most of them are belong to the 1 class or the positive class, and a very small number belong to the 0 class. This is simply the target selection. The next step is if you click on verified reviews, and what you guys see here is you can actually extract information about the data from here, from the verified reviews. So for example, if you'd like to, let's say, click on table, what you guys see here is this is simply the different reviews. It's showing you that a lot of people said, I love it, it works. Some people said Alexa hardly comes on. And there is Alexa is amazing, great speaker. And these are the actual reviews, just a sample of our reviews. Alright, so now I'm pretty much ready to start our training process. But before we do that, if you guys remember, I can go ahead here and click on show advanced options. And if you guys remember, we generally select the train validation holdout, indicating that I can essentially select most of my data to be allocated towards training. So I can, let's say 60% will be allocated to training. I can say 20% will be allocated to validation. And then the remaining 20% will be allocated for the testing or the holdout dataset. Okay. All right. And now I'm pretty much ready to go ahead and start our training process. So if I go ahead and click on start, that's simply gonna trigger our training process. And right now, if you guys can see here on the right hand side, I should be able to see that I have the total number of workers. here showing you that I'm setting the target feature and then creating the cross-validation and hold out partitions. And then I'm going to load the data set, characterize the target, save the target and partitioning information, analyze features, and finally generate the model blueprints as well. And please note that right now, after the model is being trained, I want to show you guys a couple of key insights about the data as well. And one of the key visualizations that we're going to make is known as the word cloud. And I really like the word cloud because it gives you a massive insight about the data, and we can actually gain information about which feature or which word has been repeated frequently. So right now what you guys see is that tons of models are being trained, and we're actually going to analyze all these models in the next task. So that's beyond this task here, which is task 5. But what I wanted to show you guys is, first of all, when it comes to data quality assessment, if you guys remember, is before we actually trained the model, we didn't have any issues with the data quality assessment. However, right now, when I selected the rating, when I selected the feedback to be my target, if you guys remember, the feedback was my target. What you guys see here is right now, Data Robot has actually flagged me, telling me, well, there is a target leakage. There is a leak in my data. What do we mean by that? If you guys remember, we had our rating column here, and the rating column is actually related to the feedback column, if you guys remember. If you guys remember the rating, it's essentially either 1 star, 2 star, 3 star, 4 star, or 5 star. And if you guys recall, the 4 stars and 5 stars were linked or were connected to the feedback of 1. If you guys remember either 4 or 5, that means feedback is 1. Anything else means that feedback is 0. And basically what Data Robot is telling me right now is telling me there is a data leakage. There is something that is not that right because we are using the rating right now as an input to my model. And it shouldn't be there. Okay, it shouldn't be linked or should it be leaked to the output or to the model in that fashion. Okay, and just ignore it for now. And what I'm going to do next is I wanted to show you guys. So if you go ahead and click on models, and if you go ahead and click on insights, I wanted to show you guys the first visualization, which is the word cloud visualization. So if you click on word cloud, you guys will get really interesting and exciting visualization. Basically, you can get how the most common words that I have in my data. So if you guys remember, because we have around 2,800 rows that belong to the positive class, that means most of my customers are happy or maybe loving the product. These are the most common words that have been repeated. So a lot of people said love, for example, said, let's say, music, say Alexa, or maybe said they are great. And this is super powerful because think of it that you can essentially go ahead, grab your favorite data set from any website, and then you can feed it into Data Robot, and then you can get an idea of what are the most common words that the customers were talking about. Okay? And if you guys hover on top of it, you guys will see that how many rows appear. So on the here, you should be able to see love, for example, appeared in 481 rows. The word good appeared in 152 rows. Easy appeared in 199 rows, and so on. Super interesting and super powerful as well. And what you could do as well is if you go ahead here, and what you guys see that there is a filter stop words, and simply stop words. These are the common words that appear in the English language. For example, the word the, for example, are, am, all these words, we call them stop words. And if we want to do or perform a sentiment analysis, most of the time, we don't really care about stop words because they are very common and they don't have much of a value to us. And that's why what we do in general is we try to filter out these stop words. We try to remove them. And that's why what you guys see here is the Data Robot by default has already filtered out all the stop words. So you don't see here any am, I, the, and so on. However, if you remove this here, if you remove the check mark, you guys will see that, lots of other words appear. So for example, the word the appeared quite frequently. And let's say but, can, me, and so on. And essentially, when you train any AI model, I don't want the AI model to think that the word the has importance. It's actually not important to me. The word but, the word, for example, let's say with, all of these, I don't want them. And that's why most of the time what we do by default is that we filter out the stop words and we keep the most common, the most prominent words in here. And that's essentially how you test your machine learning models, and these are the actual filtered out data that we're going to consume to train our model as well. Okay, so please know that there are tons of other visualizations that you guys can do. For example, you can do text mining, you can do tree-based variable importance. This is just what I want you guys to cover for now, which is a word cloud. And that's it. That's simply all I have for this task. I hope you guys enjoy it. In the next task, in task number 6, we will learn how to actually analyze the various models on the model leaderboard. And that's all I have. I hope you guys enjoy this lecture and see you in the next one. Hello everyone and welcome to task number 6. In this task, let's go ahead, train our models and also explore our models too. If you guys recall, in the previous task, we learned about the data exploration, or how to explore our text data primarily. We learned about the word cloud, how to visualize word cloud, what do we mean by stop words, how to enable and disable them as well. And we also have been able to divide our data into training, testing, and cross-validation, and actually kickstart the training as well. So what I'm going to do next is I'm going to head back to data robot, and I'm going to go up here. So here we're back here. And if you guys remember, if we actually have kickstarted the training already. And if you go to models, you should be able to see all the different models on the model leaderboard. So what you guys see here is the light gradient boosted trees has been recommended for deployment. It actually has the best performance of all. And if you guys go ahead and check the metrics, if you guys recall, there are so many metrics here. If you grab the AUC, or the area under the curve, if you guys remember, as long as the area under the curve is greater than 0.5, that's not bad, I would say, because that means we have a better than random classifier. And as we get closer to 1, that means we are having a better classifier. And right now we saw that the best one, which is the light gradient boosted trees, actually achieved around 0.95, which is really good. And if you scroll down on the leaderboard, you'll be able to see actually pretty comparable results for the remaining of the models. Okay, the worst one actually achieved 0.89, and that was a random forest classified model. And if you guys recall as well, here in Data Robot, and that's the powerful, I would say, feature in Data Robot, is that you guys can see that these models are actually implemented in different tools and in different languages as well. So for example, this model here is actually implemented by the light gradient, light GBM model. And if you scroll down, you should be able to see that this is actually a data robot model. If you scroll down here, you should be able to see that this one, because it's an artificial neural network, is actually a Keras model. And essentially Keras is a high-level API that leverages TensorFlow, which is Google's framework, to build, train, test, and deploy AI ML models at scale. And one of them here is XGBoost model, and so on. And the last one is actually, it's a Python model. Okay, so the next step is, let's go ahead and explore our model blueprint. If you guys remember, if you click on the model here, you should be able to see our blueprint. So this is the blueprint for the model. So basically you grab the data, you extract the categorical variable, you separate them from the text variables. And then I'm not going to dig deeper into what's actually going on, which is the matrix of word grams. And this is beyond the scope of this course. But if you guys wanted to learn a little bit more about how to do natural language processing and actually write the code for it and so on, please check out a couple of my other courses as well available on Udemy. I just, instead of leveraging, no-code tools, I actually go ahead and show you guys what's actually happening behind the scenes, and we can actually go ahead and code along together all these different algorithms. And I also have the XGBoost algorithm as well, coded as well using scikit-learn or sklearn library. And after you take the categorical variables, you do one hot encoding, and then you feed it here to ElasticNet classifier, and then we have the light gradient boosted trees, and that finally or eventually generate our predictions. Okay, The next step is if you go up here and you click on, so if you click on the leaderboard, and what you do is that you click on that model here, which is light gradient boosted trees. If you click on evaluate, you should be able to see here what we call it the lift chart, indicating that these are the model predictions in blue, and the orange one are the actual values. It looks like the model actually did really well overall. And if you click on rock curve or receiver operating characteristic curve, here what you guys see is I can see the confusion matrix. So essentially the true positives were 569, the true negatives were around 34, and these are the samples that the model has been able to correctly classify. And then we have the troublemakers. These are the false positives and false negatives. So the model has essentially misclassified 9 samples plus 18 samples. And if you guys scroll down, you should be able to see, if you guys recall, you can essentially change the threshold value here, and by changing the threshold value, you can essentially change the performance of the classifier, and you can either optimize based on the AUC, for example, or if you wanted to maximize F1 score or precision or recall and so on. So what you guys see here is I have the F1 score, which is simply the harmonic mean between the precision and recall. It's set at 0.97, which is really good. That means the model actually did a very good job, essentially. Okay, and the next step is if you click on understand, what you guys see here is essentially I have 2 features. The first one was the verified reviews, and these ones of course has the most importance because essentially this is a text data which contains a lot of rich information essentially. And then the second one, the variation, had a very small impact, almost 3% impact on the output. Okay, all right. So if you click on evaluate, and then if you click on feature fit, what you guys see here is you can say compute feature fit, and then you should be able to see, for example, if you pick, let's say, the variation feature, for example, you should be able to see the predictions versus the actual for every single variation. So for example, for the black dot, for the white dot, for example, for the charcoal fabric, for every single variation, I should be able to see what was the model predictions versus the actual values. And it's taking some time for it to run. And essentially what you guys see here on the right hand side, that right now we're calculating the feature fit, and here we go. So if you guys see under variation, this is simply the predictions. So here on the x-axis I have every single variation that I have in this feature. So for example, here I have the let's say, for example, the oak finish, and this is simply what the model predicted, which is the blue one, and I have what is actual value, the orange one. So it looks like the model is actually doing pretty okay overall. Like there is a little bit, of course, an error here or residuals, but overall the model is doing okay, an okay job overall. And then finally, if you guys click on understand, and then if you did click on prediction explanation, you guys will get really powerful, I would say, explanations of our feature. Basically, what you guys see here is going to show you the top predictions that belong to the positive class and the top ones that belong to the negative class or zero class. And you should be able to see also why the model came up with these predictions. And again, it's taking some time for it to generate the prediction explanations. And here we go. What you guys see here is, for example, I have when the prediction was 1, for example, what you guys see is the verified reviews. Basically, the model came up with 1 because the review was love it, for example. And also because the variation was the heather gray fabric. It seems that the heather gray fabric, generally, most of the people actually were positive about it. About the feature, about the variation, about the look, for example, of the product. If you go ahead and maybe change the predictions, and instead of 1, maybe pick, like, let's say, really low prediction, what you guys see here is the model generated negative, or I would say the sentiment was negative, or the class was 0. The reason because, well, the verified review was really terrible actually. The product does not, and light bar never went orange. It looks like a customer who was actually not happy about the product. And if you change, let's say, the prediction, for example, maybe one of the least as well, what you guys see here is waste of money over the Eco Generation 2. maybe pick another one, doesn't work all the time, and so on. So it looks like the actual model was able to essentially get the sentiment which matches our human as well sentiment, which is super powerful. And that's about it. That's simply all I have for task number 6. I hope you guys enjoyed it. In task number 7, what we're going to do is we are going to go ahead and actually deploy our model and then create an application and generate predictions. So that's all I have. I hope you guys enjoyed this lecture and see you in the next one. Hello everyone and welcome to task number 7. In this task, let's go ahead and deploy our model and create an application as well. If you guys recall, in the previous task, we have been able to analyze various models on the model leaderboard. We checked out the model blueprint. We visualized our lift chart. We also checked out various metrics, such as the ROC or receiver operating characteristic curve. We also showed here our confusion matrix. We also checked out the feature importance. And we found that verified reviews has the highest importance, of course, followed by the variation. We also showed the lift chart and also generate the prediction explanation, indicating the top 3 reviews that have been classified as positive and the worst one as well classified as negative, and why was that too. Okay, all right. So today's task, I classified it as easy as well because it's pretty straightforward and because we have done that before already. So let me show you guys how to go ahead and deploy the model. So let's go back to our data robot. And what I'm going to do is I'm going to first deploy our model. And if you guys remember, to deploy the model, what you need to do is to click on Deploy Auto Model. So please note that this model here has been recommended for deployment. And of course, the model ID here was 21. If you click on Deploy Auto Model, that is gonna deploy the model for us. And then afterwards, you need to click on Auto Model. And that's about it. That's simply how you deploy the model. Pretty straightforward. And then next, you can go ahead and click on Create Application. And if you click on Application Gallery, you can go ahead and generate a predictor because that's what we want. So if you click Launch, you need to click on Model from Deployment. Essentially, I'm creating an application that leverages the endpoint behind the scenes. So I'm going to go ahead and select the recommended model for feedback on Amazon reviews. And then afterwards, you click on Launch, and that's going to essentially launch our application for us. And once it's ready, you should be able to see the open here is being activated, indicating that the application is ready and up and running. And again, it's taking some time for it to run. And please note that what I've just explained right now, we're going to be deprecated from Data Robot, and it's going to be replaced by an AI app. And I haven't covered it yet, essentially just to avoid you guys being confused, I would say. But you guys will get an idea that essentially the AI application here, the new feature that they created, is actually pretty straightforward and pretty much similar to the same process that we generated right now by creating an application and leveraging the endpoint behind the scenes. So if you click on Open right now, you should be able to have our first record, create a record. I can call it, let's say, test 1, for example. And I can right now test my deployed model. I can say, let's say, I love Echo, such a great product. And if you, of course, have to select the variation, I'm going to say, let's say, oak finish. You say get prediction. And here we go. What you guys see here is the prediction was actually very positive, high. That means the model behind the scenes have been able to classify this review as a positive review, and it's telling you that because the verified reviews here was positive and the variation as well was oak finish. You can go ahead and maybe test the models. For example, say I hate it. For example, I hate it. It's waste of money, or it's waste of money, for example, something like that. And if you select, let's say, for example, call it, let's say, a walnut finish, and you run it again, what you guys see here is the prediction became low, and it has been classified as one of the low points here, indicating that this review belongs to the zero category or the zero class, and indicating that the customer right now is not happy about the product. Okay, all right. So that's simply all I have for this task. I hope you guys enjoyed it. It's pretty straightforward, of course, what we have done so far. is we have been able to pick the best model, deploy the best model, create an application out of it, and then generate a predictor, and then create a record, and then test the model performance using a positive sentiment or a negative sentiment as well. And then that's all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go ahead and improve the model performance. Please stay tuned, best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 8. In this task, let's go ahead and cover the final project part A. What I want you guys to do is I want you to drop the rating column to avoid data leakage. If you guys remember, before we had a data leakage because we had the rating column that is leaked to the output, right, which is leaked to the feedback column, if you guys recall. So in the course package, I've included the a new data set which is entitled Amazon Reviews No Leakage, and essentially in this data set we have dropped the rating column. So I want you guys to essentially repeat pretty much what we have done, but with the new data set. I want you guys to retrain the model, tweak the model hyperparameters to enhance model performance, analyze the confusion matrix, accuracy and loss graphs, and finally upload the model and also deploy it as well. Okay? Pretty straightforward, pretty simple final project, and that will be part A of the final project. In the next project, I'm going to provide you guys with a brand new data set where you can go ahead and use Data Robot to perform sentiment analysis. Please stay tuned, best of luck, and pause the video and then give it a shot, and I will see you guys after the final project is complete. Alright, hope you guys were able to figure out the project. Let's go ahead and head to Data Robot and actually do that trick for us again. So here we go. So now we have Data Robot again. So I want you guys to go to the home page, create a new project. We have done that so many times already. And then you can go ahead and drag and drop the Amazon reviews with no leakage. And what you guys see here is we have been able to upload the data, redraw data, and perform exploratory data analysis. And basically what you guys see is in this new data set, we don't have the rating column fed as an input anymore. So we won't have data leakage, and let's see if that essentially improved the model performance for us or not. Alright, and here we go. What you guys see here is the data has been uploaded, EDA has been performed. Now I can go ahead and select my target, and what you guys see is the rating column is no longer available here. So if you click the feedback will be used as targets. Here we go. And you can go ahead and click start, and that's gonna kickstart our training process. And of course it will take some time to go through all these different 7 steps. And once that is complete, I can go ahead under models and analyze the model performance as well. And of course, you check the verified reviews. You can go ahead and click on the date. It's the same data, so nothing changed really. And the variations, here I have all the different variations of our Amazon Echo product. So what I'm going to do is I'm going to go ahead, pause the video, and then I'm going to be back once the model is trained. Alright, so here we go. Now the model has been trained and one of them has been recommended for deployment. And if you guys go ahead and check out the area under the curve, you will be able to see the results is at 0.938 for AUC. And of course, this model, which is the Extreme Gradient Boosted Trees classifier, has been recommended. Of course, to deploy that, first of all, before deploying it, you can go ahead and check out the evaluate. You can check out the lift curve, the ROC or the rock operating curve or receiver operating characteristic curve. And you should be able to see the confusion matrix here, which is pretty comparable to the previous one as well. And to deploy the model, you can click on Deploy Auto Model, and that will deploy it for you. And then click on Auto Model, and then you can go to Application, same deal, and then click on Application Gallery, pick up the Launch or Launch the Predictor, Model from Deployment, and pick the other one, which is had the Amazon Reviews No Leakage. And you click Launch, and then you should be able to, once the application is deployed, to click open the application, and then assess or test the performance of that application using a new data set that the model has never seen before during the training phase. It's taking some time for it to be deployed and for the application to be created. But right now, here we go. Now it's the model, the application is available. You can create a record. You can call it test 1, for example. And then you can say, I love Amazon Echo. and you can generate prediction. And what you guys see here is the prediction right now is 99.9 high. It's pretty much the same as before. All what we have done is just, instead of using leaked data, we essentially remove the rating column, and we have been able to train the model again and generate predictions as well. Okay, all right. So that's pretty much all I have for this task. I hope you guys enjoyed it. In the next task, that will be a lot more interesting, I would say, because we're going to be dealing with a brand new data set. I'm going to give you guys brand new data, and we'll be able to build, train, test, and deploy a natural language processing model to perform classification. So please stay tuned. We're almost there. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 9. In this task, let's go ahead and cover our final project part B. If you guys remember, in the previous task, we covered final project part A, and we have been able to retrain the model, but with data that has been cleaned up, essentially the data that doesn't have any leakage in it. And we have been able as well to analyze the confusion matrix, accuracy and loss, and finally as well upload the model and finally deploy it as well. Okay. Right now, we are going to shift gears a little bit, and instead of using Amazon Reviews dataset, I included a dataset for what we call it the fake news dataset. And what I want you guys to do is essentially use that data to perform classification. I just wanted to classify the data or the news to be either fake or real. I want you guys to perform EDA and then plot the word cloud and then train multiple models with Data Robot and then assess the trained model performance and finally deploy the best model and perform inference as well. Okay. Alright, so that's all I have. Best of luck. Please go ahead, pause the video, and then I'm gonna see you guys after the final project B is complete. Alright, so I hope you guys were able to figure out the final project. Let's go ahead and walk you guys through what I have came up with. So what you guys see here is in the course package, I've included the fake news dataset. And please know that this dataset is quite extensive. It's actually like above 100 megabytes. So I assume you guys have noticed that when you train your models in Data Robot, it's actually taking a very long time for it to train and for the model to be ready for deployment as well. But it's pretty much the same process. We're gonna go ahead here in the home page. I'm gonna click on create new project. And then all what you need to do is to drag and drop fake news dataset to here. And what you guys see is essentially we're going to be uploading the data, reading raw data, and performing exploratory data analysis. And again, it's pretty much the same as the previous process. The only difference is in this dataset, we have our title for the piece of news. We also have the text, the actual text data. And then finally, we have the category as well, if it's like, you know, like a Middle East related, for example, news or North American news and so on. And then finally, we have our class indicating whether this news is fake or real. So what I'm going to do is I'm going to pause the video and then I'm going to be back once the data is uploaded and everything looks good. Alright, so what you guys see here is the data has been uploaded, everything looks great. And if you guys scroll down, you should be able to see when it comes to the data quality assessment, we don't have any issues as well, which is good. And if you scroll down here and check out the class, you guys will see that we have pretty much balanced data set, I would say. So this is class 0 and this is class 1. And again, indicating whether it's fake news or real news. This is the date. So it looks like we have like equal samples, you know, across various dates in here. If you check out the subject, these are the different subjects. So we have the politics news, maybe world news, maybe we have government, for example, Middle East related or US news. And if you check out the text, this is the actual news, the actual articles, basically. And these are the title, which is essentially, think of it as 2 text fields that we're going to feed to our AI ML model, essentially, to train. Okay, so if you guys, assume you guys know that already, so we're gonna pick the class and that will be used as a target. So if you click target, that would be good. And then to start the training, all what you need to do is just click start, and that essentially is gonna start our training process. And again, as a disclaimer, Guys, this will gonna take a very long time for it to run because the data itself is huge. It's like 100 times or 100x bigger compared to our previous data set, which is the Amazon reviews data set. All right, so what I've got here is I've already uploaded the data before, okay, and it took around, let's say, 30 minutes at least to come up with these results in here. So what you guys notice is, first of all, the model looks like it's actually trained pretty well. So the validation AUC, or area under the curve, is almost 100, okay. And if you check out the best model, that's the Elastic Net Classifier model, and you guys will see that here we're consuming the data, doing text variables, we're doing matrix of word grams occurrence, and then we are training an Elastic Net Classifier model to generate our predictions. If you click on evaluate, you guys will see that the model actually is kind of overfitting the training data. It's just too good to be true, I would say. And if you check out the ROC curve, or ROC, or Receiver Operating Characteristic Curve, you guys will see that we have been correctly able to classify like basically almost 3,500 here and 3,700 here, and we misclassified only 2 samples. These are the false negatives and false positives, so 2 plus 1, 3 samples in total have been misclassified, which is pretty great. And then to deploy the model, of course, you need to click on O2 model to deploy it, and then to go to applications, you can go to application gallery, generate launch a predictor, and then you can say model from deployment, and then you can select the recommended model for fake news dataset. You click launch, and you should be able to see here, I've actually launched it here already. So if you click open, that will open the prediction application. You created a new record, and then you can go ahead. I actually have the one record here that has been created already in the past, so I'm gonna use last values. So for example, this is just a sample of our of a data set essentially, and if you say get predictions, what you guys see here is based on this news, based on the text data, and based on that title, this has been classified as 1 or flagged as 1, meaning that this news is essentially a fake news. Okay, all right. So that's pretty much it. Of course, there's a lot of things that you guys can do beyond the scope of the of today's projects. And that's simply all I have. I hope you guys enjoyed this project, and I hope you found it useful, fun, engaging, interesting as well. So please take some rest and relax, and tomorrow we're gonna go ahead and get started with a brand new project. Please, I hope you guys enjoyed this lecture, and see you in the next project.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, and welcome to day number 9. Today we are going to introduce you guys to a new tool which is known as AWS SageMaker. AWS stands for Amazon Web Services, and SageMaker is essentially a machine learning and AI framework that will enable anyone to build, train, test, and deploy AI and ML models at scale. And within SageMaker, we have also a feature which is known as SageMaker Autopilot that will make our life extremely easy, and it will essentially help us or allow us to simply upload the data and just let AWS SageMaker Autopilot do that trick for us and essentially train multiple models, and we will be able to select and deploy the best model. We are going to see that essentially the features are very similar to Data Robot, but AWS SageMaker offer a ton more features and services that are available for you if you wanted to perform image recognition, test classification, and also deal with tabular data as well. Okay. So in task number 1, let's go ahead and cover the project card. And please note that today's activity, I would say, is quite easy. So right now we are on the easy scale. So the project card, the goal is first, build, train, test, and deploy an AI model to identify credit card customers who are more likely to default on their payments. So essentially we are going to consume various features about our customers, and then we're going to feed all these features to an AI model, and that model is able to tell us which of these customers are more likely to default on their credit card payments. And of course, this project is huge, and you can essentially effectively apply it to any financial institution. such as banks, for example, with the objective is to reduce credit card default risk. The tool is AWS SageMaker Autopilot, and the data that we're going to use is essentially our customer features, and the output will be either 0 or 1, indicating whether that customer defaulted on the payment or not. So gonna be pretty straightforward, pretty simple. So let's go ahead in task number 2 and cover the business case. So that's all I have. I hope you guys enjoy this lecture and see you in the next one. Hello everyone and welcome to task number 2. In this task, we are going to cover the business case. Please note that this task is categorized under the easy category. So let's go ahead and get started. If you guys remember, in the previous task, we have been able to cover the project card, and we learned that we are going to use AWS SageMaker Autopilot to build, train, test, and deploy an AI model with the objective to essentially predict which customers are more likely to default on their credit card payments. So the first question is, what AI applications that we can have in business? And essentially, we can ask the question again, which is, what problems can AI solve for us? So the first type of problems is known as clustering type problems. And essentially, we can take the customer data and feed it into an AI model. And then the AI model can essentially perform what we call it clustering or segmentation. It can essentially group a couple of customers together based on their features. So one of the questions that AI essentially can help answer here is, which group of my customers should I target for my new marketing ad campaign to try to maximize conversion rate? So essentially, if I feed in data about my customers to the AI model, I can essentially group them into different clusters or categories, and then I can target a specific group of these customers with a targeted marketing ad campaign, so I can maximize conversion rate and the success of the campaign as well. The second type of problems is known as recommendation type problem. And basically, one of the questions that AI can help answer is, which product should I recommend to my customers to try to maximize revenues? And essentially, AI can help solve what we call it recommendation type problems by trying to study collaborative information about my customers and about their historical behavior as well. So AI can essentially help recommend different products and services to the customers based on their features and based on historical data that I've been able to acquire on all my customers in the past. The third type of problems is known as classification type problems. And basically, one of the questions is, are my customers happy or not? And essentially, as a data scientist, you can leverage data science to solve classification type problems. And the answer to these problems can generally belong to 2 or more categories. The fourth type of problem, which is known as regression type problems. And please note that we have covered already the difference between classification and regression in previous earlier case studies. And when it comes to regression, essentially I'm trying to predict a continuous value. A question such as, how much should I pay for my newly hired employee, for example, which is, if you're looking for a continuous number, that could be salary, for example, I need to apply AI to solve regression type problems. And then the final type of problems is known as time series forecasting problem, which is, one of the questions is, how much revenue will my business generate next month? I'm trying to predict what could happen in the future in the form of a time series based on past historical data. Okay, so let's go ahead and cover our business case today. So in today's case study, we will assume that you work as a data scientist at a bank in Taiwan. And the bank has collected extensive amount of data about their customers, such as their demographics, historical payment records, the amount of bill, for example, dollar values that they have. And the data has been collected between April of 2005 and September of 2005. And the data contains 25 variables. So I wanted to show you guys how to explore these variables in the next slides. And if you guys wanted to check out the source of the data, here is the link to the data. It's available on Kaggle website. Okay, so here are the outputs and inputs. So the output is essentially what we call the default payment. So essentially the output is a class. It's either 0 or 1. So I can essentially predict whether my customer, based on his or her features, I'm able to say or predict whether these customers are gonna default on their payments or not. That's when it comes to the outputs. When it comes to the inputs, I have many features. So first, I have the customer ID. I have their limit balance, which is the amount of given credit in NT dollars. And please note that this is a case study in Taiwan. The second one is their gender as well. We have also the education, and the education could be grad school, university, high school, and unknown as well. We also have their marital status. Are they married or single? We also have their age as well in years. And we also have different features as well, indicating their repayment status in various months, in September, in August, July, June, May, and April. And we also have the bill amount, which is essentially the amount of bill statements that we have in various months. So starting from September up until April, essentially. And these are the inputs and outputs that I'm going to use in my model. So now it's time for our reading time and quiz. And the article that I have for you guys today is, I have the link available for you guys here. The article is really interesting, and it should take around, I would say, I think I have it here, around 10 minutes for you guys to read. And essentially the title of the article is 15 Business Applications of AI and Machine Learning. So you guys see here, there are many applications available here for use in healthcare, for example, in recruiting automation, in trying to optimize energy cost, in predicting vulnerability, exploitation, we have market prediction, and so on. So please go ahead, give it a shot, read the article, and as always, I've included a 5 minutes quiz for you guys after you read the article. And that's it. That's simply all I have for task number 2. I hope you guys enjoyed it. In task number 3, let's go ahead and give you guys an overview of AWS or Amazon Web Services. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 3. In this task, I'm going to show you guys an overview of AWS or Amazon Web Services. If you guys recall, in the previous task, we have been able to cover the AI applications in business. We learned about 5 different applications of AI in business, and we also went through a case study, and we also went through a quiz and reading materials as well. And I also showed you guys an overview of the inputs and outputs that I have to my model, and we learned that we are going to essentially train a classifier model, and the model is able to essentially classify to me the data either 0 or 1, indicating whether my customers will gonna default on their credit card payments or not, based of course on their features. Okay, so let's go ahead and cover AWS. So the question is, what is AWS? So Amazon Web Services, or AWS, is the world's top cloud computing platform. And essentially, AWS offers many services. There are over 165 fully featured services, and essentially 40 of them are not offered anywhere else, which is super powerful. And when I say you have fully featured services, think of it as a company. And let's say you wanted to, for example, train AI models, for example, just something, let's say, absolutely basic. You wanted to first store customer data, and you wanted to maybe perform any analysis on that data and maybe train a simple machine learning model on that data. The first question is, should I go and buy all these different, let's say, GPUs, for example, and maybe all these different servers and build everything, all the entire platform in-house? Or should I just go ahead and maybe rent it out, maybe lease it essentially from someone else? And that's a key decision when it comes to any IT, I would say, department, is whether should I build everything in-house or maybe leverage some other people who have mastered that already, and I can just go ahead and instead of buying all this different equipment and doing all that fixed cost, I can just go ahead and just lease it essentially. And that's the overall idea here. With AWS, it can offer you everything you need without owning anything. It's like you are renting or leasing essentially these services. So basically, AWS can offer to you storage, for example. So if you wanted to store your data, you can store it essentially on AWS or Amazon servers. You don't need to buy any servers at all. Just pay as you go, which is super powerful. You can also have databases. You can also leverage compute. So if you wanted to, let's say, train AI models, if you guys remember, we need essentially GPUs, we need TPUs, we need CPUs, and that's why instead of buying hardware and configuring all that hardware and going through all that mess, and you need a lot of expertise to do it, well, don't worry about it. Just go ahead and lease or rent these services from Amazon, and they have already mastered that for you already. We also can do Internet of Things. We can do AI and machine learning. We can do analytics and networking. All of that with the power of Amazon Web Services or AWS. And essentially AWS is adopted by millions of customers worldwide, and including both small and large scale enterprises. And of course, the power of AWS is that it enables companies to be more agile, to be more flexible, and a lot more secure at a fraction of the cost. As I mentioned, again, instead of buying these different hardwares, I can essentially become agile, become flexible, and pay as I go and lease and rent these services. And then finally, AWS provides services for a broad range of applications as shown here on the chart. Okay, so if you guys remember, we had three main components to essentially build any AI or ML models. If you guys recall, I need data, and I need a ton of it. I need a model, which is the mathematical model basically that I can feed that data to, and essentially I need to feed that data to my model on a compute, right? I need a GPU, for example, to train that model, and that's where the third element comes into play. So let's go ahead and show you guys a quick tour on AWS. And essentially, I'm going to show you guys that AWS can offer to you all these different services, and they are fully featured and readily available for you to use. So let me show you first the slides, and then I'm going to head right away to the AWS portal to show you guys the AWS in action. So essentially, when you open AWS, this is the essential interface that you will get. And if you guys see here that you will notice that there are essentially the three components that I mentioned are readily available for you. So for example, if you wanted to do storage or databases, there are tons of features available for you and tons of functionalities essentially are available for you. We have what we call it AWS S3 or Simple Storage Device. And I'm going to dig deeper into S3 in the next task, but essentially think of it as it's a massive essentially data storage location available for you, and you can just go ahead and upload data to it. Pretty simple. And if you wanted to leverage compute, for example, well, you can go ahead and use EC2, for example. And EC2 is essentially the compute that we can use to train our AI models. If you wanted to train a simple model, you can use simple compute. If you want to train a lot more complex models, you can use GPUs and TPUs as well. And then the last element, which is, of course, you need a model. And this is essentially captured in here. So Amazon offers a tool known as Amazon SageMaker, and within SageMaker there are tons of algorithms that are available for you. You don't have to go and reinvent the wheel and build everything from scratch, and there are tons of services available for you. So there is like what we call it Amazon Recognition, for example, to recognize images. There is Amazon Transcribe, there is Amazon Textract, there is Amazon Translate. Amazing services and readily available for you as well to use. Okay, so let me go and show you guys AWS portal. Alright, so here I'm at AWS portal, and all what you need to do, guys, is to head to AWS and then sign up for your for a new account. And please note that you need to insert your credit card information, and you will gonna get a free credit when you sign up for the first time. Please make sure that you're using the free credit available for you, because if not, AWS SageMaker actually is quite expensive. So please make sure that you are in the free tier and you have essentially credit that is available for you if you sign up for the first time. Okay, so if you guys head to services, what you guys see here is all the services that I was talking about. So for example, here I have the storage, and here I have S3, for example. I have the, if I wanted to leverage databases, all the different databases available for you here, such as RDS or relational databases storage. We also have the DynamoDB and so many other services as well. And please note that I have a course available on Udemy that essentially cover AWS SageMaker Practical for beginners. It essentially dig a little bit deeper into SageMaker, into various algorithms and the coding behind it as well. But please know that this activity is beyond the scope of this course. I just wanted to show you guys SageMaker Autopilot today, because within Autopilot, we'll be able to build, train, test, and deploy AI models without writing a single line of code. And that's the objective of the entire course, essentially. If you wanted to leverage compute, you can essentially use EC2, for example. And you can also use different other services, such as Lambda, for example. And the last key area, which is our models, essentially, and these are available here within Amazon SageMaker. So there are tons of features available for you here. So if you want to open Amazon SageMaker, for example, and there are many other services such as Amazon Recognition, as I mentioned earlier, there is Transcribe, Translate, and so on. And these are the main three core components that we'll be dealing with. I need essentially storage to store my data. I need compute to actually train my model on. And I need the actual model. I need the actual algorithm that is already developed for me. I don't need to go ahead and reinvent the wheel. And that's available here within the Amazon SageMaker, essentially. Okay? All right. So that's it. That's simply all I have for this task. I hope you guys enjoyed it. In the next task, I'm going to dig a little bit deeper into AWS S3, which is a storage, and also the EC2 as well, which is compute. And I'm going to show you guys from a very high level Amazon SageMaker, and then we're going to head right away to our SageMaker Autopilot, and we'll be able to build our model from scratch. So that's all I have. I hope you guys enjoy this lecture, and see you in the next one. Hello everyone, and welcome to task number 4. In this task, I'm going to give you guys an overview of AWS S3, which is essentially the storage service that we're going to use to upload our training data. And I'm going to show you guys as well EC2, and essentially this is the service that is primarily used to run compute. So essentially I can train our AI models by leveraging compute instances using AWS. Please note that this lecture is intermediate level difficulty, so let's go ahead and get started. If you guys remember, in the previous task, we covered a quick introduction of AWS. We learned what is AWS, what are the different services offered by AWS. We also learned that AWS can essentially empower us to cover all the different 3 components that we need to build any AI models. If you guys recall, we need data, we need to store it somewhere, we need a model, we need algorithms, and we need compute as well, and GPUs, TPUs, and CPUs to run our models as well. So AWS can offer these 3 key areas, and I also showed you guys a quick tour of AWS services. So what I wanted to do today is I wanted to dig a little bit deeper into a couple of these areas. Essentially, I want to show you guys SageMaker pretty quickly. I wanted to show you S3, and I wanted to show you EC2 as well. And please note, all what I'm doing right now is I'm just giving you guys a very high level overview of these services. If you guys wanted to dig a little bit deeper, again, I have many courses on AWS certification and also on AWS SageMaker Practical. Please go ahead and check out my profile on Udemy, and you should be able to see these courses. So the first question is, what is S3? So Amazon S3, or AWS S3, essentially is a storage service that allows individuals and enterprises to store and protect any amount of data. Think of it as a massive hard drive that is available for you in the cloud. You can just take your pictures, take your videos, take whatever, and just upload it to S3. And Amazon S3 offers a lot of features, such as scalability, data availability. It's of course, AWS or Amazon is all about security, so it's extremely secure, and performance as well. So S3 is extremely easy to use and essentially allows enterprise to organize their data, and you can essentially create different, what we call buckets in there, and that's where that logo appears here. Essentially think of it as more of directories or folders, and I can essentially go ahead and upload data to these buckets of available on S3. And please note that each bucket will have global universal unique name. Amazon S3 is extremely durable to actually what they call it like 11 nines, like 99.99999%. So it's extremely durable, and also it is available. It has 99.9% availability as well. Okay. So the first question is, what does S3 look like? Again, I'm not going to dig a little bit deeper into how to configure S3 and so on, but this is just from a very high level what we do. We can go ahead, once you open S3, you can say create bucket, and then you can simply upload data directly to it, okay? And please note, when we are going to use our AWS SageMaker Autopilot, you just need to specify the path to the bucket. Okay, and that's it. We're not going to even open Amazon S3 at all. We're going to do everything and automate the entire process. Here, I just wanted to show you guys that there is something or a service called S3, and it's primarily used to store our data. That's all I want you guys to know for now. The next service is EC2, which is essentially used for compute. So Amazon EC2, or Elastic Compute Cloud, offers resizable compute capacity in the cloud. So one of the key challenges essentially that you have in any company or enterprise is, well, I wanted to train an AI model, okay? And first of all, I don't know how big my model will be. Like, do I need 1 GPU? Do I need like 10 GPUs? Do I need 50? I don't know. Especially in the beginning, we don't know what's going to happen in the future. We don't know how many customers, for example, will sign up for our services or buy our products. And that's why a key important aspect here, or key important point, is EC2 can allow us to have essentially configurable or resizable capacity, compute capacity in the cloud. So for example, I can start with a very small compute initially, and then I can scale it up, for example, depending on demand and depending on the complexity of my models that I'm going to need in the future. So EC2 is a service that allows you to simply rent a server in the cloud. That's all it is. And instead of buying a server, configuring it, and pay all that fixed cost up front, I was just going to go ahead and rent it. Rent a server in the cloud. And EC2 covers 22 regions and 69 availability zones all over the world. Okay? Alright. So the third area that I wanted to show you guys, or service, is Amazon SageMaker. And Amazon SageMaker is a fully managed machine learning workflow platform that provides services for data labeling. So for example, if you have images, let's say, and you wanted to label these images, Amazon SageMaker can offer you that service. You can upload the images, and then you can hire people globally. We call them mechanical Turks, and they can go ahead and label these images for you. And of course, you have to pay per label. You can also use Amazon SageMaker to build models, to train models, to tune these models, and to also deploy them as well and perform hyperparameters optimization. Amazon SageMaker allows data scientists and developers to build scalable AI/ML models easily and efficiently. And we can essentially deploy these models in production at a much faster rate and at a fraction of the cost if you decide to do these stuff in-house. And essentially, Amazon SageMaker allow anyone to build, train, and deploy AI/ML models at scale. So as I mentioned, it offers data labeling services. And what's super powerful as well about SageMaker is there are tons of available algorithms for you within Amazon SageMaker that are ready for you to use. So you don't have to go and kind of reinvent the wheel. State-of-the-art algorithms have been developed for you, and they are also available in what we call it AWS Marketplace. And AWS Marketplace is kind of a little bit of a scary place to be honest. And think of it as you can use Amazon to buy and sell products, right? AWS Marketplace, you can essentially buy and sell AI models, trained AI models. Think of it as a marketplace for little brains. So you can buy, let's say, a brain that do image classification. You can buy a brain that can do, let's say, natural language processing, which is, again, pretty scary, but of course, super powerful. The second area is train. You can essentially train multiple models using EC2 instances. You can manage environments for training, and you can also do hyperparameters optimization. And if you guys remember, we have done hyperparameters as well, tuning in the past in a couple of other tools as well that we covered before, such as Data Robot. And finally, to deploy the model, you can easily deploy and scale models, and auto-scaling can essentially result in 75% savings. Essentially, you can say, okay, I may be starting my service is new, I don't have a lot of customers, I'm gonna start small. And then as a number of customers start to use the service, I can essentially perform auto-scaling. So based on demand, I can scale here the actual compute power that I have. And you can essentially do that, and that will allow you to do a ton of savings. And AWS estimate these savings to be around 75% approximately. Okay, so what I'm going to do today is I'm going to show you guys a super powerful feature within Amazon SageMaker is known as Amazon SageMaker Autopilot. And I have a quick screenshot here of the SageMaker Autopilot service. Essentially, Amazon SageMaker Autopilot, it automatically builds, train, and tunes the best AI and ML models, and you can essentially have full control and visibility over these models. And essentially, instead of requiring deep machine learning expertise, you can essentially automate the entire process using the AutoML feature. And I'm going to show you guys that what we need to do is to essentially upload the data to S3 and then kickstart the Amazon SageMaker Autopilot feature. And then Amazon SageMaker is going to train multiple models for you. We're going to show you the best model, and then we're going to choose that best model and essentially deploy it afterwards in production. And that's it. That's simply all I have for task number 4. I hope you guys enjoyed it. In task number 5, let's go ahead and get started. And I'm going to show you guys AWS SageMaker Autopilot demo. Please stay tuned. Best of luck, and I will see you guys in the next task. Hello everyone, and welcome to task number 5. In this task, I'm going to show you guys AWS SageMaker Autopilot, and then I'm going to show you how to essentially upload the data and how to kickstart an experiment, train multiple models, and then analyze and deploy the best model of all. Please know that this lecture is in the intermediate level difficulty, so let's go ahead and get started. If you guys remember, in the previous task, I have been able to show you guys all the different key services offered by AWS, such as S3 for storage. We also covered the EC2 for compute, and finally SageMaker that we're going to use to build, train, test, and deploy AI ML models at scale. Okay. So please note that here I have snapshots of essentially every single process or stage or step, I would say, that we're gonna follow along. So here is the home page. Let me walk you through it really quickly, and then I'm gonna shift to SageMaker Autopilot and show you guys how to start the experiment. So first, once you open the home page of Amazon SageMaker Studio, you will essentially upload your credit card data, which is the CSV data that I've included in the course package. And you will also need to upload the Jupyter notebook as well. And please note that in this course, I will try, as promised, to make it with no code at all. But what you need to do is that you need to run a script, okay? And that's the script here included in this Jupyter notebook here. And within that script, all it does is just generates the path that we need for our data and for our location as well, where we are going to store our model artifact. So basically, after the model is trained, I need to store that model somewhere, and that's why I need to specify this path when I kickstart my experiment. Don't worry about it, I'm going to show you guys all of that in great details. And then you need to open the notebook, and then you need to run the script. I'm going to show you guys, we're going to run it together. And then you need to go ahead and essentially start our experiment, autopilot experiment. I'm going to show you guys how to start the experiment. You need to specify, give it a name, and you need to here specify the path as well for the S3. And then next you need to essentially provide all the different metrics and locations of essentially all. In order to run an experiment, you need to specify where the data is, you need to specify which target column that you wanted to predict essentially. You need to specify whether you're doing regression type problems or classification type problems. And of course, you need to specify the metric, like what are you trying to optimize for. And when you're done, you just click on create experiment, and essentially that will kickstart our experiment for us. And please know that this training should take around 2 hours approximately to complete. So it's not like Data Robot, where essentially you can get results in like a couple of minutes. Here it's a little bit different. It's actually training like many models, and it's doing or generating code targeted for production purposes. So you can actually use that and deploy it in production. And then afterwards, you should be able to see the best model here. That's essentially the best model. And you can go ahead and deploy the best model. And of course, explore the AI ML model's explainability by seeing which feature is the most prominent or important one. And then once the model is trained, you can go ahead and deploy an endpoint. When I say an endpoint, meaning that you can essentially have a trained model where you can do inference on, similar to what we have done before in Data Robot. And that simply should conclude our task. So let's go ahead and get started and show you guys all the different steps in action. So what I have here is I have the AWS Management Console. And what I want you guys to do is to please go ahead and look under Services and go and click on Amazon SageMaker. So when you click on Amazon SageMaker, it should open here. And essentially what I wanted to do is I wanted to open what we call it Amazon SageMaker Studio. And within the Amazon SageMaker Studio, I would be able to essentially run the SageMaker autopilot. So please note that within Amazon SageMaker, just the basic one, you can essentially open a notebook. Okay, so you can go ahead here and create a notebook instance. When I say notebook instance, that means you can actually create a notebook where you can write code, upload the data, and do all these different processes in code. And again, please know that this is beyond the scope of this course because I'm trying to keep everything with no code. But if you guys wanted to learn a little bit more about it, you can go ahead and check a couple of my other courses where I have a ton of notebooks and actually showing you guys what's actually happening behind the scenes with all the code scripts and so on. So please go ahead and click on Open SageMaker Studio, and you should be able to say Open Studio here. So once you open the studio, you guys should be able to have our what we call a Jupyter Lab, and within the Jupyter Lab I can go ahead and start the experiment. Okay, so this is essentially the home page that I've got here, and the next step is I need to essentially locate my Jupyter notebook. And also I need to locate my CSV data, which is my credit card data as well. Alright, so what you guys wanted to do first is you need to first upload our Jupyter notebook and also upload the data as well. So in order to do that, you can go ahead and click on Upload button. And once you click on Upload, you will be essentially directed here. You need to navigate to the course day 9. And that would be the credit card default prediction. And essentially here I have the Jupyter notebook and I also have the credit card as well data too. So basically just select those and just click open. And it's telling me that I already have them loaded here, so I don't need to overwrite. I'm just gonna keep them as is. So I'm just gonna say cancel for me. But you guys, if you're doing it for the first time, you should be able to see the Jupyter notebook appeared in here. And also the CSV data appeared as well here in this panel. So to open the Jupyter notebook, you guys need to double click on the notebook, and here we go. And please note that again, here there is code, okay? And my promise to you is that we are not gonna write any lines of code. All of what we need to do right now is we just need to run or execute this code, okay? So let me show you guys what's actually going on in here. Please note that this is the data, right? This is the credit card data that I need to essentially upload, okay? So what I'm going to do first is I'm going to import key libraries. These are Pandas and NumPy. And Pandas is a super powerful library that could be used to deal with tabular data, or what we call it data frames. We're going to also import NumPy as NP, and NumPy is primarily used for numerical analysis. And please don't worry about them too much. All we're doing next is I'm going to use Pandas and I'm going to read that CSV file. So to do that in code, you just need to write pd.readcsv, and then you need to specify the name of the file, which is UCI creditcard.csv. In order for you guys to execute or run a cell, all what you need to do is to press Shift and Enter at the same time. So when you press Shift and Enter on your keyboard, here we go, what you guys see is this number has been updated, indicating that this cell has been executed. So all I have done so far is I have been able to read my CSV file here and put it in credit card DF, okay, just in a data frame essentially. And if I wanted to see what's in that data frame, I'm going to say, please grab my credit card and say .head. And if you press Shift Enter now, here we go. Here's essentially my data set. Basically, if you guys remember, here I have the education, I have the marriage status, I have the age of the customers, I also have their bill amount and the pay as well, 0, 1, 2, 3, 4. And finally here I have the target column. And that's essentially the class that I'm trying to predict, which is either 0 or 1, indicating if my customer has defaulted on their credit card payments or not. So that's it. Basically all I have done here is I have been able to import the data. That's all it is. The second stage is I wanted to essentially upload the data to an S3 bucket. Basically, instead of opening Amazon S3 and doing the upload manually, I just wanted to go ahead and do that in code, okay? So basically, all these bunch of cells in here, again, you guys were not gonna write any code. All what you need to do is to execute or run this code. All what I'm doing is essentially I'm just uploading that data, which is my UCI credit card information, to a certain location in S3. And if you guys remember, S3 is our data storage location or kind of service within AWS. So to do that, I'm going to import SageMaker, and then I'm going to create a session. Okay, so I'm gonna say SageMaker.session, and that will create a session for me to be able to kind of think of it as more now you're talking to S3. You need to specify a prefix, and that will be the path that I'm going to specify within Amazon SageMaker, within Amazon S3. So essentially the prefix is SageMaker, AutoML, and then input. And in order to upload our data, which is my credit card data, to S3, all what I need to do is to say the following: session, which is I created here, dot upload data. You need to specify the path, essentially the name of the file, and you need to specify the prefix as well. And then that will be the URI, essentially the path to my S3 bucket. So if you guys press Shift and Enter on your keyboard, here we go. Now, voila, now we have been able to essentially upload our CSV data, which is our credit card data, to S3. And this path is very important because we need it when we execute the experiment. All I need when I execute or run an experiment, I need to tell Amazon essentially tell Amazon SageMaker that here is the data. That's the path to the data. That's all I need first. And please note, when the model is trained, the model artifacts, the actual model parameters, the actual model weights, for example, if you are training an artificial neural network, it has to be stored somewhere. And that's essentially what I'm doing here. So essentially, this is the path that I'm going to use to store the output. So if you press Shift and Enter, here we go. Essentially, what I have right now is I have a location, another path that I need as well to specify when I execute or run my experiment. And that's it. To run these cells, again, Shift and Enter, and here is Shift and Enter, and here we go. This is essentially all I need from the entire notebook right now to execute and run my experiment. And what I'm going to do is, in the next lecture, I'm going to show you guys how to run an experiment. So that's all I have. I hope you guys enjoyed this lecture, and see you in the next one. Hello everyone, and welcome to this lecture. Let's go ahead and keep going, and let's go ahead and start our experiment. If you guys remember, in the previous task, we have been able to simply upload our data to an S3 bucket, and we have been able to generate the path here for our data and also for the output or for the model artifacts. So in order to start an experiment, you need to essentially go here, and what you guys see is that there is SageMaker resources. So if you click on it, you should be able to see that there are tons of options available for you. Don't worry about it. All what you need to do is to say create autopilot experiment, And please note here in the drop-down menu, you can create projects, you can create pipelines, you can create endpoints. So please go ahead and click on experiments and trials, and then click on create autopilot experiment. Here we go. What you need to specify first is I need to specify a name to our experiment. So here, let's say I'm going to call it credit card autopilot, for example. I'm going to call it, let's say, trial. The next step, don't worry about the tags, all of these are optional. You need to specify the S3 bucket location. So please go ahead and click on enter S3 bucket location, select that option. And here you need to specify the path to our S3 bucket. Essentially, you need to specify the path to the data. So to do that, if you guys remember in the previous lecture, we had a path in here. This is the path to my credit card information, to my data. Right click and then say copy, or you can just say Control C. Go back to create experiment, and then you need to say Control and then V, and that essentially is gonna copy our S3 path. Next, you need to specify the location to the output, which is essentially my model artifacts. To do that, please go ahead and click on enter S3 bucket location. And again, go back to my Jupyter notebook, grab my S3 output location here, and then say Control C to copy. Go back to the experiment, and then say Control V to paste it. Here we go. Please make sure that this here is the output. Okay? Alright. Next, what you need to do is that you need to specify the type of the problem that you're trying to solve. Well, if you know the type of problem, which is in our case essentially is a binary classification problem, that's okay, go ahead and choose it. If you know maybe it's a regression type problem, select regression, or it might be multi-class classification when you have more than 2 target classes. Or, well, maybe I'm confused, maybe I'm new to machine learning and I don't know what's actually going on, just select auto and it's going to be good to go. The one important as well point that you need to specify here is the target column. If you guys go to the target here, you will see all the different features that I have in my data. So here I have the education, the sex, for example, the age, all the different payment amounts, the bill amounts, and of course, this is essentially my target column. That's what I'm trying to predict. I'm trying to predict whether my customer will default on their payments or not. And what you guys see here is after the model is trained, you have the option to perform auto deployment. Essentially, you're going to select the best model and deploy it automatically. I generally don't like that because the experiment might take maybe, let's say, 2 hours, for example, and I don't want the model to be deployed right away, especially if you are not on the free tier option. You will incur a lot of money. Like, these services are very expensive. So I highly recommend that you guys turn it off, okay, for now, and then click on create experiment. So when you are done, okay, so here you specify, again, let me recuperate again. So first you need to specify the experiment name. You need to specify the location for the Amazon S3 bucket, the location of the data. You need to specify the actual target column. And of course, you need to also specify the location as well of the output. And then go ahead and just say create experiment. And that simply is going to kickstart our experiment for us. And please note that I already have the experiment ran already. So I'm just gonna say create experiment, and I'm gonna stop it right away, okay, to avoid incurring any cost, because again, I already have the experiment ran. I'm gonna walk you guys through the results right now. So if you just click on create experiment, what you guys see here is we're gonna go through multiple stages or multiple processes. Essentially, it's gonna generate 250 models, and this process might take around a couple of hours for it to complete. You're going to do pre-processing. You're going to generate candidate definitions. You are going to also perform feature engineering. We're going to perform hyperparameters tuning and also generate AI ML models explainability report, which is super powerful. Please note that again, this process might take many hours. For me, it took like 2 hours approximately. But what I'm going to do is I'm going to stop the experiment for me, okay? But for you guys, again, especially if you are on the free tier, you can go ahead and give it a shot and let it just keep going. But what I'm going to do in the next lecture is I'm going to show you guys the analysis on the experiment that I already ran. And that's it. That's all I have for this task. I hope you guys enjoyed it, and see you in the next lecture. Hello everyone and welcome to this lecture. In this lecture, I'm going to show you guys the results of our autopilot experiment. If you guys remember, in the previous task, we have been able to kickstart our experiment and we have been able to train multiple models, and as I mentioned, it took around 2 hours approximately for all these 250 models to train. And essentially these are the results that you will end up with once the model is trained. So what you guys see here is there are so many experiments that ran here, and it's showing you as well, think of it as more of a leaderboard similar to what we got before within Data Robot. And essentially here I have all the different metrics. So for example, here I have the F1 beta, here I have the accuracy, and here I have the F1 score. And essentially, if you take a look at the accuracy, the model is actually doing an okay job. It's around like 77% accuracy. And it actually makes sense because this is a real world data, and it's actually quite challenging data as well. So even if you deploy or run, let's say, like a really advanced AI model on it, these results are pretty comparable because again, this is very, I would say, complex, challenging data sets. So this is essentially the best model here has been selected by AWS SageMaker Autopilot for deployment. And another point that I wanted to show you guys is if you click on Open Data Exploration Notebook, what you guys see here is essentially it's showing you some sort of a report that shows you the data, shows you how many features do we have in the data. And it can actually show you as well if there has been any missing values, for example, and if there has been any feature engineering that has been conducted on the data as well. Please note that there is a lot of, I would say, details in here, and I'm not going to dig a little bit deeper into them, but the overall idea is, as AI developers, we generally hate when we deal with models that are black box. We don't want to just feed in the data to a tool and that tool will kind of, do a magic and just generate, any results out of it. I actually wanted to have some sort of understanding of what's going on behind the scenes. And that's the power of AWS SageMaker Autopilot. Basically, it can show you the data, it can show you what kind of analysis has been conducted on the data, and it can also show you here kind of a statistical summary of the data, showing the mean, the median, the min, the max. For example, if you check out the age here, it can show you the minimum age and the maximum age for our customers, which is 21 years old and 79 years old, and the median is 34 years old, and the average is around 35 years old approximately. Okay? Alright. If you go back and if you click on the Open Candidate Generation Notebook, basically here you will get an idea of how many models have been trained and what kind of models are running as well behind the scenes. One of the best models that AWS, actually SageMaker, got it right is a model or an algorithm known as XGBoost algorithm. So XGBoost is a super powerful algorithm that has won several Kaggle competitions, and here is an example. So for example, that's one of the models which implements XGBoost, and it can also show you what kind of hyperparameter optimization has been conducted as well. Again, this is quite advanced as well, I would say beyond the scope of this course, but if you guys wanted to dig a little bit deeper, again, please go ahead and check any AWS courses that I have as well available on Udemy too. Okay, alright, so if you guys head back and if you wanted to deploy the best model, you can just right click on it, and before we deploy the model, you can actually open the model details. So if you click on Open in Model Details, you guys will see here that we have what we call it the feature importance. Essentially, it's showing you that pay 0 is one of the most important features, followed by the limit balance, and then pay 2, pay 6, and these are essentially the importance of our features. And again, that will help you kind of get an idea of what the important features are. And this is some sort of AI ML models explainability that we covered before in previous projects as well. Okay. Please go back, right click on it and just say click on deploy model, and what you guys see here is you can actually go ahead and create real-time predictions. So if you come here, you need to specify the SageMaker endpoint. So for example, I'm going to call it credit card prediction endpoint. you need to specify what kind of instance you're going to be running on. So for example, if you're expecting, let's say, high compute, for example, or maybe you are expecting, let's say, a lot of customers who are going to do inference on the endpoint, you can essentially go from medium up to X large, and there are so many different variations here. Let's go ahead and stick with the basic one, which is the medium. You can also select how many instances you want. I'm just going to select just one instance, and all what you need to do is to go ahead and just click on deploy model, and that simply is going to deploy the best model for you. And that's pretty much it. That's all what we need here to build, train, test, and deploy an AI model at scale with AWS SageMaker Autopilot. Let's go ahead and go back to our slides. And please note that here I took many snapshots, essentially of every single stage, every single process that we went throughout the training, throughout the model deployment. And that simply concludes our task. I hope you guys enjoyed it. In the next task, a very, very important point that I wanted to show you guys is how to delete the endpoint. This is very crucial and very important, because if you leave the endpoint running, it will incur a ton of cost for you and you will end up with a huge bill. And that's why I wanted to highlight it as important, and I'm going to cover it independently in a separate task. And then in the following task, we're going to show you guys a final project. And that's all I have. I hope you guys enjoyed this lecture, and see you in the next one. Hello everyone, and welcome to task number 6. In this task, I wanted to show you guys how to delete the endpoint. If you guys remember, in the previous task, we have been able to essentially build, train, test, and deploy multiple AI models at scale using AWS SageMaker Autopilot. So right now, and this is very important and it's a very short task, is I wanted to make sure that you guys are able to delete the endpoint. So if you go to Amazon SageMaker, under inference, you will see an endpoint. So if you click on endpoint here, you should be able to see the endpoint that you have deployed as well, and it's showing as well to you the status which shown here in service. Please, please, please make sure to delete the endpoint. So essentially, by clicking on actions and then delete endpoint, that is going to delete the endpoint for you, and that will make sure that you don't incur any additional cost. Please make sure that if you leave it running for maybe like a month or so, that will incur a ton of cost for you. Even if you have the free tier, if you leave it for a prolonged period of time, that might consume all the money that is available in there. So please make sure to delete the endpoint, and once it's deleted, you will be able to essentially get rid of any endpoints. So if you go under endpoints, you're not going to be able to see anything in here at all. Okay? All right. So that's it. That's simply all I have for task number 6. I hope you guys enjoyed it. In task number 7, let's go ahead and cover the final project. Please stay tuned. Best of luck, and I'll see you guys in the next task. Hello everyone, and welcome to task number 7. In this task, let's go ahead and cover our final project. If you guys remember, in the previous task, we have been able to delete our endpoint, and please make sure, it's very important to make sure that you deleted the endpoint. And now it's time for our final project. And please note that this lecture is categorized under the intermediate level difficulty. So let's go ahead and get started. So the final project today is, the objective is to predict the health insurance cost incurred by individuals based on their features such as their age, gender, BMI or body mass index, the number of children, the smoking habits, and geolocation as well. So the available features are the sex, the BMI or body mass index. We also have the children, number of children that have been covered by the health insurance. We have also the smoker habits. We have also the region. And finally, we have the target output, and the target output primarily is the charges. And please note that what I wanted you guys to play with right now is I want you guys to explore essentially AWS SageMaker Autopilot, but to solve regression type problems. What I showed you guys today in the today's project is a classification type problem, and this is a regression type problem. I'm trying to predict a continuous value. I'm trying to predict the charges that has been incurred by the health insurance essentially. And using AWS SageMaker Autopilot, I want you guys to train multiple models, select the best model, and analyze its performance as well, and then deploy the best model afterwards. Here is a link to the data, and you guys should be able to see the data under the final project folder in the course package. So here we go. So what you guys see here is I have my day 9, and you should be able to see a final project here. So if you click on that folder, you should be able to see our insurance data, and you should be able to also see our startup Jupyter notebook. And please know that the process is going to be pretty much the same as the what we covered already with the credit card default prediction, but of course the difference will be that right now we're solving regression type problems. Of course, you need to go ahead, play around with this notebook, run it a little bit, copy as well the S3 locations, and kickstart an experiment in AWS SageMaker Autopilot. And that's it. That's all I have for this final project. Best of luck, and please go ahead, give it a shot, and I will see you guys with the solution lecture in the next lecture. Hello everyone, and welcome to this lecture on AWS SageMaker Autopilot demo. If you guys remember, in the previous lecture, we have been able to understand from a very high level Amazon SageMaker. We learned the different elements within SageMaker, how it interacts with S3 and with the EC2 container registry. And we also went through a quick overview of SageMaker Autopilot and its features. And now we're pretty much ready to go ahead and start our project with our own data set. Okay, so please note that here I've included a series of snapshots of basically what we're going to do throughout the entire project. Okay, so in case if you guys maybe wanted to refer back to these notebooks, you can go ahead and go through these screenshots. But what I'm going to do right now is I'm going to essentially do all these steps together within AWS SageMaker Autopilot. All right, so what I'm going to do first is I'm going to here go to my Amazon SageMaker Studio. And what I'm going to do at first is I'm going to here show you how we can create an experiment. So if you guys go to this icon here, let me zoom in a little bit so you guys can see a little bit better. So if you go to the command here and click on that icon, you should be able to see a ton of options. So if you scroll down, you should be able to see here under the SageMaker, we have our experiment. And that's essentially how you kick off the experiment. So if you just click on the experiment here we go, you should be able to enter the experiment name. You need to specify essentially a series of things. First, you want to specify the experiment name. Second, you need to specify the location of your data set. Where did you store the data in Amazon S3? And then next, you need to specify what's the target column that you're trying to predict. Like, what is the name of the variable that you're trying to predict, essentially. And then next, we want to know what is the location of the S3 bucket where you want to store the model artifacts. That's essentially the output data location. And that's it. You just say create experiment, and Amazon SageMaker Studio will essentially create 250 runs for you. Imagine we're gonna try different models. We'll try to optimize the models as well. We'll do all of that, and then at the end we'll tell you, well, after all my experiments, here is my best model, and I can take that model and simply deploy it in practice. Okay, so the question is, how can I store the data to S3? Okay, and please note that as promised, I'm trying to keep the course with almost zero coding. Okay, so what I wanted to do here is I just wanted to upload the data to Amazon S3. Okay, so you can either do it manually, or I've attached a script for you guys, so you guys don't need to write any code, but you just need to upload the script and just run it. All what that script does simply is just upload the data to Amazon S3, and then we are going to get the links to the S3 buckets and just copy them in here, and that's it. So what I want you guys to do is to please go ahead and click on the upload files. So just gonna say upload files here, and you guys will see that here I have my course package, and in the course package I've attached two things for you. The first one is the script that we're going to use to essentially upload the data to S3 and to also obtain the path to all my S3 buckets. And I've also included here the insurance data. This is simply a CSV file that contains all the data set that we're going to use. So please go ahead and select these two together, and you just say open. And you should be able to see here that I have my, let me show you. So here I have my insurance prediction autopilot startup, and also here I have my insurance data. All right. So what I want you guys to do is to please go ahead and double click here on the insurance prediction autopilot startup. And here we go. This is simply a Python script. All what it does, it is just first import pandas as PD. And pandas is simply a library that is used for data frame manipulation. Think of it as more of a dealing with Excel in a tabular format, but in Python. And all what I wanted to do is I wanted to go ahead here and say pandas pd dot read CSV, and I wanted to import the CSV file here, which is, I called it insurance underscore data. You guys again will see that in the course package I've included the script, which is insurance prediction autopilot startup, and I've also included the data set, which is entitled insurance underscore data. And in order to run the cell, all what you need to do is to go ahead up here and click run. So when you run the cell, that means you are executing these two lines of code. And then if I wanted to see essentially what does the data frame look like, which is my insurance underscore df, I can say insurance underscore df dot head. So if you run that, here we go. You guys will see that here is simply, this is a data set. So I have the age of the customers, I have the sex of the customers, I have the body mass index, I have the children, number of children, I have their smoking habits, I have also the regions, and finally I have the charges, and that's simply the variable that I'm trying to predict. Okay, so all these are inputs to the model, and this one is an output from the model. Okay, so please note that all what we have done so far is we have simply just uploaded the notebook, uploaded the data, and all what I've done here is I've read the CSV file, I've read the content of the CSV file in a data frame, which is insurance underscore df. Okay, all right. So let's actually make sure that we ran that. Okay, looks great. So in task number 2, all I wanted to do is I wanted to upload the data to an S3 bucket. Okay, so here please note that all what we have done is that we have been able to visualize our data frame, and now I just wanted to upload the CSV file to my S3 bucket. But instead of doing that manually, I just want to do that here using that script. So first I'm going to import SageMaker. Next I'm going to import or create a SageMaker session using SageMaker SDK. So we're going to say SageMaker.session. This is simply will create a session for me. And then next, I'm going to specify the path to my bucket. So I'm going to say modern AI zero coding. You guys can call it anything you want. And then I'm going to say /input, and that will be my prefix. And then next, I'm going to take the session, which is what I created before, and then I'm going to say upload data. I'm going to specify the file that I wanted to upload, and this is simply my insurance underscore data.csv, which is what I got in here. And I'm going to specify that the key prefix to be my prefix, which is what I specified in here. This is simply the path to my S3 bucket. And if you guys press Shift and Enter, so if you either press Shift and Enter or you click play here, they do the same thing. So if I just click play here, here we go. You guys will see that now I have, this is the path to my CSV file on Amazon S3. So if you go to S3, here I have my bucket. This is the bucket path here. And here I have the actual file that I've uploaded to S3. Please note that all what I'm doing here is I just wanted to obtain this information because I will need it when I go and create my experiment. The next step is I'm going to specify that path, and that will be the output, essentially. If you guys remember, I was going to use Amazon S3 for two reasons. The first one, to upload the data, and that's what I've done here. The second one is I'm going to use it to put, or after the model is being trained, I'm going to put all the model artifacts in there, and that will be the output. So please note that here I have the inputs. So I have modern AI zero coding input. Here I have modern AI zero coding output. Okay, that will be the output path. So that's it. You press again Shift and Enter, or you click Run. Here we go. So these are the essentially the two links that I'm looking for to create my experiment, and that's it. That's all the coding that's required for this specific task. Okay? All right. So that's all I have for this lecture. I hope you guys enjoyed it. In the next lecture, let's go ahead and continue along and create our own experiment. So please stay tuned, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. Let's keep going and continue our the creation of our experiment. If you guys remember, in the previous lecture, we have been able to explore our data set, if you guys recall. So here we have been able to import our data, which is our insurance_data.csv. We visualize the data here. We learned that we're going to use the charges as my target column. And we have been able to just simply upload the data to our S3 bucket. We just specify the path, and that path we're going to be using it to when we create our experiment. And then also we specify the location to store our outputs, and that will be the second path as well that we're going to use to upload our model artifacts in there. Okay, so let's go ahead to our experiment. If you guys remember here, I need to go to my commands, and if you scroll down, you should be able to see, let's keep going. Here I have my experiment. Please go ahead and click on it. Here we go. First, you need to give the experiment a name. So I'm going to call it, let's say, AI with no coding. You guys can call it anything you want. And maybe I'm going to call it, let's say, trial, for example, because I already have another experiment that ran before that is called AI with no coding. So again, you guys can give it any name. So here we go. The second step, please skip the tag part. That's optional. Next, I need to specify the location of my S3 bucket that contains my data set. And here it's simply telling me connect your data. So if you select enter S3 bucket location, you just need to specify the S3 bucket address. So if you guys go back to our script that I've attached before, I'm assuming you guys ran it already successfully, this is what we need. So just click on this path, right click on it, and say copy, or you can just say Control C, and then if you go back to the experiment, you go here and then you say Control V. Here we go. So now I specify the path to my data set in S3. Next, I need to specify the name of the target column, what column I'm trying to predict in my data. So if you guys go back to my script, if you guys remember, that was the name of my column, which is charges. Again, I can simply copy it, go back to my target and paste it, and I'm going to say create charges. So here we go. So essentially now Amazon SageMaker Studio knows that I'm looking for the charges as my target column. So again, all it needs the location of the data where the CSV file is located in S3. It needs what target column I'm trying to predict. This is crucial. Next, I need to specify the output data location where I'm going to store my model artifacts. Again, if you guys go back to my script here, this is essentially the location where I want to store my model artifacts. Again, select it, Control C, go back to the experiment, and then select Control V. Here we go. And you guys can come here and specify what type of problem you're trying to solve. Is it a binary classification problem? Or is it maybe a regression type problem? Or maybe multi-class classification? If you guys remember, we explained the difference between regression and classification before, and we know that our problem is actually a regression type problem because we're trying to predict a continuous variable. However, if you're lazy or you don't care, just select auto, and then Amazon SageMaker Studio on its own is going to predict what type of problem you're trying to solve. Okay? And that's it. All what you need to do is to go ahead and say create experiment. That's all what you need. And please note that if you guys go back to the slides, here I've included detailed explanation of every single step. So how to create the experiment, give the name to the experiment, here how to select the location for the S3, select the name of the target column, and also select the output and say create experiment. So let's go back and say create experiment. So here we go. Now I'm pretty much ready to create my experiment. So I'm going to say create experiment, and here we go. So you guys will see that now what AWS SageMaker Studio Autopilot is going to do is going to do everything for me on my behalf. So I'm not going to be writing any code essentially, and it's going to do pre-processing for me. So you're going to clean up the data. It's going to perform candidate definition generated, essentially trying various types of models and various type of configurations of models. It's going to also perform feature engineering to try to improve the performance of my model. And it's also going to perform model tuning as well, which is again super incredible. If you guys go back, I would say when I started in the AI field maybe 10 years ago, and someone told me that you can develop super powerful AI models with just zero coding, this is just unheard of. You know, like now it's at, you know, it's just really simple. Just all I need is the data and an AWS account. And you guys will notice here that you can essentially create 250 trials. So the process, I would say, might take around approximately an hour or maybe an hour and a half to run the experiments. And again, it will take maybe for the first 10 minutes before you see any outputs being generated in here. And that's it. That's all I have for this lecture. I hope you guys enjoyed it. In the next lecture, I'm going to show you guys the results of our experiments because I already have one that I started beforehand. So that's all I have. I hope you guys enjoyed this lecture and see you in the next one. Hello everyone and welcome to this lecture. In this lecture, we're going to continue with our experiment within Amazon SageMaker Studio. And if you guys remember from the previous lecture, we have been able to kick off our experiment. We specify the location of our CSV file in S3. We specified also our target column that we're trying to predict, which is what we call it charges. We also specify the location of the in S3 where we wanted to store our model artifacts. And that's it. That's essentially all what you need. And of course, you need to give an experiment a name, which is what we call it here, AI with no coding trial. But what I've had run beforehand is I've actually ran another experiment, okay, which is, I called it Insurance Prediction Autopilot, all right? And you guys will see that if you guys go up here, this is essentially what you see after approximately an hour and a half of running. So these are all the different experiments that the model, that the AWS SageMaker Studio have created for us. So you guys will notice that here I have a ton of iterations, okay? And there's a lot of tuning as well jobs that have been created. And here I have the objective, which is MSE, which is mean squared error. So if you guys keep going here to the bottom, you will see that this is the best tuning job that has been created. It's highlighted by an asterisk here, by star. And that's the least MSE, which indicates that that's the best model that was able to fit my training data. So in order to deploy the model, all what you need to do is to select any of these models. So of course I'm going to go ahead and select the best one. So I'm going to scroll down and I'm going to select the best one that has the asterisk or the star in there. Here we go. That's the best. And you can just say deploy model. That's it. So I'm going to say deploy model. And you guys would see here that I'm able to, so now the model has been deployed, okay? And that's it. It's pretty incredible because now you have been able to kind of automate the entire AI ML workflow for you, okay? So you guys can see here, this is essentially I need to specify the endpoint. So if you guys remember, in order to run predictions on the model, you need to give it a name to the endpoint. So the endpoint, for example, I'm going to call it, let's say, insurance prediction endpoint. And here you can go ahead, please make sure there's no underscore, just dash is good. And then next, please make sure that here you can select essentially what type of instance that you need to use. So you can either use all these instances depending on the computational complexity of your model. So you can either select either T2 medium, there is T2 large, and of course as you go up, that means the cost as well of these instances will go up as well. So let's select the simplest one, I would say. You can also specify how many instances you'd like. So maybe if I wanted to select more instances or less, just select one for now. And you can simply say deploy model. And this is simply how you essentially deploy an AI model in the field. And again, you can use that to deploy it at scale as well. So if you wanted to build an application, all what you need is just data and an AWS account to create your AI model, to perform model hyperparameters tuning, to train the model, and to finally deploy the model as well at scale. Okay? All right. And I wanted to also show you guys here one last thing, which is here you have two things. Okay? So you have what we call it Open Candidate Generation Notebook. And the second one is called Open Data Exploration Notebook. So if you open the first one here, simply what SageMaker Autopilot would like to do, would like to show you here, is more of what we call the white box approach. In general, AI developers do not like black boxes. So basically what we have done right now is just we uploaded the data, but here we don't even have much visibility of what actually happened behind the scenes, right? But what's powerful is that you can actually know what happened inside the scenes. So here it's more of a report that can tell you what type of models that have been used, what type of feature engineering that has been used, what type of data, for example, that has been used to train the model. So it's like a report. It can kind of, help you increase the confidence in the training process. So if you guys scroll down here, you should be able to see there's a lot of code in here, but here it's showing you the candidate pipelines. So these are the various candidates that the Amazon SageMaker Studio Autopilot have used. So for example, here it has used the XGBoost algorithm. So that's one of the algorithms that have been used. And it also have used robust imputer to convert missing values to NaN, or not a number. It also used the threshold one hot encoder. So all these are essentially kind of processes that that AWS SageMaker Studio went through in order to generate the first candidate notebook. So here, and finally, it performed robust standard scalar. So all these have been performed. And please note that this algorithm here is known as XGBoost, or extreme gradient boosting. We haven't covered that in this course. It's going to be beyond the scope of the course. But think of it as this is like a really powerful algorithm to perform machine learning regression and classification tasks as well. The second candidate notebook is, again, here we have another XGBoost. We perform one hot encoder as well, and robust standard scalar too. So if you guys scroll down, there is another, again, run here with the same deal. Here, they have also used linear learner algorithm. So linear learner is simply just simple linear regression, which is what we have covered already in the beginning or the start of our project. And again, we had our robust PCA, or principal component analysis. Please know that there's a lot of details I would say here, but again, you don't need to know what's actually going on in here. Just in case if you are a developer and you want to know what actually happened behind the scenes, this is not trivial. Like these algorithms, these are the state-of-the-art, cutting-edge algorithms that have been used and deployed at your fingertips without even writing any code. If you go back and you open the data exploration notebook, this is simply is going to show you kind of a summary of your data. So it's telling you that your data set consists of around 1,300 rows, and the data set had 7 columns, and the column named charges has been used to be the target column. If you guys remember, that was the column that I'm trying to predict. This problem has been identified as a regression type problem because I'm trying to predict a continuous variable. And it's telling you as well that the labels have that range. So this is the range of my data. And if you scroll down here, you should be able to see a sample of my data set. We know that these columns exist in the data set. And it's telling me here that there is a percentage of missing values. So essentially it's telling you that SageMaker Autopilot will try to fill out any missing values if exist. So if you scroll down here, you should be able to see as well all the count statistics. And if you scroll down, it's telling you how many unique entries do I have in every column. So for example, for the smoker, I know that there are 2 categories, either smoker or not. For the regions, I had 4 regions in my data. And for the children, I had 6 categories. If you scroll down, you should be able to see as well a statistical summary of your data. What is the median of the columns, what is the minimum, and what is the maximum as well. And that's it. This is simply how you leverage AWS SageMaker Studio to automate the entire AI ML workflow for you. All right, okay, so that's all I have for this project. I hope you guys enjoyed it, and see you in future projects. Hello everyone, and welcome to this new project on no-code machine learning with Google Vertex AI. Google Vertex AI is a brand new tool offered by Google, and it essentially will make our life extremely easy. So what we're going to do is that we're going to learn how to build, train, and deploy really powerful machine learning models at scale without writing a single line of code. Okay, so going to be super powerful and super fun. All right, so let's go ahead and get started with an introductory lecture on the rise of machine learning in higher education. So machine learning and artificial intelligence have been transforming higher education in many areas, such as marketing and recruitment of students. AI and machine learning is also applied right now in students' admission and enrollment as well. It's also applied in curriculum and resource planning and forecasting. AI and machine learning are also applied in developing a personalized students' learning experience. So basically, instead of offering all students the same content, then machine learning and AI can consume the students' features and then provide them or offer them with a personalized learning experience targeted for their skill set and their background. And of course, we have the automated student support, essentially AI-powered counseling. And please note that in this project, what we're going to do is that we're going to focus on the students' admission piece. So basically, what we're going to do in this project is that we're going to consume students' data. We will consume their GPA, their grades, their the background, for example, about their school. Is it a research institution or not? We'll also get their TOEFL score, which is their ability in English, in writing and speaking as well English. And we're going to consume all that data and then generate a single score that could tell me if that student has a high chance or a lower chance of admission at a given university. Okay, so here we go. So the project overview. So as I mentioned, in this project, we are going to build a regression model, and the objective of this model is to predict the chance of admission of a given student into a specific university based on the student's profile. So here are the list of inputs. So we have our GRE score. This is simply a score that can tell me how that student is essentially did on the GRE test. and this number is out of 340. We also have the TOEFL scores, and TOEFL is essentially an exam to test students' ability in writing and speaking as well English. And the number here, or the score, range between 0 up until 120. We also have the university rating and like their background, their education background. What is the rating of their university? And this number could range up till 5. We also, student of course, whenever they apply to a given school, they have to write a statement of purpose, and they have to also write a letter of recommendation. And essentially what we're going to have here is the statement of purpose. We can have a number that indicates how powerful that statement of purpose is. We also have the letter of recommendation strength, and that's again a number indicate how powerful that letter of recommendation is. We also have the undergraduate GPA, and that's a score out of 10. And finally, we have the research experience, if let's say the students have research experience or not. And this is simply a binary input, either 0 or 1. 0, that means students do not have research experience, and 1 indicates that students have research experience. So basically what we're going to do again, we're going to build a machine learning model that will consume all that data from all these different students, and is going to generate the output will be the chances of admission. And that number will be essentially a score that range between 0 and 1. All right? Okay. So let's dig a little bit deeper, and here's an overview of our project. It's going to be a super fun project. Here we have all the different inputs, okay, GRE score, TOEFL, university rating, and so on. Here we have a machine learning model. We're going to feed all these data as input to the model, and the model will generate one output. And that one output is basically the chances of admission. And please note that because the output here is a continuous output, meaning it's a number that can range anywhere between 0 and 1. So it could be 0, it could be 0.2, 0.1, 0.5, 0.7, whatever. And because the output here is continuous, we call this problem a regression type problem, because we're trying to predict a continuous output, such as chances of admission, such as temperatures, for example. It could be any number. We have, let's say, stock prices. Again, this could be any number too. And that's what we call it regression type problems. We also have in machine learning what we call it classification type problems. And these are problems when the output is binary or categorical. Meaning, I could say, well, the patient is healthy or sick. Maybe I am happy or sad. These are discrete outputs. And that's not our problem here. We're going to cover classification type problems in the next project. Okay, so now it's time for our reading time and a quiz as well. And the topic of our quiz is the rise of AI and machine learning in higher education. And please note that here the reading material is expected to take around 15 minutes. And afterwards, I'm going to include a quiz for you guys. And the quiz is approximately, we're going to take around 10 minutes to complete as well. So what I want you guys to do is I want you to read these two really solid articles. The first article entitled A 5-Year Vision for AI in Higher Education. And the article is written by Mika Castello. I hope I'm pronouncing her name right. And there is also another article entitled Artificial Intelligence in Higher Education, Application, Promise and Perils, and Ethical Questions as well. And that's by Ilana Zaidi. And I highly recommend that you guys, again, read them so to be able to answer the quiz. And I have the articles open, so let me show you. So this is the first article. Basically, the article dig a little bit deeper into the different AI applications in higher education. So for example, AI could be used for student admission and enrollment, and that's essentially one of the topics for our project. We also have marketing and recruitment. We also provide student support with the power of machine learning and AI, and of course the instructional design and how we can offer a personalized learning experience to students. And again, it's really interesting read. You guys can go ahead and see the promise and perils, like, like what's the issues, for example, and what ethical issues could arise as well because of the application of machine learning and artificial intelligence. And if you guys check out the other article here is on a five-year vision for artificial intelligence in higher education. And again, it talks about the applications of AI, what's the vision as well over the next 5 years. It's an interesting read, and that's why I ask you guys to please go ahead, read these 2 articles, give it a shot, and attempt to solve the quiz afterwards. Okay? Alright. So that's simply all I have for this lecture. I hope you guys enjoyed it. In the next lecture, what we're going to do is I'm going to go ahead and cover the basics of machine learning regression. Okay, so it's going to be a little bit of math, and then afterwards we'll go right away and start to build our model using Google Vertex AI. So please stay tuned, best of luck, and I'll see you guys in the next lecture. Hello everyone, and welcome to this lecture on Machine Learning Regression 101. If you guys remember, in the previous lecture, we learned about the rise of AI and machine learning in higher education. And if you guys remember, we provided an overview of our project. We learned that we're going to consume all these various inputs about different students, such as their GRE score, their TOEFL, university rating, how powerful their letter of recommendation is, and the statement of purpose as well. And then we are going to generate an output, and that output will be our chances of admission. And if you guys remember that because the output here is a continuous output, essentially could take any number between 0 and 1, we call this type of problem a regression type problem. And that was the overview of our model. We're going to build a machine learning regression model. We'll take in all these inputs and generate just a single number, essentially. Okay, and finally, I hope you guys were able to figure out the quiz, and I hope you went through these 2 articles and you found them interesting as well. Okay, so what I wanted to do right now is I wanted to cover the basics of machine learning regression, and I will try to keep it short and to the point with minimum math, because in the next lecture, we'll go ahead and build, train, and deploy our machine learning model with Google Vertex AI. Okay. So let's assume that you wanted to develop a relationship between the GRE score, which is one of the features that we have in our data, and between the chances of admission. And let's assume that you are a university, for example, and you have been able to collect all that data about different students. For example, what you guys notice is maybe students who have a high GRE score tend to have a high chances of admission. And maybe students who have low GRE score, who did not do well on their GRE exam, then they might have a low chances of admission. And what you did is that simply you collected all these data points. Each of these data points contains an X and Y coordinate. And what we wanted to do right now is that we wanted to develop a relationship. And we're going to assume that we're going to develop a relationship, and that relationship is simply containing just a simple straight line, essentially. So I wanted to find the best straight line that can go through all these data points. And if you guys remember, if you covered any course on basic mathematics, for example, you will find that this equation is the equation for a straight line. Y is the output, okay, and Y will be equals to B plus M times X. So the question is, what's B, what's M, and what's X? Well, so X is what we call it the independent variable. And when I say independent variable, this is simply a variable that I can change independently, meaning I can change here the GRE score, which is the X value, and by changing it, I'm going to impact my dependent variable, which is what we call it the chances of admission, and that will be the Y value here. So the overall idea of building regression-based machine learning model is that we wanted to obtain a relationship between 2 variables, between the independent variable X okay, and in this example is the GRE score, and between a dependent variable y, and that's what we call the chances of admission. And that's all what I'm trying to do. I'm trying to find the best straight line that can go through that data that can essentially govern the relationship between x and y, between GRE score and the chances of admission. So if you guys remember from any, again, basic math course, that m is what we call it the slope of the line. So the slope of that straight line is the m, and essentially it's the delta y divided by delta x. It's that distance here, delta y, divided by delta x, and that will give me the slope of the line. So for example, this line could be going this way, it might be going this way, for example, or maybe it might be, let's say, horizontal, who knows. And that's what I'm trying to do. I'm trying to find the best adjustment for that straight line based on the slope, and that would be the value of m. And the next parameter that we're trying to find here is the value of b, and b is simply what we call it the y-intercept. So this line here intercepts the y-axis in this point, so this distance between the origin, or 0 and 0, and the intersection of that line here is known as b, and b is simply the other parameter that we have in here. Okay? Alright, so let's again recap. Regression works by predicting a value of one variable y based on another variable x. X, we call it an independent variable, and y, we call it a dependent variable. And our goal is to obtain a relationship or a model between these two variables. And that's all what I'm trying to do, essentially. I'm trying to find the best value for m and b that can best describe all these data points. Okay, so that's simply our simple linear regression. And what we have in here is what we call it the multiple linear regression. So let's assume that you have maybe multiple independent variables. So here, before, we only had one independent variable, which is the GRE score. Maybe right now you have more than one independent variable. Maybe you have GRE score, and maybe have your GPA as well, and maybe the TOEFL score, and so many other independent variables, right? And whenever you have more than one independent variable, then we have what we call it a multiple linear regression problem. And multiple linear regression problem examine the relationship between more than two variables. And if you guys remember in the previous slide, simple linear regression was simply trying to obtain a relationship between two variables only, x and y. Right now, I have more than one coefficient. So now, instead of only obtaining m and b, now I need more coefficients. Now I need to know what's b node, what's b1, what's b2, what's bn, and that's essentially my model. Once I know all these coefficients, then I was able to obtain a machine learning model that I can use and actually deploy in the field. Okay? Alright. So here I have two really good books available for you guys if you are interested in pursuing kind of more knowledge if you want. And the first book, it's entitled Understanding Machine Learning, and all these books are free and readily available for you. So that's the first book. And the second book is called An Introduction to Statistical Learning with Applications in R. And I've included two resources available for you guys here and two links as well. So if you just click on these links, you should be able to access the material, access the entire book, and you would also be able to explore as well the math behind the scenes, and there's a lot more details compared to what we're covering here. But the intent of this course is to provide you with the essential information you need to build our machine learning model with no code. Okay, so now it's time for our mini challenge. What I want you guys to do is, here I have 4 graphs, okay, 4 diagrams here, and I have 4 equations. And what I want you guys to do is to please go ahead and I want you to match the equation with the graph. I want you to maybe basically drag and drop here the equations to the graph and just give it a shot. So please go ahead, pause the video, and I will see you guys after the mini challenge. Alright, I hope you guys were able to figure out the mini challenge. What I ask you guys to do is to simply drag and drop these here equations and try to see which equation matches which graph. Okay, so what we see here is, well, if you guys remember, the original equation is y equals to, let me go back and recap. So y equals to b plus m times x. B is the y-intercept, and m is our slope of the line, right? That's our intent, our objective. So if I have a line, and that line could go through the origin, through 0 and 0, meaning that the y-intercept here is simply 0. That means b is equals to 0. So if you guys go back, what you guys see here is, well, this line here passes through the origin, meaning that I need to find an equation out of these that simply doesn't have a b value. It has something multiplied by x. So, well, I only have two choices. I have this equation, y equals to 1x, and 1 will simply be my m value, or the slope. The second equation that could satisfy the criteria is y equals to 4 times x, right? So what you guys see here is I have two equations, y equal 1x, y equals to 4x, and simply because I have two equations here, this line goes through the origin, and this line as well goes through the origin too. So basically I know right now that these two equations, this equation here, y equal 1x and y equals to 4x, will match this diagram and this diagram somehow. Now the question is, which one matches which, right? So basically what you guys see here is the slope of that line tend to be higher compared to the slope of that line, meaning that the m value for this one should be larger compared to the m value for this diagram here. So basically y equals to 4x, that will have to match this diagram, and y equals to 1x has to match this one here. So now I hope you guys were able to figure that out. Now I was able to match two diagrams to two equations. Now to the next fun part. I am left right now with two equations, y equals to 3x plus 5 and y equals to minus 3x plus 4. And simply what you guys see here, the slope of this line here is negative, while the slope of this line here is positive. When I say the slope is positive, meaning that as x increases, y increases too. That's a positive slope. When I have a negative slope, meaning that when x increases, the y value will go down, and that's essentially what I got here. So basically y equals to minus 3x plus 4, because the slope here is negative, so this equation has to match this diagram. And of course y equals to 3x plus 5 will match this one here. So this is simply the answer. This is the solution. Y equals to 4x, that will be the first diagram. Y equals to 3x plus 5 will match this one. Y equals to 1x will match this one here. And finally, y equals to minus 3x plus 4 will match this curve whenever I have a negative slope. Okay? Alright. So that's simply all I have for this lecture. I hope you guys enjoyed it. In the next lecture, it's going to be tons of fun. We'll go ahead, set up our Google Vertex AI account, and get started by uploading our dataset. So please stay tuned. Best of luck, and I'll see you guys in the next lecture. Hello everyone, and welcome to this lecture on Google Vertex AI Demo Part 1. In this lecture, we are going to learn how to set up our account and how to upload the data as well. Okay, so first of all, I've included here in the slides snapshots that include detailed instructions available for you guys here, just in case if you decide, for example, to maybe refer to these slides at a later date, or you decide maybe to skip the videos, for example. So what I want you guys to do first is I want you to please go ahead to cloud.google.com/vertex-AI, okay? And basically Vertex AI is a brand new tool offered by Google that will enable anyone to build, deploy, and scale machine learning models extremely fast, and we are going to essentially use models that has already been pre-trained for us, and we're going to learn how to take these models, tweak them, and essentially deploy them without writing a single line of code, which is pretty incredible. So I highly recommend that you guys, first of all, sign in to your Google account. So after you go to this link, on the top right corner, you should be able to see sign in. So please go ahead and click on sign in. And then next, what you guys need to do is you need to, I assume most of you guys have a Google account. So you need that, of course, or a Gmail account. And then you need to log in to your account. And after you log in, you will be able to go to the Google Vertex AI console. All right. So after you insert your password, you will essentially be able to access Google Vertex AI, and you should be able to see that you don't need to sign in anymore. I have signed in to my account already. Okay, so here are the features of Google Vertex AI. You will be able to build groundbreaking machine learning models with the power of Google, and of course these models have been developed by Google researchers, and these are the top-notch researchers, so the models that are deployed are cutting edge and top-notch as well. You'll be able to deploy these models at a much faster rate, at like 80% fewer lines of code. And actually what we're going to use is that we're going to use the no-code features in Google Vertex AI. So actually we don't need to write any code at all. And of course, we are going to use the ML Ops tool that will enable us to manage your data and models with confidence, and of course as well repeat at scale. So I'm going to show you guys all of that in great details. Okay, so next what I want you guys to do is to please go ahead and click on Go to Console. So if you just click on it, that will take you to the Google Cloud Platform here. And this is simply the Vertex AI dashboard. So what you guys see here is, let me zoom in a little bit. Here there is a little bit of summary about Google Vertex AI. So Vertex AI, as I mentioned, empowers machine learning developers, data scientists, and data engineers to take their projects from ideation to deployment quickly and cost effectively as well. And what you guys notice here is that there are 3 key areas when it comes to building and training your models. First of all, to train any machine learning models, well, you need data. You need to prepare your training data. And that's here our first category. So if you wanted to collect and prepare your data or import data sets, which is what we're going to do in this project, you can essentially go here and do that in this tab here. The second step is, well, you need to train the model. So what Google Vertex AI could offer is that it could offer best-in-class machine learning models that can work with your data set. And again, we're going to use Google's AutoML that will enable us, empower us to build, train, and deploy machine learning models without writing any lines of code, and everything will be automated for us. And finally, once the model is trained, you can go ahead, take that model, and generate predictions, and essentially feed in data sets to the model to generate predictions, to tell me what's actually this model is, and then we will be able to assess the performance of our model in practice. Okay, so this is from a very high level what's going on here on the dashboard. On the left-hand side, you will be able to see various features that you can leverage within Google Vertex AI. So we are in the dashboard. You will notice that there is data sets. So if you click on it, you guys will see here that you can go ahead and create your own data set. And there is also a couple of what we call the labeling tasks. So for example, if you wanted to maybe leverage the data labeling features, so let's assume that you don't have labeled data and you wanted to label your data, you will be able to essentially kickstart a labeling task and use human labelers to annotate your data for you. Essentially, Google is kind of outsourcing different labelers globally. So you can kickstart here a labeling job, and labelers across the globe can access that data and label that data for you. And please note that we are not going to use this feature in this project because we already have labeled data set and the data set is ready for us. Also, you can go ahead and create your own notebook. So if you wanted to write your own code, you can go ahead and leverage the notebook API in here. And please note that we're not going to be covering that in this course. Again, the main focus in this course is to build our machine learning models with no code. If you guys scroll down, you should be able to see we have training as well. So you can create your training pipelines too and track them. You can go ahead and start an experiment. So you can go ahead and create an experiment. And I'm going to show you guys all of that throughout the project. You can go ahead and access your models that you have trained as well. And finally, you can go ahead and access as well what we call the endpoints. So after the model is trained, you can go ahead and use that endpoint to make inference based on your trained model. Okay, so what I want to do right now is I want to go back to our data set and I want to go ahead and get started and create a new data set. So what I want you guys to do is to please go ahead and click on create, okay? And once you click on create, what you guys notice here is that there are several options available for us. So for example, you can use images. So you can actually upload images and train a machine learning model to classify images. And that's what we call it, image classification single label. We also have image classification multi-label. So if you have multiple labels for these images, you can go ahead and go here as well. You can also use what we call it object detection. So you can essentially feed in an image and then train a machine learning model to detect objects in the scene. For example, if you have images of, let's say, cars and trees, you can train a machine learning model to learn that whenever I see a tree, a bounding box will be drawn around a tree. We also have what we call it the image segmentation or semantic segmentation. And you can go ahead and perform pixel level segmentation. So on the object, instead of just doing a bounding box, you can go ahead and essentially on a pixel level kind of draw this green bounding box here, and here this blue essentially frame, and that will on a pixel level can kind of segment different objects within our image. And please note that in our project, we are going to primarily focus on tabular data. So we're not going to be dealing with images, but again, if you guys wanted to access it and maybe play with it, you can go ahead and experiment with it. The second type of data is what we call it tabular data, and that's the type of data that we're going to deal with in this project. And tabular data is simply, from its name, data that is cleaned up for us and ready available for us in a tabular format, in tables. And of course, you can either do machine learning regression or classification. And if you guys remember, regression could be used primarily to predict a continuous output. Classification will be used primarily to predict categorical output or discrete outputs, healthy or sick, happy or sad, and so on. Forecasting, you can predict what's going to happen in the future. So you generally have a time series and you're trying to predict maybe the stock prices tomorrow, or maybe predict the temperature, let's say in the next couple of days, and so on. And this basically the focus for our project, but let me cover the other types of data as well so you guys can get an idea of how powerful Google Vertex AI could be. We also here have our text data. So you can go ahead and upload text data, and essentially Google Vertex AI can do many tasks for you. So you can perform, for example, text classification. So you can classify text. You can, for example, perform text sentiment analysis, and that's a super powerful tool for any company. Basically, any company can drag or kind of obtain the data from all the social media sites for the company, and you can feed all that data to a machine learning model that can predict the sentiment. Basically, you can get an idea of, are your customers happy or sad? And that's super powerful. You can also visualize and get an idea of what these customers are talking about, why they are not happy, and a lot of insights about that data you can obtain with Google Vertex AI. And finally, we have our video as well capability. So you can go ahead and create data sets that contains video. So you can perform, for example, video object tracking. So you can track an object in like a ball here and track it in a video. You can also do video classification and video action recognition as well. Okay, I've been talking a lot, so let's go ahead and cover our specific project. So in our specific project, we'll be focusing on tabular data and then specifically focusing on regression and classification tasks. So what I want you guys to do is I want you to please go ahead and give that data set a name. So here I'm going to call it, let's say, university underscore admission data set. Okay, you guys can call it any name you want, really. And then what you need to do is to go ahead and click create. And of course, we are going to focus mainly on tabular data and regression and classification. Click create. And here it's showing me that data set has been created, but now you need to upload the data. So what you need to do is to go ahead and say upload CSV files from your computer. So you can say select files. All right. So after you click on select files, you guys will be essentially directed here to select your own files. And in the course package, I've included for you a CSV file entitled university underscore admission. And I actually have the file open here. Let me show you. So this is simply the CSV data. And that's the data set that we're going to use to train our machine learning regression model. So what I have in here is, well, the GRE score. That's the first feature. Second one is a TOEFL score. I also have the university rating. Again, higher number, that means a good university. We have the statement of purpose, which is how strong the statement of purpose was, or SOP for short. Here we have the letter of recommendation, which is, again, think of it as different numbers indicates how powerful your letter of recommendation is for each student. Here we have our GPA as well. Again, numbers indicating if that student essentially scored or GPA is good or bad. Here we have the research, if they have research experience or not. And then finally here we have our target output. This is simply what I'm trying to predict, which is my chances of admission. And what you guys notice here is, since the output is, well, a continuous output, that means we are having a regression type problem. We're trying to predict a continuous variable. And that's it, really. So all what you need to do is to please go ahead and just double click on that file, and that will upload the file for you. And here you can leave it as is. That will be the cloud storage path. You can just keep it as is. And you can go ahead and just click continue. And basically what I'm doing right now is I have simply went out, uploaded my data, and created a new data set. I call it university admission data set. So if you guys go back to our data sets, what you guys see here is, well, you have your university admission data set, okay? And you can essentially use that data to train your machine learning model, and that's what we're going to do in the next step, okay? So let's go back to our slides just to summarize what we have done so far. So in this lecture, we learned how to sign in to our Google Vertex AI account. We learned about the different features, different steps, creating of the training data, training your model, and generating organic predictions. We learned about how to upload or create various types of data sets, such as images, tabular data, text, and video. And we also have been able to select our regression and classification tab and upload our university admission.csv file here. And this is simply all the steps that we went through. And of course, we have been able to end up with our data set that is ready for us to train our machine learning model. And that will be our topic for our next lecture. So I hope you guys enjoyed this lecture, and see you in the next one. Hello everyone, and welcome to this lecture on Google Vertex AI demo part number 2. So what we're going to learn in this lecture, we will learn how to train our model. If you guys remember, in the previous lecture, we have been able to upload our data sets, just create our own data. It was very simple, pretty straightforward. I simply had a single CSV file. I just went up there, selected the type of data, which is tabular data, selected the regression or classification, and then we went out here, we selected upload CSV file, and then we simply specified the cloud storage path, and then that's it. That's pretty much it. Now we have our own data sets, and now we're pretty much ready to go ahead and train our model. And as always, I've included a ton of details available for you guys here if you guys wanted to explore it further. So if you guys remember, what we got in here is under data sets, we have our university admission underscore data set. And here it's showing the region is US Central 1. And what I need to do right now is I wanted to start a training job. So if you guys go to training here, if you click on it, you should be able to see the create. So please go ahead and click on create. Again, it's really simple. And what I need to do right now is I need to specify, well, what data set that I wanted to use for my training. And this is simply the data set that we just created, university underscore admission underscore data set. Next, you need to specify what type of problem you are targeting. Are you doing classification or are you doing regression? Well, I'm interested in regression, so we selected regression. Next, we need to specify, are we using the AutoML feature that is provided by Google Vertex AI, or you wanted to do custom training here? And please note that custom training, this is more of an advanced feature. So you will be able to run TensorFlow, which is Google's framework to build, train, and deploy machine learning models at scale, but you will need coding for it though. We also can use scikit-learn and XGBoost training applications, and you can do all of that in the cloud, but we are not going to be doing that in this course. We're going to primarily focus on the AutoML features. And the AutoML features can enable us to train high-quality models with minimum effort and machine learning expertise. And that's the overall intent of our entire course, really. So please go ahead and select, after regression, we're going to go ahead and select AutoML, and then go ahead and click Continue. Next, I need to specify a name here for my model. So maybe I'm going to call it University Admission Regression Model, for example. You guys can call it anything you want. And then next, I need to specify what would be my target column. What's the output? What is the variable or feature that I'm trying to predict? And what you guys see here is our chance of admission is simply our target column. That's my feature, or that's my output or column that I'm trying to predict in this project. So please go ahead and select chance of admission. And if you guys go down here and select advanced options, you'll be able to see a ton of options here available for you. So what you guys see here is simply, this is how we split our data. And please note that we're going to touch base on this quite a lot throughout the entire course, but let me give you an overview right now. In general, what we do is that we take our entire data set. Okay, so we go in the field, we collect data sets. And then what we do is that we generally split our data sets into three portions. We split them into training set, validation set, and testing data set. And I know that might sound a little bit confusing at first, and that's why I included a slide available for you guys here, so I can walk you through it. Okay, so what you guys see here is simply our division of data into training, validation, and testing. So the training set is primarily used for gradient calculation and weight update. Basically, we use it to train the model, okay? And then what happened is that as the model is being trained, okay, we are going to use our validation set to make sure that our model is not overfitting the training data. What we try to do whenever we develop any machine learning model is that we want to make sure that the model is able to generalize and not memorize. Meaning, and that's again a metaphor that we use quite extensively in the machine learning world, I would say, Let's assume that you are a professor and you are teaching students in a class. You give all the students, the concepts, you give them assignments, you give them quizzes, right? So you teach them the idea, what's actually going on, and you give them high-level concepts. And then on the exam, okay, after the students learn the material, you want to make sure that these students did not memorize the material. They actually understood it. And that's why during the exam, maybe you give them kind of similar examples, but maybe with different numbers, maybe with a little bit challenge in there, maybe newer ideas. And that's the idea here when it comes to our training of machine learning models. We want to make sure that these machine learning models are able to generalize and not memorize. We want to take these models, apply them in the field, and actually make good predictions on data that the model has never seen before during training. And that's a very important piece. So basically what we do is that we use a training set to train the model. And as the model is being trained, throughout the training, we use the validation set to kind of make sure that the model is still able to generalize. It's not overfitting the training data, okay? And a very important point here is the training set and the validation set, both of them are being seen by the model during training. So this data essentially has leaked into the model, okay? So the model has seen them before. So after the model is trained, so after the training is complete and everything is over, it's all good, now it's a time for the test. And that's why we use what we call it the testing data set or the holdout data set. And this is simply a data set that the model has never seen before during training. And that's again the last piece here, or the last percentage. And we use them to test our final trained model. Please note that these numbers might vary. So in general, they might be divided to 60% for training, 20% for validation, and 20% for testing. Alternatively, maybe we can go with 80% for training, 10% for validation, and 10% for testing. And that's from a very high level the difference between the training data, validation data, and the testing data set. And that's what we got in here. What you guys see here is simply I have the training set, which is 80%. The validation is set to 10%, and the testing is set to 10% as well. Okay? So you can simply just select random assignment, and that would be the assignment available for you guys here. All right. Let's go ahead and click on continue, and here we go. What you guys see here is simply I have my all my features. So here I have my GPA, I have my GRE score, letter of recommendation, and so on. And what you guys do is that you can simply select the auto transformation, and these are simply transformation process that Google Vertex AI does for you on the data automatically. Just don't worry about it. Just go ahead and click on continue. And what you need to specify right now, you need to specify the maximum number of node hours you want to spend for the training. Please note that here I'm using a free trial. So what you guys see here is free trial status. I have around $300 credit available for me, and that's available for 80 days. Afterwards, you will be charged essentially whenever you use the tool. So here, I'm just gonna stick with 1 hour. Basically, I'm just gonna go ahead, train the model for 1 hour, and let's see what's gonna happen. And all what you need to do is to please go ahead and just say start training. And that's it. And what you guys can see here is, well, the training process has started. So now we are training our model. And please note that this training process will take around maximum of 1 hour because I set it to 1 node hours for training. It might end a little bit earlier if early stopping took place and the model is maybe trained within, let's say, 30 minutes or so. Okay? All right. So let's go back to our slides. And let me review what we have done so far. So what we have done so far is we have been able to train our model. So what you guys see here is, first, we have been able to click on the train new model, and then we selected the type of training. We are essentially doing, it's a regression type problem. That's our objective. And then we use the auto ML feature. And then we specify the target column. That will be the name of my output. That's what I'm trying to predict, really. And then next we specify the model name and what is the target column, and here you can explore the additional features, and you guys will see that we're going to use 80% for training, 10% for validation, and 10% for testing. And here we went through that slide where we learned the difference between the training, validation, and testing or holdout dataset. And then finally, you need to select auto transformation for data transformation. And then what you could do as well is that you can select the optimization objective. And in the optimization objective, let's take with the default values. And these are the RMSE or root mean square error. We're going to cover the RMSE and what does that even mean in the next couple of lectures. Just use the default values. And then finally select the how many node hours you need. I just select the budget to be set to 1 and just go ahead and say start training. And that here has been, we kickstart a training job available for us. And you should be able to see that the training job and models are running here on the right hand side. And you should be able to receive a notification email once the training has been complete. And that's all I have for this lecture. I hope you guys enjoyed it. In the next lecture, we are going to learn about the machine learning regression metrics. So we'll learn how to assess a machine learning regression model. We'll learn about the difference between root mean square error or RMSE, between a mean absolute error, and also R squared or the coefficient of determination. And that's all I have. I hope you guys enjoy this lecture and see you in the next one. Hello everyone and welcome to this lecture on machine learning regression metrics. If you guys remember, in the previous lecture, we have been able to kickstart our training. So we created our own data set and then we essentially started our training using AutoML. And the training is running right now in the background and it's taking around 1 hour approximately for it to complete. Okay. So in the meantime, what I wanted to cover right now is I wanted to cover the basic metrics that we use to assess a machine learning regression model. So after the model is trained, what I wanted to do is I wanted to see how good that machine learning model is. So if you guys remember, is that here we have our GRE score, and here we have our chances of admission listed on the y-axis. And here I have my data points, if you guys remember. And all what I'm trying to do is I'm trying to come up with this simply straight line. That straight line will tell me, this is my model. I have a slope, which is M. I have y-intercept, which is B. And I ended up with this line here. And the question is, how good that model is? Well, so what we do is that we calculate what we call it the residuals. And simply the residuals is the vertical distance between what the model predicted, what the model came up with, and what's the actual true points are. So please note that these circles here, these are the actual values. That's the training data, right? This is the X and Y coordinates that came from the field. These are facts. And we call this YI. Okay, where I could take any number between 0, 1, 2, 3, and so on, indicating that this is Y1, Y2, Y3, and so on. And we call this actual because these are the actual values or true values or the ground truth, essentially. Any point that lies here on this line, this is the estimated or predicted value. So for example, given that GRE score here, the model predicted this point here, right? The model predicted that chances of admission might be, let's say, 0.7, for example. And that's why we call this Y hat. And Y hat indicate that this is a prediction or an estimate. However, the actual true value, the actual true Y was maybe 0.8, for example. And that's why what we do is that we calculate what we call the residuals or the errors. This is simply the difference between what the model is predicting, which is Y hat, minus the ground truth, minus the actual value, which is YI. Okay? All right. And then the question is, okay, what I'm going to do with it? So now I ended up with a bunch of residuals. I have residual here for this point. I have another error here as well for this point too. I have another error, another error, another error, for example. The question is, what I'm going to do with it, and that's what I'm going to do in the next slide here. So the first calculation that we can do is what we call it the mean absolute error, or MAE. And this is the equation to calculate the mean absolute error. And please note that in this course, we are not going to be doing any coding. So essentially, all these metrics will be generated for you automatically. So you don't need to worry about how they are calculated behind the scenes. The intent of this lecture is just to give you an idea of what do they mean, just kind of the intuition from a very high level. And simply the mean absolute error is obtained by calculating the absolute difference between the model predictions and the true actual values. So for every single data point that I have in here, I'm going to calculate the residuals, but I'm going to calculate the absolute value. And this is the absolute value for all the data points. And then I'm going to sum up all these values and divide by the overall number of samples, which is n. And that will give me the MAE. And the mean absolute error simply is a measure of the average magnitude of error generated by the regression model. Kind of give you an average value, approximately how good that model is. And these are the different steps. We calculate the residuals at every point, and then we calculate the absolute value. Basically, we get rid of the sign. So what you guys see here is you calculate the difference, and then you remove the sign. So if it's negative, it becomes positive. That's the absolute term. You sum up all these values here, so all these values, you sum them up, and then you divide by n, which is the overall number of residuals or samples, and that's it. If the mean absolute error is 0, that means or indicates that the model predictions are perfect. That means all the data points here lie on the line, indicating that there is no error, essentially. Okay, the second metric that I wanted to cover is known as the mean squared error, or MSE. It's actually quite similar to the MAE, or mean absolute error, but instead of using absolute values, I'm going to use the square of the difference between the model predictions and the training data set. And this is the equation, exactly the same as before, but instead of the absolute values, I'm just going to square up the residuals. So think about it. All what I'm trying to do is I'm trying to remove the sign. Okay, so I can remove the sign by either obtaining the absolute value or by squaring. If you square here any value, you will essentially is going to get rid of the sign. The number at the end will be positive, right? Okay, another key point as well that is very important when it comes to the mean squared error, because we are squaring up the error, that means the value for the mean squared error will generally be much higher compared to the mean absolute error, because you are squaring it, you are kind of magnifying it. And what you guys notice as well is that the error increases here in a quadratic fashion, while the error increases in a proportional fashion if you use the mean absolute error. And again, here are the steps. We calculate the residual for every data point, and then we calculate the square value of the residual, and then finally we calculate the average of the results from step 2. We sum them up and we divide by the overall number of samples. One important point as well is that since we are squaring the error, any prediction error will be heavily penalized. Again, the error will be much bigger because if the error is very small, for example, you square it up and now it becomes much, much bigger in a quadratic fashion. And that's why mean square error will be generally much higher compared to the mean absolute error. Okay, what about the next metric, which is RMSE, or root mean square error? Well, what we do is we obtain the previous metric, which is mean squared error, and then we obtain the square root of that. Essentially, you take the error, you take the residuals, you square it up, you obtain the average, and then you obtain the square root of it back. And what's super powerful about root mean square error is that it could be easily interpreted, because in case of the MSE before here, we have done squaring, right? So the units of the output is different compared to the units of the original data set. However, here, because I obtained the square root back again, the units will match the units of the output. Okay, so you can easily interpret the error with the RMSE. And RMSE provides an estimate of how large the residuals are being dispersed as well. And here are the steps. We calculate the residual for every data point. We calculate the square value of the residual. So you calculate the error here, the residual. You square that up. And then you calculate the average of the square residuals. You sum them up. You divide by the overall number of samples. And then you obtain the square root of that equation. And that's it. That will give you the RMSE, or root mean squared error. Okay. Finally, what we got here is what we call it the coefficient of determination, or R squared. So R squared, or the coefficient of determination, represents the proportion of variance of the output of Y that has been explained by the independent variables in the model, which is X. So let's assume that we are developing a machine learning regression model, and here we have our GRE score on the X-axis, and here I have the chances of admission. What we wanted to do is that we wanted to see or calculate what we call it R squared, or the coefficient of determination, and that essentially will tell you how much change in the output, how much change in the chances of admission has been described by the changes in the input, which is in this example is the GRE score. And this simply R squared is a number that ranges between 0 and 1. So if you have a number 1, that will be the best possible score, meaning that the output here is perfectly explained by the changes in the input, like 100%. What if I have maybe R squared equals to 0.8? Well, that means that 80% of the increase in the university admission score here, in the chances of admission, has been explained by the GRE score, which is by the independent variable X. And what's super powerful as well about R squared, or the coefficient of determination, it can give you an indication of the goodness of the fit. And therefore, it provides you a good measure of how well unseen samples are likely to be predicted by the model. And if we have a model, for example, that has a constant output, basically the output does not change based on the independent variable X, well, if you have that kind of model, R squared will be equals to 0, meaning, well, no matter how much I change GRE score, the output is fixed, the output is constant, it does not change, meaning that there is no, the change in the variance in the output is not dependent on the input. And that's when you have basically a useless regression model. And that's when you have an R squared of equals to 0. What we try to do, of course, to aspire for is to come up with a coefficient of determination as close to 1 as possible. And that's one of the key metrics that we're going to use once our model is trained in our example here. Okay? All right. So these are the key metrics that I want you guys to understand before we move forward to our part 3 of our demo. And in the next lecture, we'll go ahead and get started with our model assessment and deployment. So please stay tuned, best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. In this lecture, we are going to go ahead and assess our model performance, and we'll also learn how to deploy our model as well and make inference on that model. If you guys remember, in the previous task, we have been able to understand the basic machine learning regression metrics. We learned about the difference between mean absolute error, mean squared error, root mean squared error, and R squared, or the coefficient of determination as well. Okay, so what we have right now is, well, the training process took around 60 minutes approximately to complete. And you should be able to see that the training process here has succeeded. So the status shows success, essentially. So let me go back and show you guys what you got here. So under the training tab, what you guys see is we have the university admission regression. And it shows here, of course, we are doing tabular regression. And it shows succeeded. And it took around 53 minutes approximately to complete. So if you guys go ahead and click on models, you should be able to see our model here. So it shows university admission regression model. And if you just click on it right now, you guys should be able to see a lot of important features. So the first point is you should be able to see all the metrics that we covered so far. So the mean absolute error is set at around 0.049. Mean absolute percentage error is around 7.7%. And if you guys wanted to learn a little bit more, you can of course hover on top of it on that question mark, and it would show you guys the explanation. So for example, the mean absolute error is the average of absolute difference between observed and predicted values. And a low value indicates a higher quality model, where 0 means we don't have any errors essentially. And what you guys notice, this is the mean absolute percentage error. So within a percentage, you can get an idea of like how wrong is the model generating predictions basically. So what we got here is around 7% mean absolute percentage error. Here we have the RMSE, or root mean squared error, which is here is the root of squared differences between observed and predicted values. And of course, a lower value indicates a high quality model, where 0 means the model made no errors, basically. And what you guys see here as well is we have the root mean squared log error. We haven't covered that in the previous lecture, but it's essentially you are including the log differences between observed and predicted values. Don't worry about it too much. What we got here finally, and that's a very important metric, is R squared, or the coefficient of determination. And if you guys remember, R squared was generally a number that ranged between 0 and 1. 1 is amazing, 1 is perfect, and 0 means it's really bad model. And essentially the number here is around 0.741, which is pretty acceptable. In general, we need to push it a little bit further. And we can of course improve that by doing what we call it the hyperparameter tuning or optimization job. Okay. What you guys notice here as well is that we have what we call it the feature importance. And this is a very important insights that any machine learning engineer or data scientist want to learn about the model. So for example, what we have here is the GPA, for example, as a feature, is one of the most important features that decide whether a student will be going to be admitted to a given school or not. And this is extremely important information. So basically, if you are on the student side, if you are on the applicant side, knowing that information is quite crucial. And of course, if you are on the other side, which is on the admission, let's say, committee, understanding that the GPA plays a key role is important, followed by the GRE score as well. That's another feature. And then TOEFL score. We have the letter of recommendation, the statement of purpose, and then research, and then finally we have the university rating. And please note that in general, when we train any machine learning model, we want to make sure that this model actually makes sense. We want to do some sort of sanity check. And that's why doing the feature importance can give you more insights of what the model is actually thinking. So the model right now is deciding that the most important feature is, well, the GPA, followed by the GRE score, and so on. And that's what we call it AI ML models explainability. We wanted to explain how the model came up with these specific decisions. Okay? All right. So now we have been able to assess our performance of our model, and now it's pretty much ready. We're pretty much ready to go ahead and deploy our model. So if you guys go here and click on deploy and test, you should be able to say deploy to endpoint. So if you click on deploy to endpoint, you need to specify an endpoint name. So for example, I'm going to call it university underscore admission endpoint. You guys can call it anything you want. And then you need to here specify what we call it the traffic split. Don't worry about it too much. Here we are going to say 100% of all the traffic will be dedicated to our endpoint. Sometimes you might need to divert some of the traffic, maybe 80% to a given point and the other 20% to a different endpoint. But here we have a very basic model right now, and we are not going to be using it, I would say, at scale in production. So please go ahead and just select 100%. You also need to specify here how many number of compute nodes you're looking for. Let's stick with the basic one, which is 1. That would be the minimum number. And maybe the maximum number, it's optional, but maybe you can choose 2, for example. And then finally, you need to specify what would be the machine type that you're looking for. So you might select standard, you might select high memory, or high CPU. Again, all of that depends on how complex your model is, what is the type of application, or like the application environment, for example, that you're deploying their model at. But again, please know that we are just going to do a very basic test on our model. So let's go ahead and stick to just the default values, which is N1 standard with 8 CPUs and 30 gigabytes of memory. And then finally, I can just go ahead and click continue. You need to specify the location as well of the endpoint, and I'm just going to stick with the US Central. And you can just click deploy, and that's it. Just simply with just bunch of clicks of a button, you are able to deploy your machine learning models at scale, which is pretty incredible. And what you guys notice here is that the model is being deployed here. So it's showing that the model is being deployed, and it's taking some time for it to run. And once the model is deployed, now to the fun part. Now you can go ahead and actually test your model performance. So what you guys see here is the model again still running, and essentially I can go ahead, and once it's deployed, I can go ahead and insert features here and come up with actual predictions from my endpoint, which is pretty incredible. I actually started in this field, in the machine learning and AI field, around 11 years ago approximately. And I used to actually build these models, just write all the different codes from scratch, build all the different, let's say, neural network models and deploy the model. It was just a mess. Right now, this is like, like a dream basically for any machine learning engineer or any data scientist to be able to, just with a bunch of clicks of a button, to be able to build, train, test, and deploy machine learning models at scale without essentially writing any code, which is pretty incredible. So the model might take some time for it to run, for the endpoint to be deployed, but once it's deployed, you guys will be able to come here and insert values and simply generate predictions. So what I'm going to do is I'm going to pause the video, and then I'm going to be back once the endpoint is deployed. All right. So what you guys can see here is, well, the endpoint has been successfully deployed, and I would say it took around maybe 5 minutes approximately for it to deploy. And basically what I got here is I have a trained machine learning model that is simply ready to accept data set to make predictions. And what I've included here in the slides for you guys is I included a sample data set. For example, let's assume that I have a new student, and this student has the following features. Their GRE score is 327, their TOEFL score is 111, university rating is 4, statement of purpose, how strong is it, is 4, letter of recommendation is 4.5, their GPA is set at 9.2, and the research is set to 1. So let's go ahead and give it a shot. So what I'm going to do is I'm going to set the GPA score is 9.2, so I'm going to say 9.2. I'm going to set the GRE score, the GRE score is 327. Their letter of recommendation, how powerful or strong that is, I'm going to set it to 4.5. Their research is 1. The statement of purpose is set to 4. The TOEFL score is 111. And the university rating here was set to 4. And that's it. All what you need to do is to say, well, could you please predict that for me? And that's it. Here we go. What you guys see here is the overall prediction is around 0.85, meaning that this student has an 85% chance to be admitted to the school. Okay? And that's essentially how you can build, train, and deploy machine learning models at scale with Google Vertex AI without the need to write any code, really. And please, I highly recommend that you guys go ahead, and that will be the mini challenge for this lecture. I want you guys to please go ahead and experiment with at least 3 values. So please go ahead, give it a shot, maybe try different values here and test the model and see which feature has the highest or the most important effect on the output. All right, so what I got here, let me walk you through what we have performed so far. So what we have done so far in this lecture is we went through, after the training has been complete, we have been able to receive first an email indicating that the training has been complete. And you guys, of course, if you're doing that training on your end, you should be able to receive an email to your Gmail account indicating that Google Vertex AI training is now complete, has succeeded, and you can go ahead and check it out as well with the link that is attached in the email. Next, we have been able to cover all the different model KPIs, including the mean absolute error, the RMSE, and the R-square as well, which is a coefficient of determination. Next, we have been able to click on deploy endpoint, and then we have been able to afterwards select or give a name to the endpoint, specify the traffic split, and specify the minimum and maximum number of compute nodes and what type of machine you want to test your model on. And then finally we selected the region, and then we have been able to go ahead and create our endpoint. And once the endpoint has been successful, we have been able to make inference or generate predictions from that endpoint. We went there, we fed in here a bunch of numbers, we're able to generate predictions as we saw in here. Okay, one last point which is extremely important, and please make sure that you do not forget that. I want you guys to make sure to go ahead and undeploy the endpoint or delete the endpoint. Basically, if you don't do that, what's going to happen is you guys right now are essentially consuming resources from Google, and with this endpoint, this is a dedicated resource available for you, available for anyone really to go ahead and make predictions on your model. And that's why you need to make sure that, because we're not going to be using that endpoint again in the future, to go ahead and undeploy the endpoint. So you simply go ahead and click on undeploy and then click undeploy endpoint. So let me show you how we can do that here in Google Vertex AI. So if you guys go to endpoints, you should be able to see your endpoint here, which is University Admission Endpoint. If you just click on it, you guys will see that simply there is a delete here button that you can just click on. If you just click on and you say undeploy, and that will simply is going to remove the endpoint, so no extra charges will be credited to your account, so you don't have to worry about that at all. All right, okay, so that's simply all I have for this lecture, and that simply concludes our project. I hope you guys enjoyed this project, and in the next lecture we'll go ahead and conclude what we have learned in the entire project. Please stay tuned, best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. Congratulations, you guys made it. We have been able to complete our first project. Without writing a single line of code, we have been able to build, train, and deploy a machine learning regression model using Google Vertex AI. So let's recap what we have learned in this project. First, we went through the rise of machine learning in higher education. We learned that machine learning is being applied in several areas of higher education, including marketing and recruitment for students, student admissions and enrollment. We also covered the personalized student learning experience with the power of machine learning, and finally student support with AI-powered counseling. And we learned that in our project, we will primarily focus on the student admission and enrollment piece. Regarding the project overview, we learned that we are going to use multiple features such as GRE score, TOEFL score, letter of recommendation, statement of purpose, and so on, and essentially generate the chances of admission here as an output. And this is simply the overall overview of our model. Here are the inputs. Here is the machine learning regression model, and this is the output. And since the output is a continuous output, we learned that this was going to be essentially a regression type problem. We also went through a quick quiz. I hope you guys were able to figure that out. We read here these 2 articles and we went through the quiz as well. And then next we learned about regression. What do we mean by regression? How we can obtain the equation of that straight line here, where m and b indicates the model parameters. M is the slope of the line and b is the y-intercept. And then we learned about multiple linear regression, where we have more than one independent variable, and that was essentially our problem. We have GRE score, GPA, TOEFL score, and so on, and our goal is to try to predict the chances of admission. We also here learned that we have 2 additional resources as well, 2 open books, free, and you guys will be able to access them through these 2 different links. And we also went through a quick mini challenge. I hope you guys were able to figure that one out as well. Okay, and then we went through our first demo for Google Vertex AI. We learned how to sign into the account. We learned about the different stages of the project, including preparing the data, training your model, and then obtaining predictions. We learned how to create our own data set, and we saw that we just need to simply give a name to the data, specify if it's image, tabular, text, or video. We learned in our example that we're going to primarily focus on tabular data, primarily on regression and classification. We specified the CSV file, we uploaded the file, and then that's it pretty much. Next, we went through the model training piece, and then we have been able to simply train our model, specify if it's a regression or classification type problem. We selected the AutoML feature, and AutoML feature was super powerful because it automated the entire process for us, so we don't actually need to go and write any custom code. We specified the name of our target column, which is the chances of admission, and we learned also about the difference between the training data, validation data, and testing data set as well. And here we go. Here we had the summary slide. And then finally, we performed auto transformation of the data. And then we selected the optimization objective as RMSE, or root mean square error. And then finally, we specified the budget. We set it to 1 hour, maximum node hours is 1. And that's it. We just trained our model and just let it go, let it train. And then in the next lecture, we learned about machine learning regression metrics. So we learned about how we can assess machine learning models. We learned about the residual calculations or the error calculations, which is simply the difference between what the model is predicting, which is y hat or y estimate, and the actual value, which is the ground truth. We calculate the mean absolute error, mean squared error, root mean square error, and the coefficient of determination as well, which is r squared. And then finally, we learned how to assess our model performance and to deploy it as well. And what we guys can see here is after the model training is complete, we received an email to our Gmail account. And then we have been able to see all the different metrics, including the mean absolute error, mean absolute percentage error, r squared, and RMSE as well. We also explored feature importance, where we learned that the GPA was the most important features out of all of them, followed by the GRE score afterwards. And then all what we need to do is after the model is trained, we have been able to say deploy to endpoint. We specify the endpoint name, traffic split, and how many nodes, compute nodes we're looking for, and of course what would be the machine type. And that's it. We specify the region, and then once the endpoint is deployed, now we're pretty much ready to make predictions. We fed in here just a bunch of numbers, and we explore the predictions coming out from my model, and basically the predictions with around 84%, indicating that this specific student with these specific features has around 84% chance to be admitted to the university based on his or her features. And of course, please do not forget that. Make sure to remove the endpoint, undeploy it, just delete it, and that will essentially conclude our project. I hope you guys enjoyed this project and see you in future projects.